So in this video, we're going to talk about the topic called statistical description of data. Guys, it is actually of two parts. So yes, as per our material, we have divided this concept into two partitions. One is statistical description of data part 1, which deals with the basics of statistics. So with the help of them, you are able to understand what is a data, what is a series, means all the basic definitions of statistics are covered under a part called statistical description of data part 1. And of course, we have statistical description of data part 2, which actually into the diagrammatic presentation, of course, presentation, collection, classification, everything is covered there, guys. So the expected weightage of this concept is usually 4 to 6 marks, guys. So guys, I must tell you one thing. This is a very easy concept for the people who are very bad at mathematics, I can say, because this is completely a theoretical concept. Of course, we have MCQs in this topic, but there are easy MCQs which are dependent upon classification of data and collection of data. Like that only it is there. So means it is a very easy topic and it is a best topic for the people who are bad at mathematics. So who are not good at mathematics, I can say. So as it is completely a theory concept, and this is a very easy concept, guys, but it has so many concepts that are to be covered. So like about presentation of data, classification of data, collection of data, and what is a data. So everything that you need to learn in this topic, guys. So the usual preparation time for this concept is at least 10 hours, guys, because it has this much of volume to cover. Yeah, there are certain cases in which you will get a new MCQ even if you cover this much. So in this video, I'm going to tell you how to answer the MCQs that are related to statistical description of data also, guys. So I'm going to complete this concept within 2 to 2.5 hours, guys. So let us start off with statistical description of data part 1. So guys, before getting started, let me tell you a basic introduction to statistics. So today, statistics is a common word, no? But for different people, it conveys different meaning. For some people, if you look at our first question, which is define the term statistics, that is what the introduction to statistics. Today, statistics is a common term to everybody. From your 8th standard onwards, you are aware of a term called statistics. For some people, statistics means it is just counting. Yeah, it is all about counting. Statistics of this thing, statistics of that thing, statistics showed this much. That's how many newspapers used to write, no? Yeah, for some people, it is just a count. Some people used to say that economic condition of India has been improved from the last 5 years. That's how people say. It means economic condition means it's a qualitative phenomenon. No. To support that qualitative phenomenon, some people use statistics. That's what we have mentioned in the second point. To some people, it is just a count. To some people, for some people, they will use statistics to support a qualitative statement. Madam, how do they support that qualitative statement? Yes, guys, if someone say that economic condition of people in India has been improved during the last 5 years, it means they will calculate the per capita income, no? Yeah, per capita income means it's the average income, no? That average is a part of your statistics, no? Yes. Some people will say that statistics is helpful for establishing a relation between two or more variables. Yes. So, for example, in regression analysis, in future, you will see regression analysis. So, which might be a 6th concept to you, 6th or 7th concept. There you will establish the relation between dependent variable and independent variable. For example, rainfall and yield of a crop, guys. Yield of a crop depends upon rainfall or rainfall depends upon yield of a crop? Yes, yield of a crop depends upon rainfall. So they'll collect the data or they'll collect the statistics as I already told you. For some people, statistics means it is just the data, no? Yeah. For some people, they'll collect the data this way. They'll collect the data of regarding rainfall and yield of a crop. And they'll make a statement related to that yield of a crop and rainfall, or they'll segregate the data that is related to rainfall and yield of a crop. And they'll establish a relation between rainfall and yield of a crop. In future, if this much of rainfall is there, how much yield we can expect? That's what they will predict. Yeah, some people use it to identify the relation between a number of variables. So based upon that, they will forecast something, guys. Yes. So for some people, they will use to bring accuracy in social sciences. Not only in social sciences, guys, at many cases, statistics will be helpful in bringing precision, accuracy, because there are many cases in which we can't completely analyze our population. For example, when it comes to blood, can we pull all the blood from our body and calculate the cells that are presented in our body? We can't do that. Means it's a population analysis, but we can't do that as the item is being destroyed at the time of testing only. If I wanted to test my blood, if I pull every drop of my blood outside, means I can't exist, no. Yes, in such a case, they will collect a sample of blood. You people used to listen to that word, no? So they'll collect a sample and they will analyze that. And they will confine that study to your entire body. Definitely there's a chance of getting error, no? That error can be reduced with the help of some of the techniques that are used in statistics. Yeah, the statistics might be helpful for you in many cases, guys. For different people, it is different. Okay, so there are two definitions for statistics, guys. Let me talk about the first definition, which is singular definition. Guys, this is a very regularly used definition, guys, but we don't know that we are using it. Yes, I'll tell you how. Guys, for example, you wanted to start your CA journey during from your intermediate onwards. Means as you wanted to become a CA, you have to definitely be into a course which is related to CA, not like MPC or some other course, no? Yes, even if you're MPC, you can do that. But if you have realized that you wanted to become a CA at the 10th standard or somewhere else, means you'll definitely be into the field of chartered accountancy. You'll definitely be into the college which is offering coaching or any programs that are related to chartered accountancy, right? So guys, you look at only one college and you will go to take an admission into that college. Is it really happens? No. You look at multiple options, no? Yeah, there you are collecting a data regarding colleges, no? And then you will classify that data, which college is better, which college is not doing well. Like that you will classify it, no? And then you will analyze it. So which college suits me best? Yes, there are 2-3 colleges which are offering best. In such a case, you have to understand which suits me better. So in such a way, you will analyze. Finally, you will get a conclusion and you will be into that institute, no? This entire process is called statistics definition, guys, which is singular statistics definition. Look at this. It may be defined as a science of scientific method that is employed for collecting, presenting, and analyzing the data. And of course, after analyzing this, we'll give a valid conclusion. We'll take a valid conclusion, right? So leading to drawing statistical conclusions about some important characteristic of the data. Yes, what are we collecting about? We are collecting about the college's data, no? Yeah, this is completely statistics. Yes, of course, at the time of playing also, small kids also do this. They will collect some toys. From them, they'll understand which suits them better, which doesn't suits them better. They'll throw the toys outside, which don't suits them, and they will play with the toys that they want. No. So this is all about statistics, guys, but unknowingly we are applying it, and that is a singular definition. Okay, now what is a plural definition? So according to singular definition, it is a method of counting, no? But when it comes to plural definition, guys, statistics is such a thing that it has to talk about both qualitative data and quantitative data. That is what your plural definition. Of course, different statisticians gave the meaning to statistics in different ways, guys. According to A.L. Bowle, it is a science of counting or science of averages. And of course, according to Croxton and Cowden, it is the science that deals with collection, classification, analysis, and inference. So next, according to I.A. Fisher, statistics is a branch of mathematics which is applied to some numerical facts. Of course, olden days statistics was considered as a branch of mathematics, guys. No, not now. Now it is a full-fledged subject and it is separate subject, guys. Statistics is completely a separate subject. Now, let us talk about some specifically commonly used terms in statistics. The first term is population. What is a population? So guys, population is not about the people that we are talking. According to statistics, population means, suppose guys, if I'm talking about pencil, If I'm just talking about pencil, all the pencils in my class, pencil in a class, all the pencils in my class will be considered as a population. So population is nothing but it is the totality of set of objects under consideration. What am I considering about? I'm considering about a pencil in a class. So all the pencils in a class will be considered as a population. Now, so I have a population of 200 pencils with me as my class has 200 members. Yes, now if I take a small part of that population, if I take a part of that population, means if I take a subset of my population, that will be called as a sample. How do you call it as? Sample. It means sample is a subset of what, guys? Population. Now, what is a census? So guys, suppose if you have gathered or collected information about each and every member of population, population means it's a huge thing, no? If you have gathered or collected information about all the members of population, that is called as census. How do you call it as? Census. Now, what is a survey? Survey is an alternative name for sample survey. Madam, what is sample survey? Sample survey is a survey, is the information that is collected for sample, guys. What is a sample? Sample is a part of population. So if you collect the information about population, that is called as census. If you collect the information about sample, that is called as sample survey. Got it, guys? Now, look at the next definition, characteristic. What is a characteristic, guys? It's a regular English word. Characteristic means it's a quality possessed by an object or individual. For example, I'm talking about this pen, guys. Which color pen it is? Black color. It is the quality, no? That is called as characteristic. For example, I have a group of boys with me. All the boys are intelligent boys. I can say that I'm talking about the quality of those boys. I'm saying that they are all intelligent boys. So at some stage, I've calculated the average marks of all those people. All these boys are more than 80% percentage students. So yes, I'm talking about the marks of them, which is their quality. I'm talking about the intelligence of their boys. Sometimes I'm calculating it and sometimes I'm directly telling it. Now look at the definition of characteristic. Characteristic is a quality that was possessed by any object or an individual. Yes, yeah, that is called as characteristic. Now let me talk about the characteristic that I discussed about this pen. This pen is of black color. Means, am I able to express the characteristic or the quality possessed by this object in a numerical form? No, I can't. If I can't, it is called as attribute. How do you call it as, guys? Attribute. So if it is measurable, it is called as variable. So are you able to understand the difference between a variable and attribute, guys? If the quality possessed by an object or individual, which is nothing but if the characteristic can be measured numerically, that is called as variable. If it can't be measured numerically, it is called an attribute. Suppose if I'm talking about the height of this pen, I can express it in numerical format and that height is said to be a variable. If I'm talking about the color of this pen, that can't be expressed numerically and that can be called as attribute. Now, what is a data? So guys, you are all aware, data means information. Data means information. You have to collect information. So information about what? Something. That should be expressed in numerical format. That should be expressed in which format, guys? Numerical format. That should be. So suppose if I'm talking about the height of this pen, I have to take a tape and then I have to measure it and then I have to write it. So data means it's a collection of observations. Observations means that too, numerical observations, that's what I'm talking about. That is related to some information that should be expressed in which format only? I have already told you, numerical format. Now guys, you should understand data means it's a collection of information about whom? It can be either population or sample or about anybody else. So it's a set, no? Yeah. Each and every element of this set is called as datum. Datum is singular. Data is plural. If you are collecting information about only one particular thing, that is called as datum. And if it is the information about more than one person or more than one object, that is called as data. Data is plural, datum is singular. So classification of data I have already told you. So if it is a measurable characteristic, we can call it as a variable. If it is non-measurable, we can call it as an attribute. Variables are of two types, guys. One is discrete variable and the other one is continuous variable. I have already provided you information about attribute and variable. No? Now I'll tell you what is a discrete variable. First of all, tell me the meaning of variable, guys. What is a variable? Variable means it's a measurable characteristic, means I can measure. For example, so guys, let me talk about the number of misprints in this page that I'm talking about, or I'm reading about, or I'm discussing about. So I'm talking about this page. How many printing mistakes can be there? Either 0 or 1 or 2. Can I write a 1.5 printing mistake is there? No. And that too, is it countable mistakes will happen or uncountable mistakes will happen? Only countable, no? So if a variable assumes either finite values or countable values, countably infinite number of isolated values means different values, that is known as discrete variable. Some people will say that if it is finite, we'll call it as a discrete variable. If it is accepting only integers, I can call that variable as a discrete variable. Discrete variable is such a variable which will accept only finite values. Yeah, countably infinite will be also called as finite according to mathematics, guys. So yes, countably infinite will come under the category called finite. So you might not be aware of that, but according to mathematics, countably infinite is finite only. Okay, a variable that assumes either finite or countably infinite. Countably infinite is a form of finite. So a number of isolated values, or else it is taking only integer values. It can be considered as discrete variable. Now, can you please tell me the meaning of continuous variable? You can easily tell. Yes, continuous variable is such a variable which can assume any value in an interval. Interval means, guys, suppose if I take 0 to 1, it's an interval. Whatever the interval that you take, say it's a class interval. People call it as a class interval. That we can discuss later. First of all, look at this. I am talking about the values in the interval. How many values are there in this interval? Nobody? Only 2? No, there are infinite values. 0, 0.1, 0.2, 0.3, 0.01. Like that, how many values will be there? Infinite values, no. So if a variable takes infinite values, that's a continuous variable. If a variable assumes decimal values also, that's a continuous variable. Now you must understand one thing. If it is accepting decimal values, means it can accept integers also, because every integer can be expressed as 2.0. No? 2 can be expressed as 2.0. So continuous variable will accept both integers and non-integers. But discrete variable accepts only integers. That kind of difference you must note here, guys. Now, describe about different types of data. So, guys, collection of data or classification. Data is classified into many ways. One is raw data, and the other one is individual series, and the other one is frequency distribution. So, this frequency distribution is of two types: simple frequency distribution or a discrete series. Continuous frequency distribution, grouped frequency distribution or continuous series. Let's talk about raw data. So guys, what is the data? Information, no? Suppose I wanted to collect the information about all the people heights of my students. So collect the information about heights of my students in a particular class. I'll do that now. Let me do that. So I'll write on the, what can I say? I'll write on the height of my first student, and I'll write down the height of my second student. I'll write down the height of my third student. Like that, I'll collect the data regarding all the members in the class. That is called as raw data, which is not classified, which is just written on the paper, and that will not be used for any purpose of analysis. And that kind of data, just collected data, is called as raw data. How do you call it as, guys? Raw data. So just collected data is always called as raw data. Collected data is always called as raw data. So guys, just collected data is called as raw data. So that raw data can't be used for the purpose of analysis. So it is to be processed, means it is to be arranged, it is to be classified or else it is to be tabulated. Okay. Now, what is an individual series? Guys, the name itself is saying I'm a series, means there's no restriction about the order of elements, because if I collect the heights, if I collect the information about the heights of students in a class, will they be in a particular order like ascending order or descending order? No, it is just a series. No order is there, which is individual, means if all the elements are written one after another, so means height 170, 168 centimeters, 163 centimeters, 155 centimeters, like that. If I have written all the elements separately, all the values separately, that is known as individual series. If you want, you can arrange them in either ascending order or descending order, guys, but there is no restriction that all the elements should be in a particular order. Okay, just if you write all the elements separately one after another, that is called as individual series. Now, what is frequency? This is a very important concept, guys. For example, guys, I'm talking about the favorite color of the people who are there in my class. So, I'm writing color and I'm writing frequency. What is a frequency? So, guys, suppose that, let me say that yellow color, red color, green, orange, of course pink, or some other colors, guys, many colors, blue. So, let me write some colors. So, in all the members together, I got 20 members love yellow color, and I got to know that 15 members like red color, and of course let me assume that 30 members like green color, like that remaining people also. Means this color yellow was told by how many people? 20 people, means this color yellow got repeated how many times in my class? Tell me, guys. Yes, 20 times. That is called as frequency of the variable called yellow. So let me tell you the meaning of frequency. Frequency means number of times that a particular observation got repeated. Number of times that a particular observation got repeated and is shown in front of the observation. So my observation is yellow, which is repeated for 20 times, and my next observation is red, which is repeated for 15 times. Got it, guys? Frequency means it's the number of times that a particular observation or a variable or a quantity or a value got repeated. So, however, whether it is a variable or quantity or something else, I just wanted to look at the right side of mine. It is about number of repetitions, how many times that a particular thing got repeated, particular observation got repeated. Now, what is a discrete series? Guys, the name itself saying that I'm a series and I deal with a discrete variable. I'm a series and I deal with what kind of variable? Discrete variable. So, how does a discrete series looks like? Discrete series has variable along with frequency, guys. Okay, so that's what about discrete series. Now, so let me tell you the meaning of continuous series. What is a continuous series? Continuous series, the name itself is saying that I am a series and I deal with continuous variable, and you all know that continuous variable takes the values in an interval, no? That's way all the values of the variable will be in intervals. Against it there is a frequency will be always written. Now guys, I have told you the meaning of class. What is a class? Any interval stated by you is called as a class interval. Any interval stated by you is called as a class interval. Now, if you look at the previous example, so the first class interval is 0 to 100. What is the frequency of this? 15 means the income of the people in 15 persons income will be between 0 and 10. 7 members income will be between 100 and 200. 25 members income lies between 200 and 300. 10 members income lies between 300 and 400. 6 members income lies between 400 and 500. So you must understand that what is a class frequency. So number of observations in a particular class interval is called as class frequency. Total frequency, what is a total frequency? Sum of all the frequencies is called as total frequency, which is denoted by either n or summation f. How do you call it as? Either n or summation f. So now let's talk about a very important series, which is inclusive series. Guys, inclusive and exclusive series are both a part of continuous series. Continuous series means it's a series which deals with continuous variable. But you must understand one thing. This inclusive series is usually meant for discrete variable. I'll tell you the meaning why. Okay. So guys, what is an inclusive series? Okay. So here I'm writing 0, 1 to 10. My class interval is 1 to 10, 11 to 20, 21 to 30. Of course, if I want, I can write 31 to 40. Let me write the frequencies against 5, 7, 8, 10. Let me assume that these are my frequencies. May I know what is my first class interval? 1 to 10. Means this class interval is accepting the values from 1 to 10. Means number 1 is included, number 2 is included, number 3, number 4, number 5, number 6 and till number 10. Every number is accepted. So means this series has a particular thing that it will accept both the lower value and upper value of this class interval, both the lower value, least value of the class interval and the highest value of this class interval. So, but what is an inclusive series? It is such a series in which the higher value of the first class interval doesn't coincide with the next lower value. So guys, before that I must tell you one thing. Class limit. What is the class limit? So what is the first class interval? 1 to 10. So the least value in this class is called as lower class limit and the highest value in this class interval is called as upper class limit. Now tell me guys, what is the lower class limit of first class? 1. What is the upper class limit of first class? 10. So inclusive series is such a series in which the upper class limit of a first class do not coincide with the lower class limit of the next class. So like that, upper class limit of this class do not get coincide with the lower class limit of the next class if the series is arranged in ascending order. Look at this. Under this method, both the upper limit and lower limits are included in the class interval. In this series, upper limit of a class do not coincide with the lower limit of next class. So in such a case, upper limit of one class is always less than the lower limit of the next class when the classes are arranged in ascending order. So in this type, overlapping is avoided because it ends with 19 guys, the next one starts with 20. There's no overlapping. So this is called as a non-overlapping thing. So guys, why do you call this series as this series deals with discrete variable? I'll tell you the logic behind this guys. A continuous series is such a series which deals with which variable? Continuous variable. What is the meaning of continuous variable? Continuous variable is such a variable which has to accept both integers and non-integer and it has to accept every non-integer. But if you look at this series guys, it is accepting the integers or non-integers from 10 to 19 and this one is accepting from 20 to 29. So guys, suppose if I have an observation called 19.5, can it be included in the first class or second class? Not possible. Means it is not able to accept some of the decimal values. Means it's not going to complete the property of a continuous variable. That's why at the beginning they told that it is a discrete variable. It is not actually discrete variable, but it is not satisfying the property of continuous variable. That's why we are calling it as a discrete variable. Try to understand that. It is ignoring some of the decimal values, but a continuous variable is such variable which has to accept all the integers as well as non-integers and it is not doing so. That's why I'm calling it as a series that deals with discrete variable. As it is not dealing with continuous variable, I'm calling it as a discrete series. Try to understand. So, sorry, as it is not dealing with a continuous variable, I'm calling it as a continuous variable. So, yes. However, some fractional values can't be included in this classification. Just now I have given you example. Now, what is an exclusive series? Exclusive series is such a series, guys. Let me give you an example of exclusive series. It will be like this, guys. 0 to 10, 10 to 20, 20 to 30, 30 to 40. Let me write down the frequencies. Frequencies, same frequencies, 5, 7, 8, 10. 5, 7, 10, 8 or else. Let me change the order. Guys, look at this. What is your first interval? 0 to 10. And what is your next interval? 10 to 20. Guys, try to understand. In the first interval, we are taking the values from 0 to 9.99999 only. It means you are not including 10. That's why you are naming the series as exclusive series. How are you calling it as? Exclusive series. Exclusive series is such a series which will accept only lower limit. It will not accept your upper limit. So, and one more thing, exclusive series is such a series in which the upper limit of first class will be equal to the lower limit of next class. Upper limit of any class will be equal to the lower limit of next class. That's why we'll call this series as overlapping series. How do you call it as, guys? Overlapping series. So look at the definition, guys. In this type of classification is meant for continuous variable. In this upper limit of a class excluded that class, and it is included in the next class lower limit. In this series, upper limit of a class does not coincide with the lower limit of next class, and that's why we are calling it as overlapping series. Okay, so here we are just going to include upper limit or lower limit. We are not going to include lower limit. So what is a class limit? I have already told you, guys. For a class, whatever the highest number that you can see or whatever the least number that you can see, try to understand whatever the highest number that you are looking at or whatever the lower number that you can see are called as the class limits. For example, what is my upper class limit of class 0 to 10? 10. Lower class limit 0. What is my upper class limit for the class 1 to 10? 10. Lower class limit 1. It is the visible part that you need to understand, guys. So I am writing interval A to B. My upper limit B is B and my lower limit is A. But guys, when it comes to inclusive series, we are missing some values to 1 to 10, 10 to 20, 20 to 30, 30 to 40. Okay, sorry guys, it is not an exclusive series, no. So let me write one of the inclusive series here. So 1 to 10, 11 to 20, 21 to 30, 31 to 40. Guys, is it an inclusive series or exclusive series? Inclusive. Guys, inclusive series is a part of discrete series or continuous series? Continuous. But what is the property of a continuous variable? It has to accept both integers as well as non-integers. But here, some of the non-integers are missing, no? That is why it is advisable to convert an inclusive series into exclusive series. Madam, how do you convert an inclusive series into exclusive series? Just calculate the difference between the upper limit of a class and the lower limit of its preceding class. What is the difference between both of them? 10. 11 minus 10. Okay, this is the difference between lower limit of a class and the upper limit of its preceding class. Okay, how much is it? 1. Calculate d by 2. What is d by 2? 0.5 as d equal to 1. Now subtract 0. From the lower limit. Subtract d by 2 from the lower limit and add d by 2 to the upper limit. So can you please tell me what is 1 minus 0.5? 0.5. 10 minus 10 plus 0.5? 10.5. Guys, I have already told you, you have to add it to the upper limit and you have to subtract from the lower limit. And 11 minus 0.5, how much, guys? 10.5. Now, for the next one, calculate the difference. What is the difference? 1. And d by 2 is 0.5. This is called as correction factor. You have to add this correction factor to the upper limit and subtract this correction factor from the lower limit. Now, again, the difference between 31 and 30 is 1, no? D by 2 is how much? 0.5. So, subtract from lower limit and add to upper limit. 30.5 and 31 minus 0.5 is 30.5 to 40.5. Now, can you look at the series? Is it an inclusive series or exclusive series? Yes. So, this inclusive series is converted into exclusive series. Now, guys, let me tell you the meaning of upper boundary. So, 1 is a lower limit, 10 is an upper limit, right? But what are the actual values should be taken by this 1 and 10? 0.5 and 10.5, right? So, these are called as boundaries. So, boundaries are the actual class limits. What are they? Boundaries are the actual class limits according to the definition of continuous series. So, it has to take the values from 0.5 to 10.5, but it is showing 1 to 10 as it is an inclusive series. It is not satisfying the property of a continuous variable. That is the reason why we are converting this inclusive series into exclusive series with the correction factor d by 2, where d is the difference between lower limit of a class to the upper limit of its preceding class, and we are calculating d by 2. To calculate upper boundary, we are using UCL plus d by 2, and you could calculate lower class limit, you are using LCL minus, lower class boundary, you are calculating LCL minus d by 2. It means you should understand that boundaries are the original limits of a class interval. What are your boundaries? Boundaries are the original class limits of a class interval. Got it? So, where are boundaries, where are limits? Guys, you must understand that for an exclusive series, you need not convert them, no? Means they are boundaries and they are limits. But for an inclusive series, they are just limits. If you want to calculate boundaries, you need to convert an inclusive series into exclusive series. Got it, guys? Now, coming into the other important concept, class width. What is a class width? Class width is the difference between upper class boundary and lower class boundary. Try to understand, it is not the difference between upper class limit and lower class limit. It is the difference between upper class boundary and lower class boundary of a class. Got it, guys? Now, guys, if you look at this, so can you calculate the class interval directly to this class interval? Class length to this class interval? No, because it is an inclusive series. If you want to calculate class length, it is the difference between UCB and LCB, means you have to convert this inclusive series into exclusive, and then you can calculate the class length. Now, describe about the construction of frequency distribution. Means, guys, so I'll be given with a data like this. I'll tell you with an example, guys. I'll be given with a data like this. So this is my data. Then in this data, identify the highest observation and least observation. Guys, what is your highest observation? For now, least observation. For now, I can see 45. 45 is my least observation, right? So what is your highest observation? Till now I have seen 73, guys. Okay. So this is your highest observation and this is your least observation. Guys, try to understand. Identify, first of all, identify the highest observation and least observation in your data. That is what your first step. Find the largest and smallest observations, and now calculate the difference between largest observation and smallest observation, which is called as range. And that is nothing but 73 minus 45, which is 28. So what is your range, guys? 28. So that is what your first step involved in the construction of frequency distribution. Next, present the classes or class intervals in a table known as frequency distribution table. So how do you do that? So there is a formula to calculate the number of classes, guys. Number of classes is equals to range by class width. So he'll give you class width. So for this question or for this example, it is given that taking the class width as 5. So what is your class width, guys? 5. So number of classes is equals to range by class width, and you are getting 28 by 5. What is 28 by 5? 5.6. Guys, try to understand, though it is 5.1, just go for the next integer. Means take it as approximately 6. Now, arrange them between classes. How do you arrange them? So, it's a simple task, guys. Sorry, guys. So, what is your least observation? 45. Okay. 45 to 50. As you are saying that your class length is 5, no. Next, 50 to 55. Next, 55 to 60. Next, 60 to 65. Now, 65 to 70. 70 to 75. Guys, how many classes you got? 6. Yes. As per our discussion, we need to write how many classes? 6. Now, what is your first observation? 70. So, where is 70? Last class. Here, there is up to 69.99. So, there is 70. Draw a tally mark. This is called as tally mark. Next, 73. Draw a tally mark. Next, 49. Draw a tally mark. Next, 61. Draw a tally marks here. Okay, next, 47, 57. 47 will be here. 57 will be here. Next, 50, 59. 50 will be here. 59 will be here. Next, 59, 68. 59 will be here. 68 will be here. Next, 45, 55, 65. 45 will be here. 55 will be here. 65 will be here. Now, 45, 55, 65 over now. 68, 56. 68 will be here. 56 will be here. There's 4 already completed. For the fifth one, you have to cross it. Next, 68, 55. Where is 68? 68 here, 55 here. Next, 70, 70, 57. 70 repeated, oh, sorry guys, not 70 here, 70, 70, 57 again here. Next, 44, 69, 73. 44, oh, sorry guys, I should write my smallest observation as 44. It's not a big deal. Oh, now I have to change the classes also, guys. So 44 is my smallest observation. Sorry for it, guys. 44. 44 minus 73, no? 29. So 29 by 5. So of course, there's no change in the number of classes, guys. But there is a change in the class interval. Now I have to change everything, guys. Means I have to start from 44. Got it? 44 to 49. Next. 49 to 54. 54 to 59. Like this, I have to write the classes. Okay. Next, 59 to 64. Next, 64 to 69. 69 to 74. That's how I need to write. And then I need to identify tally marks. The same process, guys. Suppose if you're done with all the applying all the tally marks, then write down a frequency table. How many times this interval got repeated? 3 times. Next, 1. Next, let it be 6. Let it be, sorry, 7, guys. It means what is frequency talking about a class interval? So, guys, the frequency of the class interval 55 to 60 is 7. Let us assume it. It means there are 7 observations between 55 and 60. That's what he is telling you. That is what the literal meaning of frequency. So, what is the frequency of a class interval? Number of observations lying in a class interval. Number of observations lying in a class interval is called as the frequency of the class interval. So, try to understand. Now, what is a mid value? Guys, mid value has a formula which is UCL plus LCL by 2 means upper class limit plus lower class limit by 2 or upper class boundary plus lower class boundary by 2. Whatever you use, you will get the same answer, guys. There is no difference at all. So, that is what the formula for mid value, guys. So, if you want to write the mid value, just write down a mid value and then write down frequency. The series so obtained is called as mid value series. How do you call it as, guys? Mid value series. Mid value series is the frequency distribution which deals with mid value. Now, guys, sometimes he'll give you mid value. Sometimes he'll give you mid value. How to calculate class limits or class boundaries? So, I'll tell you a very simple example here, guys. Look at this. This is a mid value. Forget about it. So, let us assume that you don't have these things. So, you have just mid value and you need to convert them into exclusive series. How to convert these mid values into exclusive series? So, just calculate the difference between two mid values, guys. What is the difference between mid values? 10. So, this is called as D. Now, calculate D by 2 every time. D by 2. What is D by 2? 5. So, what is your mid value? 10, no. Subtract 5 from mid value to get lower limit. Sorry, D by 2. And add D by 2 to mid value to get upper limit. Means, mid value plus D by 2 is your upper limit. Mid value minus D by 2 is your lower limit. What is mid value? 10. And D by 2 is 5. No. What is 10 minus 5? 5. And mid value is 10 and D by 2 is 5. 10 plus 5 is 15. Are you able to see? Yes. Now, D by 2 is again 5 as the difference is 10. 20 minus 5 is 15 and 20 plus 5 is 25. Next, again the difference is 10 only. So, D by 2 is 5. 30 minus 5, 25. 30 plus 5, 35. So, that's how mid value minus D by 2 is your upper limit, lower limit, and mid value plus D by 2 is your upper limit. Okay, so that's how you can talk about mid values. Now, guys, there is no restriction that all the classes should be having same width or length. What is the formula for class length? Upper limit, upper boundary minus lower boundary. There are certain series in which all the classes will not be of having same length. That kind of series is called as unequal class interval series. If the class length is same throughout the class intervals, that series is called as equal class interval series. For example, what is the difference between UCB and LCB? 10. What is the difference between UCB and LCB? 10. Again, 30 minus 20, 10. 40 minus 30, 10. 50 minus 40, 10. So class length is same. So the series is called as equal class length series. But when it comes to this classification, so if you look at this, 30 to 60 length 30, 60 to 80 length 20, unequal class length series. Okay, now let's talk about another important concept, open-ended series. Guys, if the lower boundary of first class, let me repeat, if the lower boundary of first class or the upper boundary of last class or both were unknown, let me repeat, if there is no lower boundary for the first class, means we don't know the lower boundary of first class, or else we don't know the upper boundary of last class, or both we don't know, such a classification is called as open-ended classification, and it is not the correct scenario. Even if we wanted to calculate them, there is a chance of correcting it, but that is not perfectly true, guys. So how to convert this open-ended series into a regular series means it is just an assumption, it is not 100% true. What we'll assume means we'll take the class interval of next class as the class interval of first class. What is the class interval of this class? 10. So we'll feel that the class interval of this class is also 10. So upper limit is 10. We don't know the lower limit, but you know that class length is equals to upper boundary minus lower boundary. And your upper boundary is 10. So your lower boundary will be how much, guys? 0. It is purely an assumption, guys. It's not perfectly correct. Like that, we'll take the previous class length as the class length of this one. What is the class length of 30 to 40? 10. And the formula for this is above 40 means 40 to somewhere else, no? So UCL, UCB minus LCB is 40. Let me bring this minus 40 to left side. It will be 50. Upper boundary is 50. But try to understand, this is purely an assumption. It's not perfectly correct. Now coming into the very important concept, cumulative frequency distribution. So how to write cumulative frequency distribution? So guys, let me write 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50 is my class interval. Okay, let me write down the frequencies this way. This is my class interval and my frequency 5, 7, 10, 8, 2. Let it do. So guys, 0 to 10, all the values are less than 10 or more than 10. Tell me, guys. Less than 10, no? So I'm writing this word called less than. All the values are less than 10. So less than 10, how many values are there? 5 values. Now guys, listen to me. Less than 20 means they are between 0 to 10, or 10 to 20 means I have to cumulate these two and I have to add them up. Got it, guys? Yes, I need to cumulate the previous one. So lesser values. That's why I'm calling it as less than cumulative frequency. So less than 20, how many observations are there? 5 plus 7, 12 observations. Now less than 30 means they are from 0 to 10, 10 to 20, 20 to 30. How many observations? 5 plus 7 plus 10. How much? 22. Got it, guys? Now less than 40. Less than 40 means they are from 0 to 10, 10 to 20, 20 to 30, 30 to 40 means you have to cumulate them and you have to add them. So how many? 30. Less than 50. How many are there? 32. Guys, got to know, guys? Now I just wanted to know what is my total frequency? 32. Means last value of less than cumulative frequency is your total frequency. So if you have written this one, this is called as less than cumulative frequency distribution. In this less than cumulative frequency distribution, you will write lower limits or upper limits? Only lower limits. Now I'm writing this way. Greater than. And the next column is GCF. What am I writing? Greater than GCF. So greater than what? So all the values are greater than 0. Next, greater than 10, greater than 20, greater than 30, greater than 40. Now guys, listen to me. Greater than 40, how many observations are there? Just 2. Got it? Now greater than 30 means what, guys? 30 to 40, 40 to 50. Now you have to accumulate these things. 8 plus 2, 10. Greater than 20 means 20 to 30, 30 to 40, 40 to 50. So you have to accumulate these three fellows, which is going to be 20. Now, Greater than 10 means 10 to 20, 20 to 30, 30 to 40, 40 to 50. Put together it is 27. Greater than 0. All the observations are greater than 0. No. How many observations? 32. Means if it is LCF, you have to add all the frequencies from top to bottom. If it is GCF, you have to add all the frequencies from bottom to top. That's what you need to understand. So that's how you can write LCF and GCF. Now look at the guys. In GCF for the first class, what is your GCF? Total frequency. In LCF for the last class, what is your LCF? Total frequency. If you look at LCF, it will be in ascending order, it will be in increasing order. If you look at GCF, it is in decreasing order. Try to understand. In the construction of LCF, we will use upper boundaries. In the construction of GCF, we will use lower boundaries. That's what you need to understand, guys. So, this is all about LCFs and GCFs, guys. Next thing is about frequency, relative frequency. So what is the formula for relative frequency? Relative frequency is nothing but class frequency by total frequency, guys. What is relative frequency? Class frequency by total frequency. So guys, it means it is expressed as a part of total frequency, and remember there should be at least two classes. In a classification, there should not be only one class, there should be at least two classes. Means if one frequency is 99 and the other frequency is 1, so total frequency is 100, no? What is class frequency by total frequency for the first class? 0.99. And what is class frequency by total frequency for the second class? 0.01. So means the relative frequency will never be equal to 1 or will ever be equal to 0, because if a class frequency is 0, that class will be completely eliminated from the classification. You should not keep a class whose frequency is 0. Try to understand. So means frequency value should be at least 1. Then only such kind of frequencies or such kind of classes are presented there. So now I am going to present a class with frequency at least 1, means at most 999, 9999 if my total is 1000. If my total is 200, least frequency is 1, highest frequency is 199. Try to understand that. So means relative frequency can't be 0 or can't be 1. It should be lies between 0 and 1. Guys, try to understand 0 and 1 are not at all included. Now what is the formula for percentage frequency? The name itself is saying I am percentage. Relative frequency expressed in terms of percentage means class frequency by total frequency into 100 is called as percentage frequency. What is the frequency density? Frequency density is the ratio between class frequency and class length. What it is? It is the ratio between class frequency and class length, guys. And that is what about theory under discussion, guys. Here you must be aware of what is GCF, what is LCF, what is an open-ended classes, everything that you must be aware of, guys. Otherwise, you can't be in such a position to solve MCQs, guys. Now, guys, I have taken many MCQs from each and every model here, guys. Let me show you the first MCQ that I have taken here is MCQ number 3. So, guys, here also, I just wish to go through option elimination or verification technique. In most of the cases, I'll prefer that one only. Let's have a look at the first question. The following data relates to the marks of how many students, guys? 48 students in statistics. So what is it I need to do? These are the marks of 48 students. What are the frequency densities for the class intervals 30 to 39, 40 to 49 and 50 to 59? Guys, here we don't have any option called none. Now I have to calculate frequency density of the class interval 30 to 39, 40 to 49. If you observe this, it is inclusive series. You said that totally how many students are there? 48. What is the formula for frequency density? Class frequency by class length. What is the class length of first class? 30 to 39. Guys, try to understand. It's an inclusive series. You can't directly calculate the class length. You have to convert them into exclusive series, means it will be 29.5 and this will be 39.5. Difference between 39.5 and 29.5 is how much? 10. So class length is 10. Now my target is to calculate the class frequency, as I need frequency density. The formula for frequency density is class frequency by class length. Now I am looking into 30 to 39, which is an inclusive series, means I can take 30, I can take 39. So 38, 1, 39, 36, 36, all the numbers in the range 30. This one, this one, this one, this one. Yeah. How many numbers are there in the range 38, 30 to 39? 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 9. 9 by 10 is how much? 0.9, and that is there in option D. I don't want to calculate everything. I don't want to calculate everything. Try to understand that, guys. It's a frequency density. Yes, I need to calculate the class frequency by total frequency for all of them, but I don't do that. I'll simply go through. So, solving one part. Based upon that, I can complete the correct answer. Now, have a look at MCQ number 6, guys. For the non-overlapping classes 0 to 19 and 20 to 29 and 40 to 59, the class mark for the class 0 to 19. So guys, class mark is a other name for mid value, and the formula for mid value is UCB plus LCB by 2 or UCL plus LCL by 2. I can use both, guys. UCL plus LCL by 2 means 19 plus 0 by 2. What is 19 plus 0 by 2, guys? Tell me how much? 9.5, and the correct option is option C. Now look at the next MCQ. The midpoints of the classes are 8, 12, 16, 20, 24. Then the class limits. Guys, here how many midpoints are given to you? 5. So how many class limits also to be provided? 5, but he has provided only 1. It means I have to write the class limit of one of these mid values. I don't know who is that. Then first rule I need to apply here is I must calculate the class length. Class length is nothing but the difference between two mid values also. Look at them. What is the difference between 12 and 8? 4. 16 and 12? 4. And 16 and 20? 4. 24 and 20 also? 4. Means class length should be 4. If you look at option C, what is the class length? 8. Means this fellow went out of my discussion. Now guys, please calculate the mid value of the class 16 and 20. 16 plus 20 by 2, it is 18, and 18 is not there in any of our midpoints. So this is a wrong answer. Now, could you please calculate 20, 24 mid value? 20 plus 24 by 2, which is 22, that is also not there. Then who should be the correct answer? Definitely 22 to 26. If you want to calculate 22 plus 26 by 2, how much is that? Yes, absolutely it is 24, and that is a correct answer. That's how you can solve this question, guys. Now have a look at MCQ number 8. Let L be the lower class boundary of a class in a frequency distribution and M be the midpoint of a class. Which one of them is the higher class boundary, means upper class boundary? Guys, tell me the formula for mid value. Upper class boundary plus lower class boundary by 2. Of course, he has given you lower class boundary. What is your lower class boundary? Tell me. Your lower class boundary is L. Then tell me what is UCB equal to? 2M minus L. Am I correct? Yes. 2M equals to UCB plus L. It's not small l, guys. It should be capital L. So what is UCB equals to? 2M minus capital L. And that 2M minus capital L is there in option C. Got it, guys? Now have a look at 9th question. 9th question is for a data frequency, for a data on frequency distribution of weights. If we assume, guys, don't read the data, it is just time waste. Forget about the data, try to understand what is the question. You are able to understand the question perfectly if you don't read out those values. So forget about reading those values. Those values we can read at the time of solving MCQ. But if you want to understand the question in a better way, forget about reading the values. For a data on frequency distribution of weights, this is the data. If we assume that the class length is 5, then the number of class intervals equals to. Guys, I gave you a formula for number of class intervals. Number of class intervals is equals to range by class length. Range by what? Class length. Range means higher value minus lower value, right? What is your higher value in your classification? 73 that I can see. What is your lower value? Till now, I've seen 44, guys. I think so. Yes. Range means 73 minus 44. What is 73 minus 44? 29. And the class length is 5. What is 29 by 5? 5.8. I have already told you. If it is 5.8 or 5.9, even if it is 5.1, you have to take the answer as 6. Now let's have a look at MCQ number 10. In a graphical representation of data, the largest value is 45 and the smallest value is 25. If largest is 45 and smallest is 25, tell me the range. is 20. If the classes desired are 4, means number of classes is equals to 4. What is the formula for number of classes, guys? Range. Range means 20 by class length. Guys, tell me what is your class length then? 20 by 4. You need not even read out the full MCQ. You must understand what do you need. He has given you range, means he has given you terms that are needed to calculate range, and has given you the number of classes, means you can calculate only class in number of class in class length. What is the formula for class interval? The class length, range by number of classes, right? 20 by 4. What is 20 by 4? 5, no. Got it? So that's what about MCQ number 10, guys. Now the next MCQ that I wish to explain you is MCQ number 14. Let me show you MCQ number 14. Calculate the frequency of the class 20 to 30 in the following data. It is such a small question, though it seems to be big. Tell me the frequency of 20 to 30. Guys, look at the question. Try to understand. Yeah, there you need to draw a line segment. Guys, look at this. Starting off with 0. Let me write 10, 20, 30, 40, 50. Now I need to calculate the frequency of 20 to 30. For that, see, look at this, guys. I am writing the number of observations from 0 to 30. Or let me write it clearly, more clearly. It is simply a graphical representation, guys. You need not go for that GCF, LCF calculations, guys. It's such a simple task. I'll show you a very simple method with the help of graph. This, let it be 0, least value, highest value 50. Next 10, 20, 30, 40. So guys, I need 20 to 30. Let me know how many observations are there between 0 and 30. Look at your textbook. How many observations are there between 0 and 30? 28 means this length is 28. Now I want to know how many observations are there between 0 and 20. Look at your data and confirm how many observations are there between 0 and 20. 13. Guys, it means this entire line have 28 observations. Out of this part is 13. If this is 13 and the total is 28, what is this part? Yes, simply 28 minus 13. Tell me what is 28 minus 13? It's 15. So the number of observations between 20 and 30 are how many? 15. See how simple it is. So try to understand the meaning of the question, guys, and try to solve it. Now the next question that I wish to solve is MCQ number 16, which is similar to 14 question, guys. Salaries of the employees working under ABC Limited as follows. Below 10. 28 employees below 10,000, below 20,000, 34 employees below 50,000, 65 below 100,000, 84 employees below 1,000, 123 employees. Find the number of employees with salaries more than 50K. Before that, guys, I must tell you one thing. Below, less than 10, less than 20, less than 50, it means LCF or GCF? LCF. In LCF, last value is your total frequency. It means totally how many employees are working there? 123 employees. Now what is it you need to calculate? Number of employees with salary more than 50,000. So guys, I need to calculate the number of employees with more than 50,000. For that, I can't calculate more than. For that, I'm writing the opposite word. In sets of your mathematics, you might learn this one, guys. Writing opposite word. N of A complement equals to N of mu minus N of A. That's what you used to write. Here, N of mu means total. Totally, how many employees are working there? That you need to write. Minus, what is the opposite word of greater than 50,000? Yes, less than 50,000. Tell me, less than 50,000. Totally, how many employees are there according to you? 123. Tell me number of employees who are getting less than 50,000 salary, below 50,000. Yes, 65 members. So now you can tell me the answer. 123 minus 65. What's your answer? Your answer is 58. And that is available with option D. So try to understand this, guys. So it's not about converting everything, guys. It's all about using your mathematics at some extent, guys. Not to the full extent. At some extent, if you use your mathematics, it will be very easy. Now look at MCQ number 17. Find the number of observations between 250 and 300. More than 256 members. More than 250, 38 members. more than 300, 15 members, more than 350, 0 members. So what is the range? 200 to 350. Let me draw a line. 200 to 350. So 200, 250, 300, 350. It is said that more than 300 there is nobody. More than 350 there is nobody. So this is where I need to end. So guys, more than 200, how many members are there? 56. More than 250, 38. Means from 250 to till 350, how many people are there? 38. Now tell me guys, more than 300, how many members are there? 15. Means from 300 to 350, 15 people. Guys, the line ranging from 250 to 350 carries 38 observations. Out of 38, first part is 15. What is the next part? Absolutely. How many? 23. Just 38 minus 15. And the answer is 23. That's how you can calculate the number of observations between 250 and 300. And that is what about statistical description of data part 1, guys. Here you must know what is an inclusive series, what is an exclusive series, and what are all the basics of this concept is covered under here, guys. And try to understand. This is such an easy topic, which is very easy for maths people non-maths people in particular, I can say, as it is completely a theoretical concept. You must be aware of what is there, what are limits, what are boundaries. If you know them, if you know these simple things, this topic will be an easy concept, guys. So let's get into the next concept, guys. The next concept is measures of central tendency. So guys, here we have divided our material into 4 segments, which are measures of central tendency part 1, part 2, of course part 3, measures of dispersion part 1, measures of dispersion part 2. As you all know, central tendency and dispersion are together. We'll get 12 to 16 marks, guys. Means it is such a huge concept. If you are able to prepare central tendency and dispersion together, you are able to complete more than 35% of your preparation. Got it? This is such an important topic and such an easy concept. You need not a full basic mathematics rules even. So means this is a very simple concept. You don't need much knowledge about from previously, or everyone is learning this in a new way only, guys. But the thing is, you must understand the basics of your statistics, which means what is a data, what is an individual series, what it is the discrete series. So that's what you must learn before getting into this concept. That's why we have discussed statistical description of data part 1 already. Try to understand. So if you are able to understand those things, then only you are in such a position to understand what are the formulas that are covered here. Otherwise, you can't do that, guys. That is why learn statistical description of data part 1 and then get into central tendency part 1. In central tendency part 1, we are going to cover mean, median, and of course all the positional measures. So guys, I'll tell you some questions that are related to, so I'll tell you some theory part that is related to these things first, and then I'll get into problematic part. Again, I'll come to the theory part, which completes measures of central tendency part 1. So first of all, I'll tell you introduction to central tendency, and then I'll tell you the formulas that are related to these things, and then I'll explain MCQs, and then I'll go to theory part. So guys, the usual preparation time for this measures of central tendency or dispersion put together is at least 20 hours, guys. Try to understand. This is such a huge concept because it covers more than 35% of your weightage. So try to understand. You have to spend huge amount of time. But we are going to complete this video, which is measures of central tendency part 1, part 2, and dispersion part 2 and part 2 put together in less than 6 hours of time, guys, with many shortcuts, of course, many ways of solving MCQs along with theory concepts, guys. So now let's go to the concept, guys. What is here? What is the heading of this concept? Measures means you have to calculate something of what? Central tendency. Guess tendency. Tendency means going towards which value? Central value means if you look at a group of observations, if you focus on a group of observations, means if you focus on a data, most of the values has concentration at the middle and less values has concentration at the edges. That's what they're trying to convey. Most of the values are concentrated at central part. For example, guys, when it comes to a class, let us assume that we are having a class of 250 members. In these 250 members, I can't expect all the 250 members to be great performers, means those who are getting 96 or 97%, right? And I can't even expect huge number of students who are below 40%, right? Most of the students are average students, right? Means the concentration of percentage is high, or the frequency of a percentage is high at the middle. 60 to 70% students are high, means if I write 40% students and 95% students on 60 to 70% students. So frequency is high. Class interval, here I am writing marks on x-axis and frequency, number of students on y-axis. 40% students are low and 95% students are even low. But majority of the students are 60 to 70%, means my marks are concentrated towards a central value. That central value is measured here, and that is why we named this topic as measures of central tendency. Means all the values are tending towards a central value. That central value in statistics is called as average. How do you call it as, guys? Average. Got it? So average is a single observation. Average is a single observation which represents the huge data. So there are certain cases in which we can't remember all the data, no? In such a case, we'll just simply calculate the average of a class and we'll say that this class average is 70%. And that class average is 80%. This class average is 60 to 65%. Means a huge amount of data can be recalled with a single observation. And that single observation in statistics is called as an average. So here in this topic called measures of central tendency, we are going to calculate that average. That is why we named this topic as measures of central tendency. We are going to calculate the average. Average means all the values are tending towards a central value. We are going to calculate that average. That's why we named this topic as measures of central tendency. So what are the measures of different measures of central tendency? So there are three methods of measures of central tendency, guys. The first one is mean. The next one, median, and the next one, mode. Of course, at the middle we have positional measures also, but mostly we can say three measures: mean, median, mode. So guys, mean is of two types: arithmetic mean, geometric mean, harmonic mean. Okay, now median, mode. Along with median, there are certain positional averages also, guys. So in this concept, the central tendency is completely about these things: mean, which means arithmetic mean, geometric mean, harmonic mean, median, mode. In general, we'll say that there are three measures of central tendency. One is mean and the other one is median. The next one is mode. Now let's get into the concept called mean. So guys, people used to call this one as arithmetic mean or mean. Some people call it as average also. To a layman or a common human being, it is average. But for us, being being the persons who are a bit aware of statistics, you should call it as arithmetic mean. So mean or arithmetic mean, which is denoted by x bar. For a set of observations, let me repeat, for a set of observations, arithmetic mean is given by, for a set of observations, x1, x2, x3 and so on, xn. Means what kind of series it is, guys? Individual series. Try to understand. For a set of observations, arithmetic mean is given by sum of observations by number of observations. So how many observations are here, guys? N observations. So I must say x bar equal to summation x by n. The summation is varying between 1 to n. So you can write x bar equal to summation x by n. Now you can tell me what is the formula for summation x? Yes, n into x bar. This is another important formula. Sum of observations is equals to total number of observation into average. So this is for a individual series. Now, when it comes to discrete frequency distribution or simple frequency distribution, there will be given with x1, x2 and so on, no? So guys, let me assume that x1 is repeated for f1 times and x2 is repeated for f2 times, x3 is repeated for f3 times and xn is repeated for fn times. Now guys, try to understand. We'll assume the total frequency as n. It means n equal to summation f. Total frequency means total number of observations. Now you guys told me that arithmetic mean equal to sum of observations by number of observations, and the number of observations are n because it is summation f. Now sum means, guys, true. Look at this. x1 is repeated for how many times? f1 times. It means you have to add x1 for how many times? f1 times. If you add x1 for 2 times, you will get 2x1, no? Like that, if you add x1 for 3 times, 3x1. Like that, if you add x1 for f1 times, you will get f1x1, like that. The sum of next one, f2x2, like that. What else I need to write? And so on, fn xn. This is the formula, which we'll write it as x bar equals to summation fx by capital N or summation wx by capital N. Summation wx by capital N means which is summation w. Sometimes they'll call it as weights, sometimes they'll call it as frequencies. Now when it comes to continuous frequency distribution also, we'll use the same formula, but there in continuous distribution, this x represents mid value of a class interval. What is this x represents? Mid value of a class interval. So this is what about formula for arithmetic mean. Now guys, let me tell you one thing. So I have a group of boys with me and I have a group of girls with me in my class. So I know the count of boys and I know the average of boys, and I know the count of girls and I know the average of girls. Now I wanted to know the class average, which is obtained by combining the averages of boys as well as girls, right? So how do you calculate the class average? So there is a formula for combined average, guys. The formula for combined average x bar 1 2 equals to n1 x1 bar plus n2 x2 bar by n1 plus n2, which is the formula for combined arithmetic mean. Suppose if I am having a three groups in my locality, so x bar 1 2 3 equals to n1 x1 bar plus n2 x2 bar plus n3 x3 bar by n1 plus n2 plus n3. Got it? Now guys, sometimes by mistake, let me assume that one of the observation is 54. Due to a calculation mistake, I have entered 45. Means I'll get the correct mean or wrong mean? Wrong mean, no. How to correct that mean? Means if some observation is misreaded and miswritten, in such a case, there is a formula to calculate the corrected arithmetic mean. The formula for corrected arithmetic mean is wrong arithmetic mean, means arithmetic mean that is obtained by using wrong value, plus C minus W by N. C means correct observation, W means wrong observation. Wrong observation means which was placed and calculated. C correct observation means which is to be placed. Got it, guys? So x bar corrected equals to x bar wrong plus C minus W by N. So suppose guys, by mistake you took 2 observations in a wrong way. Then you have to write C1 plus C2 and you have to write minus W1 minus W2 by N. So if you have 3 observations that you took by mistake, C1 plus C2 plus C3 minus W1 minus W2 minus W3 by N. So means whatever the number of observations that you misread, you can write it there and replace them with the correct values. Means correct values must be added, wrong values must be subtracted. That's what we are doing, no? Yes, that is what the formula for corrected mean. The formula for corrected mean equals to x bar wrong plus C minus W by N. Now guys, coming into very important concept. So guys, my series of observations are x1, x2 and so on, xn, no? If for all these observations, if I add a fixed constant, means let me assume that the series is x. To all the observations, I have added k plus k plus k. This addition or subtraction of a constant to all the terms is called as change of origin. How do you call it as? Change of origin. Means y equal to, there's a new series which is y equal to x plus k. So before getting started, I must tell you, arithmetic mean of a constant is constant. What is the arithmetic mean of a constant? Constant. Then what is y bar equal to? X bar plus k, because k bar constant arithmetic mean is k itself. Means arithmetic mean is affected due to change of origin. If an observation k, if a fixed constant k is added to all the terms of the series, then to the arithmetic mean also you have to add the constant, like that. If I subtract k from all the values in the series, that is also called as change of origin. In such a case, my formula will be x bar minus k, like that. To all the members of my series, if I multiply a fixed constant kx1, kx2, kx3, like that, multiplication with a fixed constant to all the observations is called as change of scale. How do you call it as? Change of scale. So guys, remember, arithmetic mean is affected due to change of scale also. Means if y equals to kx, what is y bar, guys? Kx bar. Got it? Because arithmetic mean of a constant is constant itself. No. So guys, try to understand. If y equal to x by k, even not only a multiplication, division also affects, guys. So what is y bar equals to? X bar by k, because k bar equal to k. So arithmetic mean is affected due to both change of origin and scale. It means if you have an equation like y equal to ax plus b, then what is y bar equals to? A is a constant, constant arithmetic mean is itself x bar, plus b is a constant whose mean is b itself. So if y equals to ax plus b, then y bar equals to ax bar plus b. So, or else, if I gave you like this, ax plus by plus c equal to 0, guys, do not afraid of all these things. Just keep a bar to variables. Means you can write ax bar plus by bar plus c equal to 0, as a bar is a, b bar is b, c bar is c. We are writing constants as it is, as the arithmetic mean of a constant is constant itself. So, arithmetic mean is affected due to both change of origin and scale. Now, guys, whenever you come across observations having huge amounts, let it be 10,000, 20,000, like that, are there, you can use a method called deviation method. Means subtract a constant from all the observations of the data. It means, is it change of origin? Yes, then what is d bar equal to? X bar minus a, as a is a constant. Here a is called as assumed mean. How do you call it as this? Assumed mean. So d bar equal to x bar minus a. Then what is x bar equals to? A plus d bar. What is the formula for d bar? Summation d by n. How do you call it as? Summation d by n. And a is known as assumed mean method. This is the formula for assumed mean method. So suppose there's a chance of subtraction and division. Means if you are talking about continuous series, you will write this way: d equal to x minus a by c, where a equal to assumed mean and c is the class length of the class intervals, provided all the classes are of equal width. Okay, c is the class length. C is what? Class length. Then what is d bar, everybody? Tell me. X bar minus a by c. Could you please tell me the formula for x bar? X bar equals to d bar into c plus a. So, they are writing the formula as x bar equals to a plus summation fd, because you are talking about continuous series, no? Fd by summation f into c, where c is the class length and a is the assumed mean. This is called as deviation and step deviation method, guys. So guys, I don't recommend this method because you are not multiplying the values or you are not dividing the values. Your calculator is doing that. Even if that is a huge value, also go through your regular method. Don't go through deviation and step deviation method. Whatever the method that you follow, you'll get the same answer, guys. Then what is your use of wasting your time? You must be aware of these formulas. That's why I gave you these formulas, guys. Now let's get into the MCQs part that is related to central tendency arithmetic mean concept, guys. So let me show you the first MCQ that I have taken here. So I wish to solve MCQ number 4 here, guys. Look at MCQ number 4. So guys, look at this. Use your calculator to the full extent. Mean of 7, 9, 12, x, 4, 11, 5 is 9. Find the missing observation. Before getting started, guys, tell me how many observations are here? Yeah, tell me. 1, 2, 3, 4, 5, 6, 7. So what is the formula for mean? Sum of observations by number of observations. Number of observations are 7. What is the sum of observations? 7 plus 9 plus 12 plus x plus 4 plus 11 plus 5. Do one thing. Do the sum. 7, 9, 12, 4, 11, 5. Forget about x. So you got 48 plus x. Sum of observations by number of observations equal to mean, and that is equal to 9. So what is 9 into 7, guys? 63. 63 minus 48 is 15. So x value is going to be 15. See how easy it is. You don't need to write the formula, or you don't need to write multiple terms, guys. Try to understand. Now the next question that I wish to explain here is MCQ number 6. So look at this question. Just now we discussed about deviation method. No. So guys, you need not worry. It is such an easy task. D equal, for an individual series, we assumed mean A equal to 25, A equal to 25, and summation D equal to minus 21. For D equal to x minus A, N equal to 7, then the mean of the series. Guys, it's such a simple task. D equal to x minus A, no? What is D bar equal to? X bar minus A. Tell me the formula for D bar. Just tell me the formula for D bar. Summation D by N equal to X bar minus what is your assumed mean? 25. Now it's time to use your calculators. Try to understand. So guys, what is summation D minus 21? Enter minus 21. Just enter 21 plus or minus symbol. So guys, I'll show you. Just enter 21 in your calculator. This is 21, no? Now just enter this plus or minus symbol. You'll definitely get minus 21. By n, what is n? 7. By 7, how much? Minus 3. This value is minus 3. If this minus 25 comes to the left side, it will be plus 25. So what's your answer? 22. And that is there in option D. So guys, you need not worry about deviation method or step deviation method. It is all about understanding what is given to you. Now look at the next MCQ, guys. MCQ number 11. So guys, this is a formula question. I intentionally took this MCQ, the mean of first 10 natural numbers. Guys, listen to me. If the observations are in AP, if the observations are in arithmetic progression, then the formula for arithmetic mean is first term plus last term by 2. The mean of first 10 natural numbers means mean of 1, 2, 3 and so on n. So are they in AP? Yes. If they are in AP, what is the formula for arithmetic mean? First term plus last term by 2. And that is how much according to him? 10.5. Now take your calculator. 10.5 into 2. 21. Am I correct? 10.5 into 2, 21 minus 1. How much? 20. And that is there in option B. So guys, try to understand. If the observations are in AP, then the formula for arithmetic mean is first term plus last term by 2. Now have a look at MCQ number 14. Find the average of first 25 multiples of 5. Guys, try to understand. First 25 multiples of 5. What is the first multiple of 5, all of you? 5 into 1. What is the second multiple of 5? 5 into 2. Like that, I need to write how many multiples of 5? 25 multiples of 5, which is 5 into 25. Guys, are they in AP or not? Yes, if you are talking about multiples of 5, multiples of 6, everybody is in AP, no? If they are in AP, what is the formula for arithmetic mean? First term plus last term by 2. Take your calculator. Calculate what is 5 into 25. It is 125 plus 5. And then by 2. Your answer is 65. And that is there with option A. So guys, try to understand. It is such an easy question. If you follow these simple methods, calculations are quite easier, guys. Try to understand that. So here we have learned a trick in which if the observations are in AP, arithmetic mean is equals to first term plus last term by 2. So if the observations are in AP, what is the formula for arithmetic mean, guys? First term plus last term by 2. Got it? So let's see the next MCQ, guys. Next MCQ is MCQ number 16. The mean of 20 items of a data is 5. Let me assume that there are 20 observations in a series. That too, I'm considering the name of the series as X is a variable. There are how many values in that series? 20 observations. And the mean of all those 20 observations, let me write the X bar equals to 5. How many observations are there in the X series? 20. Next, let's have a look at the continuation line. If each item is multiplied by 3, means all the elements of X series is multiplied by 3, which is called as change of scale. Multiplication or division with a fixed constant is called as change of scale. So we are multiplying all the values of X series with 3, and I'm writing it as a new series which is y equal to 3x. Means what is y1? 3x1. What is y2? 3x2. That's what has given you. Then the new mean will be. Guys, there's a simple shortcut for this question. As you all know that arithmetic mean or measures of central tendency are affected due to origin and scale. If I write y equals to 5x and the arithmetic mean of, sorry guys, y equals to 3x, because every item of the series is multiplied by 3. Arithmetic mean is affected due to both origin and scale. So I must write y bar equals to 3 into x bar. As you all know, arithmetic mean of a constant is constant. And what is x bar? It is 5, no. So your answer will be 3 into 5, and that is equals to 15, and which is available with option C. Got it? The correct option is option C. Now let's have a look at the next MCQ, guys. The next MCQ is MCQ number 22. Let me show you MCQ number 22, guys. So what is MCQ number 22? Let the mean of x is 50 and the mean of u is equals to 10 plus x is what? So guys, it is said that u equals to 10 plus 5x. So the relation between u and x is u equals to 10 plus 5x. If you observe this, 10 plus means 10 is change of origin. 5x, 5 is change of scale. As you all know, measures of central tendency is affected due to both origin and scale. You must write u bar equals to 10 bar means 10, 5 bar means 5 into x bar. So 10 plus 5x bar and 10 plus 5 into x bar. Take your calculator. What is x bar equals to? Mean of x is 50. Take your calculator. X bar equals to 50. 5 into 50, 250 plus 10. Together it is 260, and that is there in option B. Have a look at option B, guys. So yes, it is option B. Now let's have a look at MCQ number 25, all of you. So this is such a simple question. So guys, try to understand the concepts of corrected arithmetic mean and combined arithmetic mean. Then you are in such a position to answer all these kind of miscellaneous questions related to arithmetic mean very easily. So look at the question. The average weight of 8 persons means there are 8 people. The average weight of 8 persons increases by 1.8 kg. If a person weighing 65 kg is replaced by a new person, means there's a fellow whose weight is 65 kg. I wanted to place, or I wanted to replace this person weight with someone else's weight. Means I just wanted to subtract this weight and I just wanted to add someone else's weight. Means you are eliminating one person and then you are adding other person. Means the concept of corrected mean you can write. No. Yes. What would be the weight of new person? That's what he is asking for. Now guys, let me tell you the concept behind this question. So guys, there are certain number of people whose weight is x bar. Let me assume that the weight of these people, yes, 8 people are there, no? Weight of these people is x bar. How many people? 8 persons. 8 persons weight is x bar. So there is one person weight as 65. You want to replace the 65 kgs weight with someone else's weight. Means you want to subtract this weight and you want to add new weight. And there will be how many persons at the new case also? 8 persons only. So by subtracting that person and by adding that person, other person's weight, the average weight increases by how many kgs? 1.5. Means new average will be x bar plus 1.5. Let's try to understand. X bar plus 1.5 is the corrected arithmetic mean. X bar is the old arithmetic mean which will be considered as the wrong mean. Now let me write down the formula for corrected arithmetic mean. X bar corrected is equals to X bar wrong plus C minus W by N. So what is X bar corrected? X bar plus 1.5 equals to X bar wrong, which is X bar plus correct observation I don't know, but I am eliminating a person whose weight is 65 by N is 8. So who are going to be directly cancelled here, guys? X bar, X bar. Now take your calculator. Tell me what is 8 into 1.5. 8 into 1.5 is how much? 12. If this minus 65 comes to the left side, it will be plus 65. Put together it is C equal to 77. Means we are adding a new person whose weight was going to be 77 kgs, and that is there in option C. Let's have a look at it. Yes, option C. So that's all about MCQ number 25, guys. Now let me show you the next MCQ. The next MCQ that I picked here is MCQ number 32, guys. Let me show you what is MCQ number 32. Yeah. Read out the MCQ. If the average mark for a group of 30 girls is 80 and a group of boys is 70, means I don't know the count of boys, but the average of boys is 70. And the combined average, I have already told you, the combined average means it's a class average, is how much? 76. Then how many are there in the boys group? How many boys are there in this group? That's what he's talking. So guys, either you can go through option verification or regular solution to this question, guys. So I'll recommend the regular solution only because it is an easier version. So if you use your calculator, this will be very easy, guys. Before that, so tell me how many girls are there? 30 girls. With their average is how much? 80. 80 is the average. And I don't know the number of boys. Let me assume that there are N2 boys with their average is 70. And the combined average is denoted by X bar 1, 2, which is equals to 76, as the class average is 76. Now let me write down the formula for combined average. N1 X1 bar plus N2 X2 bar by N1 plus N2 equals to 76. Got it, guys? So let me go for substitution. N1 is how much? 30. X1 bar 80. So please do calculate 30 into 80. Tell me how much? 2400 plus N2, I don't know, into X2 bar means 70 by N1 plus N2 equals to 76. I don't know also N2, but I know what is N1. What is N1, all of you? N1 is 30. Okay, let me bring this 30 to the right side. So 2400 plus 70 N2 equals to 76 into 30. Let me calculate 76 into 30. 2280 plus 76 N2. Let's try to understand. If you bring this 2280 to the left side, it will be 2400 minus 2280, which is 120. 120 equals to 76 N2 minus 70 N2 means 6 N2. 6 N2 equals to 120 and N2 will be equals to 20. N2 is equals to what, guys? 20, and that is there in option B. You can simply go through this, or else if you want to go for verification, N1 X1 bar, let me assume that this is N2. N2 X2 bar by N1 plus N2 means totally 51 people. The average should be 76. Or else 30 into 80M plus, if option B is correct, so 20 into 70M plus MRC. N1 X1 bar plus N2 X2 bar is over. By N1 plus N2 means 30 plus 20, 50. So take your calculator, I'll show you the calculation process. There are 30 girls, no? 30 into 80 means we are doing N1 X1 bar M plus. Okay, next N2 according to option B 20 into X2 bar. Boys average is how much? 70. M plus N1 X1 bar plus N2 X2 bar is over. MRC means N1 plus N2, N1 X1 bar plus N2 X2 bar is over. By N1 plus N2. What is N1 plus N2? 30 plus 20. It is going to be 50, which is going to be 76. So option verification is done. No, it's completely up to you, guys. If you want to go through option verification, you can, or else simply go through your regular solution. Regular solution is also comfortable. Okay, the next MCQ that I have picked here is MCQ number 42, guys. Let me show you the question. Calculate the arithmetic mean of following data. Guys, look at the question. So marks and number of students. Number of students is always considered as frequency. So marks is considered as X. So we have to calculate the arithmetic mean of marks of the students in this group. So for that we need to use a formula, as it is a discrete series. Formula for discrete series is summation of x by capital N. Capital N means sum of all frequencies. Please do calculate the sum of all frequencies. What is the sum of 6, 12, 18, 15, 9? It is totally 60. Means capital N is equals to 60. Now summation of x means, guys, take your calculator. I'll tell you the calculation process. 4 into 6 m plus. 4 into 6 m plus. Before getting started, erase your calculator's memory, guys. Next 8 into 12 m plus. Next 12 into 18 m plus. Next 16 into 15 m plus. Next 20 into 9 m plus MRC. I'll show you my MRC answer, which is 756. So 756 by 60. What is 756 by 60, guys? So this is my answer, 12.6. 12.6 is the arithmetic mean which is there in option C. So that's what about MCQ number 42, guys. Now let's have a look at the next MCQ, which is MCQ number 48. So let us read out the question. What is 48? So compute x bar for the following series. So what is a series? So income 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70. Number of persons 4, 7, 16, 20, 15, 18. So we have to calculate the average income of the group of people, because number of persons always represents frequency. This is a class interval, no? So guys, for a continuous series, it's a continuous series, no? The formula for arithmetic mean is summation fx by capital N. Madam, what is f? F is a frequency. What is capital N? So capital N means sum of all the frequencies. No, please do calculate what is capital N. 4 plus 7 plus 16 plus 20 plus 15 plus 8. Is it 70? Yes, it is 74 plus 7 plus 16 plus 20 plus 15 plus 8, and the answer is 70. So x means what? X is the mid value of a class interval. What is the mid value of 10 and 20? Just do 10 plus 20 by 2. How much? 15. Now, what is the class length? Class length is equal or unequal? Equal. If the class length is equal, just add the class length to 15, then you will get the next mid value. So 15 plus 10, 25. Next, 35. Next, 45. Next, 55. Next, 65. Guys, try to understand. You need not calculate mid values to all the classes if the class interval is equal. So just calculate the mid value of the first class and then add the class interval to all the coming classes. Then you will get the mid value. So now we are done. This is x value, this is f value, and the formula for x bar is summation of x by n. As you all know that n is 70, keep n is here, and I'll tell you the calculation process. Before that, clear your calculator's memory. 15 into 4m plus, 25 into 7m plus, next 35 into 16m plus, next 45 into 20m plus, next 55 into 15m plus, next 65 into 8m plus. MRC. I got 3040 divided by 70, no? 3040 divided by 70 is 43.42. This is 3040. See how simple it is. Though it is a lengthy question, though it seems to be a lengthy question, it is not, guys, because just a normal calculation, that too, in particular, you just need to use your calculator. That's it, guys. Now let's have a look at the next MCQ. The next MCQ that I have taken here is MCQ number 53. So we are done with mean, guys. Now let's get into the median concept. The median value of the set of observations 48, 36, 72, 87, 19, 66, 56, 91. So what is a median? First of all, let me tell you the meaning of median. So what is a median? Median is nothing but the middlemost value. Median is the middlemost value. What is a median? Let me tell you the meaning of median first. So median is a middlemost value after the values have been arranged in either ascending or descending order. Median is the middlemost value, guys. What is a middlemost value? Median is the middlemost value after arranging the observations in which order? Either ascending or descending order. In general, we'll prefer ascending order, guys. So let me write down the definition of median. Median is the observation which lies at the middlemost place after arranging the observations in ascending or descending order. In particular, I'll say that if you are dealing with an individual series, median is nothing but n plus 1 by 2th term. What is median formula? N plus 1 by 2th term if n is odd. Means if n is odd, there is only one middlemost observation. That is your median. If n is even, the average of n by 2th and n by 2 plus 1th term is your median. So, if there are, for example, if whenever n is odd, I'll tell you a very simple example, guys, so that you will be in such a position to understand the definition of median. Median is the middlemost value after the values have been arranged in either ascending or descending order. Now, let's have a look at MCQ number 53. What are your observations? 48, 36, 72, 87, 19, 66, 56, 91. Tell me how many observations are there? Tell me, guys. 8 observations are there. First of all, I need to arrange them in either ascending order or descending order. Guys, I'm completely going for ascending order. My least observation that I can see is 19. Then next 36. Let me write down the observations in the order. My next first observation is 19 and then 36 and then 48 I can see. Next 56, next 66. 48, 56, 66, next 72, 87, 91. 72, 87, 91. Guys, we have arranged the observations in ascending order. Now tell me, guys, how many observations are here? 8 observations. So, sorry guys, here n is even. 8 observations. So, when n is even, what is median? Average of n by 2th. What is n by 2? 4. So, average of 4th and n by 2 plus 1 means 5th. Average of 4th and 5th terms. What is your 4th term? 56. 5th term 66. Can you please tell me what is 56 plus 66 by 2? It is 61. So, median equal to 61. That's how people will give you the definition. But you need not use this definition, guys. Simply look at the data. Guys, in this data, let me complete. In this data, how many middlemost observations are there? 2. Whenever you find one middlemost observation, that is what your median. If you find 2 middlemost observations, just calculate the arithmetic mean of those 2 observations and that will be your median. Got it? Now, in case of discrete series, median is equals to n plus 1 by 2th term. Guys, I'll tell you the meaning of this at the time of teaching MCQs, guys. Till then, just remember the formula n plus 1 by 2th term. And next, in case of continuous series, median is equals to L plus n by 2 minus m by f into c. First of all, you must understand what is a median class. Median class is a class that corresponds to the cumulative frequency. I mean to say, less than cumulative frequency n by 2. Median is a class that corresponds to the cumulative frequency n by 2. Median class is a class which corresponds to the cumulative frequency n by 2. So now L is the lower class boundary of median class. What is L? Lower class boundary of median class. C equal to class interval of median class. F equals to frequency of median class. M equals to cumulative frequency of the class preceding median class. Preceding means previous class, guys. Preceding median class. That's what about continuous series median formula. So, median is also like mean. Median is also affected due to both change of origin and change of scale. Got it, guys? So, median is also affected due to both change of origin and scale. Means if y equals to a plus bx, then median of y equals to a plus b into median of x. A plus b into median of x. So, there's one more property for median, guys. Sum of absolute means modulus. Sum of absolute deviations from median is always minimum, means is always less than sum of the absolute deviations from any other number. This is the mathematical property of median. So, now guys, you know what is a formula for median in case of individual series, discrete series, continuous series, and you know that median is affected due to both origin and scale. So guys, now let me tell you a meaning of this. Median is such an observation which lies at the middlemost place. It means median divides your entire series into how many parts? Yes, 2 equal parts. Got it, guys? Median divides the entire data into how many equal parts? 2 parts. As it is dividing it into 2 equal parts, how many measures are there to divide them into 2 equal parts? 1 measure. So that is median. Okay, now there are certain positional averages here, guys. Yeah, there are certain positional averages here. What are those positional averages? Positional averages are the averages or the measures, positional measures that I can say. Positional measures are the measures that divides the data into a number of equal parts. For example, if you want to divide your data into 4 equal parts, guys, to divide 4 equal parts, how many measures should be there? Each and every vertical line is a measure. Yes, 3 measures. Those 3 measures are called as quartiles. Means quartiles are the measures that divides the data into how many equal parts? 4 equal parts. So how many quartiles will be there? 3 quartiles. What are they? Q1, Q2, Q3. Suppose if I ask you to tell me the formula for first quartile, guys, just use 1 into this quartile divides the data into how many parts? 4. And the numerator n plus 1 should be there. N plus 1 by 4th term if it is discrete series. So if it is individual series, your formula will be n plus 1 by 4th term. If it is continuous series, the formula will be L plus n by 4 minus m by f into c. Yeah, that's what you need to write. Now, if I ask you Q2, guys, if you look at Q2, Q2 is at which place? Second place, no. That's why I'm writing 2 into by 4 as they are dividing into 4 parts, n plus 1 by 4th. So if you look at this, 4 will be cancelled and else we are getting n plus 1 by 2th term. Who is n plus 1 by 2th term? Median. So Q2 is nothing but median. If I ask you to tell me the formula for Q3, the formula is 3 into n plus 1 by 4th term. Like that you can write down the formulas of all the quartiles. Now, next let's talk about deciles. Deciles are the values that divides the data into 10 equal parts. How many equal parts? 10 equal parts. So guys, look at this. How many deciles will be there? How many deciles will be there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. So how many deciles will be there? 9 deciles. So the first decile is denoted by D1, second decile is denoted by D2 and the last decile is denoted by D9. Guys, let me write down the formula for D3. 3 into, deciles divides the data into 10 parts. Numerator is n plus 1 and its term. Okay. Now guys, tell me the formula for D5. D5. 5 into by 10 as they're dividing into 10 parts, n plus 1 the term. Okay. 5 and 10 will be cancelled and again there will be n plus 1 by 2. Who is n plus 1 by 2th term? Median. Yeah. So quartiles are the values that divides the data into 4 equal parts. Deciles are the values that divides the data into 10 equal parts. Now percentiles are the values that divides the data into 100 equal parts. So how many percentiles will be there? 99 percentiles will be there, starting from P1 to P99. Yes, but suppose if I ask you to tell me the formula for P10, you have to write 10 into. So how many parts? 100 parts. Numerator is n plus 1 and its term. That is called as P10. Like that you can write any percentile formula. Now what I am focusing is on P50. Tell me the formula for P50. 50 into n plus 1 by 100th term. So who are going to be cancelled, guys? 100 and 50 and there will be n plus 1 by 2th term. This is n plus 1 by 2th term. And n plus 1 by 2th term will be called as median. So 50th percentile will be also equals to median. So that is what about introduction to median and percentiles. Of course, sorry, all the positional measures, guys. So positional measures are the measures that divides the data into a number of segments or number of equal parts. Okay. So if you want to divide the data into a number of equal parts and you want to calculate those positional measures, you can use all these partition values or positional measures, guys. These are also called as partition values, guys. Now let us get into MCQs part, guys. Now we have already done with 53, no? Now let's have a look at MCQ number 58. So median of a given observations is 9.5. If each observation is multiplied by 2, guys, I've already told you, median is also affected due to both origin and scale. So median of a given set of observations is 9.5, no? So I'm considering the given set of observations with x and denoting them with x. Now median of a given set of observations is how much? Just a moment, guys. 9.5. So let me write median of x equals to 9.5. Now it is said that each observation is multiplied by 2, then the median of new set of observations. So guys, I'm assuming that my y series is like this. Each observation is multiplied by 2, so means it will be like 2 into x. Then can you please tell me the median of y? Median of y equals to 2 into median of x. What is median of x? 9.5. So what is 2 into 9.5? It's 19, and that is there in option B. See how simple it is. Now let's get into the next MCQ. MCQ number 60. So guys, for the frequency distribution except calculate the value of median. So it's a discrete series, guys. I'll tell you how to calculate the median of this series. To calculate the median of this series, first of all, write down x and f. What is x? X is varying between 1, 2, 3, 4, no? So write down x is equals to 1, 2, 3, 4, 5, 6. What are their frequencies? 6, 9, 10, 14, 12, 8. 6, 9, 10, 14, 12, 8. Now, guys, to calculate median, you must calculate less than cumulative frequency. How do you calculate less than cumulative frequency? Add the frequencies from the beginning till the ending. So, the first frequency is 6. 6 plus 9, 15. 15 plus 10, 25. 25 plus 14, 39. 39 plus 12, 51. 51 plus... So guys, is it 18 or 8? Wait a second. It's 8, no? Sorry. 51 plus 8. It is 59. So guys, the last one is total frequency. Means capital N. Your total frequency is 59. Try to understand. Your total frequency is 59. Now I must understand the definition or the formula for median is n plus 1 by 2th term. Take your calculator and tell me what is n plus 1 by 2. N plus 1 by 2 is 60 by 2, which is 30. But your answer is not 30, guys. Your answer is 30th term. Let me tell you the meaning of 30th term, guys. In less than cumulative frequency, identify the cumulative frequency which just exceeds 30. Which just exceeds 30. This one. So, this is the cumulative frequency which just exceeds 30. Madam, shall we take 51? Is 51 just exceeds 30? No, 39 is the number which exceeds 30. Compared to 39 and 51, if you compare 39 and 51, 39 is a number which just exceeds 30, right? So, hey, what is x value here? What is x value here? 4. This is 4. This is your median. Okay, just understand n plus 1 by 2. N plus 1 by 2 value is 30. Identify the cumulative frequency which just exceeds 30. 39 is the number which just exceeds 30, no? Underline that part. What is the value of x there? The value of x there is 4. So, your median is 4. See how simple it is. Now, let's get into the next MCQ, guys. MCQ number 62. This MCQ 62 is for your continuous series practice only, guys. Calculate the median of the following data: 0 to 10, 10 to 30, 30 to 60, 60 to 80, 80 to 90. Guys, the reason for taking this MCQ is there's no restriction that class length is same to calculate the median. Try to understand. 0 to 10 class length 10, 10 to 30 class length 20, 30 to 60 class length 30, 60 to 80 class length 20, 80 to 90 class length 10. So there's no restriction that all the classes are of equal length while calculating median. There's no problem for me also. Try to understand. Now, write down the class interval and frequency, guys, and then I'll tell you how to calculate median. So, 0 to 10. Next, 10 to 30. Next, 30 to 60. Next, 60 to 80. Next, 80 to 90. Now, let me have a look at my frequencies. What are my frequencies? Let me write down my frequencies. 5, 15, 30, 8, 2. 5, 15, 30, 8, 2. So guys, whatever it is, whether it is median or any other positional measure, you must calculate less than cumulative frequency. Means you have to add the frequencies from the beginning to the ending. 5. 5 plus 15, 20. 20 plus 30, 50. 50 plus 8, 58. 58 plus 2, 60. And the last value is n. So what is n, all of you? 60. Guys, please do calculate n by 2. Tell me what is n by 2? 30. Now, the first task of yours is, because you did recently, identify the cumulative frequency which just exceeds 30. Is it 50 or 58 or 60? 50. Yes, underline this. This is called as median class. It means median should lie between 30 and 60. That's what you need to understand. If you look at the options also, all the options are between 30 and 80. 30 and 60? No, option A is not between 30 and 80. Means I can avoid option A because option A is not in the median class range. Median should lie in the middle, median class only. Median should lie at median class only. Our median class is 30 to 60. If you want, I'll prove it now. So, our median class is 30 to 60, no? Look at this. The lower class boundary of median class is L. And the frequency of median class is F. What is the class length of median class? 30 to 60 class length is how much? 30. And the preceding class cumulative frequency is M. Preceding means previous class cumulative frequency is M. Now, let me write down the formula for median. The formula for median is L plus N by 2 minus M by F into C. What is L here? 30. N by 2, 30 minus M, 20 by frequency, 30 into class length, 30. So, everyone is connected to 30, 30, 30, 30, no? So, your answer is 30, 30 will be cancelled. 30 minus 20 is 10, 10 plus 30, 40. What's your median? 40. Is it lies between 30 and 60? Yes, median should always lie in the median class. That's what you need to understand. And your answer is 40, which is there in option C. So now, guys, let's have a look at some of the partition values or positional measures, guys. So I'm taking MCQ number 65 to 66, guys. Let me read out the MCQ. Given that following are the wages of laborers: 82 rupees, 56 rupees, 90 rupees, 50 rupees, 120 rupees, 75 rupees, 75 rupees, 80 rupees, and 130 rupees and 65. So guys, there's no restriction that one of the observation can't be repeated. An observation can be repeated. There are two persons who are getting a wage of 75 rupees, 75 rupees. There's no problem with that. Okay, find Q1 and Q3. So guys, it's an individual series, no? So we'll apply the same method that we applied for median, guys. First of all, you need to arrange the observations in either ascending or descending order. In particular, for all the positional measures, you have to arrange the observations only in ascending order only. Okay, so let me arrange the observations in ascending order. The least observation here is 50, and then 56, and then 65, it seems. Yeah, let me write 50, 56, 65. Next observation, 75, 75, 80. 75, 75, 80. The next observation, 82. 82. Next, 90, 120, 130. 90, 120, 130. Guys, tell me, how many members are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Write n equals to 10. Now, I'll tell you the formula for Q1. Q1 means, write it this way, 1 into, quartiles are the values that divide the data into how many parts? 4 parts. N plus 1 by 4th term. Okay, 1 into n plus 1 by 4th term. Guys, please focus here. What is n? 10. 10 plus 1, 11. 11 by 4. Could you please calculate what is 11 by 4? 2.75. Guys, try to understand. Q1 is not 2.75. Q1 is 2.75 the term. Madam, we are aware of second term, but how do you identify 2.75 term? If you come across 2.75 term, it is second term plus, take the integral part. What is the integral part? 2 plus, what is the decimal part, guys? 0.75 into, write it as third term minus second term. Got it, guys? If it is 4.6, how do you write? Tell me. Fourth term plus 0.6 into fifth term minus fourth term. If it is 8.2, eighth term plus 0.2 into ninth term minus eighth term. That's how you need to write. Now take your calculator. Tell me the difference between third term and second term. 65 minus 56. How much? 9. 9 into 0.75 plus second term. What is your second term? 56. So 0.75 into 9 plus 56 and your answer is 62.75. What's your answer? 62.75. Got it, guys? So that's how you can calculate Q1. Now I want to calculate Q3 as well, no? So guys, tell me how to write down the formula for Q3. Q3 equals to 3 of, got it? 3 of n plus 1 by 4th term. You all know what is n. N is how much? 10. 10 plus 1, 11 by 4 into 3. Could you please calculate 11 by 4 into 3? How much? 8.25 or 8.25th term? 8.25th term. Guys, tell me how to write. So, 8th term plus 0.25 into next. 9th term minus 8th term. Got it, guys? So, tell me who is your 9th term? Sorry, guys. This is your 9th term. 120 is your 9th term, no? 8th term, 90. Tell me the difference between 120 and 90. 30, no? Yes. So, let me write it as this difference is 30. So, 30 into 0.25 plus what is your 8th term, guys? Your 8th term is 90. Yeah? 0.25 into 30 plus 90. What's your answer? 97.5, and that is there in option D. Yes, that's how you can calculate the positional measures. What kind of question it is irrespective, guys. So please focus on your pattern of solving. Whether it is discrete series or continuous series, you will get the same thing. You will follow the same rules that you followed previously. Now have a look at 73. Find D6 for the following observations. Guys, D6 means 6th decile. So, to calculate deciles or any other partition values, you must arrange the data in ascending or descending order. In particular, ascending order is preferable. What are the observations? 7, 9, 5, 4, 10, 15, 14, 18, 6, 20. So, let me know, observe the least observation 4 and then 5 and then 6, 7, 9, 4, 5, 6, 7, 9. Let me write down the observations in a particular order. In particular, I am writing them in ascending order. 4, 5, 6, 7, 9 is what I found. Next, after 9, 10, then 14, 15, 18, 20, right? 10, 14, 15, 18, 20. Please count the number of observations that are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, how many observations are there? 10. What is it you need to calculate, guys? 6th decile. What is the formula for 6th decile? 6 into. Deciles divides the data into how many parts? 10 parts into n plus 1 by 10th term. Take your calculator. What is n plus 1? 11. 11 into 6 by 10. What is 11 into 6 by 10? It is 6.6th term. So, how to calculate 6.6th term? 6th term plus 0.6 into 7th term minus 6th term. What is your 6th term? 4, 5. This is 6th term. This is 7th term. 6th term is 10 plus 0.6 into 7th term 14 minus 6th term 10. 14 minus 10, 4. 4 into 0.6, 2.4. 2.4 plus 10, 12.4. And your answer is option B, which is 12.4. So that is what about mean, median, and other positional measures, guys. So the next concept is about mode. Got it? Mode is the next concept. So here we have learned central tendency part 1 has arithmetic mean, median, and all the positional measures. So let us get into the concept called mode, guys. So the word, the term mode is denoted by the letter Z. So what is a mode? Mode is an observation which is repeated for highest number of times in any data. What is a mode? Mode is an observation which is repeated for highest number of times in our data. It means mode is an observation which lies in our data only when it comes to mean. Mean may be there or may not be there. When it comes to median also, if there are even number of observations at the middle, just now we have seen an MCQ, right? So, if there are even number of MCQ, even number of terms, median need not be there in the data. But mode is not like that. Mode is an observation which lies in the data, as mode is the most repeated term in the data, means mode lies in the data. Got it, guys? Means it's not an isolated value, it is there in the data, it will be there in the data. So mode is the term, mode is an observation which is most frequent observation, can I say? Means mode is an observation which has highest frequency. Means in an individual series, to calculate the mode, observe the data and observe the highest repeated term. For example, guys, look at MCQ number 2 here. Oh, sorry, not MCQ number 2, MCQ number 1. So what is the modal value of the number 5, 8, 6, 4, 10, 15, 18, 10? Which observation got repeated more number of times? Number 5 got repeated once, number 8 got repeated once, 6, 4 got repeated once, 15 got repeated once, 18 got repeated once. But number 10 got repeated how many times? 2 times. So who is repeated more number of times? 10. That observation is mode. Got it, guys? So what is your mode? Your mode is 10. So you see how simple it is. Means it is just by observation at a glance you can trace out what is a mode. But guys, there is a problem with mode. Now if you look at MCQ number 2, the mode of the numbers 7, 7, 7, 9, 10, 11, 11, 11, 12. If you look at here, 7 got repeated how many times? 3 times. Of course, 11 also got repeated 3 times. But 9, 10, 12 got repeated only once. Means there are how many modes? Yes, 2 modes. Means there are certain cases in which you will come across getting more than one mode. Such a series is said to be multimodal series. Now we come across a series having how many modes? 2 modes, no? That is said to be bimodal series. How do you call it as? Bimodal series. Means there are certain cases in which you can see more than one mode also. But as per the definition of mode, mode should be as per the definition of average. Average is a single number, no. But here you are telling 2 numbers at a time. You might tell 3 numbers if it is trimodal, no. Yeah, it's not that good average as compared to mean and median. That's what you need to understand, because average is a single expression which represents the entire data, but you are providing how many averages? 2. One is 7 and the other one is 11. Got it, guys? So that's how you can calculate mode for an individual series. The next thing is, like mean, median, mode is also affected due to both origin and scale. Means if two variables x and y are related by y equal to a plus bx, then mode of y equals to a plus b into mode of x. Or else, if variables x and y are connected this way, ax plus by plus c equal to 0. So you can write a into mode of x plus b into mode of y plus c equal to 0. Got it, guys? So like mean, median, mode is also affected due to both origin and scale. When it comes to the first case, a is the origin and b is the scale. When it comes to the second case, a and b are scales and c is the origin. Multiplicative value is scale. Additive value or subtracted value is called as origin. So a and b are scales and c is origin. When it comes to here, a is added, no. So a is origin and b is scale. Like arithmetic mean and median, mode is also affected due to both change of origin and change of scale. Madam, how do we recognize mode in case of discrete frequency distribution and continuous frequency distribution? At the time of teaching MCQs, I'll tell you the formulas, guys. Before that, let me have a look at MCQ number 6. So what is MCQ number 6? It's a simple task. The mode of a given set of observations is 20. If each observation is divided by 4, then the new mode is. Means, let me assume that the mode of old series is mode of x, means zx. I am assuming that my old series is x and zx equals to how much, guys? 20. Now, each observation of x series was divided by 4, means y can be obtained by dividing x with 4, means y equal to x by 4. Then what is mode of y equals to? As you all know, mode is also affected due to both origin and scale. Here division with x, 4 is called as scale. So zy equal to zx by 4. What is zx here? 20. So what is 20 by 4? 5 is your answer. Got it, guys? Now look at MCQ number 8. If x and y are related by x minus y minus 10 equal to 0, and the mode of x is known to be 23, then what is the mode of y? Just now I gave you a deduction, guys. It is like x minus y minus 10 equal to 0. Continue to write the relation of mode in the same manner, means zx minus zy minus 10 equal to 0. You need not worry about it as it is an equation model. Just if there is x, write mod x. If 2 into x is there, write 2 into mod x. Because 2 is a constant. Constant mode is always constant. Constant median is always constant. Constant mean is always constant. You need not worry about constant. So what is mode of x according to the question, guys? 23. So 23 minus mod y minus 10 equal to 0. So take this zy to the right side, guys. Zy equals to, what is 23 minus 10? It is 13, and that is there in option C. See how simple it is if you know the basic thing of basic formula that is needed to calculate this mode of x or mode of y. Now I told you that while explaining MCQs, I'll tell you what is a mode for discrete series. Guys, look at the 9th question. For the following data, what is a mode? Num variable x. Variable means, let me assume that my variable is x. Number of men means it is frequency. So guys, let me tell you the meaning of this series. Number 2 got repeated for how many times? Yes, 5 times. Number 3 got repeated for 6 times. Number 4 got repeated for 8 times. And 5 got repeated for 13 times. 6 got repeated for 7 times. 7 got repeated for 4 times. Now let me read out the definition of mode again. What is the definition of mode? Mode is an observation which is repeated most of the time, highest number of times. Now look at your data. Tell me which observation got repeated more number of times. Number 2, 5 times. Number 3, 6 times. Now tell me what is the answer. Yes, number 5 got repeated for 13 times, which is the highest number of times. Guys, suppose if I keep 17 here, who is my mode? Yes, number 6, at 6 got repeated for 17 times. Yes, for now the mode is 5. Mode is not the frequency, guys. Mode is the observation which is repeated for highest number of times. Repetition is frequency. Repetition is not mode. The observation that has repeated more number of times. Which observation got repeated? 5 got repeated for 13 times. So your mode is 5. Try to understand that. Now let's talk about continuous series. I'll tell you how to calculate mode in a continuous series. Now you are able to understand about discrete series, no? Now I'll tell you along with an example. Find the mode for the following data: classes 3 to 6, 6 to 9, 9 to 12, 12 to 15, 15 to 18, 18 to 21, 21 to 24. And the frequencies are 2, 5, 10, 23, 21, 12, 3. How to calculate mode? Let me write down my data. What is my data? From where to where? No need, guys. So let me keep it here only. Yeah, this is class and frequency, no? Identify the class with highest frequency and call it as a model class. Let me repeat. Identify the class with highest frequency and call that class as model class. So tell me the frequency, highest frequency 23, no? So this is your model class. How do you call it as? Model class. What is a model class? 12 to 15. Now you are in such a position to eliminate at least one option. Why? Because like median class, median lies in median class, like that mode should lie in model class. So our mode should be between 12 to 15, but option A is not between 12 to 15. So I can eliminate option A. Now we are able to understand what is a model class, right? Model class is the class which has highest frequency. Who has highest frequency? This class 12 to 15 has highest frequency. Now guys, denote the model class frequency with F. Denote the frequency of its preceding classes F1. Got it? Denote the frequency of its succeeding classes F2. Previous class frequency F1, next class frequency F2, model class frequency F. L is the lower class boundary of model class. Guys, remember, not limit, lower class boundary of model class. L is what? Lower class boundary of model class. L is what? Lower class boundary of model class. C is the class length of model class. What is the class length? 15 minus 12, how much? 3. Yes, got it? Now you are able to understand the terms now. Now let me write down the formula to calculate mode. The formula to calculate mode in case of continuous series is Z equals to L plus F minus F1 by F minus F1 plus F minus F2 into C. Guys, people will write this formula as F minus F1 by 2F minus F1 minus F2. If you want, you can write. But I'm not writing that way because some people will write this formula as L plus delta 1 by delta 1 plus delta 2. Delta 1 means difference between model class frequency and its preceding class frequency, F minus F1. Delta 2 means F minus F2 means difference between model class frequency and its succeeding class frequency. Some people write the same formula as L plus D1 by D1 plus D2 into C. Again, who is D1? F minus F1. Who is D2? F minus F2. Some people will write down the formula in the second format or in the third format, guys. It depends upon them. Now I'm going to substitute, guys. I'm directly using my calculator, guys. What is L? L means how much? 12. Am I correct? L means 12. F minus F1, 23 minus 10 by F minus F1 again 23 minus 10 plus F minus F2. What is F minus F2? 23 minus 21 into what is model class length? Model class length is how much, guys? 3. Got it? So into 3. Now take your calculator. 23 minus 10, how much? 13. 23 minus 21, 2. 13 plus 2, 15. And numerator is 13. Calculate 13 by 15 into 3 plus 12. What's your answer? 14.59 bar is what I got, guys. So I'm assuming it as 14.6. So my answer is 14.6 and that is there in option D. So this is how you can calculate the mode of a discrete series, mode of a continuous series. Of course, mode of individual series is such an easy task to you all know. Now let's have a look at MCQ number 13, guys. So 13 is a very simple question. So before that, I must tell you the what is this model related to. Guys, now you know about mean, you know about median, you know about mode. So guys, there is a relationship between mean, median and mode. There is a relationship between mean, median and mode. So this is not the exact mathematical relationship, guys. The person who gave this relationship took many series, so many series he took. He have calculated the mean, median and mode for the first series. He did the same for the second series. He did the same for all the series that he have taken. In most of the series that he have taken, he found the relationship as mode equals to 3 median minus 2 mean. But I have already told you guys, for all the series, he did not find this relation. He found this relation for most of the series. It means it's not a mathematical relation. It is called as an empirical relation. How do you call it as, guys? Empirical relation. So means it's not actually by mathematical rules. It is true at certain point of view only. For some people only it is true. It is for most of the cases it is happening. Means for very few people it's not working out. And this relation is called as empirical relation. How do you call it as, guys? So empirical relation. Mode equals to 3 median minus 2 mean. Mode equals to what? 3 median minus 2 mean, and the relation is called as an empirical relation. Okay. Now let's get into the next MCQ, guys. MCQ number 13. All of you look at this. Given that mean equals to 70.20 and mode equal to 70.50, then median is expected to be. Guys, I'll tell you a very simple trick here. So guys, if you take any series which is of regular shape, means a bell-shaped curve, median lies at the middlemost place. Median lies at which place? Middlemost place. Okay? Median always lies at which place? Middlemost place. Got it? Now, listen to me. Mean and mode also at the middlemost place, as they are the measures of central tendency. As it is a symmetrical distribution, that we'll think of later, but let me tell you a very simple trick. So if the distribution is not so symmetric, means if the curve is like this, or curve is like, or curve is like this, median is the only number lies at the middlemost place. Mean and mode try to interchange. Means Median is the number which always lies between mean and mode. Might be the positions of mean and mode got changed, but median will always lies between them. Between whom and whom? Mean and mode. Now look at mean. What is mean? 70.20. What is mode? 70.50. So your answer of median should be between 70.20 and 70.50. So I can eliminate 70.15 as it is not between 70.20 and 70.50. I can eliminate 70.20 also. So if you have any one option of this kind, you can directly go through that. But using this formula is very easy task, guys. Mode equals to 3 median minus 2 mean. So you know what is mean. What is mean? 70.2. 2 into 70.2. I don't know what is 3 median because I don't know what is median. Equals to what is mode? Mode equals to 70.5. What is mode, guys? 70.5. Now take your calculator. 70.2 into 2. So guys, if this minus comes to the left side, it will plus, no? So plus 70.5. And that is the value of 3 median, which I got it as 210.9 is the value of 3 median. So now I want to calculate median, which is by 3, and that is 70.3. So median value equals to 70.3. And that is what about mean, median, mode. So of course, positional averages also we have discussed. Now the next measure of central tendency is geometric mean. So what is it? Geometric mean. For a set of observations, geometric mean is defined as the nth root of their product for a set of n observations, x1, x2 and so on xn, x1, x2 and so on xn. Geometric mean for how many observations? N observations. Geometric mean is defined as the nth root of their product, means nth root of x1 into x2 into x3 and so on xn. So guys, some people will apply logarithm to these observations, guys. They will get log gm is equals to summation log x by n. Log gm is equals to summation log x by n. Okay. So because guys, if you apply logarithm here, you will get log of x1 into x2 into x3, which means log ABC formula is log A plus log B plus log C. This nth root will become whole power 1 by n. No, that 1 by n will come into denominator. That's what happened. Because you know the basics of logarithms, you can reduce this very easily, guys. You can write it as x1 into x2 into and so on xn whole power 1 by n, and then you can apply logarithm. This is for an individual series. But when it comes to a discrete series, means there is a x and f. There is x and f. x1 observation got repeated for f1 times, x2 observation got repeated for f2 times. In that case, geometric mean is equals to capital nth root. What do you mean by capital N? Summation f. Got it? So capital nth root of x1 power f1 into x2 power f2 and so on xn power fn. Got it? So now if I apply logarithm to this question also, I'll get log gm is equals to summation f log x by capital N. Summation f log x by capital N. So there's no task of change of origin and change of scale, guys. So now what I wanted to tell you is, if I wanted to multiply two series, means x and y series together, the formula for geometric mean of x into y is geometric mean of x into geometric mean of y. Geometric mean of x into y is equals to geometric mean of x into geometric mean of y. Next, we discussed about combined arithmetic mean, no? Yes. There is a formula for combined geometric mean. What is the formula for combined geometric mean is geometric mean of 1, 2 is equals to anti-log of what it is, guys? Anti-log of n1 log gm1 or else g1. G1 is the geometric mean of first group plus n2 log g2 or gm2 by n1 plus n2. What is it? By n1 plus n2 is the formula for combined geometric mean. So when is geometric mean is used? Geometric mean is used in calculating average rates and ratios in particular. Geometric mean is the best average to compute the average of rates and average of ratios. That is why geometric mean will be helpful in index number topic, as index numbers are completely ratios. If you have a basic knowledge of what is going through in statistics, index numbers are all ratios, guys. Geometric mean is such an average which is very good average in calculating rates and ratios. So geometric mean is used in calculating average rates and ratios. So geometric mean will be helpful in calculating index numbers. Now coming into the other concept, harmonic mean. So guys, people say that harmonic mean is the reciprocal of arithmetic mean. No guys, harmonic progression is that. But what are we talking about is harmonic mean. Guys, harmonic progression is completely a mathematical concept. If a series of elements are in AP, their reciprocals are in HP. But here we are not talking about harmonic progression. What are we talking about? Harmonic mean, and is denoted by HM. Got it? So what is a HM? So for a set of n observations, x1, x2, x3 and so on, xn, let me write down the literal meaning of harmonic mean. Reciprocal of, it's a reciprocal of what? Arithmetic mean. So, madam, you are also writing the same. No, guys, let's see the continuation. Reciprocal of arithmetic mean of reciprocals of observations. Let me read it out. Reciprocals of observations. What are reciprocals of observations? 1 by x1, 1 by x2, and so on, 1 by xn. Arithmetic mean. What is the arithmetic mean of all these observations? 1 by x1 plus 1 by x2 plus and so on 1 by xn by n. It is the arithmetic mean. But what is it we need? Reciprocal of this arithmetic mean means what do you need to write? N by 1 by x1 plus 1 by x2 plus and so on 1 by xn. Guys, try to understand. Not harmonic mean is the reciprocal of arithmetic mean. Reciprocal of arithmetic mean of reciprocals of observations. Got it, guys? So now, look at this. The formula for harmonic mean is n by summation 1 by x if you are dealing with individual series. Whenever you come across a discrete series, the formula will be n by summation f by x. In case of continuous series also, you will use the same formula where x represents mid value. Now guys, there is an important concept that you must be aware of. Combined harmonic means, if the harmonic mean of a group of n1 people is h1 and the harmonic mean of group of n2 people is h2, then the combined harmonic mean is h12, and the formula for that is h12 equals to n1 plus n2 by n1 by h1 plus n2 by h2, which is the formula for combined harmonic mean. So you know the formula for combined arithmetic mean, combined geometric mean and combined harmonic mean. Let's try to understand. Harmonic mean is also used in averaging rates and ratios, but geometric mean is the best choice in averaging rates and ratios. The next thing, try to understand. Harmonic mean is best in calculating average speed, average distance, average acceleration. Yeah, for those things, geometric harmonic mean is used. Yeah, got it? Average speed, distance, acceleration, speed, velocity, all these things. Harmonic mean is used. So, in most of the cases that are related to physics, we will use harmonic mean. You need to understand that. Got it, guys? Harmonic mean is also used in averaging rates and ratios. But who is best? Who is best? Geometric mean. For speed and distance and velocity and acceleration, all these things, who is best? Harmonic mean is best. So guys, if you were given with exactly two observations, for any two observations, there is a relation between AM, GM, HM, because AM is A plus B by 2 for two observations. GM is root AB. Harmonic mean is 2AB by A plus B. Right? So this is arithmetic mean of two numbers, and this is geometric mean of two numbers, and this is harmonic mean. Now if you look at AM into HM, what is AM into HM? Multiply arithmetic mean and harmonic mean. A plus B will be cancelled. 2 will be cancelled. What else will be left? AB. I'm writing it as GM square, and this principle is correct only if there are exactly 2 observations. If there are 2 observations, then GM square equals to AM into HM. Guys, I've told you that to calculate average speed, you must go through which method? Harmonic mean, no? So there, who is frequency? Most of the people has this confusion. The frequency of speed is distance. Try to understand. What is the frequency of speed? Distance. Keep it in your brain. You have many MCQs on harmonic mean which you need to calculate the average speed. Whenever you're calculating the average speed, the variable is speed and the frequency is distance. Got it? So now let's get into the MCQ part, guys. So the next MCQ that I have taken here is MCQ number 19. So look at the question. The geometric mean of 3 observations 40, 50 and x is 10. Then the value of x is. So what is the geometric mean of 40, 50 and x, guys? How many observations are there? 3 observations, no? So the geometric mean formula is nth root. How many observations are there? 3 observations. Nth root of their product. What are the observations? 40, 50 and x. How much it is equals to? What is the geometric mean of these 3 fellows? 10. There's a very simple task. If this cube root comes to the right side, it will be cube, no? Take your calculator and calculate 10 cube. What is 10 cube? My answer is 1000. 1000 equals to 40 into 50 into x. Just divide 40 and then divide 50. Divide 40 and then divide 50. What's your answer? 0.5. Yes, my x is 0.5 and that is there in option C, as C is 1 by 2, no? That is the correct answer. Now the next MCQ that I have taken is MCQ number 22. Geometric mean, if geometric mean of x is 10 and geometric mean of y is 15, then the geometric mean of xy. What is the formula for geometric mean of x into y? Geometric mean of x into y is equals to geometric mean of x into geometric mean of y. So what is geometric mean of x? 10. And what is geometric mean of y? 15. What is 10 into 15? 150. So geometric mean of xy equals to geometric mean of x into geometric mean of y. So we have already discussed that property, guys. Now let's see the next MCQ. MCQ number 26. Find the harmonic mean of the following numbers. What are the numbers? 1, 1 by 2, 1 by 3, 1 by n. So how many observations you can see here? N observations, no? Let me write down the formula for harmonic mean. N by summation 1 by x. Am I correct? Harmonic mean equals to n by summation 1 by x. Means you need to add the reciprocals of observations, right? So numerator is n as there are n observations. Your observations are 1, 1 by 2, 1 by 3, 1 by 4 and so on, 1 by n. So reciprocal, what is the reciprocal of first observation? 1. Can you please tell me the reciprocal of second observation, guys? 2. Can you please tell me the reciprocal of third observation? 3. And so on, reciprocal of nth observation, n. Do you know the formula for 1 plus 2 plus 3 plus and so on, n? Yes, n into n plus 1 by 2. Who will be cancelled? Nn. If n plus 1 by 2 comes into numerator, it will be reversed, no? So the answer is 2 by n plus 1. Guys, if you are comfortable with this, use this. Or else, just simply do one thing. Take n equal to 3. Means you are taking how many observations? 3 observations, no? What are the 3 observations? 1, 1 by 2, 1 by 3. We need to calculate the harmonic mean of these 3 fellows. The formula for harmonic mean is 3 by sum of reciprocals. What is the first observation? 1. Reciprocal 1. Second observation 1 by 2, its reciprocal is 2. Third observation is 1 by 3, its reciprocal is 3. What is 1 plus 2 plus 3? 6. 3 by 6 and the answer is 1 by 2. By substituting n equal to 3, how much you got? 1 by 2. Let me show you the options. Option A, n. You have taken n equal to 3. Wrong answer. Now option B, 2n. 2 into 3 is 6. Option C, 2 by, guys, what is n? You have taken 3. 3 plus 1, how much? 4. 2 by 4 is how much? 1 by 2. That matches with the answer that you have got through your question, right? So this is how you can go through option verification by the process called substitution. So during while solving many questions of mathematics, you will go through this substitution method. No. So whenever your options are having a variable n, you can simply go through substitution method. Got it, guys? So you can simply solve the question that way rather than solving this big method. Now let me show you the next MCQ. MCQ number 30. The harmonic mean of 15 quantities is 10. Means there are 15 quantities whose harmonic mean is 10. Which harmonic mean of 10 quantities is 12. What is the harmonic mean of remaining 5 quantities, guys? There is a total of how many quantities? 15. That are divided into two groups, one group containing 10 and the other group containing 5. So means N1 is 10 and N2 is 5. N1 plus N2 is 15. What is the harmonic mean of first 10 observations? 12. Their harmonic mean is H1 is 12. Now we have to calculate H2 and we know that the harmonic mean of all the 15 quantities is 10, which will denote it with H12 equal to 10. So guys, let me write down the formula for H12. The formula for H12 is N1 plus N2 by N1 by H1 plus N2 by H2. Guys, for my calculation practice, I'm interchanging this N1 by H1 plus N2 by H2 to H1 place. Means I'm interchanging these two fellows. Means N1 by H1 plus N2 by H2 equals to N1 plus N2 by H12. Got it, guys? This is for my comfort of calculation. Got it? Now, what is N1? Take your calculator. What is N1? 10 by H1. Sorry, guys. Please do this one, right side one. N1 plus N2. What is N1 plus N2? 15, no? 15 by H12. 10. 15 by 10 m plus. Do m plus. 15 by 10 m plus. Next, if this N1 by H1 comes to the right side, it will be reverse minus, no? So 10 by 12 m minus MRC. Got it? That is the value of N2 by H2. I got N2 by H2 is 0.6 bar, guys. Now I know what is N2, no? If this N2 comes to the right side, it will be by, no? So do by 5. Whatever is there in my calculator, I've shown it to you guys. This is the value of 1 by H2, but I need to calculate H2. For that, I need to use divided by equals to. Just need to calculate the reciprocal. Now you can perfectly see the answer. What is your answer? 7.5. So it's all about how you are using your calculator. So try to understand that. Got it, guys? Now let me show you the next MCQ, guys. Next MCQ is 31. So calculate the harmonic mean of this data. So I'll tell you the formula for harmonic mean of this kind of data. The formula is capital N by summation F by X. So guys, I'll tell you with the help of calculator only. Please use your calculator to the full extent. Then only you are in such a position to solve. N means all the observations frequency total. Right? Please do calculate the frequency total. 2 plus 3, 5, 5 plus 3, 8, 8 plus 2, 10. Means my numerator is 10. Now guys, summation F by X, I'll tell you a very easy way. Clear your calculator's memory. We are going to complete this with the help of calculator. We are not writing anything on the paper. F by X. My F is how much? 2 by 2. 2 by 2 m plus. 2 by 2 m plus. It's 1. Next. 3 by 4 m plus. It's 0.75. Next. 3 by 8 m plus. It's 0.375. Next. 2 by 16 m plus. It's 0.125 m plus. M plus is done now. Now clear your calculator's memory. It is 2.25. So my denominator is 2.25. So you have to calculate 10.2.25. For that, I am not doing anything, guys. 2.25 is in numerator or in denominator? Denominator. So use divided by equals to. And then in numerator you have 10, no? Use into 10. You'll be able to see your answer. How much? 4.4 bar, and that is there in option D. Means if you know how to use your calculator, it's a cakewalk to you all, guys. Try to understand. Now look at MCQ number 35. A person covers 12 kilometers at 3 kmph and 8 kilometers at 9 kmph and 24 kilometers at 4 kmph. Find the average speed in covering the whole distance. Guys, I've already told you. To calculate the average speed, guys, try to understand. You will not be segregated under models, no, in your final exam. You must understand. You have to calculate average speed. Calculation of average speed requires arithmetic mean or harmonic mean or geometric mean. Harmonic mean. And I have already told you. To calculate the average speed, you need to use harmonic mean. In harmonic mean, in speed, calculation of speed, who is your frequency? Distance, right? So it's a question related to frequency, right? Then tell me the formula for harmonic mean. Just now you used, no? N by summation f by x. Who is your frequency? Distance. This is distance, no? And who is your x? Whatever you need to calculate, the speed, average speed, whatever you want to calculate the average, to whom you want to calculate the average speed, no, that is your x. Okay, this is your distance and this is your x, and this is your distance, this is your x, and I told you that distance is my frequency. So who is my frequency? Got it? Now tell me the total of frequencies. 12, 18, 24. Please add 12, 18, 24. How much? 54. Okay, by, now it's your turn. Use your calculator. F by x. Clear your calculator's memory. 12 by 3 m plus, which is 4. Next, 18 by 9 m plus, which is 2. Next, 24 by 4 m plus, which is 6. And finally, MRC. So my denominator is 12 and I need to calculate 54 by 12. For that, 12 is already there. So that's why I'm using divided by equals to into 54. What is 54 into 54? I got this much. 4.49 bar, which can be approximately taken as 4.5. So you must understand this one, guys. Now, the next question that I have taken here is MCQ number 39. Look at MCQ number 39. So the arithmetic mean of two numbers, guys, this model is very important as there is a very recent exam question in the final exam. Very recent exam question has this format, guys. If the arithmetic mean of two numbers is 30 and the geometric mean is 24, find the two numbers. You need not do arithmetic mean is a plus b by 2, geometric mean is root ab. You don't do all those things, guys. Take your calculator. For option A, guys, you don't verify arithmetic mean. It's simply time waste. Verify geometric mean. What is the geometric mean of two numbers? Should be 24. How to calculate geometric mean? Just multiply both the numbers and then enter equals to symbol, then only apply square root. You people will do like this, guys. I'll show you. You people will write 36 into 24 because it is geometric mean, and then you will write root symbol, means you'll get something. This is not the root of 36 into 24. Your calculator feels that it is 36 into 24 and for 24 only it will calculate under root. Try to understand that. You must calculate the under root of 36 into 24 both, no? So for that, don't do that, guys. Enter 36 into 24 and then enter equals to symbol and then apply square root. Is it your answer? No, your geometric mean is 24. It's not the correct answer, no. Now go for option B, 30, 30. 30 into 30 and then equals to symbol and then square root symbol. Your answer is 30, but your geometric mean is only 24. So option A, option B are not correct answers. Option C, 48 into 12. Guys, I'm repeatedly telling you, and then enter equals to symbol, then only go for square root. What's your answer? 24. So don't waste your time by verifying with arithmetic mean. For all the options, you will get arithmetic mean is 30, guys. He'll design the options in such manner. Because ICAI designs the options in such manner only. So try to understand. Do not calculate arithmetic mean. Just calculate geometric mean and then compare both of them. Okay. So guys, this is all about formulas part that is related to measures of central tendency. We have seen arithmetic mean, geometric mean, harmonic mean and everything, no? So median, mode, all the positional averages. Now let's go for theory part, guys. Okay. So let's see the theory part that is related to central tendency, guys. So I've already told you the meaning of central tendency or the meaning of average. What is an average? An average is a single figure that has to represent the entire data. Means the entire data can be remembered with a single observation or can be identified with a single observation, right? So here we have provided you a flow chart that is related to measures of central tendency, guys. What are the three measures of central tendency? Mean, median, mode. So mean is further classified into arithmetic mean, geometric mean, harmonic mean. Of course, properties of AM and of course weighted arithmetic mean. Next, properties of GM and of course weighted geometric mean. Properties of HM and of course weighted harmonic mean. We have solved many MCQs of that kind, no? Next, properties of median, And of course, we have seen partition values also, right? So we have discussed about properties of mode. What are those partition values? We have seen quartiles, deciles, and percentiles, right? So now let's see the definition of average. As I have already told you, for a given set of observations, why we are calling it as a central tendency means average used to tending towards a central. That's why we are calling it as a measure of central tendency. Okay, so central tendency is the tendency of given observations which are moving towards a single central value. That is called as middle value, that we are calling here as an average, right? So it means that single value has to represent how many values? A group of values. So means you are representing a vast amount of data with a single observation. Okay, so that single observation should represent the entire vast data, no? So it has to be abide by certain rules. What are those rules? Let's see. So generally averages lies at the central part of a distribution, no? Yes. For example, guys, where average is used. For example, if I say that the average marks secured by that particular institution is 80%, means average student even got 80%, means that's such a good institute, no? Means an educational institute performance will be defined by its students' average performance only, right? So yes, that too. This arithmetic mean or this average will be helpful for you in comparing two distributions. Let me assume that the average of first distribution is 80% and the average of second college is 90%. Which college is better? 90% college, no? Yeah. So what are the three measures of central tendency? You know, mean, median, and mode. Of course, guys, try to understand. Arithmetic mean is of three types. Measures of central tendency are 5. Arithmetic mean is of three types. What are they? Mean, geometric mean, harmonic mean. Mean means arithmetic mean, geometric mean, harmonic mean. So mean is of three types, but measures of central tendency are 5. So what are the features of a good average? What is the criteria for a good measure of central tendency? So because a measure of central tendency is one, which represents a huge mass of data. That's what I told you, right? So since it is a single term which is representing the entire average, entire data, it has to be abide by certain rules, and these are the rules that needs to be followed by a good measure of central tendency. What is the first measure? It should be properly or unambiguously defined, means no confusion at all. It should be rigidly defined, means everybody has to tell me the same answer. It is easy to understand and easy to calculate. Okay, and one more thing, it should be based upon all the observations. The next one, it should not be affected by the presence of extreme observations, or else we can say it should be least affected. If it is affected, means it is least affected. Yes, everyone is affected, but it should be least affected. Like that, it has some mathematical properties. It should have some sampling stability, and average can be found by graphical method also, and it is easy to comprehend, means it is easy to tell, it is easy to interpret. Got it? So guys, here we have mentioned that note. There are three types of average. One is mean, median, mode, and it's further divided into arithmetic mean, geometric mean, harmonic mean. Hence the number of averages are 3 and number of measures of central tendency are 5. Try to understand. So guys, now I'll tell you the properties of arithmetic mean. Let us talk about arithmetic mean. So you know, arithmetic mean is the commonly used, which have been using from your childhood onwards, no? It is the most commonly used measure of central tendency. So to a common man, for a common person, yes, I've already told you, for a common person, it is average, but for a person who knows statistics, it is arithmetic mean. Got it, guys? What is the formula for arithmetic mean? Sum of observations by number of observations. Guys, now tell me, are you using all the observations or only some observations in the data? Yes, all the observations, no? Means it is based upon all the observations. Got it, guys? Now, is it easy to compute or difficult to compute? Easy to compute. Okay. Now, you should tell me, guys, whoever calculates will get the same answer or different answer? Yes, if you follow the calculation things properly, guys, if you made a wrong calculation and you say that, madam, we got a different data, that's not up to me, guys. So you have to enter all the values perfectly. After that, you will get the same answer or different answer. Yes, everyone in the class, not only in the class, everyone in the universe to all solve the question means they'll get the same answer. Means there is no confusion at all to tell the mean value. Means it is rigidly defined and there is no ambiguity at all. Got it, guys? So those are what the merits are. It is easy to understand and easy to calculate. It is based upon all the observations. It is rigidly defined by mathematical formula. It was least affected by. So yes, I need to tell this one. It can be subjected to further algebraic treatment. Guys, let me tell you the meaning of this. What is meant by further algebraic treatment? Means average can be combined. If it is combined, we can say that it is used for further algebraic treatment. Guys, try to understand. So you know there is a formula for combined arithmetic mean. Yes, got it? Now, what is the meaning of this? It is least affected by sampling fluctuations. As per ICAI, it is correct, guys. It is least affected by sampling fluctuations. You can note you can see this note. As per ICAI, it is given that arithmetic mean is very much affected by sampling fluctuations. But the correct answer is arithmetic mean is very much affected by extreme observations. Actually, arithmetic mean is least affected by sampling fluctuations. Got it? Arithmetic mean is least affected by sampling fluctuations, but as per ICAI, it is given that arithmetic mean is highly affected by fluctuations. So, madam, what is an extreme observations, guys? So, let us assume that we are in summer. So, when do you say that a temperature is extreme? If it is seen every day? No, guys. If it is seen some day, only one of very few days, if it is seen, we'll call it as an extreme temperature. Let me assume that the temperature is 48 degrees. I can call it as an extreme temperature. If I am seeing that 48 degrees every day, how do I call it as an extreme temperature? An extreme temperature means it can be either high or even low. When it comes to winter, suppose if I have seen the cases in which my temperature was 15.4. So those are the temperatures which are rarely happen, and that is the very least value, the very highest value. Those are called extreme values. So guys, if I say that, tell me the arithmetic mean of 1 and 2. What is the arithmetic mean of 1 and 2? 1.5. Now tell me the arithmetic mean of 1, 2, 20. Take your calculator. It is 23 by 3, which is 7.6. Two observations are at 1, 2. One observation is 20. Because of this 20, my arithmetic mean went towards 7. It means my arithmetic mean is highly affected by extreme observations. Got it? And next thing, there's no graphical representation of arithmetic mean, guys. So yes, and that too, this arithmetic mean will be meaningful only if the frequency is distributed normally. Means there is a least frequency at the beginning, highest frequency at the ending. Sorry, least frequency at the ending, highest frequency is concentrated at the middle. And one more thing, if the class interval is open-ended, means you don't know the last class upper boundary or first class lower boundary. In such a case, can you calculate mid value? You can't. In such a case, you can't even calculate the arithmetic mean, because arithmetic mean is dependent upon mid value. Got it, guys? So extreme values has a greatest effect on arithmetic mean. Okay. So, and that too, arithmetic mean is used for quantitative data only, as it is all dependent upon calculations. No. Yes, sir. But usually, arithmetic mean is the best measure of central tendency. Compared to all the remaining measures of central tendency, arithmetic mean is the best one. Got it, guys? So that's all about arithmetic mean. So what are the properties of arithmetic mean? So guys, if all the observations are k, what is the arithmetic mean of k and k? K plus k by 2, which is k. What is the arithmetic mean of 3k's? K. Yes, arithmetic mean of a constant is constant. Next, the choice of assumed mean doesn't affect the original mean that I have already gave you at the time of teaching. So regular problems, guys. So next, the algebraic sum of deviations of a set of observations from their arithmetic mean is 0. For example, guys, if you take this example, which is, let me take 1, 2, 3, 4, 5 as my set of observations. Let me take 1, 2, 3, 4, 5. What is the arithmetic mean of 1, 2, 3, 4, 5, guys? 3 only, right? Tell me what is x minus 3? 1 minus 3. Minus 2, 2 minus 3, minus 1, 3 minus 3, 0. This is 1, this is 2. What is the sum of all these things? 0 means sum of deviations of a set of observations from their mean is always 0. Now, please do calculate x minus 3 whole square. X minus 3 whole square, 2 square, 4. 1, 0, 1, 4. What is the sum? 10, no? Now, take any other number, guys, whether it is 3 or 4 or 5 or 6 or any other number. Tell me what is x minus 4, 1 minus 4, minus 3, 2 minus 4, minus 2, 3 minus 4, minus 1. So 4 minus 4, 0. This is 1. Tell me the square of all these fellows. X minus 4 whole square, 9, 4, 1, 0, 1. And the total is how much? 15. So whatever the observation that you take, but summation x minus x bar whole square is least, guys. So that's what he has given you in these two properties. The algebraic sum of deviations from a set of observations from their mean is 0. Sum of squares of deviations from arithmetic mean is minimum. So next, you know, arithmetic mean is affected due to both origin and scale. And you know the formula for combined arithmetic mean, no? Now what is a weighted mean? When is weighted average is used? Guys, if all the observations has given equal frequency, equal importance, then simple arithmetic mean is used. But if the observations are given a different importance, then weighted arithmetic mean is used. In general, most of the cases will be seen weighted arithmetic mean, because if you want to calculate the marks of different people, marks of your IP, intermediate public exam. So guys, I just wanted to know whether you will use simple average or weighted average. You people use simple average. But guys, tell me, will you give the same importance to languages as well as your group subjects? Not seen in any way, at anywhere, no? Then how do you use simple average? You have to use weighted average, no? Because each and every subject has given their own importance, no? So if the observations in the data are not equally important, then you should not use simple average. You have to use weighted average, okay? So similar concepts will be applied to weighted harmonic mean and weighted geometric mean also. Yes, weighted average will be used when all the observations are not equally important, and that is what about arithmetic mean, guys. So let's get into the next measure of central tendency, guys, which is median. So what is a median? As we all know, that median is the middlemost observation after the values have been arranged in ascending or descending order. Means a median is an observation which depends upon the position or place of a number, right? So that is why we say that median is a positional average, right? So now, what is the biggest advantage of median? So guys, median is useful to represent even a qualitative data also. So it is of moderate quality. It is of premium quality, like that we used to say, no? So moderate quality, yeah. In such a cases, we'll use median. So it is very easy to identify, guys, if the observations are arranged in ascending or descending order. But guys, try to understand, if you are having a huge data, it is not that easy to arrange them in either ascending or descending order. In case of little quantity or a very small quantity, it is easy for you to arrange them in either ascending or descending order. And one more biggest advantage of median is, even if the class interval is open-ended. What do you mean by open-ended series? You don't know the first class lower boundary or you don't know the last class upper boundary. But where do median lies? Middlemost, right? So median is not at all related to that open-ended classification, as median lies at the middle, and open-ended series is such a series in which first class lower boundary is not known or last class upper boundary is not known. So median don't have any problem with this open-ended classification. So for open-ended classification, this median is the best measure of central tendency. And of course, what are extreme values? Extreme values means they are endpoints, no? So median is the middlemost observation. Extreme values means they are endpoints. So median is not at all affected by extreme observations. And one more thing, median can be located graphically by using a curve called O-give curve, in particular by using less than O-give curve. Guys, that we'll discuss in a concept called statistical description of data part 2. Okay. So now guys, is median is dependent upon all observations? No, it's not dependent upon all observations. Means it's not taking all the observations into the account. And one more thing, guess whenever there are even number of observations in a data, how many middle terms will occur? 2, no? Let me assume that I have 1, 2, 3, 4, 5. So what is your median? 3. But if I'm having 1, 2, 3, 4, 5, 6, the arithmetic mean of 3, 4 is your median. Means, guys, listen to me. Mean is one of the types of measures, one of the measures of central tendency. Of course, median is the other measure of central tendency. If there are two different measures of central tendency, you must say that both of them are too different. But when it comes to median in case of even number of observations, Median is the arithmetic mean of two middlemost observations, means median depends upon whom? Mean. If median depends upon mean, what is the use of writing a new average or new measure of central tendency, right? So, yes, am I dependent upon him? He is the best one, no? So, that's what I'm trying to tell you. In case of even number of observations, median depends upon mean. It's not so good because they both are two different measures of central tendency, no? Yes. Now, it don't have sampling stability. Yes, guys, it don't have any sampling stability. And the next drawback that I have already explained, in case of huge number of observations, it's not that easy. Next, we can't calculate the combined median of two series. Means it is not useful for further algebraic treatment. And as you all know, our median is also affected due to both origin and scale. Got it, guys? And the next important property is, guys, this I have already explained while explaining your MCQ, no, sorry guys, problematic MCQs. So this property is sum of absolute deviations of a set of observations from their median is minimum. That I have already showed it to you guys. So let me show it to you again. So sum of absolute deviations of a set of observations from their median is always minimum. This property I'm talking about, sum of absolute deviations of a set of observations from their median is always minimum. For example, guys, what is the median of 1, 3, 4? Let me write. Guys, understand, I'm not writing them in any of the progression. Yeah, tell me the median, 4. So now what am I saying is sum of absolute deviations of a set of observations from median. What is your median here? 4. So modulus of x minus 4. 1 minus 4 is minus 3, but there is a modulus, no. It is 3. And this is 1. 4 minus 4, 0. 5 minus 4, 1. 7 minus 4, 3. What is the total sum? 6. Guys, in place of 4, even if you take 0 or 1 or 2 or 100, this is smallest deviation. If you want, I'm taking x minus 5. So guys, tell me what is 1 minus 5? 4. 3 minus 5, 2. 4 minus 5, 1. 5 minus 5, 0. 7 minus 5, 2. What is the sum, guys? Yes, 9. So this is the least sum. So means sum of absolute. Absolute means modulus. Sum of absolute deviations of a set of observations from their median is always least. That is another important property of median, guys. So as you all know, median is affected due to both origin and scale. Okay. So guys, median is rigidly defined. So it is exactly defined. Whoever calculates will get the same answer, and it is easy to understand. It is easy to calculate, but it is not based upon all observations. So it doesn't have any super much mathematical properties. It is just affected by change of origin and scale, and it is not useful for further algebraic treatment as we can't calculate combined median. And median is not affected by extreme observations as median is a middlemost observation and extreme observations are the endpoints. That's what the complete details about median. Now you know what are the positional averages. What are the positional averages? Median, of course, quartiles, deciles, octiles, percentiles, all the partition values, no, they're called as positional averages or partition values. So what are partition values? The name itself is saying I'm a value which divides the data into partitions. Partition value. I'm a value which divides the data into number of partitions. So partition values are the values that divides the given set of observations into a number of equal parts. If we want to divide the entire data into 2 equal parts, we'll take median into account. If we want to divide the data into 4 parts, quartiles, so 10 parts, deciles, 100 parts, percentiles. Okay, so quartiles divides the data into how many equal parts, guys? As you all know, 4 parts. So how many quartiles will be there? 3 quartiles. So what are the quartiles? Q1, Q2, Q3. Q1 is known as first quartile, which is also known as lower quartile. Q2 is known as middle quartile, which is also known as median. Q3 is known as upper quartile or third quartile. It is up to you. So like that, you can talk about Q3, or sorry, decile 1, decile 2, decile 3 and so on. So deciles are the observations, deciles are the measures that divides the data into how many equal parts? 10 parts. So there will be how many deciles? 9 deciles starting from D1 to D9. As you all know, D5 is your median. So what is percentiles or centiles? Centiles. Cent means 100. So percentiles are the values that divides the data into how many equal parts? 100 equal parts. So how many percentiles will be there? 99 percentiles. From where to where? P1 to P99. So who is P50? Median. Okay. So that's what given to you as a note, guys. Okay. So next thing, another way to find out quartiles. Just now I told you that median can be located graphically with the help of what? Ogive curve. With the help of that Ogive curve, you can locate any of the positional averages. How do we do? That we can explain in statistical description of data part 2. And now let's talk about the next measure of central tendency, which is mode. So what is a mode? Do you guys remember the definition of mode? For a given set of observations, mode is the most repeated observation or most common observation or the observation that has maximum concentration, right? Yes. So it means there is a chance of getting more than one mode that we have already discussed, which is known as if there are 2 modes bimodal series, if there are 3 modes trimodal series, if there are more than 2 modes, we will say that it is a multimodal series. It means the definition of mode is not perfectly defined because mode is a measure of central tendency. So as I already told you, it should be one observation which has to represent the entire data. Means it is not perfectly defined. Got it, guys? Because measure of central tendency is always one that has to represent the entire data. But if it is a bimodal series, there are 2 measures. No. Yes, that's why mode is not perfectly defined. But the biggest advantage of mode is when it comes to median. Suppose if I ask you what is the median of 1, 2, 3, 4, 5, 6. What is the median of 1, 2, 3, 4, 5, 6? 3.5. If you look at the data, 3.5 is not even the mark of any student. But the median is 3.5. That is not even in the data. Means it's an isolated value. It's a different value that is not even there in the data. When it comes to mean also, you will get the same answer, guys. Means that may be in the data or may not be in the data. There's no restriction that has to be in the data. Sometimes it will not be in the data. But when it comes to mode, mode is the data that is highly repeated in the given data, right? Mode is the observation which is highly repeated in the given data. Means mode will always be there. Means mode is not an isolated value. It will definitely be there in the data. So next, guys, what is the meaning of mode? Tell me. Most common value. There's a one important point that you need to understand. Mode is the most common value. What is an extreme observation? I've already told you. When do you say that a temperature is extreme? If it happens daily, can I call it as an extreme? No, I can't. So means it's a rare value. Am I correct? Yeah. Extreme observations are rare observations and mode is the most common observation, which are quite contracts. No. Means mode is not affected by extreme observations. That's what your next point. And of course, the graphical representation of mode is histogram, which one also will see in statistical description of data part 2. And this is perfectly used in qualitative phenomenon. So, and the next biggest advantage is by looking at the series itself, you are in such a position to tell the mode. So at a glance, you can identify what is mode. But guys, the drawbacks of mode are if the mode is ill-defined, means if there are more than, if there is no, sometimes there's no mode. Sometimes there are bimodal series or multimodal series. In all the cases, we will say that mode is ill-defined. Means mode can't be calculated directly. In such a case, we can't calculate mode, no? Whenever there are multimodal series. And whenever there is no mode, there are cases in which no mode. For example, if I'm talking about the series 1, 2, 3, 4, 5, 6, who is the mode? I can't tell. Everybody got repeated only once. Nobody got repeated more than once. No. So no mode. So such series, in such cases, we'll say that mode is ill-defined. So we can't calculate the mode. In such a case, we'll calculate the mode with the help of an empirical relation. I've already told you the meaning of empirical relation, which is not actually by mathematical rules. So we can calculate the mode with the help of an empirical relation. But I've already told you, it is not by mathematical rules, it is an assumption. For most of the cases, it is true. It is not true for 100% of the cases. Means you are just estimating mode. So means it's not properly defined. It is not correctly defined. Try to understand that. And one more thing, mode is based upon most common values only, right? Means it is not taking all the observations into the account. And it is highly affected by sampling fluctuations. Got it, guys? So, and one more thing, it's not rigidly defined. So different persons may write the answer in different ways, right? So if there are two modes, one person can say 7, the other person can say 11. So yes, because we have to tell only one term for an average, no? Yes, and that the next concept, the next drawback is, there's no chance of calculating combined mode, no? Yes, we can't calculate combined mode. It means it is not capable of further algebraic treatment, and the property for mode is just a simple task, guys. Mode is also affected due to both origin and scale that I've already mentioned it. So guys, among all the measures that we have discussed till now, who is the best measure of central tendency? Only mean. So what is the relation between mean, median and mode? Guys, I've already told you. In a symmetrical distribution, so most highest frequency is mode. This is mode. And the middlemost observation is median. This is median. And of course, this will be mean. So for a symmetrical distribution, mean equals to median equals to mode. So all the three are equal. But for an asymmetrical distribution, means if the graph is like this, or if the graph is like this, so that kind of distribution is called as asymmetrical distribution. Then mode equals to 3 times of median minus 2 times of mode, 2 times of mean. It means, guys, try to understand, difference between mean and median equals to 1/3 of the difference between mean and mode. Means mode is far away from mean compared to median. Let me repeat, mode is far away from mean compared to median, because difference between mean and median is 1/3 of the difference between mean and mode. Means whose distance is lower? Mean and median distance is lower. Mean and median distance is 1/3 of the distance of mean and mode. Try to understand. And next thing, difference between median and mode is 2/3 of the difference between mean and mode. Means the difference between, or the distance between mean and mode is 2/3 of the distance between mean and mode. Got it, guys? Distance between median and mode is 2/3 of the distance between mean and mode. All these things came from only one deduction, guys, which is mode equals to 3 median minus 2 mean, which is an empirical relation that's we have already discussed. But guys, try to understand, I've already told you, median is the middlemost observation, which always lies at the middle only. What kind of asymmetry it is? Sometimes mode stays left side and mean stay at right side. Sometimes mode stay at right side and mean stays at left side. It means median will always lies at the middle part only. Mode and mean are trying to interchange. Guys, I'll tell you why. I'll tell you the literal reason for this, guys. Look at this. Look at this. Who is mode? Highest frequency, no? So this is mode. Got it? And median, as usual, it lies at the middlemost place. Now, guys, let me tell you one thing. This distribution is negatively skewed distribution. Means skewness is towards left. Skewness means bulginess of the curve. Bulginess of the curve. So this is bulged towards the left. No. So there are observations which are very huge at the left side. As you all know, arithmetic mean is highly affected by extreme observations. Mean they will definitely come here. Got it? Means for a negatively skewed distribution, so mean is less than, median is less than mode. Now for a positively skewed distribution, this highest frequency is mode. As you all know, median lies at the middle. Now extreme observations are at the right side. So that's why mean will stay at the right side. Means the position of mode and mean got interchanged, but the median is exactly at the middle. In this case, mean is greater than median is greater than mode. Now, can you see both the cases? In the negatively skewed distribution, mean is less than, median is less than mode. When it comes to positively skewed distribution, mean is greater than, median is greater than mode. Try to understand. So, for a symmetric distribution, all the three are equal. It means if you observe these two scenarios, where do the median lies? At the middlemost place only. But who are getting interchanged? Median and mean and mode. Means median will always stay at the middlemost place. Who are changing their position? Mean and mode. Got it, guys? So median is usually lies at the middlemost place. At one side mean will be there and at the other side mode will be there. They might interchange their positions, but there are two endpoints. Got it, guys? So the relation that we discussed till now is called as an empirical relationship, and just now I told you about this note as well. Now what is a geometric mean? You know, the geometric mean for a given set of observations is the nth root of their product, and it is useful in averaging rates and ratios. I have already told you, as index numbers are all ratios, you can use geometric mean in the construction of index numbers also, and of course I gave you these formulas also, guys. Now let me tell you the merits and drawbacks of geometric mean. Guys, tell me, guys, is geometric mean is easy to calculate or difficult to calculate? Difficult. Are you able to calculate the combined geometric mean? Yes, it means it is useful for further algebraic treatment. Now guys, listen to me. What is root over 25? 5. Means if I keep 25 in the root, I am getting 5, which is lesser than 25. But guys, if I keep 0.25 in the root, I'll get 0.5, which means 0.5 is more than 0.25. Means if I substitute very small number in the root, it is giving me a big number. But if I substitute a big number in the root, it is giving me a small number. Means arithmetic mean gives less importance to large items and more importance to small items, and it is not much affected by sampling fluctuations. And as you all know, geometric mean is based upon a particular formula, so it is rigidly defined, but it is difficult to calculate as it has squares and square roots and powers. Got it, guys? Next, it is not easily understood because it has many difficult calculations. No, that's why the applications of geometric mean are very much restricted, guys. And one more thing, geometric mean is dependent upon roots. No, if any of the observation is negative, can we define geometric mean? Yes, guys, if there is cube root, we can define, but if there is fourth root, we can't know. So, what Hill says means, suppose there are 5 observations. My geometric mean will exist only if all the 5 observations are negative. If all the 5 observations are negative, then the root value is negative when the mean should lie between these numbers. If all the 5 observations are positive, also geometric mean is defined. According to statistics, he took a property, guys. I am able to define geometric mean only if all my observations are positive, all of my observations are negative, and I don't define geometric mean if some are positive and some are negative. For a mathematician, it is such a bad thing, because if I am talking about fifth root, I gave you 4 positive observations and 1 negative observation. I don't have a problem because fifth root is defined for a negative number. But according to statistics, he will not allow all these things. He will just say that I am able to define my geometric mean if all the observations are either positive or negative. If anyone is 0, entire geometric mean is 0, means in any of the class, if any one student got 0 marks, it means the average of all the members in the class will become 0. Is that such meaningful thing? No, that's why geometric mean does not exist if any one of the observation is 0. And we are able to define geometric mean only if all the observations are either positive or negative. We don't define geometric mean if any of the observation is positive and some are positive and some are negative. And we don't define geometric mean if any of the observation is 0. That's a very important point that to be noted, guys. And next, that is why its applications are completely restricted. Now, if all the observations are k, guys, what is the square root of k into k, guys? The answer is k. What is the cube root of k into k into k? If 3 observations are k, your answer is k. So, if 4 observations are k, your answer is k. So, geometric mean is geometric mean of a constant is constant. And I gave you these properties already, guys. Gm of x into y equals to gm of x into gm of y. Gm of x by y is equals to gm of x by gm of y. And combined geometric mean formula I have already gave you. Now, harmonic mean. So guys, I told you the meaning of harmonic mean very particularly. You should not say that it is the reciprocal of arithmetic mean. It is the reciprocal of arithmetic mean of reciprocals of observations. And one more thing, if any of the observation is 0, 1 by 0 does not exist. So harmonic mean will also does not exist. Try to understand. And I gave you the formulas for harmonic mean already, guys. So I told you harmonic mean is useful in averaging rates and ratios, of course, speed, distance, velocity, acceleration. But it is mostly used to calculate the average speed, average time, average rates. Okay, for such kind of questions only we'll use harmonic mean. So it is also difficult to compute as it is based upon reciprocal calculations. But it is dependent upon a particular formula. So I can say that it is rigidly defined and it is based upon all the observations. And there is a formula for combined harmonic mean. So it is capable of further algebraic treatment as well. But it is, guys, based upon reciprocals, no? Look at this. My observation is 0.00001. Let it be. What's your answer? What is 1 by 0.00001? Tell me, guys, to use your calculator. So I know 1 by 0.0001. How much? Is it 10,000? Yes, means such a small number is becoming how much? 10,000. And what is 1 by 10,000? It is becoming 0.0001. Means it is becoming such a small number, no? So try to understand. It gives least undue importance to biggest observations. Undue, there's no such importance. It gives smallest importance to big observations and it gives highest importance to such a small observations. Try to understand that. Okay, next, it is not easily understood and hence its applications are ignored. It is not such easy to understand. So, and that too, it can't be computed if any of the observation is 0. And it is difficult as it depends upon reciprocal observations. And I have already explained this concept. It gives undue, negligible importance to small items and ignores bigger items. So particularly HM is very much affected by smaller extremes because if it is the smallest observation, it is becoming such a huge number. Got it, guys? Properties of harmonic mean. If all the observations are constant, harmonic mean is also constant. And what is the formula for combined harmonic mean? H1 equals to N1 plus N2 by N1 by H1 plus N2 by H2. So what is the relation between AM, GM, HM? Guys, this you must take care of. If all the observations are different, guys, let me take 2, 5. They are positive observations only, right? Tell me the arithmetic mean of 2 and 5, 2 plus 5 by 2. Tell me how much? 3.5. Arithmetic mean is 3.5. Tell me the geometric mean. Calculate square root of 2 into 5. It is 3.1622. Tell me the harmonic mean. I'll tell you a simple shortcut, guys. 2 into 5, 2ab by a plus b means 7. I got 2.85. Guys, what do you understand? Who is bigger number? Arithmetic mean. So look at this. If all the observations are distinct, then AM greater than GM greater than HM. Now guys, what is the arithmetic mean of 2 and 2? 2. Geometric mean? 2. Harmonic mean? 2. Means if all the observations are equal, then AM equal to GM equals to HM. Now, if I gave you that my observations are positive, means they might be either equal or unequal. If they are equal means I can write AM equal to GM equal to HM. If they are unequal means I can write AM greater than GM greater than HM. I don't know whether they are equal or unequal. So that's way I'll combine both of them and I'll write AM is greater than or equal to GM is greater than or equal to HM. And another important property that I have already told you, for any two observations, I proved it also, guys, GM square equals to AM into HM. So guys, when do you use weighted arithmetic mean or weighted geometric mean or weighted harmonic mean? This property also I have told you. Weighted mean will be used whenever all the observations in the data are not given equal importance. The example that I took at the time of teaching this concept is, so I discussed about your intermediate marks. If I ask you to tell me the average of your marks, You people should not calculate sum of all the observations by number of observations, means total of your marks by number of subsection. You should not do, because you haven't given equal priority to all the subjects. Yes, I know. You ignored those languages many times and you gave highest preference to your groups. So means all your groups are not equally weighted as your languages. So you should not use simple average. You should use weighted average. So when do you use weighted average? If all the observations were not given equal significance, then I have to use weighted average. Got it, guys? So guys, when it comes to our cost of living index number calculation, the name itself, cost of living. Cost of living is affected by multiple factors, no? The essential factors, food. Yes, food. Food is the high essential factor, no? Fuel. But food and fuel are given equal priority. No. For that kind of cases, you have to use simple or weighted average. Weighted average, try to understand. So whenever all the observations are not given equal importance, I must go through weighted average. There is no other topic about it. So that is all about the theory related to measures of central tendency, guys. So guys, try to understand. You are in such a position to complete dispersion or correlation or regression, whatever. You must know the basics of central tendency. Every formula that you have used till now will be there in dispersion also. So in dispersion, you are going to use this mean, median, of course mode, of course all the positional averages that you are going to use in a dispersion also. So try to understand. Without central tendency, you can't be in such a position to understand your measures of dispersion. You are in such a position to understand dispersion only if you are aware of central tendency. Otherwise, you can't do it, guys. So try to understand. So what is a measure of central tendency and what are the properties? Try to understand the significance of everything. Okay. So that's what about measures of central tendency, guys. So let's get into our next concept, guys, which is measures of dispersion. So let's talk about the title of this topic first. Later we can talk about what are measures of dispersion and who are measures of dispersion. So dispersion. What is the regular meaning or the literal meaning of dispersion, guys? Disperse means go ahead, right? So you can split, right? So assemble means you can gather, disperse means you can split. So dispersion. So that's scatterness of observations. Got it, guys? So if you want to disperse, means you can go whatever the way that you can go. So means one observation might be here, the other observation might be here, the other observation might be here. Like this, observations got scattered. What is a measure of dispersion? You have to measure the amount of this deviation or scatterness or distance from your measure of central tendency. Let me repeat. You have to identify how your observations are moving far away from your measure of central tendency. But what is the use of this measure of dispersion? So guys, try to understand. This measure of dispersion will calculate, or it calculates the amount of deviation of your set of observations from any measure of central tendency. So guys, tell me, when do you say that a measure of central tendency is a good one? Yes, it is dependent upon all observations, right? It means the difference between the observations and a measure of central tendency should be least or highest. Least. The difference between your measure of central tendency and the observations will be calculated in a topic called measures of dispersion. Means what is the use of this measure of dispersion? This measure of dispersion will calculate the deviation of all the observations from their measure of central tendency. It means it is trying to verify the consistency of your measure of central tendency. Means whatever you have calculated in your measure of central tendency, whether it is good or not, will be explained by your measure of dispersion. Let me repeat, whether your measure of central tendency is dependent upon all observations or not, or whether it is dealing with everybody or not, whether it is at the middlemost place or not, All these things will be calculated or will be understood in a concept called measure of dispersion. Means measures of dispersion are trying to identify the exactness of your measure of central tendency. Let me repeat. They are going to explain whether your measure of central tendency is accurate or is exact or not, will be explained by a concept called measure of dispersion. So what are we going to calculate here? We are going to verify whether there is a deviation between your observation and average. Means you will calculate the difference between your observation and average. So guys, you will calculate the difference between all the observations and the average, no? So and then you will try to calculate the average of all these things. Means average of deviation from average. Let me repeat. Average means sum of observations by number of observations. Deviation from average you will do. If this is least, that's a good measure of dispersion. Otherwise, that's not a good measure of dispersion. Means there are certain cases in which there are, let me assume that there are two students, guys, whose average is same. Average marks are same. Then I have to verify which average is more consistent. In such a case, I need to calculate measure of dispersion. After calculating measure of dispersion, if student A got less measure of dispersion and student B got more measure of dispersion, means student A got 10 as the measure of dispersion and student B got 11 as their measure of dispersion. Which student got less measure of dispersion? Student A. It means his average is more consistent than the other student average. That's what measures of dispersion are going to tell us. So here, these measures of dispersion have been classified into sorry guys, let's have a look at the overview of dispersion. There are two types of measures of dispersion. One is absolute measures of dispersion and the other one is relative measure of dispersion. Madam, what is this absolute measure of dispersion and what is this relative measure of dispersion? Just now I told you guys, we'll take an average and we just wanted to verify whether this average is correct or not. For that, we'll calculate the deviation of all the observations from the average and then we'll calculate the average of all these deviations. If this is done, the measure is called as absolute measure. And if that absolute measure is expressed as a percentage of average, that is called as relative measure. But what is the problem with absolute measure? Then why you are moving towards relative measure? Because absolute measures are meant for comparison only, right? But guys, remember, if you are having 10 rupees, 5 rupees, 8 rupees, so what is the average of 10, 5, 8? Let me calculate. 10 plus 5 plus 8, 23 by 3 and your average is 7.6 rupees, right? Now if I ask you to tell me the deviations, 10 minus 7.6, I'll get rupees, no? Again 5 rupees minus 7.6, I'll get rupees, no? 8 rupees minus 7.6, I'll get rupees, no? And then I'll divide it with 3 means my answer is in terms of rupees, no? Yes, if the first person absolute measure is 7 rupees and the second person absolute measure is 7 kgs, would you compare both? Can you? I can't, because both of them are different units. In ratio proportions, you have learned this concept. You are able to compare two items only if they're of similar kind. But one is expressed in terms of rupees and the other one is expressed in terms of kgs. How can you compare? That is the reason why you're going for relative measures which are meant for comparison. So guys, absolute measure, let me assume that it is 7 rupees. What is your average? 7.6 rupees into 100. So this rupees will be cancelled, no? Yes, it means all the relative measures of dispersion are absolutely unit free and they are meant for comparison. So guys, whatever the absolute measures that we'll calculate here, we'll add a word called coefficient and we'll call them as the corresponding relative measures. Means what are your absolute measures? Let's have a look at them. Range, quartile deviation, mean deviation, standard deviation. Range coefficient, coefficient of range. Quartile deviation, coefficient of quartile deviation. Mean deviation, coefficient of mean deviation. Standard deviation has a different measure of dispersion, a different relative measure, guys, which is called as coefficient of variation. So what is a measure of dispersion? So guys, we have already talked about this. Look at this. The first important characteristic of a dispersion was given by central tendency, right? So now, two distributions may have same measure of central tendency, but they may differ in scatterness. So I have already told you, if two students got the same measure of central tendency, you will verify which measure of central tendency is correct by using dispersion. So to understand a set of observations, it is equally important to have a knowledge of dispersion, as dispersion indicates the volatility. Volatility means ups and downs, guys. So look at this, guys. All these three measures have the same measure of central tendency. All these three distributions or three graphs have the same measure of the central tendency. But if you look at the dispersion of first observation, first graph, this much of dispersion is there. Here, this much. Here, this much, which has more scatterness, guys. Third distribution. So it is more scatterness means less consistent. Got it, guys? So what is the use of calculating this volatility? Guys, suppose if you wanted to invest in a particular stock and that is more volatile, means there is no consistency for that. How do you invest? It has more risk, no? Yeah, those risk factors are also be understood with the help of this measure of dispersion. Got it, guys? So yes, we are here to calculate the dispersion, which indicates the variability of an observations from their average. Got it, guys? So how many measures of dispersion are there? So guys, we have two different types of dispersion. What are they? Absolute measures, relative measures. What are the absolute measures? Range, quartile deviation, mean deviation, standard deviation. So let's talk about relative measures of dispersion. The range corresponding relative measure is coefficient of range, quartile deviation, coefficient of quartile deviation, mean deviation, coefficient of mean deviation, standard deviation, coefficient of variation. So what is the difference between absolute and relative? Guys, tell me. Relative, to calculate relative measure, first of all, you need to calculate absolute measure. Means who are more difficult to compute, absolute or relative? Yes, relative, because as relative needs absolute, it has more calculations than absolute, right? So they are, who are difficult? Relative measures are difficult to compute, but absolute measures are easy to compute. Now, for comparing two or more distributions, we need absolute or relative? Yes, relative. So who are dependent upon units? Absolute measures are dependent upon units, but relative measures are unit free. Okay, so characteristics of an ideal measure of dispersion. So guys, these are copy pasted from characteristics of an ideal measure of central tendency. What are the characteristics of an ideal measure of central tendency? It is rigidly defined, easy to calculate, easy to understand. It should be based upon all observations, right? It should not be affected by extreme observations. It has higher sampling stability, means it must be least affected by sampling fluctuations, and it should have some desirable mathematical properties, and it is used for further algebraic treatment. All these things are the criteria came from the ideal measure of central tendency. Now let's talk about the first measure of dispersion. So the first absolute measure of dispersion is range. So what is the definition of range? For a given set of observations, range may be defined as the difference between largest observation and smallest observation. Guys, let me repeat. For a set of observations, range may be defined as the difference between whom and whom? Largest and smallest observation. It is the difference between largest and smallest observation. And the corresponding relative measure of dispersion is coefficient of range. And the formula for coefficient of range is L minus S by L plus S into 100. Here I just wanted to warn you one thing, guys. Sometimes he'll give you the value of coefficient of range in terms of percentage. But sometimes he'll give you the value in terms of decimals. Whenever you come across an option in which coefficients are in terms of decimals, means he is not taking this into 100 into the consideration. It is completely up to him, guys. We don't bother about that. We don't need to bother about that. So if your data or if your answer is in terms of more than 1 for coefficient of range, if your answer is more than 1 means it is into 100. But if your answer is like 0.55, 0.76 like that is there means He's skipping or he's avoiding multiplying with 100. So what is the formula for range? Largest observation minus smallest observation. And the formula for coefficient of range is L minus S by L plus S. Guys, when it comes to discrete series and continuous series, I'll tell you who is largest and who is smallest while explaining MCQs. Now, the next important thing that you need to learn about range is affected due to change of scale. Range is unaffected due to change of origin. Because if my observations are 1, 2, 3, 4, 5, what is biggest observation? 5. Smallest observation? 1. Difference is how much? 4. Keep in your mind that range is 4. Now let me add 10 to all the observations. 11, 12, 13, 14, 15. Guys, can you please tell me the range? 4 again. Means even if you add a fixed constant to all the observations, there's no change in the range. But if you multiply it with 10, 10, 20, 30, 40, 50, what is your range? Yes, how much? 40, right? So range is affected due to scale. But here I must tell you one thing, guys. Listen to me. If I multiply it with minus, so this one is a very important observation that you need to look at this. What is my biggest observation, guys? Take care of this. My largest observation is minus 10, guys. And my smallest observation is minus 50, guys. What is the formula for range? L minus S means minus 10 minus of minus 50. What is minus of minus 50? Plus 50. What is your answer? 40. Means even if you multiply your numbers with minus 10, your range is the multiple of plus 10. Means range is not only range, all the measures of dispersion are unaffected due to change of scale. Sorry, unaffected due to change of sign. They're just affected due to change of scale and they're not affected due to change of origin. Simply, if y equals to a plus bx, right? Range of y equals to, guys, tell me, what is the range of constant? 0. Because if all the observations are constant, what is your range? 0. So what is the arithmetic mean of constant? Constant itself, try to understand. So range of A is 0. And it is multiplied by B. I don't know whether B is positive or negative, but I am unaffected due to sign no. That is the reason why I'll write mod B into range of x. What is it I'm writing? Mod B into range of x. For example, if you come across an equation like this, ax plus by plus c equal to 0. Guys, forget about all the signs. Simply write mod a into range of x is equals to mod b into range of y. Mod a into range of x is equals to mod b into range of y. So range is unaffected due to origin and sign, but it is affected due to scale. Of course, sign is also part of scale, guys, but I'm writing it particularly because you must understand this negative sign will not affect range, not only range. All the measures of central tendency, all the measures of dispersion are unaffected due to origin and sign, but they are affected due to scale. So means they are affected due to multiplication and division, but not even affected due to a sign. Try to understand. That is another important property of range. So guys, what is the formula for range? L minus S, and range is, so guys, now look at your range formula that is there in your textbook. So what is the meaning of range? For a given set of observations, range may be defined as the difference between largest and smallest observation. If L is the largest observation and S is the smallest observation, range equals to L minus S. And the corresponding relative measure of dispersion is L minus S by L plus S, which is also called as coefficient of range. Now I'll tell you what is a range when it comes to a discrete series and a continuous series. Let's get into MCQ part, guys. So guys, I'm taking some of the examples here from range and coefficient of range and their properties. So let me show you my first MCQ here. The first MCQ that I've taken is MCQ number 1. So guys, just be focused here. Following are the wages of how many workers? 8 workers expressed in rupees, means all these values are expressed in rupees. Try to understand. So what is the wage of first worker? 82 or 82 rupees? 82 rupees, try to understand. Next worker 96, next worker 52 rupees, next 75 rupees, next 70 rupees, next 65 rupees, next 50 rupees, and then next 70 rupees. Find the range and also its coefficient. Guys, tell me the formula for range. Range means largest observation minus smallest observation. Can you please observe what is your largest observation? I can see 96 as my largest observation and I can see 50 as my smallest observation. So guys, what is your largest observation? Tell me. 96 or 96 rupees. 96 rupees and my smallest observation is 50 rupees. Try to understand. What is the formula for range? L minus S. 96 minus 50 rupees. 96 rupees minus 50 rupees is what? Yes, 46 rupees. Got it, guys? So my range is 46 rupees. Now, what is the formula for coefficient of range? Tell me the formula for coefficient of range. Coefficient of range is equals to L minus S by L plus S into 100. All of you, tell me what is L minus S? 46 rupees. What is L plus S? 146 rupees, no? Into 100. Can I cancellate rupees and rupees? And tell me what is 46 by 146 into 100? 31.51, guys. It means if you observe this, absolute measures are unit dependent, relative measures are unit free. Got it, guys? So that's how you can calculate the range. Now let's have a look at the next MCQ, and the correct option for this is option A only, right? So let's have a look at next MCQ. Next MCQ that I have chosen is MCQ number 5. The range of 10 observations is 20. If each item is divided by -2, then the range of new series is. So guys, let me assume that the old series is X. What is the range of X series? 20. So I'm writing range of X equals to 20. Range of X equals to 20. And each observation is divided by what? -2. Means it is given that Y equal to X by -2. Then tell me what is range of Y equal to? I've told you. Range of X by modulus of -2. What is modulus of -2? 2. And range of X 20. 20 by 2, your answer is 10. Guys, try to understand your answer is not -10. Your answer is +10. As it is unaffected due to sign, the correct answer is option B. Now the next MCQ is MCQ number 8. Read out the MCQ. If the relation between X and Y is given by 2X plus 3Y equal to 10, then the range of Y is 10. Then what is the range of X? So guys, what is the relation between X and Y? 2X plus 3Y equal to 10. So guys, simply I am writing the relation between X and Y is 2X plus 3Y minus 10 equal to 0. Guys, try to understand. Range is unaffected due to origin and it is not affected due to sign. It is just affected due to scale. That is why just write this way. Mod 2 into range of X is equals to mod 3 into range of Y. Write it that way. Mod 2 into range of X is equals to mod 3 into range of Y. What is range of Y according to your question? 10. So means range of X is equals to 3 into 10 by 2, which is going to be 15, and that is there in option D. So try to understand the relation, guys. Whatever it is, write down the coefficient with modulus and write down the coefficient with modulus at the other side. That's how you can solve the MCQ. Now let me show you the next question. MCQ number 10. So guys, this is a very easy MCQ. So let's have a look at the MCQ first. So guys, look at the question. The frequency distribution of rows per plant on 50 plants in a garden as follows means there are 3 roses per a plant. How many such plants are there? 5 plants. Means 5 plants bloom 3 roses. That's what he's trying to convey. 8 plants bloom 4 roses. That's what his question is. Try to understand. So, find the range and its coefficient. Guys, tell me. We are talking about the frequency distribution of what? Roses per plant. That roses per plant is your X and the next one is your frequency. Range is not at all bothered about frequency, guys. So listen to me. To calculate range, you must understand who is the biggest observation, means biggest X value. What is the biggest x value? 12. That is considered as L. And the smallest x value? 3. That is considered as S. Tell me the formula for range. L minus S is, it means 12 minus 3. 12 minus 3 means how much? 9. Now, what is the formula for coefficient of range? L minus S by L plus S into 100. But guys, just now I told you, if your answer exceeds 1, he might have given you the answer in terms of into 100. Otherwise, he has given you the answer in terms of just L minus S by L plus S. What is L minus S, guys? 12 minus 3, 9. By L plus S, 12 plus 3, 15. What is 9 by 15? First tell me. 0.6, and that is there? No. Otherwise, the answer will be 9 and 60%, because into 100, if you do into 100 means you will get 60%. Guys, listen to me. You actually need to do into 100. And that option is not there, not even none is there. Then I have to verify that without into 100 whether I am getting the answer or not. If you are getting, keep it as a correct answer. Okay guys, now let's have a look at MCQ number 11. So guys, look at this question. It's such an important question. You must understand the process of calculating range. What is the coefficient of range for the following distribution? So how to calculate the coefficient of range? So guys, coefficient of range formula is L minus S by L plus S into 100, right? So who is L? Listen to me guys. L is the upper class boundary of last class after the class has been arranged in ascending order. Are the classes arranged in ascending order? Yes. But if you look at the series, this is an inclusive series or exclusive series. This is an inclusive series. But I'm talking about boundaries, means my series must be exclusive. Madam, do we need to convert the entire series into exclusive? You don't need that, guys. So first of all, look at the difference between 20 and 19. How much? 1. D is 1. What is D by 2? 0.5. So to calculate the lower boundary, subtract 0.5. To calculate the upper boundary, add 0.5. Like that. What is the difference between 49 and 50? 1. Difference. 1. D by 2, 0.5. So to calculate the lower boundary, subtract 0.5, and to calculate the upper boundary, add 0.5. So I recommend you to do for the first class and last class only. Now, what is L? So guys, L means lower class boundary of first class. Which class? First class. So who is L? L is the lower class boundary of first class. S means, sorry guys, L is the upper class boundary of last class. L is the upper class boundary of largest value. No, sorry for it guys. L is the upper class boundary of last class. What is your last class? 49.5 to 59.5, and L is the upper class boundary. Yes. S is the lower class boundary of first class. What is your first class? 9.5 to 19.5, and this is yes. Now, you have L and S, no? Calculate tell me the formula for coefficient of range. L minus S by L plus S into 100. Take your calculator and tell me what is 59.5 minus 9.5. Yes, 50 by L plus S. 59.5 plus 9.5. How much? 69. So your answer is 50 by 69 into 100, no? So 50 by 69 into 100. And your answer is 72.46, and that is there in option D. Guys, if you don't read out the question, most of the people will keep option B as the correct answer, as just they will calculate range, and the range is 50 only. So they will keep option B as the correct answer. So read out the question correctly. So we have to calculate the coefficient of range, but not the range. So guys, what is the formula for range? L minus S. Coefficient of range? L minus S by L plus S. Who is the L? Upper class boundary of last class? Yes. Lower class boundary of first class after the classes have been arranged in ascending or ascending order of magnitude, not in descending order even. So that's what you need to understand. Now, this is what about MCQs related to range, guys. Now, I'm directly moving into the theory because you are in such a position to understand the theory only after the completion of problems, guys. You must understand what is an extreme observation. You must understand what is a sampling stability and all. These things that you can learn only after the completion of MCQs related to problems, guys. Now, let's talk about the merits and drawbacks of range. Is range is easy to compute or difficult to compute? Easy to compute. Of course, easy to understand also. So for a common man also, guys, verify the biggest observation or smallest observation means he'll do it in such a quick manner, no? Yes, but is it dependent upon all the observations or only few observations? Two observations. So the drawback advantage is it is easy to understand and easy to calculate. But the drawback is it is based upon only two observations. So guys, is it rigidly defined? Yes, as it is dependent upon a particular formula, it is rigidly defined. There is no doubt about it. Now guys, tell me, what is the formula for range? L minus S means biggest observation minus smallest observation. They are extremes? Yes, it means range is dependent upon extremes. So it will definitely be affected by extreme observations. Yes, range is highly affected by extreme observations as range itself is based upon extreme observation. And one more thing, for a continuous series, you are calculating the range based upon, based upon first class lower boundary and last class upper boundary. But for an open-ended classification, do we know the first class lower boundary and last class upper boundary? No. Means we can't calculate range, or a range is indeterminate for open-ended class interval. As for an open-ended class interval, we don't know the first class lower boundary and we don't know the last class upper boundary. Those two are essential to calculate range. So for open-ended classification, we can't calculate range. And one more thing is, I told you, what is the use of calculating these absolute measures and relative measures of dispersion? Yes, range, whatever the measure of dispersion it is, it must identify the exactness of average. Now, where is the average here? Who is the average here? So, if you are talking about a measure of dispersion is here to calculate or to identify the exactness of average. Where is the average? Where is the measure of central tendency here, guys? Means we are not calculating any scatterness here. Means it is very indeterminate. We can't use it for practical purpose. The practical purpose of your dispersion topic is to understand or to identify whether your measure of central tendency perfect or not. We are not doing that. So it is very indeterminate indefinite, as it can't be used for any practical purpose. And one more thing, it is highly affected due to sampling fluctuations, guys. Now let's talk about the uses of range. So guys, you are aware of the word range chart. So guys, when it comes to any equipment or anything, you people will find tested OK as a symbol. Tested OK. You'll just find out tested OK symbol at anywhere on the product. Means I'm not talking about groceries and all, guys. I'm talking about, suppose whenever I'm talking about locks. So on that lock, at the bottom of that lock, you can see a small thing, a small sticker pasted like tested OK. So that testing is very much essential to control the quality of a product. So that is called as quality control department. That quality control department uses range chart to control their quality, to control their problems, or to control their mistakes, or else I can say to control their defective products. Yes, on a particular day or during particular 1 hour, they'll talk about the range of defectives, means least number of defectives and highest number of defectives through the production process. For every 1 hour, the production completes, let it be. So, totally in a day, let us assume that 10 hours of operations is happening. So, they'll identify the number of defective products during the first session, second session, 10th session, and they will calculate the range of defectives during that day. And they will present it by means of range charts by using day 1, day 2, day 3 and number of defectives on y-axis. So they will calculate range charts. So this range chart will give you a brief identification for the number of defectives. On a particular day, the range became this much. Range became this much. Means number of defectives got increased. No. It means there is a problem with that machine. If there is a problem with the machine, you have to adjust that machine. You have to correct that machine. You have to repair that machine. And then only you have to start the production. No. So in such quality control cases, in order to control the quality of a product, in order to give the better quality, so many quality control departments use range charts as their handouts. The next thing is to calculate the variation in money rates and of course share values. They'll present a chart that is called as range chart. Yes, of course, meteorological department will forecast weather based upon these range charts only. So the many uses for range, but it is not directly fulfilling its required purpose, as the requisite purpose of your measure of central tendency is to identify the exactness of average. That is not happening here. Now let's talk about the properties of range. So guys, you all know range is unaffected due to change of origin, but it is affected due to scale. Got it? And same property will be applicable for all the measures of dispersion. Yeah, now coming into the next concept called quartile deviation. So what is a quartile deviation? So guys, the word quartile deviation is also called as semi-inter quartile range. So guys, let's talk about the last word. What is your last word? Quartile range. Do you guys know what are quartiles? Yes, we know very well. How many quartiles will be there? 3 quartiles. What are they? Q1, Q2, Q3. Tell me guys, who is the highest quartile? Because the observations are arranged in ascending order, Q1 is the least number, Q2 is the middlemost number, Q2 is the biggest number. No. As the observations are arranged in ascending order, you must understand that Q1 is the smallest value, Q2 is the middle value, Q3 is the highest value. Now tell me guys, what is the meaning of range? Largest observation minus smallest observation. Who is the largest quartile? Q3. Who is smallest quartile? Q1. Tell me the quartile range. Q3 minus Q1. So quartile range or interquartile range means within quartiles range. What else is there? Semi. Semi means half. So this is called as quartile deviation. So let's talk about this. It is half of the difference between upper quartile and lower quartile. Now let's talk about the first point. This measure of dispersion is based upon upper quartile Q3 and lower quartile Q1. So the difference is the range between two quartiles, which is called as interquartile range, and half of this range is semi-interquartile range. That's why we'll call quartile deviation as semi-interquartile range. Now, what is a quartile deviation? Here I must tell you one thing guys. If the distribution is symmetrical, second quartile or median equals to Q3 plus Q1 by 2 whenever the distribution is symmetrical. Now, the formula for coefficient of range is coefficient of quartile deviation equals to actually quartile deviation by median into 100. Tell me the formula for quartile deviation. Q3 minus Q1 by 2. Tell me the formula for median. Q3 plus Q1 by 2 into 100. Tell me guys, who are going to be cancelled? By 2, by 2. What else is left? Q3 minus Q1 by Q3 plus Q1 into 100. That is called a relative measure of dispersion, which is known as coefficient of quartile deviation. Got it guys? So this is the introduction to quartile deviation guys. Try to understand. Quartile deviation is an absolute measure. Coefficient of quartile deviation is a relative measure. So this relative measure is dependent upon quartile deviation by median into 100. Got it guys? Now let's get into the MCQ part guys. Means I'm talking about problems that are related to quartile deviation. Then only you are in such a position to understand the theory related to quartile deviation. Okay. So let's get into the MCQ part guys. The first MCQ that I have taken here is MCQ number 12. So let me show you the MCQ, guys. Following are the marks of 10 students. 56 marks, 48 marks, 65, 35, 42, 75, 82, 60, 55, 50. Find the quartile deviation and also its coefficient. Guys, try to understand. It's not that easy. You have to be more attentive, because if even one observation is missing, you have to recollect everything. So try to strike off the values that you have already written. So to calculate quartile deviation, we need Q1 and Q3. For that, data must be arranged in ascending order. Let's get into the order. The least observation here is, it seems, 35, and then 42, and then 48, and then 50. So let me write down the observations. 35, 42, 48, 50. Just a moment, guys. So I've told you 35, 42, 48 and 50. Let's talk about the remaining observations also. Next, 55, okay, 56, 60, let me write 55, 56, 60. Next, 65, 75, 82. 65, 75, 82. So how many members are here actually? 10 members. So what is n equals to? 10. Guys, let me write down the formula for Q1. Q1 equals to, I told you, 1 into n plus 1 by 4th term. Try to understand, 1 into n plus 1 by 4th term. So what is n? 10. 10 plus 1, 11. What is 11 by 4 equals to? 2.75 the term. So guys, I got 2.75 the term. Let me write the meaning of 2.75 term. I have already told you in central tendency, guys. It is second term plus 0.75 into third term minus second term. So guys, you need to take your calculators. Tell me what is your third term. 48 minus 42, how much? 6. This is 6. 6 into 0.75 plus, what is your second term? 42. What's your answer? 46.5. How much? 46.5. That's what Q1 is. Now, let me calculate Q3. So, what is Q3 equals to, guys? Q3 equals to 3 to n plus 1 by 4th term. As you already know, n plus 1 by 4th means 2.75. 2.75 into 3 is how much? Just a moment, guys. 2.75 into 3 is 8.25 term. So 8.25 term, how do you write? 8th term plus 0.25 into 9th term minus 8th term. So what is your 8th term? Take your calculator, sorry, 9th term. 75, no? 75 minus 65, how much? 10. 10 into 0.25, which is 2.5 plus 8th term. What is your 8th term? 65. Put together it is 67.5. So, we are just done with quartile calculation. There is something else to calculate. So, tell me the formula for quartile deviation, guys. Q3 minus Q1 by 2. Take your calculator. 67.5 minus 46.5 by 2. How much? 10.5. So, your quartile deviation is 10.5. That is there in option A. But option D, none. So, we need to do coefficient of quartile deviation also. What is the formula for coefficient of quartile deviation? Q3 minus Q1 by Q3 plus Q1 into 100. Madam, why you are writing into 100? Because all the coefficients are more than 1, no? So, I can use into 100. Now, let's calculate. 67.5 minus 46.5. What's your answer? 21 by 67.5 plus 46.5, which is 114. 21 by 114 into 100. Do that. It is 18.42, and that is there in option A. So guys, you must understand one thing. It's not that easy to calculate, but You have to do it in a systematic way. Then only the question will become easier one. Now let's talk about the next MCQ, guys. The next MCQ that I have taken here is MCQ number 18, guys. In the equation 4x plus 2y equal to 3, the quartile deviation for y is 3. Then find the quartile deviation of x. Guys, let me tell you, like range, quartile deviation is also unaffected due to origin and sign. It is just affected due to scale. So simply write 4x plus 2y minus 3 equal to 0. Now tell me the relation between their quartile deviations. Modulus 4 into quartile deviation of x equals to modulus 2 into quartile deviation of y. As the coefficient of x is 4, keep modulus. As the coefficient of y is 2, keep modulus in front of that. What is the quartile deviation of y? 3. Let it be 3. So 2 into 3, 6. 6 by 4, 1.5. And the correct answer is option C. That's how you can calculate the quartile deviation based upon equation model, and this is called as completely this will be called as change of origin and scale criteria. Now let's have a look at MCQ number 19. The value of appropriate measure of dispersion for the following distribution of daily wages is given by. So guys, we have to calculate the appropriate measure of dispersion. So we have range, we have quartile deviation, that's what we have learned. So guys, tell me, is range is determinate or indeterminate for open-ended classes? As I can see, my question is of open-ended classes. I can't calculate range. So guys, tell me, quartile deviation is based upon whom and whom? Third quartile and first quartile. If you observe the data, this is your first quartile, this is your second quartile, this is your third quartile, which divides the data into 4 equal parts, no? Means 25%, 25%, 25%, 25%. If you look at Q1, it is after 25%, no? Or at 25th percent. Means the first 25% I am not bothered about it. If you look at Q3, I am not bothered about last 25% because it is at before that, no? Means this first 25 has first class and this last 25 has last class. So my quartile deviation is based upon this middlemost criteria. Means my quartile deviation is the best choice that I can go for on open-ended distribution. In case of open-ended classes, this fellow is the best because this fellow depends upon middle 50%. Open-ended classes lies at the starting or ending. This fellow exactly lies between the here and here only, right? Means this quartile deviation is taking account into how many observations? Only 50%. Means you must understand. This quartile deviation is based upon only 50%, means it is not based upon all the observations. Try to understand that it is not dependent upon all the observations. Got it, guys? So quartile deviation is dependent upon middle 50% and it is don't have any problem with first 25 and last 25. Means it is the best choice for open-ended classification. So this is the best one. Next thing. Try to calculate quartiles. How to calculate quartile? To calculate quartiles, first of all, data must be arranged in ascending order or descending order. Let me write below 30. Below 30. Next 30 to 39. Next 40 to 49. Next 50 to 59. Just a moment, guys. 60 to 79 greater than or equal to 80. 60 to 79 greater than or equal to 80. Let me write down frequencies. What are my frequencies? 5, 7, 18, 32. 5, 7, 18, 32. And of course 28, 10. So this is my class interval and this is my frequency. Now let me go for LCF. So tell me, 5 plus 7, 12, 12 plus 18, 30, 30 plus 32, 62, 62 plus 28, 90, 90 plus 10, 100. Means your total frequency is 100. Have to calculate Q1 or Q3. Q1 means the formula is, let me write down the formula, L plus N by 4 minus M by F into C. What is N, all of you? 100. Your N is 100. Now tell me, what is N by 4? 25. Identify the class in which 25 was just exceeded in the less than cumulative frequency. 25 just exceeds 25. Yeah, this class. This is first quartile class. Okay. So L is the lower class boundary, guys. What is your lower class boundary? Is it 40 or 39.5? Yes, 39.5. N by 4. What is N by 4? 25. Minus M. M is the cumulative frequency of its preceding class. By F. F is the frequency of this class. Into C. C is the class length of this class. What is the class length of 40 to 49? It's actually 39.5 to 49.5. No, it is 10. Take your calculator. 25 minus 12 by into 10 by 18 plus 39.5, and your answer is 46.72. So your first quartile is 46.72. Now let me calculate third quartile. What is the formula for third quartile? Q3 equals to L plus 3n by 4 minus m by f into c. What is your n? 100. 3n by 4 means 300 by 4. What is 300 by 4? 75. Now guys, could you please observe the cumulative frequency which was just exceeding 75? Yeah, this one. What is L? 59.5. 3n by 4, 75 minus m, preceding class cumulative frequency 62 by f, frequency of median class. Frequency of third quartile class into class length. Guys, try to understand. This is 59.5 to 79.5, which class length is 20. So 75 minus 62 into 20 by 28 plus 59.5. Put together, it is 68.78. How much it is? 68.78. Now, you know what is first quartile and you know what is third quartile. Tell me the formula for quartile deviation. 68.78 Q3 minus Q1 46.72 by 2, and the answer is 11.03. What is your answer? 11.03, and that is there with option B. So guys, 11.03, sorry, option A. So that's how you can calculate the quartile deviation. So now, let me tell you one thing. Quartile deviation is based upon how many observations, guys? All the observations? No, it is just based upon middle 50% of the observations. Try to understand. Means it is also not based upon all the observations. Okay. So, but it is the best measure for open-ended distribution. Now, one more thing. Who are extremes? Where do extremes lies? At the beginning or at the ending? But quartile deviation lies at the middlemost place. No. So, quartile deviation is not affected by extreme observations, as the first 25% we are leaving, last 25% we are leaving. No. So, now, is it based upon all the values? No. Next. Is it useful for further algebraic treatment? No, because as Q1 and Q3 are based upon position, they are not based upon all the values. Now, is it really showing the scatterness? What is the meaning of scatterness, guys? You have to calculate an average, and then you have to calculate the difference, and then you have to calculate the average. Any sort of that thing happened? Nothing. So means it is not showing any kind of scatterness around the average. It is just showing the difference between Q3 and Q1. It is showing the distance between Q3 and Q1. But in case of a high degree of variation, means if the deviation is so high, we can't calculate the perfect deviation. No. Then how do you use quartile deviation or even range? We can't do that. Next, you know that there is only one property for quartile deviation, which is quartile deviation is unaffected due to origin and sign, but it is affected due to only scale. So coming into the next important concept, which is mean deviation and coefficient of mean deviation. So guys, what is mean deviation? The name itself is saying, I'm writing the mean deviation definition, guys. The definition of mean deviation is mean of absolute deviations from any measure of central tendency. From any measure of central tendency. Let me underline, any measure of central tendency. It can be either mean or median or mode. Let me talk about mean deviation from mean. Mean deviation from mean is denoted by mean deviation from x bar, and that is equals to mean. Means sum of observations by number of observations. Mean of what? Absolute. Absolute means I'll keep modulus. Deviations from mean. Yeah, this is the formula for mean deviation from mean. Now, can you please tell me the formula for mean deviation from median? Summation modulus x minus median by n. Mean deviation from mode, summation modulus x minus mode by n. Guys, we'll not talk about mode, as mode is not based upon, as mode is not a good measure of central tendency. So in this concept also, we'll just tell you what is the meaning of mean deviation from mode, but these applications are not so considered, guys. They're completely ignored. Now, if it is discrete series, what is your formula? Summation f into modulus x minus x bar by capital N, the same formula. Summation f into modulus x minus median by capital N. If it is about mode, summation f into modulus x minus mode by capital N. These are the formulas for mean deviation from mean, mean deviation from median, mean deviation from mode. So what about coefficient of mean deviation? Coefficient of mean deviation from mean equals to mean deviation from mean by mean into 100. Now, can you guess the formula for coefficient of mean deviation from median? Mean deviation from median by median into 100. What is the formula for coefficient of mean deviation from mode? Mean deviation from mode by mode into 100. So, what is the formula? What is the definition of mean deviation, guys? Mean of absolute deviations from any measure of central tendency. Mean of absolute deviations from any measure of central tendency. So, guys, range and quartile deviation are not based upon all observations, but mean deviation is a better measure as it is based upon all the observations. So, I have provided you all the formulas that are related to mean deviation, guys. So, this is what the introduction to mean deviation. Now, let us get into the MCQ part that is related to mean deviation. Let us see the first MCQ that is related to mean deviation, guys. Look at MCQ number 23. So, what is MCQ number 23? The mean deviation about mode for the numbers 4 by 11, 6 by 11, and of course 8 by 11, 9 by 11, 12 by 11, and 8 by 11. So, guys, we have to calculate the mean deviation about, look at this, mean deviation about mode. How do you calculate mode and what is a mode? Mode is the highest focused observation, right, or highest repeated term, right? Who is highly repeated term? What is highly repeated term? Tell me. Look at the data. Yes, 8 by 11 got repeated 2 times. Means your mode is 8 by 11. Now, let me write down the formula for mean deviation from mode. Mean deviation from mode is summation modulus x minus mode by n. So, what is n? How many observations are here? 1, 2, 3, 4, 5, 6. 6 observations are here. It means n equal to 6. Now, we have to calculate the difference between the observation and the mode. What is 4 by 11 minus 8 by 11? It's actually minus 4 by 11, but there is a modulus symbol, so we have to take only 4 by 11. Okay. Next, 6 by 11 minus 8 by 11 is actually minus 2 by 11, but there is a modulus symbol, so I'm writing plus 2 by 11. Next, 8 by 11 minus 8 by 11, how much? 0. 9 by 11 minus 8 by 11 is 1 by 11. 12 by 11 minus 8 by 11 is 4 by 11. Next, 8 by 11 minus 8 by 11 is 0. Now, tell me what is your numerator? 4 plus 2, 6 plus 1, 7 plus 4, 11. What is 11 by 11? 1. So, your answer is 1 by 6 means whatever the measure of central tendency that you need to calculate, calculate it first and then simply use the formula called summation modulus x minus that measure of central tendency by number of observations. Got it, guys? So, now let's have a look at the next MCQ. The next MCQ is MCQ number 25. If the mean deviation of the observations 1, 2, 3, 4, 5 and so on is 1.2, then the mean deviation of the observations 5, 10, 15, 20 and so on is what? Guys, if you look at the first set of data and second set of data, what kind of change is made to get the second set of data from the first set of data? Yes, first set of data is multiplied by 5 to get the second set of data. Let me assume that first set of data is represented by the series X. Okay. Now tell me, what is mean deviation of X? Mean deviation of X is 1.2. Now we have to calculate the mean deviation of Y series, which is a newly added series, and this series is obtained by multiplying X with what? 5. So Y equals to 5X. So guys, unlike, like range, mean deviation is also affected due to only scale and not even sign. It means mean deviation Y equals to modulus 5 into mean deviation X. What is mean deviation X? 1.2 into 5, because modulus 5 is 5 only, right? So what is 5 into 1.2? It is 6, guys. So that's how you can calculate mean deviation of the new series. Now let's have a look at MCQ number 27. If the two variables X and Y are related by 2X plus 3Y minus 7 equals to 0. So 2X plus 3Y minus 7 equals to 0, and the mean and mean deviation about mean of X are 1 and 0.3. So mean is 1 and mean deviation is 0.3. Then the coefficient of mean deviation of Y about mean is mean deviation of Y needs to be calculated. So guys, what is the relation between X and Y? 2X plus 3Y minus 7 equals to 0. So now I can write 2X bar plus 3Y bar minus 7 equals to 0. What is X bar according to the question? 1, no? Let me replace X bar equals to 1. What is 2 into 1 bar? Sorry, 2 into 1, 2. 2 minus 7 is minus 5. If that minus 5 comes to the right side, it will be plus 5. Means 3Y bar equals to 5, and hence Y bar equals to how much, guys? 5 by 3. So I have calculated Y bar, and then now I need to calculate the mean deviation of Y. So guys, the relation between X and Y is 2X plus 3Y minus 7 equals to 0, no? Then you can write modulus 2 into mean deviation of X is equals to modulus 3 into mean deviation of Y. So what is mean deviation of X according to the question? 0.3. So now tell me, what is 2 into 0.3? 0.6 by 3. It is how much? 0.2. So mean deviation of Y equals to 0.2. So guys, tell me, what is it you need to calculate? Coefficient of mean deviation of Y. So tell me the formula for coefficient of mean deviation of Y. Coefficient of mean deviation of Y from its mean is mean deviation of Y from its mean by Y bar into 100. What is the mean deviation of Y from its mean? 0.2 by 5 by 3 into 100. Guys, do one thing. If this 5 by 3 comes to numerator, it will be 3 by 5, no? So do one thing. 0.2 into 3 by 5 into 100. So how much? 12%. So what's your answer, guys? 12%. And that is there in option B. So it's all about understanding the relation between X and Y. So and try to understand mean deviation is a measure of dispersion which is affected due to only scale. But mean is a measure of central tendency which is affected due to both change of origin and change of scale. Now guys, I'll tell you a very easy trick to identify mean deviation of a set of n observations when they are in AP. If the given set of observations are in AP, then the formula to calculate mean deviation is n square minus 1 by 4n into d. Let me repeat, n square minus 1 by 4n into d is the mean deviation of the observations which are in AP. In an AP, if there are n observations with common difference d, then the formula to calculate mean deviation is n square minus 1 by 4n into d. Got it, guys? So mean deviation equals to n square minus 1 by 4n into d when observations are in AP. Now let's have a look at the next MCQ, which is MCQ number 29. So calculate the mean deviation of the observations 10, 11, 12 and so on 30. So guys, here what is it you need to understand? Means how many observations are there? Yes, they are continuity, no. Means they are in AP with a common difference of d equals to 1. So now guys, try to understand how many observations are there. So how to calculate the number of observations? Guys, from 11 to 30, how many observations are there? You can tell me. 20. And there is another observation which is 10. Together 21 observations. Or else, In your sequence series of mathematics, there is a formula to calculate the number of terms, which is number of terms n equals to last term minus first term by common difference plus 1. What is your last term? 30 minus first term 10. 30 minus 10, 20 by common difference 1. 20 by 1 is 20 plus 1. Together, how many terms are there? 21 terms. It is completely up to you guys. So, if you want to use that formula, you can. So, now you said that n equals to 21, no? And what is your common difference? 1 only. So, take your calculator. 21 square minus 1 by 4 by 21 into common difference is how much? 1. And I got the answer of 5.23. See how simple it is if you know the formula. So, guys, you know, if he asked you to calculate the coefficient of mean deviation also, this is the formula to calculate the mean deviation from mean, guys. You need to understand that. So, it's not mean deviation about median, or it's not about mean deviation about mode. This formula n square minus 1 by 4n into d is the mean deviation of n natural numbers which are in AP, or n observations which are in AP, which is nothing but mean deviation from mean. Now, you know that what is the formula to calculate the arithmetic mean if the observations are in AP? First term plus last term by 2. If he asked you to calculate the coefficient of mean deviation, you can calculate mean deviation by using formula, and you can calculate mean from the formula. Got it? So, now you can easily do that. Try to understand. Okay. So, it's all about understanding the formula, guys. Now, let's have a look at the next MCQ, which is MCQ number 34. Yeah, sorry, guys. That's all about mean deviation related questions, guys. Now, let us get into the theory concept that is related to mean deviation. Guys, I've already told you, mean deviation can be calculated from how many measures of central tendency? 3 measures, no. One is mean deviation from mean, the other one is mean deviation from median, the next one is mean deviation from mode. In general, is mean equals to median equals to mode? No such restriction. Means all these 3 measures are quite varying, no. That is the first drawback. If nothing is specified, what will you calculate? You need to calculate the mean deviation from mean only if nothing is specified. So guys, if we particularly said that you have to calculate mean deviation from median, everybody in the universe will get the same answer or different answer? Same answer only, right? It means it is rigidly defined by a particular formula. There's no doubt about it. But to calculate the mean deviation, we have to understand there is summation, there is modulus, and there are all deviations like that. Means if this average is in terms of fractions, every time if it is 2.578125, it's not that easy to calculate the difference, guys. You need to understand that. So means if your average is in terms of fractions, it is very difficult. It takes more time. Okay, sometimes there is a chance of getting error also, because we human beings makes errors. Definitely, it's a huge number, means taking substitution also takes a lot of time, no? So in that hurry, instead of 2.52, if I write 2.25, I'll definitely get error. So means there is a problem, or there is a difficulty in calculating mean deviation if the average is in terms of fractions. And one thing, there's no chance of calculating combined mean deviation, so it is not suitable for further algebraic treatment. And one more thing, what is the uses of measures of dispersion, guys? To identify the accuracy of given measure of central tendency, right? We already know that mean deviation, mode is not a good measure of central tendency. What is the use of verifying the accuracy of mode here by using mean deviation? No use, no, because we already told to everyone that mode is not a good measure of central tendency compared to mean and median, right? Yeah, it is useful in many cases, but compared to mean and median, it is not so good, no. Then what is the use of verifying accuracy of mode here? It is a time waste task, no? Yeah, that is another thing. But let me tell you a very important thing. So, I have told you that absolute measures means you have to take an average, and then you have to calculate the deviations, right? You have to take an average, and then you have to calculate the deviations, and then you have to calculate the sum of all of them, and then you have to calculate the average of all these fellows. All these things are being done here. Means it's completely satisfying the property of absolute measure. But there is a problem. So guys, let me assume that my average marks of a class is 50 marks. And one student got 45 marks. The other student got 55 marks. So if I am calculating mean deviation, means I'll calculate 45 minus 50 modulus. What's my answer? 5. I'll calculate 50 minus 55 minus 50 and I'll calculate the average. No, it means for the person who got 45, you're getting a deviation of 5. For the person who is getting 55, who got 55, he's also getting the same deviation. Means we are giving the same preference to the person who got 45 marks in the exam and 55 marks in the exam. How is it accurate, guys? How is it suggested? Tell me. We are giving the same preference to plus 5 and minus 5. It means he is not discriminating plus 5 and minus 5. How is it possible? It's not so correct. No. It means mean deviation is so accurate at some point of view, but it is not taking the it is taking the modulus sign. No. Means there is a problem. There is a problem. So it's not such accurate, but it is accurate, or it is a better one compared to range and quartile deviation. And one more thing, if you want to reduce the effect of extreme observations, it is better to take mean deviation from median, because median is least affected by extreme observations. No? Yes, got it, guys? When it comes to mean deviation from mean, median, mode, all these measures are based upon all the observations, because you know that median is not dependent upon all observations, but after calculating median, you have to calculate the deviation from median, no? So here every observation is included. Now the next advantage of, or the next merit of a mean deviation is, compared to range and quartile deviation, this has least sampling fluctuations. Means it is more stable compared to range and quartile deviation. Got it, guys? So what are the properties? As I already told you, mean deviation will be least if the deviations are taken from median, because we have a property that sum of absolute deviations from median is minimum. So if you take the average as median, then mean deviation will be minimum compared to mean and mode. Next, mean deviation is unaffected due to origin, but it is affected due to scale. Okay, it's not even affected due to sign. And that is all about mean deviation. Coming into the very important measure of dispersion, which is standard deviation. So guys, I'll tell you the meaning of standard deviation. So guys, to overcome the drawbacks of range, quartile deviation, mean deviation, we are coming towards a measure of dispersion called standard deviation. So standard deviation is denoted by the symbol sigma or S. If it is population standard deviation, we'll denote it with sigma, and if it is sample standard deviation, we'll denote it with S. As now we are calculating sample standard deviation only, we can denote it with S. What is standard deviation? For a set of observations, standard deviation may be defined as the square root of arithmetic mean of squares of deviations from arithmetic mean. So guys, let us write down the formula for standard deviation. Everybody look at this. Deviation from arithmetic mean means I have to write x minus x bar. Squares of deviation from arithmetic mean means x minus x bar whole square. Arithmetic mean of all these things. Arithmetic mean means sum of observations by number of observations. Square root of all these things. Yeah, this is what standard deviation is. Standard deviation equal to square root of summation x minus x bar whole square by n. Guys, try to understand the many formulas to calculate standard deviation. The first formula is summation x minus x bar whole square by n. This is one formula. And the next formula is square root of, same formula guys, after expansion it will be like this, summation x square by n minus x bar square. Do you know what is x bar? Yes, summation x by n. In case of continuous series, the formula will be square root of summation f into x minus x bar whole square by capital N, or else square root of summation fx square by capital N minus x bar square. Guys, what is x bar in the second case? Summation x by n? No, it is summation fx by n. The same formula will be used for continuous series where x represents the mid value of a class interval. So this is what the formula for standard deviation. Guys, let me tell you the drawback that is related to mean deviation. In mean deviation, we are calculating the deviations. but we are giving absolute symbol. That's a problem. That creates a problem, as it is giving the same importance to the person who got 45 and 55 that just now we have seen. That is the reason why instead of this modulus, I am applying square and then applying square root. Means I'm not avoiding any of the mathematical property. That is why standard deviation is a best measure, because the best measure of absolute measure of dispersion should be like this way. It has to talk about an average, deviations from average, average of deviations. Yeah, that's what we are doing. So it is going to satisfy all the properties that are related to absolute measure of dispersion. And one more thing I must tell you guys, if you know the merits and drawbacks of arithmetic mean, the same merits and drawbacks will be applicable for standard deviation as it is based upon arithmetic mean. So whatever the merits are there for arithmetic mean, they will all serve as merits of standard deviation. Whatever the merits are there for drawbacks are there for mean, they will serve as drawbacks for standard deviation, as standard deviation is completely dependent upon arithmetic mean. Now guys, you know what is a standard deviation. Now we have to talk about coefficient of standard deviation, no? So the formula for coefficient of standard deviation is standard deviation by mean only. Coefficient of standard deviation is standard deviation by mean, and the square of, sorry guys, S by X bar. If it is population means you have to write sigma. So guys, the square of standard deviation, S square, is said to be variance, and the corresponding relative measure of dispersion is called as coefficient of variation. The formula for coefficient of variation is S by X bar into 100. Means coefficient of standard deviation expressed in terms of percentages is called as coefficient of variation. What is the use of coefficient of variation? Whenever you want to compare the variability of two or more series, this is the best one. Coefficient of variation is the best one. So look at your theory part, guys. So I have already covered these points. The best measure of dispersion is standard deviation, as it is overcoming all the drawbacks that are there for mean deviation, quartile deviation and range, and it is based upon all the observations. No, so the idea of standard deviation was first presented by Carl Pearson in the year 1893, and I have told you the meaning of that, and I gave you the formulas of all these things, guys. Now if you look at the merits, guys, you can easily tell, because I've already told you the merits of standard deviation are nothing but the merits of arithmetic mean. So what is the first merit? It is based upon all those observations. It is rigidly defined. It has greater mathematical significance, and it is capable of further algebraic treatment. I'll tell you why, guys. There's the formula to calculate the combined standard deviation. Madam, what is the formula to calculate the combined standard deviation? S12 equals to square root of n1 into s1 square plus d1 square plus n2 into s2 square plus d2 square by n1 plus n2. So what is n1? Number of observations in the first set. What is s1? Yes, standard deviation of first set. Now what is d1? So guys, you know that what is x bar 1, 2? Yeah, x bar 1, 2 is the combined arithmetic mean, no? d1 is the difference between x bar 1 and x bar 1, 2. Got it? Difference between first set arithmetic mean and the combined average. And d2 is the difference between x2 bar and x12 bar. And what is x12 bar? Tell me the meaning of x12 bar. x12 bar equals to n1 x1 bar plus n2 x2 bar by n1 plus n2. Got it, guys? So that is what x bar 1, 2. Okay. So this is how you can calculate combined standard deviation. So I can say that it is capable of further algebraic treatment. As you all know, arithmetic mean is least affected by sampling fluctuations. The same thing is there. To compare variability, just now I told you, to compare variability, coefficient of variation is the best measure. No. Next, as it is based upon arithmetic mean, it has all the good qualities of arithmetic mean. That's what I'm telling you. Next, by using standard deviation, if you want, you can calculate the sum of squares of numbers. A summation x square also can be calculated. Okay. Got it, guys? So, but what are the drawbacks? It is very difficult to compute, guys. because it is based upon squares and square roots, no. So that's why it is not easy to understand and it is very difficult to calculate. Though it is very difficult to calculate, it is based upon all observations and it satisfies all the properties, no. So we have to do that. There is no other option. And one more thing, you know that square root means it gives more weightage to extreme values. Got it, guys? Next, it consumes more time. And tell me, standard deviation is an absolute measure or relative measure? Absolute measure. Can it compare two the series directly? No, it can't. So if we want to compare two series, we have to approach coefficient of standard deviation or coefficient of variation. What are the uses of standard deviation? So it is very much helpful in fitting a normal curve. In fitting a normal curve, mean and standard deviation plays a very important role. It is very much used in biological studies. For example, guys, so if you come across any blood test, they'll collect a sample, no? So, and they'll provide the information regarding your entire body blood samples. So, how is it possible? So, they'll just collect a sample, no? And they'll confine that study to population, no? There's a chance of getting error, no? So, yes, there always exists a deviation, no? So, means they will get some certain average. And they will provide you the limits based upon if they got certain average minus standard deviation is the lower limit, average minus average plus standard deviation is the upper limit. When you come across blood test reports, they'll get you the range of original values, ranges from this one to this one. They'll just calculate the average and they will calculate the deviation and they'll verify the range. So it is very much used in biological studies, guys. So it also helpful for, guys, here we are calculating the deviations from where? Arithmetic mean means here we are trying to verify the consistency of arithmetic mean, right? So what is the major purpose of our dispersion, guys? To understand or to verify whether the measure of central tendency is calculated by me in measures of central tendency was calculated by me is correct or not, right? So for that, we are using measures of dispersion. So here we are verifying the deviations from where? Arithmetic mean means in this topic, we are, in this concept called standard deviation, we are trying to verify the consistency of arithmetic mean. Got it, guys? So unlike, like all the measures of previous measures of dispersion, standard deviation is also unaffected due to origin, but it is affected by scale. All the measures of dispersion computed for a constant is 0. You all know. Got it, guys? So standard deviation should be more or less for the betterment, or if an average is good, means standard deviation should be less. Deviation should be always less. So a series with less standard deviation is said to be more uniform or more consistent. That's what the first property that is given to you. And I've already gave you the formula for combined standard deviation and I told you about coefficient of variation. So guys, tell me, coefficient of variation is an absolute measure or relative measure? Relative measure. What is the formula for coefficient of variation? Standard deviation by arithmetic mean into 100. So coefficient of variation is nothing but coefficient of standard deviation expressed as a percentage of, is called as coefficient of variation, right? So yes, coefficient of variation is the best one to compare two or more series, right? So whenever you are given with two or more series, which series average that you can say is the best average? The series that is having lesser coefficient of variation is going to be the best measure of the central tendency, or it is considered to be a best series. Got it, guys? Now, what is the relation between quartile deviation, mean deviation and standard deviation? So guys, for a normal distribution, for a normal or symmetrical or moderately skewed, means a little bit of skewness is there, then there is a relation between standard deviation, mean deviation and quartile deviation, which is 4SD equals to 5MD equal to 6QD. It means what is QD, guys? QD equals to 4 by 6 into SD, which means 2 by 3 into SD. What is MD, guys? MD equals to 4 by 5 into standard deviation. Therefore, what is the ratio between quartile deviation, mean deviation and standard deviation? 10 is to 12 is to 15. Guys, here you must understand one thing. Which one is having least coefficient? Standard deviation, means standard deviation is always bigger one. Next mean deviation is bigger one and the next quartile deviation is bigger one. So who is the smallest one here? quartile deviation. So that's why he gave you quartile deviation is less than mean deviation is less than standard deviation. So difference between different measures of dispersion. As you all know, range is easy. Mean deviation is also easy. But compared to range, it is difficult. Quartile deviation is also easy. But quartile deviation is based upon how many observations? 50%. Range is based upon only 2 observations. Mean deviation is based upon all observations. Standard deviation is based upon all observations. But why mean deviation is ignored? Because there is a symbol called modulus. That is what the problem. So otherwise, mean deviation is also better one. But who is easy to compute? Range. Who is difficult to compute? Standard deviation. Who is not affected by extreme observations? Quartile deviation. Got it, guys? Who is not affected by extreme observations? Quartile deviation, because it is based upon only 50%. Who is the most useful measure or the best measure of dispersion? Standard deviation. So guys, I've already explained this concept in central tendency only, guys. So this is whenever the distribution is symmetrical, mean equal to median equal to mode. Whenever the distribution is positively skewed. So left side there is mode because it is highest frequency. Median will always be there. As mean is affected by extreme observations, mean turns towards right. So now when it comes to this distribution, it is negatively skewed distribution. It is highest frequency, that is called as mode. Median always lies at the middle. And of course, so as the distribution is negatively skewed, yes, extreme observations are at the left side. So mean will always be at left side. So how do you measure skewness? So guys, there is a measure to there are certain measures to calculate the coefficient of skewness. What are they? So guys, the first formula was Karl Pearson's coefficient of skewness, which is based upon mean, median, and mode and standard deviation. The formula for Karl Pearson coefficient of skewness is, look at this formula, guys, mean minus mode by standard deviation. As you all know that the distance between mean and mode is 3 times the distance between mean and median. That's why I have written this formula. So there is another formula which is based upon quartiles, which is also known as Bowley's coefficient of skewness or quartile coefficient of skewness. What is Bowley's coefficient of skewness or quartile coefficient of skewness is? So guys, forget about this. Just simply write Q3 minus 2 Q2 plus 1 Q1 by Q3 minus Q1. Got it? So like that, skewness can be based upon deciles, percentiles also. So P10 plus P90 minus 2m by P90 minus P10, or based upon deciles, D1 plus D9 minus 2 median. 2 median means D5, guys, by D9 minus D1. So where m equals to median, D5 or P50 also. So both of them are same. Of course, here we have 2 Q2 now. Who is Q2? Median only. So the same formula, guys. First quartile plus last quartile minus 2 into median. Got it, guys? So that's how you can calculate the measure of skewness also. Now coming into the problematic part, guys. So we have seen what is measure of dispersion and how can you calculate measures of dispersion. Now coming into problematic part, let us get into the first MCQ, guys. The first MCQ here is MCQ number 34, guys. Look at MCQ number 34. What is the question? The standard deviation of 10, 16, 10, 16, 10, 10, 16, 16. Guys, look at the data first. How many observations has been repeatedly coming here? 2 observations. What are they? One is 10 and the other one is 16. Tell me, guys, 10 is repeated for how many times? 2 times. No? 10 is repeated for 1, 2, 3, 4 times. And 16 is also repeated for how many times? 4 times. Guys, here I must tell you a very important point. Whenever all the observations have same frequency, means all the observations are equally important. Means I have to take simple arithmetic mean or weighted arithmetic mean. Simple, if all the observations has given equal preference, I have to go for simple arithmetic means. See, in such a case, frequencies can be eliminated because all the observations were given equal importance. I can simply go for simple average or simple measure of dispersion, not only arithmetic mean, guys. So you can ignore frequencies whenever the frequencies are same. Now tell me, guys, how many observations are there? 2. So for 2 observations, you can use the regular formula of standard deviation, summation x square by n minus x bar square, or else for 2 observations, there is a shortcut to calculate standard deviation, guys, which is half of range. Half of what? Range. What are the observations here? 10 and 16. What is your range? 6 by 2. What is 6 by 2? 3, right? And your answer is option C. So guys, people will tell the formula like this: half mod A minus B. The standard deviation of A and B is half mod A minus B. It's up to you. That is what about MCQ number 34. Now let's have a look at the next MCQ. MCQ number 37. The mean and variance of 5 observations are 4.8 and 6.16. Mean is 4.8, variance is 6.16, and there are how many observations? 5 observations. If 3 of the observations are 2, 3 and 6, what are the remaining observations? Guys, for this question people will take the remaining observations are A and B, and mean is 2 plus 3 plus 6 plus A plus B by 5 equals 2, this much. They will do all those things. I'm not doing that, guys. I have to identify the remaining 2 observations. I'm going through option verification. Let me assume that option A is the correct answer. It means my remaining 2 observations are 4 and 9. Means what are my observations? 2, 3, 6 are given, and according to option A, they are 4 and 9. Now it's your turn to calculate the arithmetic mean of 2, 3, 6, 4, 9. Faster. What is the arithmetic mean of 2, 3, 6, 4, 9? All of them added and then divided by 5. I got this much, 4.8. So arithmetic mean is 4.8. That is verified. Now I have to calculate the variance term. What is the formula for variance? Let me write down this formula. Summation x square by n minus x bar square. Guys, let us directly do this with the help of our calculator. Summation x square. 2 square. How much? 4. Next 3 square. 9. Next 6 square, 36. Next 4 square, 16. Next 9 square, 81. So what is summation x square? 146 divided by what is n? 5. 146 by 5, which is 29.2. M plus, do M plus. Next x bar. What is x bar? 4.8. No, I need x bar whole square. 4.8 whole square, this much. M minus. Okay, now MRC. What I got? 6.16. That is completely verified. No, means you need not take let the 2 observations are A and B. Arithmetic mean is 2 plus 3 plus 6 plus A plus B by 5 equals to 4.8. And then you need not write any equation, guys. There's a chance of option verification, whether it is in mathematics or statistics. This is the easiest way, guys. Now let's have a look at next MCQ. MCQ number 43. It is given that the mean of 10 mean is 10 and standard deviation is 3.2. Mean is 10 and standard deviation is 3.2. If the observations are increased by 4, means, guys, so mean of x series is given to you. What is the mean of x series? Just a moment, guys. X bar equals to 10 and standard deviation equals to 3.2. Means standard deviation of x equals to 3.2. There is a new series that is obtained by adding 4. Means y equals to x plus 4. Guys, can you please tell me what is y bar? X bar plus 4 means how much? Yes, 14. But it is change of origin or scale? Origin. Is standard deviation is affected? Not so. Means standard deviation of y equals to 3.2. Or else if you want to go through formula, modulus 1 into standard deviation of y equals to modulus 1 into standard deviation of x, as the coefficients are 1 and 1 only, right? Now let's see what is our question. I haven't completed reading the question. Then the new mean and standard deviation. What is the new mean? 14. And new standard deviation? 3.2. That's how you can solve the MCQ, guys. It's a direct question. Now let's have a look at the next MCQ. MCQ number 46. So if x and y are perfectly related by 2x plus 3y plus 4 equals to 0. And the standard deviation of x is 9. What is the standard deviation of y? So simple logic, guys. Keep modulus 2 into standard deviation of x equals to modulus 3 into standard deviation of y. Either you can write sigma x or sx. No problem. What is the standard deviation of x? 9. So you can write 2 into 9 equals to 3 into sigma y or sy. It's up to you. So 2 into 9, 18 by 3, which is going to be 6. And that is the correct answer. Now let's go for the next MCQ. Before that, I must tell you another important formula, guys. If the observations are in AP, what is the formula to calculate mean deviation? N square minus 1 by 4n into D. Like that. If the observations are in AP, standard deviation equals to square root of n square minus 1 by 12 into d. If the observations are in AP, this is the formula to calculate standard deviation. Now tell me, what is the standard deviation of first n natural numbers? Common difference is 1, no. So you can write n square minus 1 by 12 square root of. What is the variance? Just n square minus 1 by 12. So that's how you can solve the MCQs whenever the given set of observations are in AP. Now let's have a look at the next MCQ, which is MCQ number 54. Yeah. This is a very important MCQ, guys. For a group of 60 boy students, the mean and standard deviation of statistics marks were 45 and 2 respectively. Means the count of boys is 60 and the mean is 45, standard deviation is 2. The same figures for a group of 40 girls, means strength of girls is 40 and the mean are 55 and standard deviation is 3. What is the mean and standard deviation of the marks of two groups pooled together? Means we have to calculate the combined mean and combined standard deviation. For that, let me write down what are N1, N2 and what are sigma 1, sigma 2, sorry, S1, S2 and what are X1 bar, X2 bar. N1, 60 members, N2, 40 members. What is the arithmetic mean? So X1 bar is given, X2 bar is given, S1 is given, S2 is given. Let us write down their means and standard deviations. Means 45 and 40, standard deviations 2 and 3. So guys, tell me the formula for X bar 1, 2. You all know N1 X1 bar plus N2 X2 bar by N1 plus N2. Except formula, I don't recommend you to write anything on the paper. Take your calculator. N1 60 into 45 M plus 60 into 45 M plus 2700. Next 40 into 40 M plus 1600 M plus MRC. What's your answer? Just a moment, guys. 4300. By what is N1 plus N2? Yes, 100, no? By 100. What's your answer? 40. Just a moment, guys. By mistake, I took a... Sorry, guys. 55 is the arithmetic mean. Sorry, guys. By mistake, I took it as... Yeah. Please do calculate it again. 60 into 45 M plus and 40 into 55 M plus MRC. Yes, by 100. Sorry for it, guys. And it is 49. So combined arithmetic mean is 49. Now there is a formula for combined standard deviation. Before that, let me write down the meaning of D1 and D2. D1 equals to X1 bar minus X12 bar. D2 equals to X2 bar minus X12 bar. What is D1? X1 bar minus X12 bar means 45 minus 49, which is minus 4. D2 means X2 bar minus X12 bar, which is 55 minus 49, and that is equals to 6. Now let me write down the formula for combined standard deviation. So sigma 12 equals to square root of N1 into S1 square plus D1 square plus N2 into S2 square plus D2 square by N1 plus N2. So guys, I'll tell you how to do this with the help of your calculator directly. Let's get started, guys. Clear your calculator's memory first. S1 square, how much? 4. D1 square, 16. So 16 plus 4, 20 into 60. 20 into 60 M plus 1200. Now S2 square 9. D2 square 36. So tell me, what is 36 plus 9? 45 into N2. What is N2? 40. Again M plus MRC. I got 3000 by N1 plus N2. By what is N1 plus N2? 100. And I got 30. And I have to apply square root. After applying square root, what is it, my answer? 5.477, which is approximately taken as 5.48. And that is there in your options now. See, it's all about writing the solution in the shortest possible way. So if you use your calculator, the solution will be quite easier, guys. Got it, guys? So that's how you can solve the MCQs related to standard deviation. Now let's get into the next question. MCQ number 55. The standard deviation for the following distribution is, guys, people will take change of horizon scale method. So, but I don't take, guys. I'll simply write the mid values. What are the mid values? Here 51, here 53, here 55, here 57, here 59, right? So now Calculate the arithmetic mean. First of all, calculate the sum of observations, sum of frequencies. 17 plus 35 plus 28 plus 15 plus 5. How much? Total frequency is 100. So guys, standard deviation is unaffected due to origin, no? So if you want to do that, just simply subtract 51 or 55 from all the data. What is 51 minus 55, guys? Means I'm writing D equal to X minus 55. There's no restriction that you have to take 55. If you want, you can take 51 or 52, whatever it is. But I'm taking the middlemost value. What is 55 minus 55? 0. 57 minus 55, 2. 59 minus 55, how much? Yes, 4. So 53 minus 55, how much? Minus 2. Here, minus 4. Okay, these are D values. So I know that standard deviation of D equals to standard deviation of X. So I'm calculating the standard deviation of D. What is the formula for standard deviation of D? Summation FD square by capital N minus D bar square under root. Now let me calculate D bar first. What is D? How do you calculate D bar? Summation D by N, summation FD by N. So 17 into 4M minus 35 into 2M minus, so 28 into 0 is 0, 15 into 2M plus, so 4 into 5M plus MRC, which is minus 88 I got by 100. What is by 100? 0.88. So that is X bar value, D bar value. I need D bar whole square. How much? 0.7744. This is 0.7744. Now I'll tell you the calculation process, guys. Let's get started. So X bar, D bar square, D square means 16. 16 into 17M plus. Next 4 into 35M plus. The square is needed, guys. Summation FD square is needed. F into D square is what doing? Next 28 into 0, 0. 15 into D square means 4. 15 into 4M plus. Next 5 into 4 square means 16. 5 into 16M plus MRC. The total is 552. So this is 552. By N is how much? By 100, no. So 552 by 100. Yes, 5.52 minus 0.7744. I got 4.746 under root. Please do apply under root. I got 2.1785, which is approximately 2.18. As you all know, D equals to X minus A. Standard deviation of D equals to standard deviation of X, as standard deviation is unaffected due to origin. Try to understand that, guys. Now let's have a look at the next MCQ. MCQ number 58. What is MCQ number 58? The sum of squares of deviations from mean of 10 observations is 250. Mean of the data is 10. Find the CV. So guys, look at this. Sum of squares of deviations from mean. So how do you denote sum of squares of deviations from mean? Sum of squares of deviations from mean for a set of 10 observations is 250. That's what my first line. And it is given that mean equals to how much? Mean equals to 10. Got it? Now, what is the formula for standard deviation, guys? Square root of summation X minus X bar whole square by N, which means 250 by 10. What is 250 by 10? 25. Root over 25, 5. So means standard deviation equals to 5. What is the formula for CV? Standard deviation by mean into 100. No, means 5 by 10 into 100. What is 5 by 10 into 100? Your answer is 50%. So what is your coefficient of variation, guys? 50%. So it's all about understanding the data that is given to you and then writing the answer. Now coming into the next MCQ, guys, there's the different MCQ. Look at 63. What will be the probable value of mean deviation when Q3 equals to 40 and Q1 equals to 15? Guys, while explaining the concept called quartile deviation, I gave you a formula for median. Do you guys remember? What is the formula for median? Q3 plus Q1 by 2. Sometimes he'll ask you to calculate the coefficient of mean deviation also. In that case, you need mean deviation and median. You can use that formula. For now, we don't need. Q3 is given and Q1 is given. No. So, what is the formula for quartile deviation, guys? Quartile deviation equals to Q3 minus Q1 by 2. Q3 minus Q1 by 2. Take your calculator and calculate Q3 minus Q1 by 2. 40 minus 15 by 2. What is 40 minus 15? 25 by 2. Forget about it. Now, guys, we have to calculate mean deviation. For that, we have 5MD equals to 6QD. Do you remember that? So you know what is quartile deviation? 25 by 2. 25 by 2 into 6 is 75, and that is the value of 5 mean deviation. I need only mean deviation, no? So do by 5. So what is your mean deviation? The answer is 15, and that is there with option C. That is all about measures of dispersion, guys. So guys, try to understand. Formulas are very essential here. And if you are able to understand the MCQs related to problems, you are in such a position to understand theory concepts. So try to solve, try to understand the meaning of any measure of dispersion and then calculate them and then go for theory. Then only you are able to understand the concepts of the theory, guys. Okay, so that's all about dispersion, guys. So let's get into the next concepts, guys. The next concepts are, or the next set of topics are correlation and regression, guys. So both of them together, we can expect 4 to 7 marks, guys. Yes, 4 to 7. And remember, guys, correlation and regression are such easy topics. If you know the basics of central tendency and dispersion, these things are very easy, guys. So the usual preparation time for these two concepts is at least 10 hours, guys. Yes, but after watching this video, you can reduce your preparation time, and I'm going to complete this correlation and regression topic together in 1.5 hours to 2 hours of time, guys. So let's get started. Before that, guys, whatever we have learned till now, tell me what you have learned till now. We discussed about measures of central tendency, and we discussed about measures of dispersion, right? So in both the cases, we have seen central tendency means we have seen X bar. Dispersion means we have seen standard deviation of X or standard deviation of Y. Means we have seen a series which includes only one variable. Means we have seen a series which has exactly one variable. Means such kind of distribution is known as univariate distribution. How do you call it as? Univariate distribution. But what is the name of our current concept? Correlation. So you have to establish the relation, no? To establish the relation, how many variables need to be there at least? 2 means we have to talk about at least 2 variables distribution. A distribution having at least 2 variables means I either need to talk about bivariate data or trivariate data or multivariate data. Means whatever we have seen till now is only one variable. But from now onwards, we are going to talk about more than one variable. In particular, we are going to talk about 2 variables distributions. Such a distribution is called as bivariate distribution, and the corresponding frequency distribution is known as bivariate frequency distribution. So what are we going to talk about now? Bivariate data. So the first concept or the preliminary concept is how to convert a bivariate data into univariate data. So how to convert a bivariate frequency distribution into univariate frequency distribution, and what are the types of univariate frequency distributions here? There are 2 types of univariate distributions that you can draw from a bivariate frequency distribution. What are they? Marginal frequency distribution and conditional frequency distribution. So from a bivariate frequency data, you can deduce these 2 kinds of univariate distributions. Forget about that. Now, what is correlation analysis and what is correlation analysis aims? Correlation analysis aims identifying the relation between amount of relationship between 2 variables. What percentage of relation is there between 2 variables? And one more thing, what kind of relation, whether they both are positively correlated or negatively correlated or no correlation. So means here we are concerned about type of correlation, means whether it is positive correlation or negative correlation or no correlation. That's what we are concerned about. And if it is positive, how much? If it is negative, how much? Means we wanted to measure the correlation. So what are the measures of correlation? So to measure correlation, we have 4 methods, guys. One is scatter diagram. Next one, Karl-Pearson coefficient of correlation, which is also known as product moment coefficient of correlation. Next, Spearman's correlation coefficient or else rank correlation coefficient. And next one, coefficient of concurrent deviation method. So guys, the teaching order will not be like this, guys. So first of all, we'll teach scatter diagram, and then we'll go for coefficient of concurrent deviations, and then we'll go for Spearman's rank correlation coefficient, and then we'll talk about Karl Pearson coefficient of correlation. As you all know, even though this is the teaching order, the best method to calculate coefficient of correlation is Karl Pearson's only. But we'll follow a method in which we'll teach the simplified, easy method first, and then we'll teach a better method, and then we'll teach a bit better method. Lastly, we'll teach the best method. So the first method of coefficient, calculation of coefficient. So before that, let me tell you the definition of correlation. Yes, for example, let me assume that I'm a student at a particular university which is conducting many internal exams before the final exam. So guys, I just wanted to write these internal exams because I wanted to assess my marks in my final exam based upon this internal exam performance. Yes, how can you write the final exam directly without writing even internal exams? How can you perform better without writing these exams in a better way? Yes, right? Means if you want to perform the future or the final exam in a better way, you have to perform these internal exams in a better way. No, means performing a better, giving a better performance in your final exam is completely dependent upon giving a better performance in your internal exams. No, and I just wanted to assess myself whether am I ready for final exam or not by writing my internal exams. Means are my internal exams are connected to final are my final exams are connected to internal? Yes. If I give a good performance in the internal exams, I can definitely perform well in the final exam. If I don't perform good in the final internal exams, I may not be able to perform them in the final exam. No. So yes, this is how I can connect two variables. What is my first variable? Internal exams performance. Second variable, final exam performance. These two variables are directly connected or inversely connected. Yes, if you perform better in the internal exams, you are in such a position to perform better in the final exam. If you don't perform better in the internal exams, you can't perform better in the final exams, right? So both of them are moving in the same way or opposite way. Same way, and that correlation is said to be direct correlation. Relation between two variables. Is it direct or inverse? Direct, right? Next, when it comes to this rainfall and yield of a crop. So are there, yes, tell me, what kind of correlation is there? Yes, we'll get a better yield if the rainfall is better. So people can ask me this way, madam, if it is too much, guys, all these things are under certain restrictions. If it is so much more, if it is floods, I can't talk. I'm not talking about that scenario. I'm talking about my general rainfall system only. I'm not talking about floods and all. Got it, guys? So this is under certain restrictions only. So my yield of a crop, I'm going to get a better yield if I have a better rainfall. I'm going to get a bad yield if I'm not having any rainfall, right? Yes, they're also positively correlated, no? Now, temperature and sales of umbrellas. So, if I'm having a least temperature, means I have a chance of getting rain. So, there is a chance of selling umbrellas, no? Yes, guys, I'm talking about my current area, guys. So, if we are having a bit of lower temperature, there's a chance of rain to us according to our climatic conditions. So, I feel that if my temperature is a bit low, there's a chance of getting rain. So, there's a chance of improving. Yeah, sales in umbrellas means if temperature is going downwards, my umbrella sales are going upwards. Got it? Means they are how they are connected, directly or inversely. So if they are directly connected, we'll say that it is positive correlation. If they are inversely connected, we'll say that there is negative correlation. But what percentage they are connected? Are they 50% connected? Are they 80% connected? That and all we'll calculate with the help of coefficient of correlation. How do you calculate? With the help of a measure called coefficient of correlation. As you all know, coefficient. Is it an absolute measure or relative measure, guys? It's relative measure. Means is it unit dependent or unit free? Absolutely unit free. As it is a relative measure, it is always unit free. For every comparison, we'll use a measure called relative measure. Relative measures are abbreviated with the word called coefficient. Each and every coefficient is unit free. So all the relative measures are unit free, and of course correlation is also a relative measure which must be unit free. So let me tell you the definition of correlation. So correlation analysis and regression analysis are the two important ways which deals with multivariate distribution. I have already told you. So this example also I have already taught you guys. So now I've told you what is a direct correlation and what is an inverse correlation, and we discussed about measures of correlation also. So how do you measure a correlation? A correlation can be measured with a coefficient called coefficient of correlation, which is denoted by the symbol Rxy, means coefficient of correlation between x and y. So before that I must tell you one thing guys, coefficient of correlation is always symmetric, means there is no difference between coefficient of correlation between x and y and x. Both of them are same. Coefficient of correlation between x and y is same as coefficient of correlation between y and x. I'll prove it for you later guys. So guys, it measures the amount of association. Amount means value of association between two variables. It always lies between -1 to +1. How much it is? It lies between -1 to +1. If it is -1, it is called as perfectly negative correlation. If it is +1, it is called as perfectly positive correlation. If it is 0, I'll say that there is no correlation. So guys, measures of coefficient of correlation is unaffected due to origin and scale. There's no effect of origin and there is no effect of scale, but there is an effect with sign. Coefficient of correlation is just affected by sign. Got it guys? So is it an absolute measure or relative measure guys? Relative measure. So is it unit dependent or unit free? Unit free. If R equals to +1, what kind of correlation? Perfect positive correlation. -1, perfect negative correlation. R equals to 0, no correlation. Now guys, from 100% to 75% means 0.75 to 1. It is called as high degree. If it is plus means high degree of positive. If it is minus means a high degree of negative. From 0.5 to 0.75, 50% to 75%, it is moderate degree. What kind of degree? Moderate degree. From 0 to 50%, we'll call it as low degree of correlation. Got it guys? So now let's talk about different types of correlation. The first type is simple correlation. The name itself is saying that I'm a correlation which measures the strength of association between exactly two variables. I'll talk about only how many variables? Two variables. The next one, positive correlation. When do you say that two variables are correlated positively? If one variable is moving upward, the second one should also move upward. If one variable is moving downwards, the second one should also move downwards. Means if both of them are moving in the same direction, it means if x value gets increases, y also needs to increase. If x value gets decreases, y also needs to get decrease. So such a correlation is said to be positive correlation as direct correlation. Okay. So examples are given guys, height and weight, rainfall and yield of a crop, profit and investment. Okay, now what is a negative correlation? If two variables are moving in opposite direction, means if there is an increment in the first variable, the other variable should decrease. Or else if the first variable got decreased, the second variable should increase. Means, so if one variable is moving in upward direction, the other variable should move in downward direction. Such a kind of correlation is said to be negative correlation or inverse correlation. The next one is zero correlation or uncorrelation. Means corresponding to a change in one variable, if the other variable do not get changed, then we'll say that both of them are uncorrelated and the correlation between both of them is 0. For example, I am talking about my shoe size or my dress size and my intelligence. How can you say that? If my dress size gets increases, I am getting an intelligent girl. Is that possible? No, right? So means such kind of correlation is said to be, they are not correlated, or else we'll say that there is a zero correlation. Now coming into the very important concept, partial correlation. The name itself is saying that I am partial towards some people. For example guys, let me assume that I have rainfall with me. So, sorry, yield of a crop with me. My yield of a crop depends upon many factors. What are the factors? Rainfall, next type of soil, next best thing, irrigation facilities, next fertility of soil or else type of soil, next types of seeds used, So types of fertilizers used. Everybody matters, no? Means my Y is dependent upon the factors R, S, I, and of course many things. So guys, I'll assume that fertility of soil, types of soil, type of seed I used, irrigation facilities, I'll assume that all these fellows are constant. There exists a change in yield of a crop only if there exists a change in rainfall. Means whatever the soil it is, whatever the irrigation facility they are, we'll assume that yield of a crop just changes with rainfall. Is it exactly correct? Not so. But this partial correlation assumes that rest of the things were always constant. Means there is no change in the fertility of soil. There is no change in the irrigation facilities. Means that it will feel that people you have everything common. Is it common? No, but it assumes that way. Irrespective of the remaining things, means by assuming the remaining factors are constant, it calculates the correlation between yield of a crop and rainfall. Such a correlation is called as partial correlation. So means whenever there are more than two variables, you will calculate the relation between only two variables by assuming that all the other fellows are constant. That is called as partial correlation. Now, whatever the correlation it is, guys, the limits are -1 to +1 only. Multiple correlation. So guys, try to understand. Just now we took an example in which yield of a crop is affected due to multiple factors, no? So, they will calculate the average of all these factors and they will say that it is some other variable called Z. So, if they calculated the average means they have used all the fellows, no? Now, they will calculate the relation between Y and Z. Means correlation between one variable and the joint effect of all the other variables. Look at this. So, when there are more than two variables, we study the relation between one variable and the other variables taken together. Got it? So, such kind of correlation is said to be multiple correlation. Now, there is other correlation which is total correlation. So, means guys, so why yield of a crop is affected by rainfall, irrigation facilities, fertility of soil. They will calculate the correlation between yield of a crop and rainfall. They will calculate the correlation between yield of a crop and irrigation facilities. They will calculate the correlation between yield of a crop and type of soil. And then they will calculate the average of all these things, which is known as total correlation coefficient. Got it, guys? So that is how they can calculate the total correlation. This is also they're taking all the variables into consideration. Got it, guys? Now, what is a perfect linear correlation? So, guys, for example, if I write y equals to 2 plus 3x. 2 plus 3x. It means y depends upon x, guys. Let me write x equal to 0. If x equal to 0, what is y, guys? 2. If x equal to 1, what is y? 5. X equal to 2, what is y? 8. X equal to 3, what is y? So 11, right? Means corresponding to a unit change in x. X got increased by how much, guys? Whether it is increased or decreased. Corresponding to a unit change in x, there exists a change of how much in y? 3 units. Even if after changing 1 to 2, there exists a change of how many units? 3 units. From 2 to 3, there is 1 unit of change. From 8 to 11, there are 3 units of change. Means corresponding to 1 unit of change in x, there is 3 units of change in y. Corresponding to 1 unit of change in x, there is 3 units of change in y. Means corresponding to a unit change in x, there exists a constant change in y. Such kind of correlation is said to be linear correlation. Here x values are getting increasing and y values are also increasing. It means it is perfectly positive correlation. But if I take this example, y equals to 5 minus 2x. Let me take x equal to 0. What is y equal to? 5. X equal to 1, y equal to 3. X equals to 2, y equals to 1. X equals to 3, y equals to minus 1. X equals to 4, y equals to minus 3. Means corresponding to a unit change in x, there is how much change in y? Minus 2 units of change in y. This is also a constant change, but it is reducing. Got it, guys? Yeah. Both of them are examples of linear correlation. I'll tell you a very easy way, guys. If I gave you y equal to a plus bx, if b is positive, correlation coefficient is positive, means rxy you can directly say plus 1. If b is negative, I can say that rxy equals to minus 1, that we just proved now. So yes, look at them. Plus 1, if coefficient of x is positive, we are getting positive correlation. If coefficient of x is negative, we are getting negative correlation. If you want, you can see this. X values are increasing, but y values are decreasing. See, means both of them are moving in same direction or opposite direction? Opposite direction. So you can directly tell me that coefficient of correlation is how much? Minus 1 you can directly tell. Try to understand that. So there's no problem even if there is b is positive or negative. If b is positive, it is perfectly positive. If it is negative, it is perfectly negative. This is called as perfect linear correlation. Now coming into the next important concept, non-linear correlation. So guys, in your CA foundation, you were confined to reading only linear correlation. So non-linear correlation, we don't have MCQs based upon non-linear correlation, but you must understand what it is. Otherwise, you can't solve the MCQs related to theory. The relation between two variables is non-linear, means corresponding to a unit change in x, there will not be a constant change. For example, guys, if I write y equal to 2x square plus 1, let me take x equal to 0. What is y? 1. X equals to 1. What is y? What is y? Tell me. 1 means 3. X equals to 2 means 9. Means x values are getting increasing and y values are getting increasing. Means both of them have a correlation, but it is not constant, and we'll call it as a non-linear correlation. So guys, that is, it can be like ax plus b, a plus bx plus cx square, or a into b power x, or a power x. It can be like anywhere. Got it, guys? So it means by drawing all these points between, by presenting all these points between coordinate system, you will not get a straight line. You will get some other shape. Got it? Now logical correlation, which is very important, guys. So guys, in this topic, I told you that there are 4 methods of calculating coefficient of correlation: scatter diagram method, Karl-Pearson, Spearman's rank correlation, concurrent deviation. So guys, if I present the values in the formula, definitely it's the mathematical formula, no? It will calculate something. It doesn't know what it is substituting. You, the people who are substituting, must know what are you substituting. So guys, suppose if I substitute x as, if I take x as shoe size and y as intelligent, I'll take them values and I'll substitute it in my formula. As it is a formula, I don't know what you are substituting, no? It will definitely show some value. Let me show that the different correlation between shoe size and intelligence that you have measured by using a particular formula is 0.5. It means it is saying that relation between shoe size and intelligence is 50%. Oh, can you accept that, guys? Yeah, it is mathematically showed, but it is not logically correct. It means the relation between two variables is mathematically proved, but not logically. Such kind of correlation is said to be illogical correlation. Now tell me, when do you say that a correlation is logical? So I have to prove the correlation between two variables mathematically as well as logically. Then only I'll say that it is a good correlation or logical correlation. Otherwise, I'll say that it is an illogical correlation. Now, let's get into the measures of correlation, methods of measuring correlation coefficient. The first method of measuring coefficient of correlation is scatter diagram method. So, guys, this is the diagrammatic presentation of bivariate data. Let me repeat. This is the diagrammatic presentation of bivariate data. So, in this method, you will plot x values on x-axis and y values on y-axis. So, sometimes x values can be negative, sometimes y values can be negative. There's no problem. There's no restriction that you have to confine your graph here on. So, you need to plot the values of x and y between the coordinate system. If all the plotted points are like this, look at this, guys. You got a straight line. You got a straight line in which, guys, try to understand, x value is here at the lower part, y value is also at the lower part. Now, x value got increased, y value also got increased. Now, x value got much increased, y value also got increased. Again, X value got increased, Y value got increased. Just tell me what kind of correlation it is. What kind of correlation it is? Perfectly positive as they're directly moving. But now the graph was not like this. It's going somehow. It's not perfectly going. Can you see? Yeah, it is high degree of positive correlation. Now, if it is like this, it is low degree of positive correlation. Now, look at the next diagram. This is what I'm drawing. All the points are plotted and I got my curve or my straight line like this. Means, guys, look at this. Here, X value is 1, starting value, but Y value is very high. But as soon as X value got increases, Y value is getting increasing or decreasing. Decreasing means X and Y are how connected they are, how they are connected, negatively correlated. Got it, guys? For example, now I have my variables like this. It is negative, but is high degree of negative. Now my X and Y got connected like this. It is negative, but low degree of negative. Now look at this, guys. My points are distributed unevenly. There's no pattern for that. It means X and Y are moving in a zigzag order. Means there is no correlation. So that's how you will plot X and Y values between coordinate system and you will get a straight line. Means if you got a straight line means it's a correlation. What kind of correlation? Perfect correlation. If that straight line is going from lower left corner to upper right corner, that is positive correlation. And if that straight line is coming from upper left corner to lower right corner, the correlation is negative correlation. If the points are not distributed in a particular manner, the correlation is 0. So guys, this is what scatter diagram. But here I must tell you one thing. So it will measure even if it is a curve. It can show. Means this is a method which will identify whether the given correlation is linear or non-linear. It is useful for both linear and non-linear. So this scatter diagram method will be applicable even if the variables are correlated linearly as well as non-linearly. But guys, if I say that my correlation is highly positive, means from which range to which range? 0.75, sorry, 0.5 to 0.75 to 1. How much between them? Can I directly tell the value perfectly? No, I'm just giving you range. It is from 0.75 to 1. I don't know who is that value. Means I can't tell you the direct value. Means I can't tell you the direct degree or value or magnitude. People call it as degree or magnitude of coefficient of correlation. It will tell me the direction. Means it will tell me whether it is positive or negative. It can't tell you the value perfectly. That is the first drawback. And the next thing is, if there are 20 observations, I can plot them. But if there are 200 observations, how can you do that, guys? Not easy, no. So yes, scatter diagram is difficult to draw if there are more number of observations. Got it, guys? So it's a very simple method, but the problem is it does not going to tell you the amount. It will tell you the direction only. Got it, guys? So I've told you about all these diagrams, guys. So guys, now look at this diagram. So guys, this is X value. X value is 1 means Y value let it be 2. Even if X is 2 also Y is 2. If X is 3 also Y is 2. Means X values are changing. There is no change in Y values. Means it's a 0 correlation or no correlation. Means if you get a straight line which is parallel to X axis or Y axis. In this case, guys, my X value is 1. My Y values are keep on changing. Means X value is always constant. Y values are keep on changing. Means corresponding to a change in Y. There's no change in X. It means no correlation. What kind of correlation it is, guys? You people feel that it is curvilinear correlation. No. So at 50% it is up and the other 50% it is down. 50% plus 50% minus put together it is 0. That's why they gave you it as a no correlation. So I have already told you this is not going to tell you the exact value. It will just tell you whether the correlation is positive or negative. That is why it is purely a subjective concept. So, and it is not suitable for large number of observations, and it will not tell you the direction or degree of correlation. It will just tell you the direction only. Now, coming into the other concept of correlation, other method of calculating coefficient of correlation is coefficient of concurrent deviations. So, what is coefficient of concurrent deviation? So, how to calculate coefficient of concurrent deviation? Guys, let me assume that I am having n pairs of observation. How many pairs of observation? N pairs of observations. Okay. Then coefficient of concurrent deviation for these n pairs of observations Rxy equals to plus or minus square root of plus or minus 2c minus m by m, where c equals to number of concurrent deviations. What is c equals to? Number of concurrent deviations, and m equal to number of deviations. Keep it in your mind, right, guys? I'll tell you what they are. Okay. First of all, let me take an MCQ, guys, so that you will be in such a position to understand the question perfectly. So, let me start off with a particular MCQ so that you can understand the concept in a better way, guys. Let me show you an MCQ. So, look at MCQ number 2. The coefficient of concurrent deviations for the following data. Guys, look at this. For the first value of x, keep an equals to symbol against it. Whether it is the value of x or the value of y. Now, look at the next observation. Compared to the first observation, next observation got increased or decreased? Decreased. If it is decreased, just write minus symbol. If it is increased, write plus symbol. Let me repeat. Compared to your previous observation, if the next observation got increased, keep plus symbol. If the next observation got decreased, keep minus symbol. If there is no change, keep equals to symbol. Got it? So now, compared to 43, 38 got reduced. Next 78 got increased. Compared to 78, 66, minus. Next 66 to 83, plus. 83 to 38, decrease. 38 to 23, decrease. 23 to 83, increase. 83 to 63, decrease. 63 to 53, decrease. Now, 65 to 60, decrease. 55, decrease. 61, increase. 35, decrease. 75, increase. 45, decrease. 40, decrease. 85, increase. 80, decrease. 85, increase. So, guys, if you look at the data, how many observations are there? 11. 11 pairs of observations. But you got how many deviations? You got only 10 because the first one can't get any deviation. That's why I gave you equals to symbol. Got it, guys? Yeah, that's what you need to understand. So, got it, guys? How many deviations you got? 10. That is what M means. So, how many deviations you got? 10, guys. The next one. Now, you multiply both the symbols. Equals to into equals to minus into minus plus. Next minus into minus plus. Next plus into plus plus. Minus into minus plus. Plus into plus plus. Minus into minus plus. Next minus into minus plus. Plus into plus plus. Minus into minus minus. Minus into plus minus. So guys, concurrent deviation. Sorry guys, this is plus no. Concurrent deviations means number of positive signs. What is the meaning of positive signs? In how many cases both the observations are in the same direction? Means here x value got decreased, y value also got decreased. That's why we got plus symbol. Means number of cases in which both of them are in the same direction. So in how many cases they are in the same direction? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is what number of concurrent deviations. People tell that it is number of positive signs. Now the formula is plus or minus square root of plus or minus what is 2c 20 minus m by, sorry guys, 2c 2 9s 18 minus 10 by 10. Now guys, listen to me. Madam, what is this plus or minus? Guys, what is 18 minus 10? 8 by 10. 8 by 10 means 0.8, no? Is that 0.8 is positive or negative? First, if you get a plus symbol, keep plus symbol inside and outside. If you get a minus symbol, keep minus symbol inside and outside. Let me repeat. Whatever the value of 2c minus m by m, if it is positive, Rxy is plus in both the cases. Keep a plus symbol in both outside and inside of root. If 2c minus m by m is negative, keep a minus symbol inside and outside of root. Got it, guys? So now you got 0.8, no? Under root 0.8. 0.89 is your answer. So your answer is 0.89. And that is there in option C. Got it, guys? So that's how you can calculate coefficient of concurrent deviation, coefficient of correlation through concurrent deviation method. Now let's see MCQ number 1. For 10 pairs of observations, number of concurrent deviations were found to be 4. Guys, tell me, for 10 pairs of observations, how many deviations happens? 9. It means m equals to 9 and number of concurrent deviations are denoted by 4. Okay, then what is the value of coefficient of concurrent deviations? Guys, tell me, formula plus or minus square root of plus or minus 2c minus m by m. Got it? What is 2c? 8. 8 minus 9 is minus 1 by 9. So since this 2c minus m by m is negative, keep a minus symbol inside or outside. Means I'm keeping a minus symbol here. Again, I'm keeping a minus symbol here. And your answer is minus 1 by 9. Now you are able to understand, guys. In root, negative numbers are not allowed. No. That's why we are keeping a negative sign inside and outside. That inside value will be plus, but this value, entire value will be minus. So minus of 1 minus 1 by 9? 1 by 9. 1 by 9 under root 1 by 3. Which 1 by 3? Minus 1 by 3. So just take care of the sign. Try to understand the importance of sign, guys. So it depends upon the question. So try to understand, guys, in your textbook or in your ICAI material, he'll provide you the formula as plus or minus square root of plus or minus 2c minus n by n. 2c minus n by n. But I'm not using that way, guys, because if I use 2c minus n by n, there's a chance that people feel that it is 2c, n is the number of observations. And that is the reason why I try to discriminate n and m, guys. So whenever he asks you a formula, just follow the same. Or else simply go through 2c minus m by m. That will be comfortable for you. Got it, guys? So now let's talk about the basic advantages and drawbacks of this method, guys. So what are the advantages and drawbacks of this method and what is happening here? Let's see. So guys, concurrent deviations is completely based upon deviations, no? Tell me, guys, for example, if I look at my previous MCQ, one of the observations from 60 to 88, it has happened. What much of difference increment is there? 28 increment. So let me assume that my next observation is 89. So for this increment, I'll keep plus symbol. For this increment also, I'll keep plus symbol. Means, am I focusing on my direction or just value? I'm not at all bothered about value, even if it is a difference of 1, even if it is a difference of 28, even if it is a difference of 2000. I'll just write plus symbol as there is an increment. Means, are you able to understand? Is it giving you the direct exact sign or exact degree? It is giving me the exact degree or exact sign but not the exact degree, because I am not bothering about plus 20 or plus 200. I'm giving the same importance to both. How can I accept that, guys? How can I accept? In mean deviation also I said plus 5 minus 5, I will give you same importance for the person who got 45 and 55. Not so correct. Like that, if I get a difference of 28 also, I'm getting plus symbol. If I get a difference of plus 200 also, I'm getting plus symbol. Means I'm not taking the values into consideration. I'm just focusing on the signs. That is what my problem is. So concurrent deviations are not going to tell you the concurrent deviations are not going to tell you the exact degree. They're just telling you the direction. But if you have a huge mass of data in which you are focused about degree, you are focused about sign of correlation, means you just wanted to know whether it is positive correlation or negative correlation. This is the best choice. But when it comes to scatter diagram is also giving you direction only. But if it is more than 30, it is so tough. But even if it is 30 or 200, it is just writing plus symbols and minus symbols only, right? It is such an easy method. If you have a huge mass of data in which you are focused about direction but not degree, this is the best way. And tell me, guys, it is not showing any difference between long-term oscillations and short-term oscillations, because whether it is a difference of 20 or 200, I don't bother. Yeah, it does not discriminate larger differences or smaller differences. Got it, guys? So it means there's a problem with degree. There is no problem with direction, but there is a problem with degree. So properties, guys, you all know this, whatever it is a correlation coefficient. It must lie between -1 and +1. Now, the next thing that you need to understand is, so our formula, according to our formula, the formula is plus or minus 2c minus m by m. But according to ICAI material, we have to follow 2c minus n by n. Guys, listen to me. If c equal to 0, how much you are getting? -1. So you need to keep a minus symbol inside, outside, no? So minus of root of minus 1. What's your correlation coefficient? -1. So r equals to -1 when c equal to 0. Let me take c equal to n. So 2n minus n by n, how much? 1. So I need to keep a plus symbol both inside, outside. So I'll be getting r equals to +1. Guys, if I take c equal to n by 2, what is 2 into n by 2? N. N minus n, 0. If I take c equal to n by 2, then r value will be equal to 0. So guys, I've already told you, it is just used to calculate the direction whenever there are huge mass of data. But it will not be useful for long-term oscillations. Whenever the difference is huge, you will not get the perfect answer. And it is not showing a difference between long-term oscillations and short-term oscillations. And these values are rough indicators. They're not the exact coefficient of correlation.Got it, guys? And that is all about coefficient of concurrent deviation. Now, coming into the next important method, the next important method of calculating coefficient of correlation is Spearman's rank correlation coefficient, which is the best method to calculate coefficient of correlation between two attributes. Means for a qualitative phenomenon, this is the only method of calculating coefficient of correlation between two qualitative phenomenons. Means if I ask you to calculate the degree of association between two judges who are in a beauty competition, it's all about qualitative phenomenon, no? For such kind of cases, we have to go through a measure called Spearman's coefficient of correlation. So it completely dependent upon giving ranks to the people who are there in the data. That is why we are calling it as Spearman's rank correlation coefficient. Let me write down the formula for Spearman's rank correlation coefficient. Rxy equals to, due to Spearman's, is 1 minus 6 summation d square by n into n square minus 1 when there is no repetition of ranks. If there is repetition of ranks, Rxy equals to 1 minus 6 into summation d square plus m1 into m1 square minus 1 by 12 plus m2 into m2 square minus 1 by 12 and so on. So if it is m1, m2, m3, you have to write 3 cases. If there are 3 repetitions, by n into n square minus 1. Madam, what is the summation d square? So d means difference between rank of x and rank of y. So we have to assign the ranks to the first series and second series separately. And then we have to calculate the difference between their ranks, and it is denoted by Rx minus Ry. For suppose if a rank got repeated twice, we have to take m1 equals to 2. Or it means if an observation got repeated twice, you have to take m1 equals to 2. If an observation got repeated thrice, you have to take it as m2 equal to 3. Now let me tell you another important thing is, there is an observation 60 which is repeated twice in X series and twice in Y series. Then you have to take m1 equal to 2, m2 equal to 2. This 2 is for X series and this 2 is for Y series. X series is different and Y series is different. Guys, you should not tell that, madam, it is the same observation. Why you are writing that many times? No guys, X series is different, Y series is different. If an observation which is repeated in X series, you have to take it separately. And even if it's the same observation that is repeated in Y series, you have to take it separately. And that is what the formula for Spearman's rank correlation coefficient, guys. Here you must understand, summation d, sum of difference in ranks is always 0. And rank of x plus rank of y is always equals to n plus 1. You should understand that. If that is happening, means whatever the rank that you are writing is a perfect rank, otherwise it's a wrong rank, then you have to assess again and you have to verify it again. Okay, so that's all about Spearman's rank correlation coefficient, guys. Now let's see the MCQs that are related to Spearman's rank correlation, so that you are in such a position to understand how to calculate Spearman's rank correlation coefficient, and then you are in such a position to understand the theory related to Spearman's. So let's see MCQ number 8, guys. The following are the marks in statistics and the marks in mathematics of a group of how many students? 10 students in an examination. Find the coefficient of rank correlation. So guys, our target is to calculate the rank correlation, right? So to calculate the rank correlation coefficient, we have a formula Rxy equals to 1 minus 6 summation d square by n into n square minus 1. So here, x and y values are given to you know. We have to calculate the ranks, guys. So for that, we have to look at the term which is having least value. Guys, here, there's no restriction that you have to give a highest rank or first rank to the least value. If you want, you can give least rank to the highest value also. It is up to you. For me now, I'm simply going up with giving highest rank to the least observation. So what is my least observation here? X is 9, right? So my least observation is 9. So I'm giving my first rank to 9. So guys, remember, there's no restriction that you have to give least rank to least observation, or else let us do this way. Let us give least rank to the highest observation. This is the highest observation, no? 65. I'm giving first rank. Next highest rank is 57 is the highest observation, that I'm giving second rank to this person. Next 48. Next 40. Are we done? Now, next, coming into the next observation, 33. Are you done? Next, next observation after 33, it is 24. Done? Now, guys, please focus. After 24, the next highest observation was 16, which is repeated for how many times? 3 times. Means we have to actually assign 7th, 8th, 9th ranks to these 3 people if they are different. But all the 3 are same, no? In such a case, we'll give the rank in such a manner that we'll calculate the average of 7, 8, 9. What is the average of 7, 8, 9? 7 plus 8 plus 9 by 3. How much? It is 8. So we will give rank 8 to all these 3 people. But guys, try to understand how many ranks got completed till now? 9. Because we are done with giving 7, 8, 9 ranks by taking the average. Now here, I just wanted to mark one thing. So this observation 16 got repeated how many times? 3 times. So I'm writing M1 equals to 3. Got it, guys? Now, so are we done with giving 9 ranks? Yes. Now let's go for the 10th rank. Where is the 10th rank? This one, right? This is the 10th rank. So this is how we'll assign ranks. Got it, guys? Now let's go for ranking system with respect to Y. Guys, now you must understand that you should not give the ranks in a reverse order. It means in X series, we have given highest rank to the person who got highest marks. So here also we should follow the same criteria, guys. So the first rank will be given to whom? Number 24, right? Any other observation? Yes, number 24. Next, 20. Next, 19. Next, 15. Next, guys, look at this. There is a competition between rank number 5 and rank number 6 because 13 got repeated how many times? 2 times. Can you please tell me the average of 5 and 6? 5.5. So after writing this, you must write here the rank 13 number got repeated 2 times. So you must write M2 equals to 2. Done. Now coming into the next one. 13 got completed, no? Now let's go for the next number. What is the next number after 13? 9. So we are done with 5, 6 ranks, no? Now we have to come for rank number 7. Next, if you look at 6 and 6, there's a competition between rank number 8 and rank number 9 because after 5, 6 we are done with 7th rank, no? Next 2 ranks are 8 and 9 in which 6 got repeated twice. So the rank should be average of 8 and 9 which is 8.5. After writing this immediately, you have to write M3 equals to 2. Now the last rank, this is rank number 10. This is how we can assign ranks to the people who are there in X and Y series. So now guys, listen to me. We need summation D square. D means rank of X minus rank of Y. But I don't want D. I don't want to write many columns. What I'm trying to write is just calculating D square with the help of my calculator. See guys, take your calculator and calculate 3 minus 5.5. What is 3 minus 5.5? 2.5. Okay. Whole square is minus 2.5. It's not considered because square is needed, no? Into equals to. I got 6.25 guys. Now use m plus. Now 5 minus 5.5. 5 minus 5.5. How much guys? It is minus 0.5. I am not worried. It is d. I need d square. It means I need into equals to, which is 0.25, no? Now use m plus. Like that, let us perform all the calculations. Next 4 minus 1 into equals to m plus. Next 10 minus 8.5 into equals to m plus. Guys, look at this. So here we are trying to calculate the difference of ranks. This is what we are doing. So we are done with 4 minus 1 also now. So now 10 minus 8.5. 10 minus 8.5 whole square m plus. Next 8 minus 4 whole square m plus. Next 8 minus 10 whole square m plus. Next 1 minus 2 whole square m plus. Next 6 minus 7 whole square m plus. 8 minus 8.5 whole square m plus. 2 minus 3 whole square m plus MRC. And we got 43.25. So we got 43.25. Now try to understand. This is 43.25. No. Now we have to understand whether there is any mistake. Means you can do it again guys. Let me repeat the calculation. I'll tell you the calculation. So 3 minus 5.5 whole square m plus. 5 minus 5.5 whole square m plus. 4 minus 1 whole square m plus. 10 minus 8.5 whole square m plus. Next 8 minus 4 whole square m plus. 8 minus 10 whole square m plus. 1 minus 2 whole square m plus. 6 minus 7 whole square m plus. 8 minus 8.5 whole square m plus. 2 minus 3 whole square m plus MRC. Sorry guys, I've got 41 this time. Sorry, I did a calculation mistake. So here summation D square equals to 41. And guys, I just wanted to know how many observations are here? 10 set of observations. Now look at your formula. Rxy equals to 1 minus 6 summation D square by n into n square minus 1. But along with that, since repetition of ranks is there, we have to calculate this. For that, can you please calculate what is m1 into m1 square minus 1 by 12? So m1 means 3 into 3 square means 9. 9 minus 1, 8 by 12. So this is 2. m1 into m1 square minus 1 by 12 is 2 when m1 equals to 3. Now what is m2 into m2 square minus 1 by 12? So it is 0.5. So again I need to write m3 into m3 square minus 1 by 12, no? So that is also 0.5. Now what is summation D square to you all? 41. So now n into n square minus 1, n is 100, 10, no? 10 into 100 minus 1 means 10 into 99, which is 990. Okay, let us perform the calculation now. 41 plus 2 plus 0.5 plus 0.5. Okay, 41 plus 2 plus 0.5 plus 0.5 into 6 by 990 plus or minus, because it is having a minus symbol, and then plus 1. So what's your answer? 0.83. Let me repeat the calculation guys. So summation D square, how much? 41 plus m1 into m1 square minus 1 by 12. What is m1? 3. 3 into 3 square. How much? 9. 9 minus 1. 3 into 9. 3 into 9 minus 1, which is 3 into 8 by 12, which is 2. Now m2. 2, no? No. 2 into 2 square means 4. 4 minus 1 into 3 by 12, which is 0.5. This is 0.5. 41 plus 2. 43, no? Plus 0.5 plus 0.5, 44. So your answer is 6 into 44 by 990 plus or minus plus 1, which is 0.73 bar guys, sorry. 0.73 bar. And that is there in option C. So that's how you can calculate Rxy. So that is what about calculation of coefficient of correlation. So due to Spearman's. So first of all, we have to calculate the ranks, and then we need to calculate the difference of squares, and then we need to do so if whether there is any repetition or not. So after performing all these things, you can do that. Now look at MCQ number 11. The coefficient of rank correlation of marks obtained by 10 students in statistics and accountancy was found to be 0.8. So guys, whether it is rank correlation or somebody else, will denote the coefficient of correlation with what? Rxy only. It means Rxy equals to 0.8. Guys, when it comes to exam, you need not write all these things, guys, because you know what it is. So don't waste your time by writing all these things. Just keep aside, or else just underline the data that is given to you in the textbook, it's in the exam question paper itself, and identify who are there. It means if there are 10 students, no, that will denote it with n. The correlation between x and y is Rxy. And it was later discovered that the difference in ranks of two subjects were obtained by one of the student was wrongly taken as 7 instead of 9. It means the 9 is to be substituted, but he has substituted 7. So understand, guys, the difference in ranks means D was taken as 7 instead of 9. So now we need to subtract 9 and we need to add 9. Got it, guys? The correct coefficient of rank correlation is, so before getting started, guys, what is the formula for Rxy? 1 minus 6 summation D square by, may I know what is n? 10, no. 10 into 10 square minus 1 is 99. Means 10 into 99 is 990. Guys, I'm taking this entire value to the left side. Now I'm bringing the 0.8 to the right side. It means 6 summation D square by 990 equals to 1 minus 0.8. So tell me, guys, what is 1 minus 0.8? 0.2. Use your calculator. Into 990 by 6. So guys, this is what I'm having. Summation D square is 33. Now tell me, the summation D square is correct summation D square or wrong summation D square? Absolutely wrong. So we have to subtract 7 or 7 square, as we are talking about D square. 7 square. What is 7 square? 49. That's why I'm subtracting 49. And we have to add 9 square, which means we have to add 81. Put together, it is 65. This is correct summation D square. Now, guys, I'm not performing anything else. I'm not writing anything else. So, correct summation D square is 65. If you want to write, you can, or else leave it, guys. Now, tell me the formula for Rxy. 1 minus 6 summation D square by n into n square minus 1. Okay, you know what is D square, summation D square? That is there. Into 6 by n into n square minus 1 means by 990. Okay, now we have to write, we have to keep a plus or minus symbol and then plus 1. So what's your answer? 0.60606. So that is there in option A. So guys, it's not about writing many things on the paper. It's all about reducing the length of the solution by writing the correct things. That's it, guys. So that's what about coefficient of rank correlation due to Spearman's. Now let's get into the theory part that is related to coefficient of rank correlation due to Spearman's, guys. So what are the advantages and drawbacks of this coefficient of correlation? So guys, first of all, you need to try to understand that Spearman's rank correlation coefficient is completely dependent upon ranks only. It is such a correlation coefficient which is trying to calculate the coefficient of correlation between two attributes even. So means coefficient of rank correlation is such an easy task, such an useful task for a qualitative information, right? So that's what your first point. Okay, but one more thing is, this is based upon values or ranks. Ranks only, right? Means in a data, if only ranks are given, that is the best one, no? So I have already told you that. What is summation D? 0. And rank of x plus rank of y, n plus 1. Got it, guys? So yes, summation D is always 0. And now, if the ranks of x and ranks of y are in reverse order, means ranks of y or x are in decreasing order, ranks of x are in y are in increasing order, x ranks are in decreasing order, and y ranks are in increasing order, then obviously summation D square will be 0, guys. Because they are in opposite direction, no? Yes. In such a case, what is the rank correlation coefficient? Sorry guys, if the ranks are in the same order, sorry for that guys, ranks are in the same order, so means if it is the first rank here, the first rank here, difference in ranks is how much? 0. If it is the second rank here, the second rank here, or if it is the third rank here, it is the third rank, means difference of ranks is how much? 0. In such a case, what is Rxy equal to? 0. Okay, now who is the most easier, who is the best one to talk about qualitative data? Just Spearman's rank correlation coefficient. And one more thing, it is difficult compared to scatter diagram and concurrent deviation, but it is easier compared to Karl Pearson that we haven't discussed yet. But guys, try to understand, best method should be like it is useful for both frequency and non-frequency data, and this method will not be useful for frequency data. Of course, not only this method, coefficient of concurrent deviations will also be not used for frequency data. And the next thing is, guys, if you have huge data, means if you have 40-50 observations, is giving ranks is an easy task? No, it's a tough task. So it's very difficult. That is why it is not such useful. And one more thing, guys, is it depend upon values or ranks? Ranks means it depends upon the order of the observations, but not the exact value of the observation. Even if there is a decrement of 1 or decrement of 200, we are giving the next rank to the next person. No, means it is not taking the values difference into the consideration. It is just taking ranks into the consideration. That is the another important drawback of the Spearman's rank correlation coefficient. Now coming into a very useful method and a best method of calculation of coefficient of correlation is Karl Pearson coefficient of correlation, which is also known as product moment coefficient of correlation. How do you call it as? Product moment coefficient of correlation. Got it, guys? So how do you call Karl Pearson coefficient of correlation? We can call Karl Pearson coefficient of correlation as product moment correlation coefficient. How do we call it as? Product moment coefficient of correlation. So what is the formula for the calculating this Karl Pearson coefficient of correlation? Means what is the formula to calculate coefficient of correlation due to Karl Pearson? Rxy equals to covariance of xy by standard deviation of x into standard deviation of y. So one thing I must tell you guys, here the joint variation of x and y is called as covariance of x and y, which is compared with the individual variations product. Let me repeat, the joint variation of x and y is denoted by covariance, and which is compared with the product of variations of x and y series. Means joint variation is compared with individual variations, then we can get the total variation. That's what according to Karl Pearson. Okay, got it, guys? So according to Karl Pearson, Rxy equals to covariance by sigma x into sigma y. No, so the coefficient of correlation limits are what? -1 to +1, right? So -1 less than or equals to Rxy less than or equals to +1. Guys, if Rxy covariance is 0, then Rxy will be 0. If covariance is positive, guys, you must understand standard deviation of x and standard deviation of y are always positive, because the definition itself is saying that I am a positive square root of, yes, means standard deviation is always positive. So it means Rxy will be negative if covariance is negative, Rxy will be 0 if covariance is 0, and Rxy is positive if covariance is positive. So the sign of Rxy is completely dependent upon the sign of covariance of xy. And what are the limits of Rxy, guys? -1 to +1. So means what are the limits of R square, guys? 0 to 1. 0 less than or equals to R square less than or equals to 1. Based upon this, we can write 0 less than or equals to covariance square of xy by variance of x into variance of y less than or equals to 1. Right? Because R square means it's square, no? So it means covariance of xy whole square is less than or equals to standard deviation, variance of x into variance of y. That's a very important formula. So means product of variances of x and y should be greater than or equals to covariance of xy whole square. And one more thing, -1 less than or equals to Rxy less than or equals to 1, no? So covariance by sigma x into sigma y less than or equals to 1, no? Take the sigma x into sigma y to the right side. So means covariance is less than or equals to standard deviation x into standard deviation y. It means sigma x into sigma y is greater than or equals to covariance, or covariance is less than or equals to sigma x into sigma y. So what is Karl Pearson coefficient of correlation? Rxy equals to covariance of xy by sigma x into sigma y. So madam, what is the formula for covariance of xy? So covariance of xy has many formulas, guys, and this is the distribution, or this is the coefficient of correlation which is applicable for both frequency data and non-frequency data. If it is useful for both frequency and non-frequency. And there is another formula, 1 by n summation xy minus x bar into y bar. You all know what is x bar. X bar equal to summation x by n and y bar equal to summation y by n. Now I'll tell you the definition of, or exact value, exact definition of covariance, guys. If I replace y with x, I'll get 1 by n summation x minus x bar into x minus x bar. Who is that? 1 by n summation x minus x bar into x minus x bar. It means 1 by n summation x minus x bar whole square. It is variance of x. So variance is a special case of covariance, right? If both the variables are same, it is nothing but covariance. Now I'll tell you the formula for frequency data also, guys. So frequency data, the formula will be 1 by capital N into summation Fij, means it's a bivariate frequency distribution, no? Xi minus x bar into Yj minus y bar. This is the formula for covariance. Now I'll tell you the direct formula of Rxy. Rxy has many formulas, guys. Let me write down all the formulas that are related here. Summation x minus x bar into y minus y bar by square root of summation x minus x bar whole square into summation y minus y bar whole square. This is the first formula for Rxy. And the next formula, n summation xy minus summation x into summation y by square root of n summation x square minus summation x whole square, along with you have to write for y, n summation y square minus summation y whole square. Now guys, I must tell you one thing. Coefficient of correlation is unaffected due to origin and scale. It is just affected due to sign. So guys, different people will give you the formulas in different ways, guys. I'll just tell you a very simple shortcut to identify relation between RUV and RXY while explaining formulas. So I've told you coefficient of correlation is unaffected due to both origin and scale, but it is affected due to sign. Next, let me show you this coefficient of correlation due to Karl Pearson. So what are the properties? It establishes both direction and degree. I have already told you this is the best one. And it is independent of change of origin and scale. I have already told you coefficient of correlation is always symmetric. Rxy equals to Ryx. So for any two independent variables, guys, try to understand the variables are what? Independent. The coefficient of correlation, independent means there is no relation, no. So coefficient of correlation will be 0, right? But if the coefficient of correlation is 0, it doesn't mean that the variables are independent, because I'll tell you an example. Y equal to what? X square. Let me take the values. X equals to minus 1, 0, plus 1. What is y? 1, 0, 1. Can you please tell me what is summation xy? 0, no? What is summation x? 0. Summation y? 2. Now look at this formula. Rxy equals to n summation xy. Summation xy is 0, no? 0 into everything will be 0. Summation x is also 0 and 0 into everything will be 0. So entire numerator became 0, no? 0 by anything? 0. So coefficient of correlation became 0. Does it mean that x and y are independent? No, x and y are completely dependent. They've given you a relation y equal to x square. But what is happening here? Guys, Karl Pearson starts off with an assumption that I am the person who is calculating the coefficient of correlation between two variables who are linearly dependent. If you substitute the variables which are non-linearly dependent in my formula, I'll give you some random value. It doesn't mean that I'm doing error. You only did the error. You only did a mistake, because I'm the person who will give the relation between two variables only if the variables are linearly connected. If you substitute some other variables, it's not my problem. It's your mistake. You should not substitute the variables which are not linearly connected in my formula. My formula will be very good only if the variables are linearly independent. Second thing, my formula will be good only if the variables are logically related. If you substitute shoe size and intelligence in my formula, I'll definitely give you some value. As I'm a formula, I'll give you value. But you have to think of the values that you are substituting in the given question. So because I'm the person who will give coefficient of correlation between two variables perfectly only if my variables are linearly and logically correlated. Got it, guys? So, and this is the best method of coefficient of correlation, guys. And I've already told you, this will be used for both frequency data and non-frequency data. And of course, this is used for higher algebraic treatment also. But the problem is, I've already told you, it is applicable only in case of linear relationship. And it is dependent upon variance means standard deviation. No, it is highly affected by extreme observations. But this is more time consuming method, guys. The problem with this is it is more time consuming method. That is the drawback of Carl-Pearson coefficient of correlation, guys. Now let's get into the MCQ part that is related to coefficient of correlation. Okay, so let's get into the MCQ part, guys. Now let's see MCQ number 14 first. What is MCQ number 14? So guys, read out the MCQ thoroughly. It is such an easy MCQ, but it is such an important MCQ. The covariance between two variables is 20 and the variance of one variable is 16. What is the variance of the other variable? Guys, he asked you about the standard deviation limits or variance limits. Variance limits. If he asks you about variance limits, use this condition. Means covariance of xy less than or equals whole square less than or equals to variance of x into variance of y. Let me write covariance of xy whole square less than or equals to variance of x. So they'll write s square x into s square y. So now according to your question, what is the covariance? 20. 20 square means 400. Got it? Less than or equals to. What is variance of one variable? 16. Let it be x. So variance of x is 16. And we have to talk about s square y. Take your calculator and tell me what is 400 by 16. 400 by 16 is nothing but 25. 25 less than or equals to s square y. Now reverse it. S square y is greater than or equals to 25. So that's what your correct answer. Option A. Now let's get into the next MCQ, guys. MCQ number 18 that I chosen, guys. Look at MCQ number 18. For any two variables x and y, it is known that covariance of xy is 8. R is 0.4. The variance of x is 16. And the sum of squares of deviations of y from its mean is 250. The number of observations, guys. What is it given to you? Covariance of xy is 8. R is 0.4. Now let me write down the formula for R. What is the formula for R? R equals to covariance of xy by sigma x into sigma y. Am I correct? Sigma x into sigma y. Now guys, what is R according to him? 0.4. Covariance 8. Let me replace or let me substitute. R is 0.4. Covariance is 8. By standard deviation of x is 4. And I don't know the standard deviation of y. For standard deviation of y, he gave some information. I forgot about it and I'll just calculate what is sigma y. 8 by 4 into 0.4. No, take your calculator. 8 by 4 by 0.4 and you got sigma y equal to 5. Try to understand one thing, guys. Sigma y equals to 5. Just try to understand what is sigma square y. 25, no? Tell me the formula for sigma square y. Summation y minus y bar whole square by n is sigma square y and that is equals to 25. Now let me show you the next line of my question. The sum of deviations of y, sum of squares of deviation of y from its mean is 250. Sum of squares of deviation of y from its mean is 250, means this value is 250. It means 250 by n equals to 25. Can you please tell me what is n equals to? 10. And that option D is the correct answer. Now let's go towards the next MCQ. Compute MCQ number 20. Compute the coefficient of correlation between x and y for the following data. N is 10, summation x y 220, summation x square 200, summation y square 262, summation x 40 and summation y 50. Guys, before writing all these things, just write down the formula for Rxy by using the given things. The formula for Rxy is n summation xy minus summation x into summation y by square root of n summation x square minus summation x whole square. The next part, square root of n summation y square minus summation y whole square. Guys, my suggestion to you all is take your calculator and calculate everything with the help of calculator. N summation xy, I'll tell you what is n. 10 into 220, 10 into 220, which has got plus symbol, so use m plus. Minus summation x into summation y means 40 into 50, m minus MRC, and I got 200. So 200 is my numerator. And I am writing 200 in terms of numerator. And in denominator, we have to write down both the values under root. Okay. Now, again, clear your calculator's memory. Guys, clearing your calculator's memory means there should not be any m symbol at the topmost corner of your calculator. Now, again, n summation x square minus summation x whole square, no? So, 10 into 200 m plus, 10 into 200 m plus, summation x whole square means 40 whole square m minus MRC, and I got 400, guys. Let me write this 400 here. Next, clear your calculator's memory. Next, n into summation y square means 10 into 262 m plus, next 50 square m minus MRC 120. So, are you done? Now, you have 120 in your calculator, no? Now, I'll show you. Have to write down the direct answer. 120 is there, no? Multiply it with 400. Okay. There is a square root, no? Just enter square root. It is in numerator or in denominator? Denominator. Use divided by equals to. Divided by equals to. Into 200. What's your answer? 0.912 something. And 9128. And that is there in option A. So, try to understand the importance of using your calculator, guys. If you use it means not only the product moment correlation coefficient, anything will be easier for you. Now, look at MCQ number 22. Guys, try to understand. Find the coefficient of correlation between x and y series. That's what your question. For this, you have to do n summation xy minus summation x into summation y by n summation x square minus summation x whole square. That's what we recently used, no? That formula you need to use. But before getting started, look at your question. X values are in which direction? Increasing order. Now listen to me. Y values. 5, 4, 3, 2. Most of the Y values are in which order? Descending order. Got it, guys? X values are increasing. Most of the Y values are in decreasing order. But the last one is in increasing order. So there's no chance I can say negative correlation is there. There might be a chance of getting zero correlation also. So first of all, let me complete one thing. Let me calculate summation xy means 1 into 5. How much, guys? 5. 2 into 4 plus 8. Now 3 into 3, 9. Next 4 into 2, 8. Next 5 into 6, 30. So I got summation xy as 60, guys. Okay. So let me write summation xy as 60. What is the n? How many observations are there? How many set of observations? 5. Now, could you please tell me what is summation x? 1 plus 2 plus 3 plus 4 plus 5. How much? How much? 1 plus 2 plus 3 plus 4 plus 5. 15. Now, could you please calculate what is summation y? 5, 4, 3, 2, 6. Add all of them. 5, 4, 3, 2, 6. It is 20. Now, let's talk about summation x square, summation y square later. Let me complete my numerator so that I'll get a clarity about sign. If it is negative means I can directly keep the correct answer. No. So, n summation xy, guys. What is summation xy to you all? Look at your textbook. 60 into 5. Tell me what is 60 into 5? 300. M plus. Got it? Minus summation x into summation y means 15 into 20. How much, guys? 300. So, numerator is how much? I don't want to calculate my denominator. My numerator is 0. If my numerator is 0, entire Rxy means if my covariance is 0, my Rxy will definitely be 0. So I need not solve anything. I need not solve the complete question. Now look at 26, guys. So guys, this is a very important question that I have already explained you. The relation between two variables x and y is 2x plus 3y plus 4 equal to 0. Then the coefficient of correlation between x and y. Guys, before getting started, do a simple task. Keep y at the left side. Take x value and constant to the right side. Means it is like 3y equals to minus 2x minus 4. Could you please tell me what is y equals to? Minus 2x by 3 and minus 4 by 3. Just look at this. It is like y equal to a plus bx. Look at the coefficient of x. Is the coefficient of x is positive or negative? Negative. If it is negative, rxy is perfectly minus 1. If coefficient of x is positive, it is perfectly plus 1. Got it, guys? So simply try to keep y value at the left side. It is like y equal to a plus bx. I have already told you, if b is positive, rxy is plus 1. If b is negative, rxy is minus 1. It is called as perfect linear correlation. Do you guys remember? So yes, that's what it is connected to. Now let's have a look at next MCQ, guys. MCQ number 29. This is a very important model, guys. The coefficient of correlation between x and y is what? 0.5. So rxy equals to 0.5. Rxy is equals to what, guys? 0.5. Now let's have a look at the next line. Then the correlation between the variables 2x minus 4 and 3 minus 2y. So guys, let me write 2x minus 4 as u. 2x minus 4 as u. And v equal to 3 minus 2y. Guys, listen to me. If your x coefficient is having a plus sign, means keep plus 1 here. Now look at this. What about y coefficient here? Minus, no. Just write minus 1 here. Then can you please multiply plus 1 into minus 1? Which sign you got? Minus sign. It means directly write RUV equal to minus 0.5. As I told you that coefficient of correlation is unaffected due to origin and scale. It is just affected due to sign. Now this is the sign. Okay. Now guys, for example, I gave you u equals to minus 2x minus 4. V equals to minus 2y plus 3. What is the sign that x has? Minus symbol. So keep minus 1. Y has minus symbol. So tell me guys, what is minus into minus? Plus. So RUV equal to plus 0.5. Got it, guys? So that's how you can write it down. So guys, try to understand. Suppose if I have given you RXY equal to minus 0.4. Then what is RUV equal to? RUV equal to RXY or minus RXY? RXY only, because both of them are having minus symbols, means minus into minus will be plus. So RUV equal to plus RXY. Suppose if this is plus, I have to write plus. So RUV equal to minus RXY. What is RXY? Minus 0.4. And I have a minus symbol already. Minus of minus will be plus. So means if both of them are having same signs, RUV equal to RXY. If both of them are having opposite signs, means RUV equals to minus RXY. That's how you can proceed, guys. Now let me show you the next MCQ of mine. The next MCQ is MCQ number 33. Look at MCQ number 33. There are two equations, m plus 3p equals to 2 and 6n plus 2q equals to 1. The coefficient of correlation between p and q is 0.5. What is the coefficient of correlation between m and n? So let me write what is RPQ. RPQ equals to 0.5. Keep it aside. Now we have to calculate the coefficient of correlation between m and n, no? So we have to keep m at the left side and take p to the right side. So what is m equal to? Minus 3p plus 2. Got it, guys? M equal to minus 3p plus 2. Now we have to write n at the left side and take everybody to the right side. 6n plus 2q equals to 1, no? So I'm writing 6n equals to minus 2q plus 1. 6n equals to minus 2q plus 1. So what is n equal to, guys? Minus 2 by 6, q plus 1 by 6. Guys, just focus on the sign but not the value. So here p is having plus symbol or minus symbol? Minus symbol, so write minus 1. Here q is having plus symbol or minus symbol? Minus symbol, so write minus 1. Okay, tell me what is minus 1 into minus 1? Plus 1. So Rmn equals to, I can write Rpq plus Rpq, and that answer is 0.5. See how simple it is. It is just plus 0.5. Got it, guys? let's get into the next concept called coefficient of determination and coefficient of non-determination and coefficient of alienation, guys. There's a very important concept, guys. So we have many MCQs based upon this concept, guys. So let's get into the concept, guys. So just a moment, guys. Yeah, coefficient of correlation is trying to measure what kind of relationship? Linear relationship, guys. So now, what is the square of coefficient of correlation called as? The square of coefficient of correlation is called as coefficient of determination. And 1 minus r square is called as coefficient of non-determination. So, madam, what is this coefficient of determination, guys? We have x and y, no? Between x and y, there is some part of variation, no? So, this independent variable is trying to explain the amount of change in dependent variable, or this independent variable is trying to explain what part of change is there in dependent variable. So, independent variable is trying to explain the amount of change that is going to happen in dependent variable. So, some part will be explained, guys, not the complete part. So, the explained part is called as explained variance and the unexplained part is called as unexplained variance. Both of them put together is called as total variance, no? So, explained variance plus unexplained variance is equals to total variance. Now, what is coefficient of determination means? Coefficient of determination is nothing but explained variance by total variance. What is coefficient of determination? Explained variance by total variance, which is denoted by r square. And coefficient of non-determination is nothing but unexplained variance by total variance. But what is unexplained? Total minus explained, right? So, by total. So, total means 1. 1 minus explained by total variance, which is nothing but 1 minus coefficient of determination. So, what is coefficient of determination is denoted by r square. So, it will be 1 minus r square. So, that's what the theory that is related to coefficient of determination and non-determination, guys. Now, there is another important concept called probable error. So, what is this probable error, guys? I've already told you. In statistics, we always deal with sample. And we'll confine this discussion to population. In general, we will confine these values, or we'll calculate the values of population based upon sample values. So, but tell me, guys, how can you say that the sample value is directly equal to population value? You can't tell like that, no? There is some more discrepancy between population value and sample value, no? Yes, look at this. Probable error is an instrument which is used to test the reliability of the value of R. Means whether the value calculated by you is correct or not can be guessed with the help of probable error. And that probable error formula is probable error is equals to 0.6745 into standard error. Most of the people will say 2 by 3 into standard error. Okay, so it is actually 0.6745 into standard error. Madam, what is the formula for standard error? Standard error is equals to 1 minus r square by root 10. Okay, so how do you use this? It is used to test the significance of rxy. If modulus r is less than 6 times the probable error, which is higher, guys? Error is only higher, no? So probable error, the value calculated by you or the r value calculated by you is not correct, is not significant. Got it, guys? So, if modulus r is greater than or equals to 6 times the probable error, means r is bigger, no? So, the coefficient of correlation calculated by you is correct. So, now what are the limits of population correlation coefficient? The limits of population correlation coefficient are, for the coefficient of correlation due to in population is denoted by rho xy. Rho xy limits are r minus probable error and r plus probable error. People call it as r plus or minus probable error. Now, let's get into the next MCQ, guys. MCQ number 36. So, what is MCQ number 36? Just a moment, guys. I'll show you what is MCQ number 36 here. So, MCQ number 36 is this one. The coefficient of correlation. The coefficient of correlation between two variables is minus 0.9. What is the coefficient of determination? Tell me the formula for coefficient of determination. R square. R square means 0.9 whole square, which is 0.81. Now look at MCQ number 42 is. So what is 42? R equal to 0.7 and N equal to 64, find out the limits for the population correlation coefficient. Just now I told you the limits of population correlation coefficient, R plus or minus probable error. No? What is the formula for probable error? Probable error equals to 0.6745 into 1 minus R square by root n. According to your question, what is R value? 0.7. Calculate 0.7 whole square. Got it? 0.7 whole square, which is 0.49, right? So plus or minus plus 1 by, guys, listen to me, n value is 64, root over n means 8. So divided by 8 is what I am using, into 0.6745. Into 0.6745 will give you 0.042999, guys. I am taking it as 0.043. And you said that R equal to 0.7. So 0.7 minus 0.043 is lower limit. 0.7 plus 0.043 is your upper limit. So calculate 0.7 minus 0.043. How much? 0.657 is my lower limit. Now 0.7 plus 0.043 means 0.743. Now look at your option 0.657 and 0.743, option A. So guys, but I'll tell you a very simple trick to calculate these kind of questions. Just simply calculate the average of these two terms. If the average of these two terms is 0.7, that's a correct answer. And if you want, you can use your calculator. Tell me what is 0.743 plus 0.657 by 2? It's 0.7. But what is 0.652 plus 0.95 by 2? No, it's not 0.7. It's 0.801. So it's a wrong answer. Now 0.263 plus 0.869 by 2. Tell me how much is this? 0.566. It is also not 0.7. Why? Because guys, by adding these two things, we'll get R 2R only, right? 2R by 2 means R only, right? So after adding both the limits, if you divide them with 2, you should get R. That is what the shortcut to solve these kind of questions. And that is all about correlation, guys. Its significance, its limits, everything is important. In particular, the way that you are using your calculator plays a very important role. Guys, please focus on change of origin and change of scale questions, guys. They're very important for your exam. So guys, let us get into the next concept, which is regression analysis. So as we have already discussed that regression analysis is the continuation of correlation analysis, right? So in regression analysis, what are we going to do? In correlation, we have calculated the coefficient of correlation, no? Means we found whether there is a relation between X and Y or not. If so, how much relation? Whether it is positive or negative. If it is positive, how much? If it is negative, how much, right? So what is the best measure of coefficient of correlation? Carl Pearson, no? So we are going to use that fellow called Carl Pearson coefficient of correlation here. It means we will be establishing a relation between the two variables X and Y. How are those two variables are related? Means we'll find out a mathematical relationship between X and Y. And then with the help of this relation, we can calculate the value of dependent variable based upon the value of independent variable. So to identify this relation between X and Y, we will use a method called method of least squares. So we have to use a method of least squares to identify the constants and to establish the relation between X and Y, or the independent and dependent variable, so that we are able to draw a regression line, or we are able to forecast what is regression line. So how many regression lines will be there? There are two lines of regression. One is regression line of Y on X and the other one is regression line of X on Y. Guys, though they have mentioned that it is a regression equation of X on Y and Y on X, I am saying that it is a line because my Carl Pearson coefficient of correlation deals with only what kind of relationship? Linear relationship only. That's why I am not calling it as a regression equation. Yes, the original regression analysis will give you whether it is a linear relation or curvilinear relation, it will give you. So there you can call it as regression equation because there are curves also. But here in my foundation syllabus, my discussion is completely confined to only linear analysis. So with the help of regression line of, madam, what is regression equation of Y on X? Guys, Y on X means here Y is dependent upon X. It means X is independent variable and Y is dependent variable. The name itself is saying that Y on X means Y is dependent upon X. For example, yield of a crop, rainfall. Who is dependent upon whom? Yield of a crop depends upon rainfall. Rainfall is considered as independent variable and yield is considered as dependent variable. Here we mention what is a dependent variable and what is an independent variable. What is the dependent variable? The variable which is predicted on the basis of another variable is called as dependent variable. Means we'll predict rainfall based upon, we'll predict yield of a crop based upon rainfall. That yield is called as dependent variable as it is calculated with the help of rainfall. Now, who is an independent variable? Independent variable means the variable which is used for prediction. Which variable got used? Yes, rainfall. That is called as independent variable, which is also known as explanatory variable or regressor. So next, dependent variable. Guys, just remember ED. It ends with ED. Explained variable or regressed variable are called dependent variables, and you know what is an independent variable. Got it, guys? So what is the meaning of regression? Regression analysis is aiming at establishing the average relation between two variables. Why it is the word average used? Because you all know that statistics is completely dependent upon certain criteria. If the rules are not followed, you will not get the correct answer. And statistical relations are true only on an average. That's why they mentioned the regression analysis aims in establishing an average relationship between dependent variable and independent variable. Got it, guys? So, after establishing this relationship, if you substitute the value of independent variable, then you will get the value of dependent variable in terms of original units of data. For example, if I am talking about rainfall and yield of a crop, I'll write yield equals to A plus B into rainfall. So rainfall will be in millimeters or centimeters. Yield will be in tons. Means though you have substituted rainfall in terms of millimeters, you will get yield in terms of tons only. Yeah, that's what he is telling you in terms of the original units of data. So guys, this is very much helpful in human activity. I have already told you, like correlation, regression analysis will be also useful for us in many ways. For example, suppose if I wanted to, if I invested something in a particular business, it is giving me this much of profit. If I invest more, how much am I going to get? Means these predictions are very much helpful in very human activity, right? So in every human activity, so regression is there. Regression plays a very important role. With the help of regression analysis, we'll just estimate the profits. We'll just estimate the amount that we are going to receive in the future, so that we will invest or we will not invest. That we'll decide, no? Yeah, these forecasts or these projections are very important for each and every human activity. Got it, guys? So what is regression analysis doing? Here, first of all, we'll establish a relation between independent variable and dependent variable. In that relationship, if we substitute the value of independent variable, we'll get the value of dependent variable. That's what we are going to do in this concept called regression analysis. So types of regression. So already we have discussed, guys, simple, multiple, linear. Linear means the relation between x and y is, it's a form of a line. Multiple regression, the name itself is saying, I'm a regression analysis which is studying about more than two variables. Got it? So what is a simple regression? It is a relation between exactly two variables. Guys, try to understand it's not linear. It can be anything. Got it, guys? Y equal to a plus bx, x equals to a plus by, or something else. So, but try to understand it is the relation between exactly two variables. It's not about linear relation. It can be anything. Y equal to a into b power x. Like that also. Try to understand. Here, a and b are called as constants, which are also known as regression parameters. Now, what is the principle of least squares and how do you draw regression line? So, guys, I'll tell you a very easy way to identify this, guys. In future, with the help of regression analysis, we'll draw an estimated, we'll calculate estimated values, no? So, let me draw all the estimated values here. As it is a line, it will definitely show you a line. But in future, after 2 or 3 years or after 10 years, we'll see the original figures also, right? So let me assume that the original figure is here. Means the original figure is away from the actual figure. So here the difference between estimated value and actual value is called as error. Now tell me, guys, difference between actual value and estimated value is positive or negative? Positive. Suppose, let me assume that my actual value is here. Means difference between actual value and estimated value is negative. This difference is called as an error. So, what is a least squares principle? Least squares principle is this way, guys. Let me assume that y equal to a plus bx is an estimated line. It is an estimated line only, right? It's a regression line, no? It's an estimated line. The sum of squares of differences between actual value and estimated value square is minimum. That is called principle of least square. Sum of squares of differences between actual value and estimated value. Estimated value means this much, guys. So he is denoting it with y cap, means summation y minus a minus bx whole square is minimum. This is called as least squares principle. Got it, guys? Sum of squares of differences between actual and estimated values is minimum. And we have talked about this estimated error in the calculation, guys. So whatever we are doing it now is an estimated value. If the actual value lies upward, difference between actual and estimated is greater than 0, so error is positive. If the actual value lies downwards, difference between actual and estimated value is negative. So they have showed the error as negative, guys. So, madam, what are the formulas to calculate regression equations? Okay, so guys, there are two regression equations I have already told you, as there are two variables. One is x and the other one is y. That's what we are talking about. Means if here x is dependent variable, y should definitely be independent. If y is dependent variable, x should be independent. No. Now look at this. So I'm saying that regression equation of y on x means who is dependent upon whom? Y is dependent upon x. And the formula for regression equation of y on x is y minus y bar equals to byx into x minus x bar. And the regression equation of x on y is, means x is dependent upon y. The formula is x minus x bar equals to bxy into y minus y bar. Madam, who is this x bar, y bar? You guys know it, right? X bar means mean of x, y bar means mean of y. There's no discrepancy at this stage. Okay, now, madam, what about this byx? Byx is the regression coefficient of y on x. Let me repeat. Regression coefficient of y on x. And the formula for byx is r into sigma y by sigma x, or sy by sx. And the formula for bxy is bxy equals to r into sigma x by sigma y. Now, if you multiply bxy and byx, what are you going to get? Yes, r square. So, bxy into byx is equals to r square. R square equals to bxy into byx. Now, I wanted to tell you another thing. So, guys, tell me, sigma x, sigma y are positive or negative? Always positive. So, means the sign of bxy or byx depends upon the sign of r. It means if r is positive, both bxy and byx are definitely positive. If r is negative, both of them are negative. If r is 0, both of them are 0. Means you must understand this way. Both bxy and byx must have same sign. Got it, guys? Must have same sign. Otherwise, data is inconsistent. Now, what is r square equal to bxy into byx? No, then r equals to plus or minus square root of bxy into byx. Madam, when it is positive. If both bxy and byx are positive, then r is positive. No. If both of them are negative, then r is negative. No. If both of them are 0, then r equal to 0. Try to understand. So, the sign of rxy is completely dependent upon the sign of bxy and byx, or the signs of bxy and byx are depends upon the signs of rxy. Guys, try to understand. Is bxy equal to byx? No, means bxy is not equals to byx. Means coefficient of regressions are asymmetric, but rxy equal to ryx. Regression coefficients are asymmetric, but coefficient of correlation is symmetrical information. Got it, guys? Now, look at the regression lines. Y minus y bar equals to bxy into x minus x bar, and x minus x bar equals to bxy into, y minus y bar equal to byx into x minus x bar, and x minus x bar equal to bxy into y minus y bar. Now, listen to me. If r equal to 0, what is byx? 0. What is bxy? 0. Then what is the equation of y on x? Y minus y bar equal to 0. What is the equation of x on y? X minus x bar equal to 0. It means if r equal to 0, y on x equation will be like y minus y bar equal to 0 means y equal to y bar. So like that, x minus x bar equal to 0 means x equal to x bar. So guys, this line y equal to k is parallel to x-axis. This line x equal to k is parallel to y-axis means how are they? Yes, they both are perpendicular. Like that, if r equal to plus or minus 1, both the regression lines will coincide. Both the regression lines will coincide. If r equal to plus or minus 1, both the lines will coincide so that the angle is 0 degrees. Some people will say 180 degrees, guys. It's up to them. So we people will say that 0 degrees because they both coincide, no? Yes. Where is the angle 90 degrees? Yes. It means the angle between two regression lines depends upon coefficient of correlation. Angle between two regression lines is completely depends upon coefficient of correlation. So guys, there are certain formulas for bxy and byx. Along with that, what I have taught you, bxy equals to r into sigma x by sigma y, no? R into sigma x by sigma y. So what is R? R means covariance of xy by sigma x into sigma y, no? So what is R? Covariance by sigma x into sigma y into sigma x by sigma y. Who are going to be cancelled? Sigma is sigma x. What else is left? Covariance by variance of y. Got it, guys? Like that. So look at this, guys. Here y should come into denominator, no? Like that. Byx equals to covariance by sigma square x. Okay. Now, how do you write bxy? Bxy equals to summation x minus x bar into y minus y bar by, got it, guys? Summation y minus y bar whole square, or else n summation xy minus summation x into summation y by n summation y square minus summation y whole square. Like that, you can write down the formula for bxy also. What is the formula for, byx also? What is the formula for bxy? Byx summation x minus x bar into y minus y bar by summation x minus x bar whole square. That is equals to n summation xy minus summation x into summation y by n summation x square minus summation x whole square. These are some basic formulas about regression equations, guys. So now I have already told you about the sign. Rxy, bxy, byx, all of them have the same sign. So next thing, you know that what are the limits of r square, guys? 0 to 1, no? It means 0 less than or equals to r square less than or equals to 1. So who is r square? You know that r square equals to bxy into byx. So product of two regression coefficient must be less than or equals to 1. And one more thing, guys, this is a very important thing. Regression coefficients are unaffected due to origin, but they are affected due to scale. So guys, instead of this formula, I'll tell you a very simple formula. U equal to a plus bx. V equal to c plus dy. V equal to c plus dy. BUV, right? So what is the coefficient of U here? B, right? B by coefficient of D, coefficient of Y, D. B by D into, just write RXY. Follow the same order. If I ask you what is BVU, D by B into RYX. Okay. Next, now you know that AM is always greater than or equal to GM. Do you remember that? Yes. Arithmetic mean is always greater than or equals to geometric mean. So means A plus B by 2 is greater than or equals to root over AB. You know that. So let me replace A with BXY and let me replace B with BYX. BXY plus BYX by 2 is greater than or equals to. So guys, sorry guys, geometric means root AB, no? It means greater than or equal to root over BXY into BYX. May you know who is this fellow called root over BXY into BYX? Yes, he is nothing but R. Means R is BXY plus BYX by 2 is greater than or equal to R. That's what given to you as a next point. And you know what is R equals to. Okay. Now, if R equals to plus or minus 1, then what is R square equals to? 1 only, right? If R equals to plus or minus 1, then R square equals to 1. What is R square? BXY into BYX, and that is equals to 1. Then what is BXY? 1 by BYX. Got it? What is BYX? 1 by BXY. Got it? So if R equals to plus or minus 1, both the regression coefficients will be the reciprocal of one another. If sigma x equals to sigma y. So guys, what is the R BXY equals to? R into sigma x by sigma y. Both of them will be cancelled, no? So what is BXY equal to? R, like that BYX is also equals to R. Now, what is BYX? BYX measures the change in y for a unit change in x. Here the change is going to happen in x. Guys, I have already told you Here we are confining our discussion to only linear equation. It means b by x will be like this, y equal to a plus bx. So in correlation analysis only we discussed about linear, non-linear. Linear correlation means corresponding to a unit change in x, there exists a constant change in y. Means b by x always talks about change in y for a unit change in x. Like that, bxy always talks about change in x for a unit change in y. And we discussed about this properties of regression, guys. So guys, what are the lines of regression, guys? X minus x bar equal to bxy into y minus y bar, and y minus y bar equal to bxy into x minus x bar. The point of intersection of both the regression lines is x bar and y bar. Means both the regression lines intersect at the point x bar y bar, or else simply if you substitute x bar y bar in the equation, it will be satisfying, because if you substitute y bar here, you will be getting 0. If you substitute x bar here, you will be getting 0, means 0 equal to 0. Here also you will be getting 0 equal to 0. Means both the regression lines are passing through the point x bar and y bar. And I've already told you, if r equals to plus or minus 1, both the regression lines are identical. If r equal to 0, both the regression lines will be perpendicular. And the slope of regression line of y on x is b by x. It looks like a y equal to mx plus c format. So, but the slope of regression line of x on y will be 1 by bxy, because guys, if it has to be in the form of y equal to mx plus c, you need to bring this 1 by bxy to the right, no? Then only it will be like y equal to mx plus c, which is slope intercept form. Do you guys remember? Earlier in your 10th standard, you used to read these things, y equal to mx plus c. Yes, here the regression line of x on y having a slope called 1 by bxy after converting it into a standard form. So what is the purpose of regression? Yeah, you already know. You are going to forecast the value of dependent variable based upon the value of independent variable. Along with that, you are going to calculate, you can calculate r value based upon bxy and b by x. And of course, you are establishing the relation between independent variable and dependent variable. Now, let's talk about correlation versus regression. Guys, you already know correlation is an absolute measure or relative measure. Relative measure, it is used for comparison. But regression is going to calculate some value based upon another value, and you already know that it is unit dependent. Got it? So, regression analysis is unit dependent and it is an absolute measure. Correlation analysis is unit free and it is a relative measure. And you know, bxy is not equal to byx, but rxy equal to ryx. So, correlation is symmetrical, but regression is asymmetrical. So, who is independent of units? Correlation. Who is dependent upon units? Regression. Who is independent of both origin and scale? Correlation. Who is dependent on scale? Regression. And that is what the theory that is related to this concept called regression analysis, guys. Now let's get into the MCQ part. Here the first MCQ that I have chosen is MCQ number 1, guys. Let me show you MCQ number 1 here. Yeah, this is my first MCQ. Let's read out the MCQ, guys. If y is dependent variable and x is independent variable, means y on x, that's what we need to understand. Independent variable should be always written at the right side. Okay. And standard deviations of x and y are 5 and 8 respectively. Correlation between x and y is 0.8. Find the regression coefficient of y on x. Guys, tell me the formula for regression coefficient of y on x. byx equals to r into standard deviation y by standard deviation x. Take your calculator. What is r? 0.8 into standard deviation y. Standard deviation y is 8 by standard deviation x 5. And I got an answer of 1.28, guys. And that 1.28 is there in option B. Now let's see the next MCQ. MCQ number 5 that I wanted to show you, guys. Let me show you MCQ number 5. So what is MCQ number 5? So it's a very important one, guys. Given 2x minus 3y equals to 10 and 3x plus 4y equals to 15, which of the following is a regression equation of x on y? So guys, to understand whether the given equations represent regression lines or not, first of all, take minus common if possible if there is any negative symbol outside, or else keep the lines as it is. Now tell me the coefficient of x. What is the coefficient of x in the first equation? I just wanted to know whether it is positive or negative. Positive. This one also positive. Both of them are having same sign or different sign? Same sign. But if you look at the coefficients of y, one is having negative sign and the other one is having positive sign. Here it is negative and here it is positive. They are not going to represent regression lines. As I told you, bxy and byx must be having same sign. So simply understand, verify whether both the equations are having same sign in respect of x and in respect of y. Madam, suppose if you are having an equation like this, guys, can I bring minus outside? Yes, I can write 2x plus 3y equal to minus 10. These things are common, guys. You should understand on your own. I can pull out minus. So both the x's are having same sign. Both the y's are having same sign. Okay, or else you can simply talk about this way. Calculate the ratio between x coefficients in both the ways. What is the ratio between both the x coefficients? Sign positive. Here, negative. They won't represent regression lines. They should represent, they'll represent regression lines only if both the ratio is same. That's why you can remember. It's up to you. Okay. So they don't represent regression line. So the correct answer is none. Now guys, let's have a look at next MCQ. MCQ number 8. Madam, if they represent, how do we identify? I'll tell you guys. I'll tell you in a while. First of all, look at MCQ number 8. For the regression equation of y on x, the value of byx. Guys, remember, if it is the regression equation of y on x, y should be at the left side, x should be at the right side. Keep y at the right side means, let me write 3y equals to minus 2x minus 50. Got it? Now, I need to keep just y at the left side means I'm dividing with 3. Got it, guys? So that it will be by 3 and here also by 3. Here, whatever the coefficient that x has, it will be called as byx. How do you call it as? Byx. What is byx? Minus 2 by 3. Got it, guys? Minus 2 by 3. Now, let's have a look at the next MCQ. MCQ number 11, guys. So, now here I'll teach you how to identify both the regression equations. So, read out the question. If 3x plus 2y equal to 21 and 6x plus y equals to 29 are the two regression lines, then the corresponding coefficient of correlation between x and y is. So, he himself said that they both are regression lines. You need not verify whether they are regression lines or not. If you want to do, what can you do? Positive by positive, positive. Positive by positive, positive. Both of them are having same signs. So, they are regression lines. Now, guys, I'll tell you a very simple way to identify who is regression equation of x on y and who is y on x. Just listen to me, guys. Calculate the ratio of coefficient of x by coefficient of y in the first equation. How much? 3 by 2. 1.5. Now here, 6 by 1. How much? 6. Who is least? 1.5. Least value is y on x. Least value is what? Y on x. Highest value is x on y. Means the first equation is y on x equation and the second equation is x on y equation. Calculate the coefficient of x by coefficient of y for both the equations. The least value equation is going to be the y on x equation and the highest value is going to be the x on y equation. Now I got to know the first equation is y on x. If it is y on x, who should be at the left side? Y should be at the left side, no? So I must write 2y equal to minus 3x plus 21. But I have already told you, just to keep y only at the left side. It means it is equals to minus 3 by 2 plus 21 by 2. Could you please tell me what is b by x? Minus 3 by 2. Now, the second equation is x on y. No, I have to keep x at the left side. Means I have to write 6x is equals to minus y plus 29. But I have already told you, you just need to keep x only. Means divide with 6. Now, tell me the coefficient of y here. Minus 1 by 6, guys. Try to understand. Both of them are having the same signs or different signs? Same signs. So, I have already told you, both of them must be of same sign. And R will be also having the same sign. So, means R should be positive or negative? Negative. So, these two options got eliminated, no? Now, what is the formula for R of, guys? R equals to square root of bxy into byx, no? So, square root of bxy into byx means 3 by 2 into 1 by 6. Take your calculator. Of course, it is positive. Forget about it. 3 by 2 into 1 by 6 is R square. But I need R, no? Means square root you have to apply. So, which is 0.5. But guys, do I need to write plus 0.5 or minus 0.5? Minus 0.5 as bxy and byx, both of them are having negative signs. So, my correct answer is option B. And that's what about MCQ number 11. Now, let's have a look at MCQ number 15. Guys, what is b by x? B by x minus 1.6. And what is bxy? Minus 0.4. Then tell me rxy without writing anything on the paper. Without writing anything on the paper or without keeping anything on the calculator. Yes, as bxy and byx, both of them are having negative sign. So R will be having negative sign, and the only option which is having negative sign is option B. Try to understand it, guys. It is such an easy task. Now look at 18th question. The regression line of y on x is given by y equal to x plus 2. Carl Pearson coefficient of correlation is 0.5. Then sigma square y by sigma square x. Guys, what is the regression line of y on x? Y equal to x plus 2. May I know the coefficient of x here? 1. That is called as bxy or byx? Byx. Try to understand, that will be called as byx. What is byx equals to? 1. Could you please tell me the formula for byx? R into sigma y by sigma x. So what is sigma y by sigma x? 1 by r. Am I correct? So take your calculator and tell me what is 1 by r. 1 by 0.5. 1 by 0.5 means how much? 2. It means sigma y by sigma x is equals to 2. But what do you need? Sigma y by sigma square y by sigma square x means it's the square, no? How much it can be? 4 only, right? So that's what about MCQ number 18. Now let's have a look at MCQ number 19. If the regression coefficient of y on x, coefficient of correlation between x and y, and the variance of y are 3 by 4, root 3 by 2 and 4 respectively, what is the variance of x? So guys, regression coefficients are given, correlation coefficient is given, and one variance is given. You have to calculate the variance of the other fellow, right? So guys, tell me, what is the formula for regression coefficient of y on x? Tell me, byx equals to r into sigma y by sigma x. Then tell me the square. B square yx equals to r square into sigma square y by sigma square x. What is byx according to you? 3 by 4. Then tell me the square. 3 square by 4 square means 9 by 16. What is r equal according to you? Root 3 by 2, r square. 3 by 4 into, what else is given to you? Sigma square variance of y, how much? 4 by sigma square x. Let me cancel it 4 and 4 and let me bring the sigma square x to the left side. So 3 into, this 9 by 16 come to the right side means it will be 16 by 9, no? Take your calculator. 3 into 16 by 9 equals to 16 by 3 only, right? And that is there in option. Let me show you the option, guys. 16 by 3, which is there in option B, guys. So that's how you can solve MCQ number 19. Sorry, now let's have a look at MCQ number 22. If u equal to 2x plus 5 and v equal to 3y minus 6 and the regression coefficient of x on y is 2.4, then the regression coefficient of u on v. So guys, look at here. U on v is what you need to calculate, no? RUV. Guys, listen to me. If it is u, write down the coefficient of x first. What is the coefficient of x? 2. Now the next term is v, no? Coefficient of y, how much? 3 into uv is the order, no? Write bxy. What is bxy? 2.4. Now 2 by 3 into 2.4, how much? It's 1.6 and that is there in option A. See how simple it is. If you want to calculate this, it is a very simple task, guys. Now let's have a look at MCQ number 25. So guys, do not be afraid of the length of the question. If the question is lengthy means the answer is quite simple. Now look at 25. If the relation between two variables u and x and u is u plus 5x equal to 12 and v and y is 3y plus 7v equal to 13 and the regression coefficient of x on y means bxy equal to what? 2.1. What would be the regression coefficient of u on v? Guys, u on v means keep u at the left and take the remaining fellows at the right. Means I can write u equal to minus 5x plus 12. U equal to minus 5x plus 12. Like that. What is next equation? 3y plus 7v equal to 13. No, keep v at the left and take the remaining fellows to the right. 7v equal to minus 3y plus 13. 7v equals to minus 3y plus 13. But I have already told you, you just need to keep v only. That is why you have to divide with 7. Got it? Now, what is that given to you? bxy 2.1. And you have to calculate buv. Guys, I have already told you what is the coefficient of x. Minus 5. Keep it in the numerator. Now, what is the coefficient of y? Minus 3 by 7. Keep it in the denominator. Into bxy. What is bxy to you? 2.1. If this 3 by 7 comes to the numerator, it will be 7 by 3 and minus got cancelled. No? It means 5 into 7 by 3 into 2.1. Take your calculator. 5 into 7 by 3 into 2.1, and the answer is 24.49 bar, means it is 25. See how simple it is. If you know the logic, you need not calculate anything. Sorry guys, 24.5, no, sorry, 24.5. And I can see the option A, 29 by 2, wrong answer. 49 by 2, could you please calculate 49 by 2 by using your calculator? It is 24.5, and that's a correct answer. Now let's have a look at the next MCQ guys. MCQ number 27. So guys, try to understand. The two regression equations are 2x plus 3y minus 28 equal to 0 and x plus 2y minus 25 equals to 0. Find the value of x when y equal to 8. Guys, you need to understand, y value is given, means y is independent variable. You have to calculate x value, means x is dependent variable. So you have to choose an equation which is x on y. Let me repeat. You have to choose an equation which is x on y. How do you identify x on y? Yes, calculate 2 by 3. How much? 0.6 bar. Calculate 1 by 2. 0.5. Tell me guys, which is smaller? 0.5. Smaller one is y on x. So bigger one is x on y. So I have to take the equation 2x plus 3y minus 28 equal to 0. And I need to substitute y equal to 8. Take your calculator. 3 into 8, how much? 24. 24 minus 28 minus 4. If thus minus 4 comes to the right side, plus 4. 2x equal to 4 means x equal to 2. See how simple it is. Now coming into the next MCQ. Let's see 30 guys. If the regression line of y on x, x on y, means he particularly tell us who is x on y and who is y on x respectively. Then the arithmetic means of x and y, means he has given you who is x on y equation and who is y on x equation. We need to calculate what is x bar, y bar. So guys, I have told you a property. Both the regression lines are passing through the points x bar, y bar. So some people will do this way, 2x bar plus 3y bar, 5x bar plus 6y bar. Since they are passing through. Now they will solve, means they will multiply the first equation by 2, means they'll get 4x bar plus 6y bar equals to minus 2. Next 5x bar plus 6y bar equals to minus 1. And they'll subtract both the equations. So I'll get minus symbol, plus symbol. What is 4x bar minus 5x bar minus x bar equals to minus 2 plus 1. How much? Minus 1. So x bar equal to how much? Minus x bar equal to minus 1. So x bar equal to how much? Plus 1. And that is there in only option A. You need not even calculate a y bar also. If you want to calculate y bar, substitute x bar here. 2 into 1. How much? 2. If this 2 comes to the right side, it will be 3y bar equals to minus 1 minus 2, which is minus 3. So what is y bar equals to? Minus 1. That's how you can. But you need not guys. You need not even do this method also. Simply go through substitution method. It means to say, if you want to calculate arithmetic means of both x and y, substitute them. It has to satisfy. Means if x equal to 1, here it will be 2 into 1. What is how much? 2. 3 into minus 1 as y equal to minus 1. So it will be minus 3. May I know what is 2 minus 3? Minus 1. Satisfied, no? X equal to 1, no? So it will be 5. 6 into minus 1, it will be minus 6. What is 5 minus 6? Minus 1. Got satisfied? No. Yeah, that's how you can calculate the arithmetic mean of x and arithmetic mean of y. See how simple it is. Got it, guys? So it's all about regression, guys. Here in regression analysis is such an easy concept which you can solve the MCQs also easily, provided certain shortcuts are there with you. Along with that, theory also very easy, guys. It is all dependent upon your formulas and certain basic things, basic logics of mathematics, which is completely related to slope or something else like that. That's all about regression, guys. So let's get into the next concept, guys, which is index numbers. So what is an index number? And what are the advancements that we are going to see in this topic that we can discuss later, guys. But first of all, let me tell you, the expected weightage of this topic is usually 5 to 6 marks, guys. And one thing that I can say is, this is comparatively an easier concept compared to your measures of central tendency or measures of dispersion. The formulas in this concept also very much easier compared to the remaining topics, as they are all completely dependent upon a particular rule. And the usual preparation time for this concept is usually 10 hours, guys. But in this video, I'm going to complete the entire concept, or I'm going to cover all the concepts in a span of 1 to 1.5 hour duration, guys. So this concept has equal significance in respect of theory as well as problematic part, guys. So sometimes we can expect more theory from this concept as well. So let's get into the concept, guys. Let me tell you the meaning of index numbers first. So what is an index number? And what is the purpose of index number? So where index numbers are used? So that's what we are going to learn firstly. So guys, what is an index number? Index numbers are used to observe the relative changes or differences from time to time or from place to place. For example, guys, when I take the price of a particular commodity, let me take the price of rice during last 2 months. I mean to say, let me assume that it is May and April. So guys, your index number is a tool which measure the change in the price of this commodity from time to time. April to May. If you want to compare April with May, you can, or else if you want to compare May with April, you can. Or else, if you want to compare the same rice cost in the month of May or June, in city A and city B, it can also be done. That's what he is trying to convey. Index numbers are the convenient tools that are used for measuring changes in a particular commodity. That too, guys, try to understand. If you are measuring change, means you are comparing, no. That are used to measure the relative changes or differences from time to time or from place to place. It means, let me explain with a small example. Why arithmetic mean is used? How arithmetic mean is used? Arithmetic mean is used to represent a group of data, no? Yes, a group of data will be given, will be understood with a single value, no? Yes, like arithmetic mean is used to represent a set of values. Index numbers are also used to represent a set of values. So like not only the cost of rice, you can write rice price and some other wheat price, some other maize price, some other milk cost. You can talk about a group of commodities prices that are changed between May and April or April and May from a particular time to other time, or else the same item's price in city A and city B. You can compare from time to time or from place to place. There's no restriction that you have to confine your discussion to time. If you want, you can confine your discussion to place also. Got it, guys? So what is an index number? So guys, let me tell you the meaning of index number. An index number is a ratio. Let me write down the definition of ratio. A definition of index number. An index number is a ratio or an average of ratios. Average of ratios. An index number is a ratio or average of ratios, both of them expressed in percentage form. As I already told you guys, index numbers are meant for comparison, so they are always expressed in percentage form. Got it, guys? Means they are relative measures or absolute measures. Relative measures means they are unit dependent or unit free. Most of the index numbers are unit free. Try to understand, most of the index numbers are unit free. So what is the definition of index number? An index number is a ratio or an average of ratios expressed in terms of percentage. Like I said, there you can involve 2 or more time periods. There you can involve 2 or more time places. Okay. So what is index time series? The name itself is saying that I'm time series, means my data is varying over time. So my index time series is a list of index numbers constructed for how many time periods? 2 or more time periods. Yes. What are the characteristics of an index number? So index number is nothing but, just now I told you, index number is an average row. So it's a special type of average. Index numbers are always expressed in percentages. Index numbers measures the relative changes or differences from time to time or from place to place. So how do index numbers called as? Index numbers are called as economic barometers because they measures the strength of economy. They are helpful for you in understanding the kind of or type of economy. So economy means it is completely dependent upon prices and everything, right? So yes, they are helpful to understand the kind of economy that we are in. Okay, like that. Index numbers helpful in forecasting the future profits, means they will be helpful in understanding the kind of business that we are going to invest. So that's why they mentioned that they are the signs and guideposts in a business highway. Got it, guys? So index numbers are classified into how many ways? Guys, if you want to measure the change in prices, you have to go for price index number. If you want to measure the change in quantity, you have to go for quantity index number. If you want to measure the change in total value or expenditure, you have to go for value index. If you want to measure the changes in somebody else, means if I wanted to measure the change in my profit, I will go for profit index number. No, all those index numbers are called as special purpose index numbers. But on the basis of number of variables or number of commodities used in the construction of index numbers are classified into two types. Simple index number. Simple index number means index number constructed for single item. Let me assume that I am talking about the cost of rice or the price of rice. So in the month of May, in the month of June, July, August, September, October, how many time periods are given? More time periods, but I'm talking about only one commodity, no? So that kind of index number is said to be simple index number. Got it, guys? Like that. If you are involving or if you are talking about index number which is having more than one variable, that is called as composite index number, or else since you are dealing with group, no, it is called as aggregate index number. So now tell me, what are the factors involved in the construction of index numbers? First, guys, so guys, suppose if I wanted to construct the price index, now selection of data is very important. I should not whether I need to take wholesale price or retail price. So that is first important. One more thing, you have to collect the data from the people, no? Means you have to collect the data, you have to take a sample of data. So the process involved in taking that sample is also very important. Got it, guys? So selection of data is very important. Most of the index numbers are constructed for samples but not population. So if you want to construct price index numbers, you will collect the data regarding prices. You can't collect the data regarding quantities, right? So try to understand. Selection of data is very important. Next, base period. Guys, if you're talking about prices, you're comparing the price of rice in March with price of rice in June. So with whom you're comparing? With June price you're comparing, no? That is called as base period. So base period is a standard point of comparison. Let me tell you one thing. How can I compare the cost of or price of today's rice with 20 years back price? It can't, it is not so correct, no? Yes, base period means I can't compare with too long values. Got it, guys? So base period should not be too long. It should not be far away. It should be relatively recent. Then only that comparison will be useful. How can you compare this with last 10 years back data? So comparison will be relatively recent. My base period is also relative. Base period means it's a standard point of comparison. That should be relatively recent. You should not go for very far period. Even if you compare that, what is the use of that? Are you going to predict the coming 20 years? Not no, right? So it is of 1 year or 2 years predictions only will do. So what is the use of comparing this period with a very back year? So selection of base period is also very important. Got it, guys? So next, selection of formula is also very important. So because, guys, I told you, index number is a ratio or average of ratios. There are many averages, no? Yes, you have to choose the best formula. Many formulas are dependent upon many averages. So you have to take the best one. Got it, guys? Next, you should understand the selection of weights. What is weight? I have already told you while explaining measures of central tendency and dispersion only. Weight means relative importance. At that time, I told you that. I told you this example. Guys, whenever I'm constructing an index number which is cost of living, my cost of living depends upon regularly being a South Indian, my cost of living depends upon rice price, milk price. So these are the common necessities that I have, no. So can I give or shall I give equal importance to rice as well as sugar and milk? I can't. So there is a particular criteria, there is a particular weight given for each and every commodity, no. Yes, that I need to take care of. I have to give the appropriate weight to the corresponding item. Got it, guys? Now, choice of variable, I have already told you. If you want to measure the change in price, you have to go for price index number and you have to collect the data regarding prices. If you want to measure the changes in quantity, you have to calculate quantity index number and you need to talk about or you need to select data regarding quantity. And this one also I have already told you, selection of formula. We have many formulas and you need to choose the best. Okay, got it guys? So madam, who is best? In the coming concepts, we are going to talk about that guys. So write about different methods of constructing index numbers guys. There are two methods of constructing index numbers. One is simple method, another one is weighted. Both of them deals with aggregate and average. And aggregate and average. Here we will call it as average of relatives. So the average that we use here is arithmetic mean and geometric mean. So what is the first method? Let me talk about simple. Every time I told you there is an aggregate and there is an average. Simple or unweighted aggregate method. Summation P1 by summation P0 into 100. So there are no weights. Just simple aggregate. Actually, we'll do summation P1 by N guys. We'll collect the average of all the prices in the current year. The current year price is denoted by P1 and the base year price is denoted by P0. We'll collect the average of, we'll calculate the average of all the prices in the current year and that is compared with the average of all the prices in base year. So that is expressed in terms of percentages. This by N got cancelled. That's why we've called this method as simple aggregate method as it is based upon aggregates. So now let me tell you the formula for weighted aggregate method. So weighted aggregate method formula P01 index number of the year 1 based upon the year 0 is summation P1W means the corresponding weights of prices by summation P0W into 100. Extra weight is added wherein your central tendency and dispersion frequencies are added. No, yeah, like that. Simple or unweighted aggregative index formula is summation P1 by summation P0 into 100. Now, weighted or aggregative method formula is summation P1W by summation P0W. Now, there are average of relatives method. No. Now, let me talk about simple average of price relatives. Simple average of price relatives that using arithmetic mean. Next, I'll talk about weighted average of price relatives using arithmetic mean. So, guys, try to understand the meaning of the definition. Using arithmetic mean means I'll calculate relative. Madam, what is a relative? Relative means change in the price of a single commodity. Means for every commodity, I need to calculate P1 by P0 into 100 and that is denoted by P, capital P. Means I'll calculate relatives for all the commodities that are denoted by P. For them, I'll calculate the simple average means the formula will be summation P by N. P01 equal to summation P by N where P equal to P1 by P0 into 100. Weighted average of relatives formula will be, guys, actually we'll calculate P1 by P0 into 100 first and then P01 equals to summation PW by summation W. Here the same formula, what is capital P equal to? P1 by P0 into 100. So actually I have told you many times while explaining central tendency dispersion guys. We'll use the similar formulas but the thing is, the difference is when it comes to weight in place of small and capital N will be replaced. Capital N means sum of frequencies there, here sum of weights. So now this is simple arithmetic mean of price relatives. No, now there will be a formula for simple geometric mean of price relatives. So for that also calculate P. What is the meaning of capital P? P1 by P0 into 100, whether it is simple or weighted. Now, simple geometric mean of price relatives is equals P01 equals to nth root of product P, right? Pi P. After applying logarithm, we'll get P01 equals to anti-log of summation capital P by N. Summation capital P by N. What is capital P? P1 by P0 into 100. Now, when it comes to weighted geometric mean, P01 equals to anti-log of, sorry guys, this is summation log P, because here we'll get logarithm, no? So, anti-log of, so guys, look at this, anti-log of summation W log P by summation W, where P equals to P1 by P0 into 100. These are the formulas of unweighted or simple average of simple aggregative method or weighted aggregative method. Next, simple average of price relatives, weighted average of price relatives. You can go through these formulas. Next, weighted index. I have already told you the meaning of weighted index. Weighted means each observation has given its relative importance. So because here relative importance plays a very important role. We can't give equal importance to all the persons who are there that we are dealing with. So here two weighted methods are of two types. One is weighted aggregative method. The other one is weighted average of relatives. So but this weighted aggregative index, this is a weighted aggregative index, no? So this weighted aggregative index has many index numbers. Here I am showing all those index numbers names, guys. Lashpace, Pashas, Dorbish, by Fishes and Marshall, Edgeworth, Walsh and Kelly's. These are all part of weighted aggregative index that we can discuss later, guys. Now, let's talk about weighted aggregative index. What is weighted aggregative index formula? Weighted aggregative index formula is P01 equals to summation P1W by summation P0W. So guys, try to understand. If W equals to Q0, that is called as Lashpace index. So let me write it properly, guys. If W equals to Q0 means quantity of the commodities in the base year. Got it, guys? So then what is P? This is called as Lashpace index. How do you call it as? Lashpace. Then tell me the formula for Lashpace. Summation P1 Q0 by W is to be replaced with Q0. Summation P0 Q0 into 100. This is called as Lashpace index. Next, what is the next index number? Pashas index number. So how do you need to write Pashas index number? If W equal to Q1, the index number is called as Pashas index number, which I am denoting with P01P. The formula is summation P1 Q1, because W means Q1, no? By summation P0 Q1 into 100. So are we done with Lashpace and Pashas? Yes. The next index number is, guys, there are two index numbers. One is Dorbish-Bowley and the other one is Fisher's index number. Who is Dorbish-Bowley and who is Fisher's? Both Dorbish-Bowley and Fisher are based upon Lashpace index number and Pashas index number. Dorbish-Bowley index number is nothing but the arithmetic mean of Lashpace and Pashas. And Fisher index number is the geometric mean of Lashpace and Pashas. P01 Lashpace into P01 Pashas. Got it, guys? So Dorbish-Bowley is the arithmetic mean of Lashpace and Pashas, and Fisher's is the geometric mean of Lashpace and Pashas. Got it, guys? Yeah, now coming into the next concept, next index number, Marshall and Edgeworth index number. For Marshall and Edgeworth index number, quantity should be equals to, or weight should be equals to Q0 plus Q1 by 2. He is doing equal justice to both the quantities. He is taking the average of both. Yes, both them. It means P01 will be summation P1 into Q0 plus Q1 by 2 by summation P0 into Q0 plus Q1 by 2. Guys, if you observe, by 2 will be cancelled, no? Yes, now the rest of the formula will be P01 due to Marshall Edgeworth is summation P1 into Q0 plus Q1 by summation P0 into Q0 plus Q1. Got it, guys? In 200 is obviously a load. Got it, guys? Marshall and Edgeworth. Now, the next index number, we are done with Marshall Edgeworth, no? The next index number is Walsh index number. What is Walsh index number? For Walsh index number, weight is equals to square root of Q0 Q1. Got it, guys? Means P01 due to Walsh is equals to, so summation P1 into, he took the geometric mean, the previous one took the arithmetic mean, no? As P1 into square root of Q0 Q1 by summation P naught into square root of Q naught Q1 into 100. This is Walsh index number. So we discussed with Q naught we discussed with Q1, we discussed with the arithmetic mean of those two things, geometric mean of those two things. Next we discussed with Q naught plus Q1 by 2 and we discussed with square root of Q naught Q1. Means all the possibilities were done now. Now there is another person whose name is Kelly's. He went through the word taking weights is equals to any other quantity which is not equals to base year quantity and that is not equals to other current year quantity, and his index number name will be called as weighted aggregative index with fixed weights. Let me repeat, weighted aggregative index with fixed weights. Got it, guys? And the formula for Kelly's index number is, sorry guys, P01 due to Kelly's is equals to summation P1Q by summation P0Q into 100, where Q is not equal to Q0 and Q is not equal to Q1. Got it, guys? This is neither a quantity of base year nor the quantity of current year. These are the different index numbers that we discussed, guys. These are all the parts of weighted aggregative index. So got it, guys? So based upon this, we have many MCQs and we have advantages and drawbacks of these index numbers, guys. So that we can discuss later. And next thing is quantity index number. Guys, if you want to measure the change in prices, you will go for price index number. No, like that. We'll measure the changes in quantity also, right? So what is the use of quantity index numbers? So guys, if you are talking about quantity index numbers, changes in the output of an economy, right? Means changes in the output of an industry, means it is talking about the strength of our production. Got it, guys? Yes. To construct quantity index numbers, what are the weights? Prices will definitely be weights, no? Next, value index number. So value index number means, value means product of price and quantity. Value means what? Product of price and quantity. Value index number is denoted by V01 and is given by V1 by V0 into 100. Who is V1? Summation P1 Q1. Who is V0? Summation P0 Q0 into 100. So it is talking about the expenditure of the people. Price into quantity, nothing but expenditure only, right? Yes, that's what we are talking about. The next important concept is test of adequacy that we'll discuss later, guys. So of course we have many concepts here. So but here test of adequacy is such an important concept, but you will understand the meanings of these test of adequacy after solving the MCQs that are related to problems, guys. Now let me go for problematic part, guys. Because you know the basics of formulas, so you can solve multiple choice questions, guys. Let me get into the first MCQ. The first MCQ that I have taken is MCQ number 3 here, guys. Let me show you MCQ number 3. The wholesale price index. Let me show you the question clearly, guys. The wholesale price index of agricultural commodities in a given region at a given date is 280. So means wholesale price index number is already constructed and its index number is 280. So what is this 280 means? I'll tell you with an example, guys. So guys, look at this. My current year price is 10 rupees. My current year price is, my base year price is 10 rupees. And my current year price is 12 rupees. So base year price is denoted by P0, current year price is denoted by P1. Now tell me what is price index number? Simple relative, because I'm talking about one item. No, if I'm talking about one item, I'll call it as relative. If I'm talking about group of items, I can call it as an index number. Relative number observe the change in only one variable. Here I'm having only one variable. So P1 by P0 into 100, which means 12 by 10 into 100. What is 12 by 10 into 100, guys? 120. So guys, now listen to me. My P0 is 10, but my current year price is only 8 rupees. What is my price index number? P1 by P0 into 100, and what is my answer? 80. Now I must tell you the meaning of this. So guys, in the first case, my index number is more than 100 or less than 100? More than 100. It means I must understand that my current year price got increased compared to base year price. Got it? What percentage? 20% increment. Whatever is more than 100. It is 120, no? So I must say that there is a 20% increment. What is 20% of 10, guys? 2 rupees. There's a 20% increment, right? Yes. Now, if you observe the second index number, the second index number is less than 100. Got it, guys? Yes, it is less than 100 means the price that you're talking about is decreased. Got it, guys? The price that you're talking about was decreased. Decreased by what percentage? It is how much less than 100, guys? 20 less than 100 means the price was decreased by 20%. It means, now according to my question, my index number was 280. Means is it more than 100 or less than 100? More than 100. It means I must tell you that there is an increment in the value that I'm talking about. What percentage of increment? How much it is more than 100? 180. So there is an increment of 180% in the prices or income. Yeah, prices compared to the base year. What percentage of increment? The percentage increase in the prices of agriculture commodities was 180. Guys, suppose if it is 380. What's your answer? 280. Yeah, try to understand that. It is such an easy task. Now, let's have a look at MCQ number 7, all of you. From the following data, calculate the simple aggregate price index number. Let me tell you the formula for simple aggregate price index number, and then later we can look at the data. So, simple aggregate price index number is equals to summation P1 by summation P0 into 100. Guys, tell me the meaning of P1. Prices in the current year. P0, prices in the base year. Now let's see the data. He's given you base prices and he's given you current prices. How do you denote base prices with? Base prices are denoted by P0. Current prices are denoted by P1. Now my formula consists of summation P1 by summation P0. Take your calculator and calculate all the prices in the current year price summation. 42 plus 35 plus 38 plus 120. So 235. If you look at this, rice price in the current year was 42 rupees, wheat was 35, pulses was 38, and fish price was 120. And rice price in the base year 35, yes, wheat is 30, pulses 40, and fish price is 107. Compared to all, pulses prices only got reduced compared to all the data. But on an average, I can say that all the prices got increased. Means my index number is always more than 100 as the prices got increased. Let me calculate the total, guys. I got a total of 235. 235 as my current year total. Means I need to write 235 in the numerator. Like that, will you please calculate the denominator? Means summation P0 means sum of all the prices in the base year. 35 plus 30 plus 40 plus 107. And I got a total of 212. So 212 is my denominator. Now take your calculator. 235 by 212 into 100. So I got 110.849, which I can take it as 110.85 approximately, which is 110.85. Got it, guys? And that is there in option B, guys. Option B. Now let me show you the next MCQ, guys. The next MCQ that I have taken here is MCQ number 11, guys. What is MCQ number 11? So guys, forget about the question. Let's have a look at what it is. From the following data, commodities are ABCD, base year price. How do you denote the base year price with, guys? P0, right? How do you denote the current year price with? P1. Base year quantity is denoted by Q, as it is base year, we are denoting with not. Quantity in the current year will denote it with Q. Current year means it is 1. Calculate the Fisher index. What is Fisher index? Fisher index is the geometric mean of lash pays and passes. Guys, why I have taken this MCQ means, if you solve this MCQ, you are in such a position to calculate what is lash pays, what is passes. So, okay, now, guys, let me write down the formula for lash pays index number. P01 due to lash pays is summation P1 Q0 by summation P0 Q0 into 100. Got it, guys? Next, P01 due to passes is summation P1 Q1 by summation P0 Q1 into 100. So, we are done with lash pays index number and passes index number, right? So, both the index numbers are here. Now, we have to calculate the geometric mean of both. So, first of all, let me calculate lash pays. Means for that, we need P1 Q0. Means you need to multiply these two quantities, guys. Use your M plus button to reduce the length of solution. So, guys, P1 Q0 means 6 into 3 M plus. Got it, guys? 6 into 3 m plus. Next 6 into 4 m plus. Next 9 into 2 m plus. Next 1 into 3 m plus MRC. I got a total of 63. So here my numerator is 63. Got it, guys? Here my numerator is 63. Now I need to calculate P naught Q naught. Try to understand. I need to calculate P naught Q naught means 4 into 3. That's 1. 4 into 3 m plus. Guys, clear your calculator's memory before getting started. Next 5 into 4 m plus. Next 7 into 2 m plus. Next 2 into 3 m plus MRC. And I got an answer of 52. Okay. By 52 into 100. Leave it aside. Later we can perform all the calculations. Now, I need to calculate P1, Q1. So, what is P1, Q1? These two quantities, no? So, what is P1, Q1? 6 into 2. Next, 6 into 4. Next, 9 into 2. Next, 1 into 5. Put together it is 59 is what I got. 59. So, let me write down 59 here. Now, I need P naught Q1. Just take care of this, guys. P naught Q1 means the first one and the last one needs to be multiplied. Means 4 into 2. Next, 5 into 4. Next, 7 into 2. Next, 2 into 5. Put together, I got a total of 52. Got it, guys? So, let me write 52 here. Okay, now, guys, tell me, lash pay is into passes, no? So, 63 by 52 into 100, take your calculator. 63 by 52 into 100 is my lash pace. 121 point something, keep it there. Into 59 by 52 into 100. So, totally it is 13,746 point something. But what is Fisher's is equals to? Fisher's is the square root of lash pays and pashes product. So, you have the product of lash pays and pashes, just apply square root. What's your answer? 117.2. How much is your answer? 117.2, and that is there. 244 is there, guys. But 117.3 is there. So, we have to take that. Now, the next MCQ that I have taken is MCQ number 23. Guys, between I haven't taken any MCQ because all the questions are completely based upon lash pays and pashes questions only. Now, let's go for the next index number calculation, 23. So, guys, here, the reason for taking this MCQ is you will complicate this MCQ by writing the solution, but please be here. If the ratio between lash pays index number and pashes index number is 28:27, then the missing figure of the following table P. Commodities, there are two commodities whose names are X and Y. Base price, base quantity. Current price, current quantity. Base price is denoted by P naught. Base quantity is denoted by Q naught. Current price is denoted by P1. Current quantity is denoted by Q1. Guys, tell me, what is lash pays is to pashes ratio? 28/27, no? So, before that, look at this, guys. Let me write what is lash pays formula. Summation P1 Q naught by summation P naught Q naught by pashes formula. Into 100 will definitely be cancelled, no? Next, summation pashes formula. P1 Q1 by summation P naught Q1. This is pashes formula. If you want, I'll write into 100 also for you. But into 100 will be cancelled, no? So, try to understand. Now, I just wanted to bring this denominator to numerator so that it will be reversed. Summation P naught Q1 by summation P1 Q1, and that is equals to 22/27, and that is equals to what, guys? 22/27. This is what? Sorry, 28/27 it seems, guys. Sorry, guys. It is 28/27. Now, what is summation P1 Q naught? I need to add P1 Q naught. 10 to 20 plus 5P. Got it? So, let me write 20 plus 5P. Next, I need to write summation P naught Q naught. P naught Q naught means 10 plus 5, 15/15 into summation P naught Q1. What is P naught Q1? This is 1 into 5, 5. 1 into 2, 2. 5 plus 2, 7. By summation P1 Q1. 2 5 is 10 plus 2P. 10 plus 2P, and that is equals to 28/27. Now, listen to me, guys. From here onwards, I don't want to move one more step. I need to calculate p-value. For that, I'm going for option verification. What is option verification? So according to option A, what is p-value, guys? 7. Let me take 7, guys. All of you listen to me. 5 sevens are 35. 35 plus 20 put together 55. 55 into 7, 385. Got it, guys? Now, you said that what is P equals to according to option A? 7. 2 sevens are 14. 14 plus 10 put together 24. 24 into 15. What is 24 into 15? 360. So guys, even after cancellation also I can't see 28 by 27. Or else if you are still doubted about it, calculate 385 by 360. Tell me what is 385 by 360? 1.06944. But what is 28 by 27? 1.0370. So that's a wrong answer. So option A is not correct answer. Now let me show you what is option B. Option B is 4, no? Guys, be careful. 5 into 4, 20. 20 plus 20, 40. 47s are 280. Got it, guys? Your numerator is 280. Yes, 4. 2 4s are 8. 8, no? 8 plus 10, 18. 18 into 15, 270. So how much you are getting? 28 by 27. See how simple. There's no need of cross multiplication. There's no need of doing something. So it's stop there. And I've told you, if it is solving, whether it is mathematics or statistics, you will definitely get option verification. Try to understand that. Now let me show you the next MCQ of mine. The next MCQ that I've taken is MCQ number 26, guys. Let me show you MCQ number 26. So guys, read out the question. The total value of retained imports into India in the year 1960 was 71.5 million per month. And the corresponding total for 1967 was 87.6 million per month. The index of volume, guys, index of volume, volume means quantity. So the quantity index of imports in 1967 compared with 1960 was 62, means quantity index number was 62. I must write Q01 equals to 62. Got it, guys? So here who is base here, guys? 1960. The price index for retained imports for 1967 over 1960. Before that, we know that value index V01 equals to total value in current year by total value in base year in 200. Take your calculator. What is the total value of retained imports into India in the current year? 87.6. Calculate 87.6 by 71.5 in 200. Tell me how much is that? 122.5 is what I got, guys. So I'll keep it here. So I got value index number V01 equals to 122.5174. Guys, whatever I got, I'll keep it in my calculator only. Now I'll tell you what is the meaning of value index. Value index is the product of price index into quantity index. And according to the question, what is quantity index? 62. If this 62 comes to the right side, it will be dividing, no? So divided by 62. Tell me, guys, how much you got? 1.97. Guys, listen to me. Your price index number will be 100, will be having 100, and your quantity index number will be having another 100, no? So your value index number must be having 100 or 200s. 200s, but there is 100 that you did know. So that is the problem. Okay. So otherwise, you'll be able to understand that is 197 point something. You got 1.97. So you can directly tell the correct answer, guys. 197.1.97608 means I can take it as 197.61 approximately. And that is what about MCQ number 26, guys. So guys, try to understand. Price into quantity equals to value. Got it? Price into quantity equals to value. Price into quantity equals to value. That's what we have received. We have got here, guys. So we were given with value index number or calculation, and of course quantity index number is directly given to you. So price index into quantity index is equals to value index. That's what we did here, guys. So let's see the next question, guys. The next question is MCQ number 28. From the following data, calculate the cost of living index number. As you all know, guys, cost of living index number is weighted or unweighted? is always weighted as we don't give equal importance to all the persons who are there. Means all the things that are there, food, clothing, fuel and light. Shall we give the same importance to the food and clothing? It can't be possible, no? If you look at the data also, they've given 50% of importance to food. Compared to that, clothing is just 2%. Fuel and light means fuel and power. They just gave 3%. But for the rent, it is 16%. Miscellaneous means all the other expenditures. They've given 29%. And the corresponding indices are also given. We have to calculate the cost of living index number. So guys, here our index number and weights are given. Means I and W is given. Means we have to follow family budget method, which is summation IW by summation W. What is the formula for weighted cost of living index number? Summation IW by summation W. We know what is I, we know what is W, and what is summation W. So please do calculate the weight of all the index numbers. 50 plus 2 plus 3 plus 16 plus 29. Put together, it is 100. So sum of weights is going to be 100. Now summation IW, please do calculate that. So I into W means 241 into 50 M plus. Next 221 into 2 M plus. Next 204 into 3 M plus. 256 into 16 M plus. 179 into 29 M plus MRC. So my answer is 22,391. Let me show you my answer, guys. This is what my answer, 22,391. So now I have to calculate the index number, no? What is the formula for my index number? Summation IW by summation W. And summation IW is 22,391 by summation W means 100. So by 100, if I do that means I'll be getting 223.91. 223.91 is there in option B. And that's what about MCQ number 28. Now let's get into the next MCQ, guys. The next MCQ that I want to show you is MCQ number 31. Let's have a look at MCQ number 31. So guys, this model is very important for your exam also. So try to understand what is given to you in the question. Suppose a business executive was earning 2,050 rupees in the base period. They might be the earning per day or per month. That we are not focusing, guys. His earnings were 2,050 in the base period. It is usually a monthly salary. What should be his salary in the current period if his standard of living is to remain the same? To maintain the same standard of living, according to the cost of living index number, the salary or the earning should also be changed in the same proportion. To calculate the cost of living index number, he gave you something. Given that summation W equals to 25, summation IW equals to 3,544. As you all know, cost of living index number is summation IW by summation W, which means 3,544 by 25. What is 3,544 by 25? I got 141.76. Means the current year index number was 141.76. And as you all know, base year index number will be always treated as 100. In the base year, he is getting a income or earning of 2,050, right? 2,050 means if the index number was 100, his income was 2,050, but the index number is now 141.76. It has got increased, no? So corresponding to the same ratio, the salary or the earning must also be increased. How do you calculate that? So guys, if they are getting 100 means, if it is 100 means it is 2050. If it is 141.76 means it is how much? Guys, in ratio proportions you have learned this way, guys. So one number is multiplied, one number is divided, two numbers are multiplied. Means 141.76 into 2050 by 100. Let me write down. My answer is 2,906. Got it, guys? 2,906.08. I can approximately take it as 2,906. So means to maintain the same standard of living means whatever he bought in base period, if he wanted to maintain the same standard of living, at least he has to get an earning of 2,906. Got it, guys? 2906. So that's what about MCQ number 31. Now let's have a look at MCQ number 32. Guys, it's a very simple question, but try to understand the meaning of it. Cost of living index number in 2015 and 2018 was 97.5 and 115 respectively. So guys, there's nothing called, he haven't given you 100 as an index number of base year. So for 2015, it is 97.5 and 2018, it is 115. The salary of the worker in the year 2015 was 19,500. So try to understand how much additional salary was required for him in 2018 to maintain the same standard of living. Means it is somewhat similar to 31, guys. So let me tell you how it is related to 31. So cost of living index number in the base year was how much? 97.5. At that time, he is getting a salary of how much? 19,500. Coming into 2018, the index number has changed to 115. So how much he should gain? That's what he is asking. But let me tell you how much he need to get actually. For that, you need to do 115 into 19,500 by 97.5. And my answer is 23,000. But let me tell you, or let me clarify one thing, guys. He is already getting 19,500 from the base year onwards. But for now, he need to get how much to maintain the same standard of living? 23,000. Out of 23,000, he is already getting 19,500. Means how much extra he need to get? 3,500. So the extra money that he need to get to maintain the same standard of living is 3,500. That's what your answer is for MCQ number 32. Now let's have a look at MCQ number 34. Yes, there's another different kind of MCQ, guys. So guys, this is such a question in which cost of living index number is based upon many factors, no? Yes. But due to a change in one single factor, the cost of living index number will definitely be changed, no? So here the question is, what is the percentage of that particular commodity in the entire, what is the weight of that particular commodity in the entire cost of living index number? That's what he wished to convey. So means, look at this question. When the cost of tobacco has increased by 50%, cost of tobacco was increased by 50%. A certain hardened smoker who maintained his formal scale of consumption, means even though the cost of tobacco was increased very huge, he is not able to control it. He has to maintain the formal scale of consumption, means whatever he consumes earlier, he wanted to consume the same. He said that the rise had increased his cost of living by 5%. Means because of the rise in the cost of tobacco, his cost of living index number became increased by 5%. Earlier, if it is 100%, now it became 105. That's what he wished to convey. Before the change in price, the percentage of his cost of living due to buying tobacco is what? So this is called as due calculation, guys. So due calculation has a particular formula. Let me write down the formula here, guys. So the formula is change in CLI, change in total cost of living index number, got it? By change in commodity into 100. Change in CLI by change in commodity into 100. What percentage of change is there in CLI? 5%. What percentage of change is there in commodity? 50% into 100. So how much is your answer? 10%. This is how some people will do that, guys. So some people will say the answer like this. Change in commodity by change in CLI. What is change in commodity? 50. And change in CLI? 5. 50 by 5 is going to be 10. It's completely up to you. Either you can use change in CLI by change in commodity into 100, or else just write change in commodity by change in CLI. Change in commodity is 50, change in CLI is 5. Again, the answer is 10%. So it's completely up to you, guys. So whatever the formula that you will use, you will get the same answer, which is called as due calculation. So change in cost of living index number due to a particular commodity is called as due calculation. For that due calculation, you can simply use this formula as change in CLI by change in commodity into 100 or change in commodity by change in CLI. It's completely up to you. Now let's have a look at next MCQ, MCQ number 36. If the price index number for the year say 1960 is 110.3 and the price index number for the year say 1950 is 98.4. So guys, try to understand. 1960 price index number was 110.3 and 1950 index number was 98.4. Then the purchasing power of money for the year 1950 over 1960. So means purchasing power of money in the year 1960, which is compared with 1950. Try to understand. Purchasing power of money for the year 1960 means my current year is 1960. That I need to write 110.3 by which year I need to compare with 98.4 into 100. Guys, actually let me tell you the formula for purchasing power of money. Purchasing power of money is 1 by CLI into 100. Some people will write. But let me write, sorry guys, 1 by CLI into 100. Your 100 is not needed because I'll tell you why. People assume that base year index number is 100. Generally, we must write this way. Base year index by CLI means current year index, I can say. So guys, now look at your question. We have to calculate the purchasing power of money in which year? 1950. So 1950 is our current year over 1960. So 1960 was base year. There's no restriction that 1960 is a base year. No. Yeah, there's no problem. Even if 1960 is a base year, there's no restriction that 1950 alone to be the base period. There's no such restriction, guys. It depends upon the question. So you have to calculate the purchasing power of money for which year? 1950. So 1950 should serve as current year. What is current year index? 98.4 over 1960. So means your base year is 1960. No, base year value should be written in numerator. So your answer is 110.3 by 98.4. What is 110.3 by 98.4? 1.120 is what I got. I'm taking it as 1.12. Got it, guys? So that's how you can write. You can solve MCQ number 36. Now let's go ahead with the next MCQ. MCQ number 40. What is MCQ number 40? So it's a different question, guys. Try to understand the meaning of it. During a certain period, cost of living index number goes up from 110 to 200. Means the initial cost of living index number was 110. Now it became 200 now. And the salary of a worker is also rise from 330 to 500. Then the real terms is, it means, guys, during a certain period, your cost of living index number is from 110 to 200, means your initial cost of living index number was 110. Now it is 200. But the salary of an employee was 330 here and 500 here. So it means that you people feel that there is an increment in the salary. Initially it was 330, now it was 500. But I just wanted to know, is this increment is it according to the proportion? That's what I need to understand. So it means, guys, try to understand. The question is, then in real terms, whenever you find this word called real terms, calculate the word real wage. So guys, there is a word called deflating. Deflation means adjusting, correcting, or identifying the terms that are to be corrected. Adjusting or correcting the terms that are to be done. So what is this deflating includes? Deflating includes purchasing power of money, real wage index. What is purchasing power of money? So guys, as you all know, purchasing power of money is nothing but 1 rupee value. Or the purchasing power of money is directly proportional to cost of living index number or inversely. Inversely. Why? Because the cost of living gets increases means how can a common man survive? His purchasing power will be reduced. No. His purchasing power of money is an opposite word of cost of living index number. And the formula for purchasing power of money is 100 by CLI. Some people will write. Some people will write base year index by CLI. CLI means current year index. So this is called purchasing power of money. So now real wage. Real wage means, suppose guys 1 rupee value got reduced to 90 paise. It means even if I'm getting 100 rupees, it is actually 90 rupees only because my 1 rupee value got reduced to 90 paise, no. So now what is it I need to understand? Real wage is nothing but money wage into purchasing power of money. Money wage into purchasing power of money. Now what is real wage index? The name itself is saying that I am an index number, means current year real wage by base year real wage into 100. That is called as real wage index. So madam, what is the use of all these things, guys? Suppose my cost of living index number got increased. It means the purchasing power of common man got reduced, no. So though there is an increment of salary, it is not actually in terms of actual proportion, right? So people will get dearness allowance. That dearness allowance is not a part of their basic salary. So it's an extra allowance which is received by the employee because the cost of living number got increased and the purchasing power of common man got reduced. As a result, they have to pay more. That is called as dearness allowance. To calculate that dearness allowance or to correct their salary policies or wage policies, this deflating concept will be helpful. Deflating. Value of money is getting reduced. So that value got reduced. No, it has to be adjusted. Otherwise, how can normal people survive? Got it? So this concept of deflating had three terms. One is purchasing power, the next one is real wage, and the next one is real wage index. Based upon the purchasing power, based upon the CLI, people will calculate purchasing power. If the purchasing power of money got reduced, means we have to, the government need to adjust their policies, right? So that depends, that comparison can be done with the help of real wage index. Got it, guys? Yeah. So now let me calculate real wage. What is the formula for real wage? Money wage into purchasing power. What is money wage? Money wage means 330 into purchasing power means 100 by CLI, means 330 into 100 by 10. 330 into 100 by 10. So what is 330 into 100 by 10? Sorry guys. It is only money wage, no? Yeah, now I have to do this way. Just a moment, guys. Yeah, 330 into 100, sorry guys, by 110, no? By cost of living is 110. 330 into 100 by 110. What's my answer? Yes, 300. So 300 is my real wage. Got it, guys? Though I'm getting 330, as the cost of living index number is more than 100, that means my purchasing power of money, means my 1 rupee value got reduced. So what is it? Originally, I'm getting only 300, like that. Salary is 500 into 100 by what is your CLI here? 200. 500 into 100 by 200, how much, guys? 250. Means, guys, if you observe this, people feel that, yes, we got an increment. Initially, we used to get 330. Now, we are getting 500 means people will be satisfied. But according to the cost of living index number, it was doubled compared to base year. But your salary was only 250 in additional norms. Means, are you getting profit or loss in this mode? Yes, it's a loss by how much? 50 rupees compared to the previous year. Loss by 50 rupees. So try to understand that, guys. Now let's have a look at next MCQ, MCQ number 42. Guys, try to understand the question. For the following data given below, prepare link relatives. So what is the concept of this link relatives and what is the use of this base method? So guys, here you can calculate the index number by using different methods of base. One is called fixed base method. In this method, the base period is fixed. So, of course, till now what we have seen is this fixed base method. So, this fixed base method has a drawback that the base is fixed. No, even if it is 200 years back, that will be like that. But according to our criteria, base period should be relatively recent. No. So, to overcome that drawback, we are going through the other method called average base method. It means whenever the base period is affected by extremities, to reduce the effect of extremes, we'll calculate the average of 2 or more years, and that will be considered as a base period. This method of taking average base means, let me assume that there are 15 years with us. Out of these 15, one is a base year which is affected by abnormalities. In such a case, we don't take that one as a base period. Along with that, we'll take the average of 2 or 3 years and we'll take that value as the base year value, which is called as average base method. So these two are regular methods, P1 by P0. Here, there P0 is fixed here. Here P0 will be calculated based upon the average of 2 terms or 3 terms, like that. It depends upon the data that is given to you and a question that was asked by you. Now, coming into another method, chain base method. The name itself is saying that chain base means my base is in a chain mode. Means if I am having years called 1990, 1991, 1992, 1993. Here for the year 91, 90 serves as a base. Next chain. Yeah, for the year 92, 91 will be the base, which is very much helpful nowadays, because in nowadays cost of living index number has been rapidly growing. No, it means year to year comparison is so needed. In such a case, we have to go with an index number called chain based method. So construction of index numbers in chain based method is very important. For that, first of all, we need to calculate link relatives. What is it we need to calculate? Link relatives. And then we need to calculate chain based index number. So what is link relatives? The name itself is saying that I'm connected to my previous person. No. When every person price is compared to its exactly preceding year. So means current year index by previous year index into 100. Now guys, listen to me. Suppose if I'm having a data from 1986 to 1991. Try to understand what is my current year if I'm at first year, 1986. Is there any previous year here? No. In such a case, take the link relative of that first year as 100. Because we don't have any previous year, no. That is why just assume that link relative of first year is always 100. Okay guys. Now, look at this. We have to calculate the link relatives for this data given below. So, link relative of first year is always 100. For the second year, means for 1987, current year index is 98. Previous year index is what? 94. So, 98 by 94 into 100. Please do 98 by 94 into 100. I got 104.25, which he is taking it as 104.3. So guys, try to understand that 104.3 is available in two options. So means I can eliminate option B and C directly. Now, let me calculate the link relative for the year 1988. Means the current year is 1988, no? So the previous year is what? 1987. So current year index 102 by previous year index 98. 102 by 98 into 100. What's my answer? 104.08 is what I got. 104.08. I'll approximately take it as 104.1. Now, can you please pick the correct answer? B and C already eliminated. Option A is the correct answer. So, though guys, I'll show you other one also. So, for 1989. 1989 is the current year, no? So, what is your previous year? 1988, whose index is 102. So, you have to calculate 95 by 102 into 100 and your answer is 93.13. So, I am taking it as 93.1. The next year 1990 means current year is 1990, previous year is 1989. So, I have to write 98 by 95 into 100 and my answer is 103.15 and 103.2 that they have taken. Next 100 by 98 into 100. 100 by 98 into 100. My answer is, sorry guys, yes, 100 by 98 into 100. Just a moment. 102.04, which can be approximately taken as 102. So means when a year-to-year comparison is required, we'll go through a method called link relatives. After calculating the link relatives, we will calculate the chain base index. What is the formula for chain base index? Chain base index of current year is equals to link relative of current year into chain base index of previous year by 100. So, link relative of current year into chain base index of previous year by 100. Try to understand, guys. What is it you are calculating? Chain base. So, means you can't know, you don't know what is the chain base of current year, no? You just know the chain base of previous year. So, the formula for CBA of current year is link relative of current year into CBA of previous year by 100. Got it, guys? So, now I'll show you another example, guys, which is MCQ number 43. So, look at the data. From the following data, that is base is 1992, the construction of chain base index number for 1993 to 1996. Guys, I've already told you, first year link relative is always 100. Like that, first year chain base index also 100. First year chain base index also 100. Okay. So, because there is no previous year that we know, right? So, what is the formula for chain base index for the year 1993? Link relative of current year, which means 103, into chain base index of previous year. What is the chain base index of previous year? 100 by 100. What is 103 by 100 into 100? My answer is 103. Now, let's listen to me. What is the formula for chain base index of 1994? Link relative of current year, which is 1994 link relative, into chain base index of 1993, which is 103 by 100. So, calculate 105 by 103 into 100. Oh, sorry, 105 into 103 by 100. And my answer is 108.15. Now, I can write this one as 108.15. Now, listen to me. For 1995, link relative of current year. What is link relative of current year? 112 into chain base index of previous year. How much? 108.15 by 100. So, it means 112 into 108.15 by 100, and my answer is 121.128. They have taken it as 121.13. Now, this is there with me, no? So, for 1996, link relative of current year 108 into chain base index of previous year 121.13 by 100. And my answer is 130.818, which I can take it as 130.82. Now, if you look at the actual question, we have to calculate the chain index numbers from which year onwards? 93 to 96. So, what is your answer? 103, 108.15, 121.13, 130.82, and that is there in option B. So, means construction of chain base index number needs link relative. So, chain base index number is a index number in which if you want relatively recent comparison, you have to go through chain base index number. So, how many methods of construction of index number is there, guys? According to base, 3 methods. One is fixed base, next one is average base, and the next one is chain base. Fixed base is a regular method in which base year is fixed. Whenever your base period is affected by abnormalities, you have to take the average so that the effect of abnormality will be a little bit decreased. So, that is the best way. Whenever there is an effect of abnormalities in case of base period, you have to go for average base. If you want a relatively recent comparison, you have to come with an index number called chain base index number. In this chain base index number, there are 2 steps. One is calculation of link relatives, means year to year comparison is needed. You have to go through link relatives. Relatives means change in one commodity. So, relative is the comparison of exactly one commodity, no? So, relative, that two link relatives which are interlinked. One is connected to the previous, one is connected to the previous. That is called link relative. And then you have to calculate chain base index number. Got it, guys? So, that's what about chain base index number. And you know what is deflating, right? So, now coming into the next important concept, shifting of base. So, when is shifting of base is allowed, and what is the use of this shifting of base? Yes, whenever your base period is fixed, means with a very old base you have constructed many index number. For example, if you look at MCQ number 45. So here the data is from 1980 to 1991. Guys, the generation got changed because of these 11 years, no? So try to understand, there is huge data here. There is huge data here. So there are 12 years data. Within this 12 years, a lot of changes happened. But he gave the index number with a comparison of 1980. This is the fixed base. But whenever the years are passing by, we need to compare with a relatively recent year. No. That's why he is asking you, the following data is the index number of prices for the year for the base 1980. Shift the base from 1980 to 1990. So base shifting is needed whenever the base period is very old, or else if you want to compare the data with the relatively recent period, you can shift the base from a particular year to the other year. The process is called as base shifting, shifting of base from a particular period to the other period. Got it, guys? So this is called as base shifting. Whenever you want a comparison which is relatively recent, you have to go with shifting of base. And what is the formula for shifted index number? So let me write down the formula for shifted index number, guys. Shifted index number is equals to, so guys, here new index numbers, new base year serves as base, no? That is why in denominator, you have to write the index number of the year to which base is shifted. So to where base is shifted? 1990. So means you have to write 1990 index number in the denominator. Got it? So now in numerator, you have to write current year index. Of course, in 200 is very common. Got it, guys? So current year index by index to whom base is shifted in 200. So guys, tell me, to where you have shifted base? To 1990. To 1990, you have shifted base. What is your 1990 index number? 140. So what is your current year index number? 100. So your answer is 100 by 140 into 100, right? So calculate what is 100 by 140. 100 by 140 into 100 is 71.42. So guys, look at the options. 71.42 is there in how many options? 2 options. So I can completely avoid option B. 71.4 is there. Now if we look at the option, 74.3 is the next one, 75.7, 76.4, 78.6, 80.1, 82.1, 83.6, 89.3, 93.6. But look here. It is 99, it is 100. This is for which year? Last but one. Last but one is what, guys? 140 is the current year index by to which year base is shifted? 1990 only. So by 140 into 100. What is 140 by 140 into 100, guys? 100 means there's a chance that who is the correct option? Option A. Let's see whether option A is correct or not. I too don't know, guys, because option D is none. I should not take risk. Now let me calculate 104 by 140. Please do calculate 104 by 140. 104 by 140 into 100, which is 74.28. Next, 106 by 140 into 100. 106 by 140 is what? 106 by 140. And the answer is 75.7142. Next, 107 by 140. 76.42. Next, 110 by 140 into 100, which is 78.57. Next, 112 by 140 into 100, which is 80. Next, 115 by 140 into 100, which is 82.14. Next, 117 by 140 into 100, which is 83.57. Next, 125 by 140 into 100, which is 89.28. Next, 131 by 140 into 100, and the answer is 93.57. Next, 140 by 140 into 100, and you know that the answer is 100. Next, 147 by 140 into 100, and the answer is 105. Now you can look at option A. So let me read out first term. First term is 71.4, next 74.28, which is 74.3, next 75.7, next 76.4, next 78.57, which he is taking it as 78.6, next 80, next 82.14, he has taken at 82.1, next 83.57, he is taking it as 83.6, next 89.28, he is taking it as 89.3, and next 93.57, he is taking it as 93.6, 100 and 105. So option A is a correct answer. If option D wouldn't be none, I'll definitely go through this method called elimination. I don't do this much of MCQ, guys. So I can verify who are coinciding, who are not coinciding. I'll just calculate who are not coinciding. What is the use of doing this much of question, right? So just be smart enough, guys. Try to go through option elimination whenever it is possible, guys. Now let me show you the next question. MCQ number 48. This is where most of the people get confused, guys. That's why I've taken this question. So let me read out the question, guys. In 1996, let me keep a comma here so that I'll be able to understand that my entire question is about 1996. In 1996, the average price of a commodity was 20% more than in 1995, but 20% less than in 1994. And moreover, it was 50% more than in 1997 to the price relatives using 1995 as the base year. Means what is 1995 base year? It means 100 only, right? So guys, you must understand one thing. Just try to understand. There is a data from 1994 to 1997. So I'll just write my years. So from 1994 to 1997, I'll write all the years. And I know that what is my base year? Here my base year is 1995, whose value is 100. Got it, guys? So my base year is 1995, whose index number is 100, and that is there in all the options, right? Got it? But the options are same, no? How can I say? So I can't tell you, right? So now listen to me. Let me read out the first line. In 1996 means 1996 value is, let me assume that 1996 value is X. In 1996, the average price of a commodity was 20% more than in 1995. What is 1995 value? 100. 20% means you have to calculate 120%, guys. That's it. 120% of 100. Tell me what is 120% of 100? 120. Now, are you able to eliminate any of the options? Yes, I can eliminate option B. But 8, I have two options, no? Now, guys, try to understand. The next line will definitely tell you what is the answer. But 20% less than in 1994. Who is 20% less than in 1994? That you need to understand. Guys, let me assume that the value of 1994 is X and the value of 1997 is Y. I've already told you the entire information is about 1996. Means 1996 data is 20% less than in 1994. What is 1994 data? X. X means, guys, you have to understand that it is 100% of X. 20% less than of X means it is just 80% of X. That's what you need to understand. 80% of X. Could you please tell me what is X equals to? 120 into 100 by 80. My answer is 150. People feel that it is 20% less than means they will write 80. People feel that it is 50% more means they'll write 150. It's not that, guys. Here you're comparing your data with not 95 with 1996. So, and your answer is 150. Now, let me show you the next line. The next line is, and moreover, it means who? 1996 was 50% more than in 1997. Means 1996 is 50% more compared to 1997. What is 1997? Y. 50% more than in 1997 means 150% of Y, which means 150Y by 100. Take your calculator and calculate what is Y equal to. 120 into 100 by 150, right? What's your answer? 80. So y value is 80. And what's your answer? 150, 100, 120, 80. The question that you need to understand that the entire question was compared with 1996, though the base was 1995. You just need to understand that. Okay, guys. Now let's talk about splicing. What is splicing, guys? So, guys, slice means you need to split. No. Splice means you need to combine. So means I'll tell you the literal meaning of splicing, and I'll tell you why the splicing is useful. How is the splicing useful? So what are the factors involved in the splicing? Okay. So guys, if you look at this years from 1990 to 2000 data is given. Got it? So means there's a huge data in which first index number started off with a base 1990. And the production got ended with 160. Guys, let me assume that I'm manufacturing some kind of keys or locks. So from 1990 to 1995, that model worked. Suddenly in 1995, there's a new model launched. Because of force, I'm also able to launch the same. That's why in 1995, there's a production of old commodity as well as new commodity, which is my old locks are also produced and new locks are also produced. But as an advancement in technology, people are just preferring new locks. People are not preferring old locks. What is the use of producing old locks? Do I need to keep them in my pocket? I can't. So that is why the production from 1996 has been stopped. And they've started the production, new time production from 1995 onwards. Got it, guys? Yeah. Means due to an advancement in technology, people will just avoid the old methods and they will start the new methods. But if you want to combine both the series and you want to combine both the series to compare your business data, the combining of these two discontinuous series, there is a discontinuity here for this. There is a discontinuity here for this. If you want to combine two or more discontinuous series and you want to make it as a continuous series, the process is called as splicing. How do you call it as? Splicing. So splicing means combining two or more series of index numbers provided there is a overlapping year. What is your overlapping year? 1995. Here in overlapping year, old series index number is called as overlapping year index. What is your overlapping year index here? What is your overlapping year index here? 160. So, how to do splicing? Guys, if your new series is combined with old series, if your new series is joined with old series, means the forward values got filled, no? The splicing is called as forward splicing. If your new series, guys, look at this. If your new series is combined with old series, the splicing is called as forward splicing. But if your old series is combined with new series, backward values are filling up, splicing is called as backward splicing. For anything who is playing a key role means this overlapping year index plays a key role. This I am calling it as overlapping year index. Overlapping year index. So, what is the correction factor or what is the multiplication factor that is need to be used in forward splicing? Guys, listen to me. If it is 100, it is 160, no? If it is 110, how much it will be? 110 into 160 by 100, right? Like that. If it is 115, how much it is? 115 into 160 by 100. So, every time you are multiplying it with 160 by 100, no? Means overlapping year index by 100 is called as the multiplicative factor of forward splicing. Now, look here. Means overlapping year index by 100 is called as a multiplication factor. Now, look at here. So, if you want to go through backward splicing, you have to think like this. If there is 160, it is 100. If it is 140, how much it will be? 140 into 100 by 160. Am I correct, guys? Yes. If it is 125, how much? 125 into 100 by 160. So, every time you are multiplying it with what? 100 by 160 means 100 by overlapping year index, and that is called as correction factor or multiplicative factor of backward splicing. Which splicing? Backward splicing. So, guys, if you want to do this, Means backward splicing or forward splicing, it depends upon the multiplication factor. Now, if you look at 49, from the following data, splice the index numbers taking 1995 as base. If 1995 is the base, means I have to talk about new series, no? Means I have to take old values to the new series, means I have to do 140 into 100 by 160. What is 140 into 100 by 160? It is 87.5. Next, 125 into 100 by 160. What is 125 into 100 by 160? It is 78.125. Next, 120 into 100 by 160. It is 75. Next, 100 into 100 by 160. It is 62.5. So, your backward spliced values are 62.5, 75, 78.125, 87.5, and the next values are quite common. There's no change in the next values. So this is what about forward splicing and backward splicing. This splicing is nothing but combining two or more discontinuous series to get a continuous series. So where the old series of index numbers stopped at a particular year, there itself new series of index numbers has started. It means there is an index number for overlapping year. That overlapping year index plays a very important role here. Guys, you must understand one thing. If you are going through backward splicing, means you are changing your base to 1995 from 1990, it is called as base shifting. But if you want to splice this way, means if you want to write down these values, it is called as forward splicing. No, it means you are shifting your base 1995 to 1990. It is called as reverse base shifting. So let me tell you one thing. Let me clarify one thing. Backward splicing requires base shifting. Forward splicing requires reverse base shifting from 1995 to 1990. I'm going no. So yes. So that is what forward splicing and backward splicing. So where both of them have a common base here. So guys, we are done with MCQs, right? Now let's see the test of adequacy concept, which is another important concept in particular in theory from index numbers. You'll definitely get one MCQ from here, guys. So what is test of adequacy and why is this test of adequacy? So as you all know that we have many index numbers, right? Dash base, bashes, or simple aggregate or weighted aggregate, like we have many formulas, no? So to understand which index number is best, we are abide by certain rules, right? So those set of rules is called as test of adequacy or test of consistency. What are those tests? Means if your index number is satisfying these tests, your index number is said to be a best index number. Got it, guys? Now let's see what are those tests of adequacy. There are 4 tests of adequacy, guys. The first test of adequacy is unit test. The name itself is saying that unit. As index numbers are meant for comparison, your index number must be unit free. Got it, guys? Whether you are talking about price index number or quantity index number or value index number or any other special purpose index number, the index number computed by you by using a particular formula should be unit free. Got it, guys? So which index number is not satisfying this unit test? Except a simple aggregative index, all the other indices are going to satisfy unit test. Let me repeat, guys. Your unit test means the index number calculated by you should be unit free. And the only index number that is not going to satisfy unit test is simple aggregative index. So means if you have better knowledge about all the index numbers formulas, except the simple aggregative index, all the remaining people are going to satisfy unit test. Next, what is the next test? The next test is time reversal test. The name itself is saying that I'm reversing my time, means I'm converting my base period into current period and current period into base period, means I'm shifting my base to current period, means so P01. And what is its reverse index number? P10. If you interchange the time periods, the index number should also be reversed. If you reverse the time periods, means base period is becoming current, current is becoming base, no? Whenever you reverse the time periods, the index number should also be reversed. Guys, try to understand. Here we are not using into 100 at all. Okay. So, try to understand. P01 equals to 1 by P10. Now, bring this P10 to the left side. P01 into P10 equal to 1, where P01 is the price index number of 1 on 0 and P10 is the index number of 0 on 1. So guys, here Lashpay's index number and Pascher's index number are not going to satisfy this test. I'll tell you why. Because if I write P01 due to Lashpay's, what is P01 due to Lashpay's? Summation P1 Q0 by summation P0 Q0. This is P01 due to Lashpay's. Now tell me, what is P10 due to Lashpay's? Guys, it's not a great thing, guys. Just replace 1 with 0 and 0 with 1. Interchange 0 and 1 means summation P0 Q1 by summation P1 Q1. The product of these two things must be equals to 1 means all the things must be cancelled. Can you see anything will be cancelled? No. Nothing would cancel, means it is not equal to 1, means Lashpay's index number is not going to satisfy, yes, time reversal test. Next, let me talk about Pascher's index number. P01 due to Pascher's into P10 due to Pascher's, which is summation P1 Q1 by summation P0 Q1 into summation, interchange 0 and 1, P0 Q0 by summation P1 Q0. Anybody got cancelled? No, nobody got cancelled. Then how can you get 1? It is not equals to 1. It means Lashpay's and Pascher's index numbers are not going to satisfy this time reversal test. But one thing I must say, Fisher index number is going to satisfy this time reversal test. I'll show you how. So what is Fisher index number? Fisher index number is the product of Lashpay's and Pascher's, no? Now we have to calculate P01 Fishers into P10 Fishers. If the product of both of them is equals to 1, that will be time reversal test will be satisfied. So as you all know that Fisher's index number is based upon the geometric mean, no? So there exists a root. So let me write down Fisher's index number. So summation P1 Q0 by summation P0 Q0 into summation P1 Q1 by summation P0 Q1, right? This is P01 due to Fishers. Now let me write P10 due to Fishers. Means let me interchange 1 and 0. In place of 1 I need to write 0. In place of 0 I need to write 1. So P0 Q1 by summation P1 Q1 into, in the second part also interchange 0 and 1. Means I'll get summation P0 Q0 by summation P1 Q0. So guys, look at here. This is summation P1 Q0. This is summation P1 Q0. This is summation P0 Q0. This is summation P0 Q0. This is summation P0 Q1 and this is summation P0 Q1. This is summation P1 Q1 and this is summation P1 Q1. Everybody got cancelled? No. So the total answer will be equals to 1. So P01 due to Fishers into P10 due to Fishers is equals to 1. Means this is going to satisfy time reversal test. I will tell you a simple secret to remember this thing, guys. Those who are dependent upon geometric mean will always satisfy time reversal test. As you know that you have many formulas, but some only are dependent upon geometric mean. And remember, those who are dependent upon geometric mean will always satisfy time reversal test. But those who are dependent upon arithmetic mean, they cannot satisfy this time reversal test. As time reversal test is dependent upon the product mean is a geometric mean. So the one which deals with geometric mean will always satisfy time reversal test. So I don't say that the remaining mean members are not satisfying. Arithmetic mean will not satisfy, geometric mean will satisfy, but the remaining things, whether they satisfy or not, you have to check. Oh, got it, guys? So that's what about time reversal test. Now the next test of adequacy is factor reversal test. Madam, what is factor reversal test? Recently we reversed time, no? Now let us reverse factor. Factor means we are just having two factors here, guys. What are the factors? One is price and the other one is quantity, right? So factor reversal test means the index number calculated by you should satisfy this way. Price index number into quantity index number should be equal to value index number. Price index number into quantity index number is equals to value index number. As you all know that value is equals to price into quantity. But change in price into change in quantity should be equal to change in value. That's what they're saying. And that test is called as factor reversal test. Remember, guys, Fisher's index number is the only index number which will satisfy this factor reversal test. If you want, I'll prove it, guys. So look here. So price index number due to Fisher's. What is price index number due to Fisher's? Summation P1 Q0 by summation P0 Q0 into summation P1 Q1 by summation P0 Q1 is the price index number due to Fisher's. Of course, there is a square root, right? Now, quantity index number, madam, how do we write quantity? Just simple task, guys. In place of price, keep quantity. In place of quantity, keep price. Means into summation Q1 P0. In place of P, replace Q. In place of Q, replace P. Q1 P0 by summation Q0 P0 into summation Q1 P1 by summation Q0 P1. So, guys, observe who are going to be cancelled. So, this is P1 Q0, this is P1 Q0. Got it? Now, this is P0 Q1, this is P0 Q1. Now, if you look at the numerator, summation P1 Q1 into summation P1 Q1 2 times repeated and there is a square root. So, square root will be cancelled, else I'll be getting summation P1 Q1. Now, if you observe denominator, summation P0 Q0 into summation P0 Q0 has been repeated twice. So, it will be summation P0 Q0 whole square under root and that will be summation P0 Q0. This is value in current year by value in base year, no, which is nothing but value index number. Means we found that price index number into quantity index number became value index number, and that means Fisher's index number is going to satisfy factor reversal test. Of course, Fisher's is the only index number which satisfies factor reversal test. And one more thing I must tell you, guys, Fisher index number is the index number which is satisfying both the reversal test, means time reversal test and factor reversal test. That's why Fisher index number is said to be an ideal index number. How do you call it as? Ideal index number. Now, what is the circular test? Guys, in time reversal test, we have seen a shifting of base, no? Shifting of base from 0 to 1 and 1 to 0 means you are shifting a base between one period only. So, if it is desirable to shift the base among only one period, you can prefer time reversal test. Now, the circular test that we are talking now is an extension of time reversal test, in which if you want to shift the base over 2 or more periods of time, so it means 0, 1, 2. So, 0, 1 means I am shifting the base from 0 to 1. Next, I am shifting the base from 1 to 2 and I am shifting the base from 2 to 0. A complete circle got completed, no? That is why it is called a circular test. Whenever you want to shift the base among more than one period, you have to go for circular test. If P01 represents the price index number of 1 on 0, here the index number is calculated for the year 1 with a base of 0 and my target is shifting base, means my base period is actually 0. Now I am shifting it to 1 and the current period serves as 2. Now my base period is 1 and the current period is 2. This current period will be the base for the next index number, means it will be P20 and that is equals to 1. If that is equals to 1, so it is going to satisfy circular test. So there are few things that are satisfying circular test, guys. One is simple aggregative index number and the other one is Kelly's index number, which is also known as weighted aggregative index with fixed weight. Here we have provided the tabular format for the index numbers which are satisfying a particular test. If it comes to unit test, I have already told you, except simple aggregative method, all the remaining index numbers are going to satisfy, no? So this is what about unit test. Now coming into factor reversal test, just now we discussed. So the only index number that is satisfying factor reversal test is Fisher's index number. So that's why we gave a tick mark to Fisher index number. Just now I told you circular test will be satisfied by only 2 index numbers. Simply you can remember first and last. First is simple aggregative index. Last one is Kelly's index number, which is also called as weighted aggregative index with fixed weight. Now, if you want to verify whether a particular index number is satisfying time reversal test or not, you can do that because P01 into P10 calculation is quite easy for you. If P01 into P10 equal to 1, that is, an index number is going to satisfy time reversal test. Simple aggregative will satisfy time reversal test, guys, of course. So I have already told you, geometric means will always satisfy. Yes, weighted aggregative will satisfy, arithmetic mean will not satisfy, geometric mean will always satisfy, Lash pace will not satisfy, Pashes will not satisfy, Darvish-Foley is based upon arithmetic mean, no, that can't satisfy, Fisher's index number is satisfies, and Marshall-Edgeworth is based upon the geometric mean of quantities, no, it will. So, next, Walsh index number will satisfy the index, sorry guys, Marshall-Edgeworth is based upon the arithmetic mean, no, it will not satisfy. Walsh index number is based upon the geometric mean of quantities of base year and current year, no? So it will satisfy. Kelly's index number is a fixed index number, a weighted aggregative index with fixed weights, no? It is also going to satisfy. Got it, guys? And this is a very important concept. So we have discussed everything about under the concept called index numbers, guys. So here, problems play a little bit more role compared to theory, I can say, because you will understand theory better only if you are able to write what is the formula and you are able to calculate something, then only you understand the literal meaning of that theory. So you can understand theory a better way only if you do problems. Try to understand that. So try to solve many problems, then you will get more conceptual clarity about slicing, shifting of index numbers, types of construction of base. All these things you will get to know about them only if you are able to solve MCQs under that model, guys. So practice more number of MCQs so that you are able to understand the theory concepts also very well. Got it, guys? So let's get into the next concept, guys, which is statistical description of data part 2. So guys, we have already discussed statistical description of part 1, which contains all the basics that are needed for statistics. You have learned what is an inclusive series, exclusive series, what is a discrete series, what is a continuous series, and what is an attribute, what is a variable, how to convert inclusive series into exclusive series. So how to draw tally marks, how to construct a frequency distribution. There we have learned all the basics. Now we are into the actual concept called statistical description of data. So in which we are talking about the definition of statistics and all the terms that are involved in statistics, everything that we are going to discuss here, guys. Before that, let me tell you, the weightage or the expected weightage of this concept is usually 6 marks, guys. And it is a completely a theoretical concept. So if you are good at theory, this concept is going to help you in giving you more marks, guys. It is completely a theory concept. Yes, of course, it has few MCQs on theory. Few MCQs on problems, but compared to MCQs on problems, here there are many MCQs on theory and more focus is on theory only, guys. So this is a very easy concept for the people who are based upon theory. Okay, so the usual preparation time for this concept is usually 8 to 9 hours, guys, because it has that much of theory. Each and everything that you need to learn, then only you will be able to understand the next concepts. Okay, everything is interlinked, guys. Okay, but now I'm going to finish this in a span of 1 or 1.5 hour, guys. So let's get into the concepts, guys. So before getting into the problems, I'm directly going into the theory concepts, guys. So what is the overview of this topic? Applications of statistics. So we have already discussed the definition of statistics, no, collection of data, classification of data, presentation. That's what we are going to discuss here. Collection, classification, presentation. Okay, that presentation is of two types. One is graphical presentation and the other one is textual and tabular presentation. According to data collection, data is divided into two types. Okay, according to the presentation, they might be either frequency distribution or cumulative frequency. If it is tabular presentation, means it's a frequency distribution or cumulative frequency distribution. So graphical representation, there are frequency curves and non-frequency curves. Okay, so define the term statistics. What is statistics? I've already told you. For some people, it is just counting. For some people, it is average. For some people, they'll use to bring the precision in social studies. I've already told you. Yes, but there are two definitions in statistics. What are they? We have already discussed, guys. Singular sense, singular definition, plural definition. Singular definition deals with collection of data, classification of data, presentation of data, analysis of data, and finally giving a valid conclusion. But what is a plural definition? So best definition of statistics should be such that it has to deal with both qualitative data and quantitative phenomenon. That is what the plural definition is saying. So what are the definition of statistics according to different statisticians? According to A.L. Bowley, it is just a science of counting. I've already told you. For some people, it is just a number. Yes, for some other people, according to Coxton and Cowden, the science which deals with the collection, of course, classification analysis and interpretation of data. Yes. According to R.A. Fisher, statistics is fully a branch of mathematics which is applied to numerical facts. So what is the history of statistics, guys? Statistics is originated from the Latin word status, guys, Italian word statista, German word statistics, French word statistique. Somehow, statistics was or used to be a branch of mathematics. Nowadays, it became a full-fledged subject, and it is a separate subject, guys. So in olden days, statistics used to become a part of mathematics, but now it is a full-fledged subject, guys. So I've already told you, many members felt that statistics is just a number. So olden days, Kautilya kept his records. You know that Kautilya is the person who wrote the book called Arthashastra, right? So he has written a book called Arthashastra. So in that, he collected the records of births and deaths of the people of his kingdom, and he just told that this is what statistics to me. Yeah, for him it is just a count. So in olden days, during the reign of Akbar, in his time, he find the statistical records of agriculture, means what crop is happening and how much production is there. So that was written by his finance minister called Abul Fazl. Maintained a record of agricultural things, and he called that one as statistics. So of course, initial days, the very first census was conducted in Egypt in the year 2000 BC to 3000. Got it, guys? So now, what are the applications of statistics? I've already told you. Today, statistics is applied anywhere, everywhere. Yeah, I've already given you an example, guys, which is if you want to join in a college, you can't directly get into that college and you can't directly take the admission. You will collect a lot of information about the colleges that are offering courses that you need, and you will understand which you will analyze, or you will inquire people. You will collect the data about that particular college by collecting the information from the previous students, right? Yes. So you are not directly into the statistics term, but many people are using that without knowing that they are using statistics. So guys, statistics has almost universal acceptancy applications, guys. And one more thing, nowadays, because of this cutthroat competition, if anybody wanted to implement any new method, they will go through all the calculations. No, those calculations itself is statistics. No, those projections itself is statistics. No. Yes, whatever, whoever, many people are using statistics unknowingly. So statistics is used everywhere, guys. So not only in commerce and industry, not only in economics. In economics, you will go for projections, right? Suppose when it comes to commerce and industry, I've already told you, if you want to implement a new method or new technique into your business, it's not that easy, guys. You have to analyze something that can be done with the help of statistics. Not only in commerce, not only in economics, guys. Even while I was submitting my research papers also, I did the applications of statistics only. So whatever you do nowadays, you have to apply the statistics only. So you have to apply statistics to understand whether the data collected by you is accurate or not. So it is applied everywhere, guys. Nowadays, statistic applications are universal applications, guys. So now, what are the divisions of statistics? I've already told you. So there is descriptive statistics, means it deals with only numerical data. So what are they? What are the numerical data? So we have discussed central tendency. We have discussed dispersion, skewness. Yes, now those are descriptive statistics. What are applied statistics? The name itself is saying I'm applied somewhere. I'm not a calculated value. So I'm going to draw a particular conclusion. Yeah. Specific problems that are related to real situations are there in applied statistics. That's why we are calling it as applied statistics, as we are applying in our real life. So sample survey is quite helpful for us in a regular day-to-day life, guys. Next, inferential statistics. The name itself is saying that I'm going to conclude something. So that conclusion can be done with the help of chi-square test, t-test, f-test, chi-square test, all those things, guys. The next statistic is inductive statistics. So this is completely related to forecasting, guys. Where we have seen forecasting? Yes? Yeah, random variables somewhere near. Got it? So forecasting techniques are there. Next, mathematical techniques. What are those mathematical techniques? So guys, in integrations and in derivatives, of course, in trigonometry, in matrices also, you will use these mathematical statistics, guys. Next, analytical statistics. The name itself is saying that I'm used for the purpose of analysis. Got it, guys? So they are used to draw the functional relationship between two or more variables. Then only you can analyze them, no? So at which concept you have deduced these mathematical relationships? Regression analysis? Of course, that is based upon correlation analysis, no? Yeah. So that is what analytical statistics, guys. Now, what are the limitations of statistics, guys? Statistics is meant for comparison, no? Now, if I talk about only one person data or my data, is there any point of comparison here if I'm talking about one observation? No. It means statistics always deals with group of data. To a single observation, there is no significance. Got it, guys? Now, statistical calculations are done with mathematical data only, right? Even if it is qualitative, if you want to calculate the average, I can't directly calculate, even if it is mean or mode, median or mode. I can't do that, no. Means, however it is qualitative, I'm converting it into quantitative. Though statistics is saying that I'm going to deal with both. He's dealing with only quantitative data. Even if there is quality, that is being converted into quantity. And one more thing, whatever the calculations or whatever the projections that you are doing here, all those results are true only on an average. They're not 100% true. Okay. So, and that too, whatever the inferences or whatever the results that you are drawing with the help of statistical analysis, they're also true only on an average. They're not true 100%. Means statistics is completely giving you estimated values. They're not giving you actual values. They are true only on an average. So, and that too, whatever the statistical method that you follow, they abide by certain conditions, like I told you. Correlation analysis. So they have Carl Pearson coefficient of correlation. It will give you correlation coefficient between any two values, any two set of data. If you substitute wrong data, it is your problem. That formula will definitely give you an answer. If you substitute shoe size and intelligence, since it is a formula, it doesn't know what you are substituting. It will definitely tell you an answer. But the thing is, it is abide by certain conditions. You have to substitute two variables only if they're logically and linearly are connected. So otherwise, if you substitute a set of values there in the formula, you will get a conclusion that is not the correct conclusion, because I'm abide by certain rules. If that rules are not strictly adhered to, I'll get wrong conclusions. So try to understand that. So you have to follow the rules that are given to you. Otherwise, the results or the conclusion that you will get is the wrong conclusion. So what is the first part of statistics definition? Collection of data. Means you have to collect the information. Data means what? Quantitative information about some particular characteristic under study. For example, I wanted to collect the heights of group of people in my class. So I'll take a tape and then I'll collect. So what kind of information I'll get? Quality or quantity? Quantitative information only, right? So guys, I myself went to the class and I only collected information about the heights of all the people. Means with a measuring tape, I only measured the heights of all the members of my class. So means I'm the person who collected the information about the heights. I only collected. For me, the data collected by me is a primary data. How do you call it as? Primary data. Means you are the person. You are the source of that data. Got it? So now I've collected that information. No. If somebody else use that information, to them it is secondary data. To them it is what? Secondary data. For example, I'll read newspaper every day, guys. So that information is collected by me or someone else? Someone else. So to me, it is secondary data, as I'm the second person. I'm not the first person. So the person who collected the information and who has written that article is the person who has collected that information. No? To him, it is primary data. To everyone else, It is secondary data. So what is a primary data? Primary data is a data that is collected by an investigator or an agency for a specific person directly, for a specific purpose directly from the field of inquiry. So what is my field of inquiry here? My class. I've collected the information about the heights of all the people directly, not by using any middle person. If there is no middle person, I am the person who have collected the information. I myself called as source. So I am the person who has collected that. So for me, as I am a source, my data will be primary data. If it is used by somebody else, it is secondary data. So every information that you are collecting from the internet is always the secondary data. So guys, but you should not take the secondary data directly from any non-believable source. If I collect information from my Facebook, how can it be correct? Somebody else written it on their wall. How can I accept that? I can't take it directly. So from where you have to collect the secondary data? I can believe my secondary data if it is collected by some authorized organizations like international sources, WHO, so World Health Organization, International Labour Organization, International Monetary Funds. So all these things are believable sources, no? So Central Statistical Office organization. So agricultural statistics, they'll provide agricultural statistics, no? All those information provided by them is 100% correct. So I can use them as they are believable sources, no? And sometimes without publishing also, there many articles will be there, guys. So that kind of articles are also believable because they are deducted, they're not published. So such unpublished sources will also be accepted as the sources of secondary data. You can't directly take the secondary data, guys. So what are the methods of collecting primary data? So guys, before that, I'll tell you what is the secondary data. Secondary data is the data that was collected by somebody else and I'm using it. So if I'm using that data, it means there's a chance of getting wrong answers also, guys. So that is why you should not take directly take the secondary data, and you should not keep it in your pocket. So before taking that secondary data from someone else, you need to check for the consistency of the data. That consistency of the data can be done with the help of what? Scrutiny. So statistical analysis is completely dependent upon data only, guys. Whatever the data that you are taking should be very good. You should not take the data from any unbelievable source. Even if it is believable source also, you must verify whether it is consistent or not. That consistency must be done with the help of some patience and some intelligence and some statistical methods. So guys, so everybody is not so perfect, no. Errors might be there. Errors might be there. So while writing, if I write 93.5 instead of 95.3, that's not actually by intention, guys. It is just a clerical mistake, no. Copying mistake, no. Those kind of things will also be there. So one has to apply their patience and intelligence, and then they need to check whether the data is good or not. So this scrutiny can be done in two ways, guys. One is internal consistency and the other one is external consistency. So what is internal consistency? Sorry, what is external consistency? Guys, suppose if I wanted to collect the information about the heights of group of people in my class. So means I have to talk about my student name and roll number and their height. So guys, I got the data with name and roll number only. What is my purpose? Collection of heights. Is there any height that is provided to you as a table? No. Means by looking at this at a glance, you are able to understand whether the data consists of all the requisite fields that you need or not, right? So my data don't have height column. Then what is the use of collecting the data, guys? So that kind of checking is called as external consistency. But so by looking at it once, you are able to understand whether the data is externally consistent or not. Now, if that data is externally consistent, and then go for internal consistency. What is an internal consistency? Internal consistency means whether the data collected by that person is accurate or not. For that, you can go for random checking. You can go for some other method. So it is up to you. And that is called as internal consistency. Internal consistency means whether the data is collected by you is correct or not. Means out of 200 members, randomly check 5 members. If that is accurate means you can proceed. Or else, if my information is about 4 numbers of group of students, I'll just call 2 or 3 members and I'll confirm whether that number belongs to their parents or not. If it is more so means, I'll say that my data is internally consistent. So internal consistency, external consistency, both of them are done means you're done with scrutinizing data. You can't directly take the secondary data, guys. One must understand whether the data is consistent or not. If it is consistent, then only you have to use it. And the process of checking the consistency of data is called as scrutiny of data. Now let's get into the methods of collecting primary data. So what are the methods of collecting primary data? The first method, so that we have already discussed, guys. Let us talk about this method. What is this method? Observation method. If I wanted to collect the heights of group of people, I can't directly calculate by looking here, no. So I have to take a tape and then I need to observe and then I need to measure and I need to understand, right? So that is what observation method. Now, what is the first method? Interview method. Interview method is divided into many parts, guys. The first one is personal interview. Personal interview means we have to go to the person, we have to meet the person, and we have to inquire the person directly, which is called as personal interview. Got it, guys? Again, indirect method. Guys, suppose there is an accident that has happened before me. So, guys, can I collect the information to the person who is affected by that accident? He'll definitely scold me if I ask any information, guy, how this accident happened, whether you turned wrongly or he turned wrongly. If I ask them means he'll definitely tap me, right? So I should not ask them like that. I need to understand so how that first happened, or else any person who looked at that. So I have to collect the information from that. So guys, sometimes if accident happens means that person may be there or may not be there, no? In such a case, how can I collect the information from that person directly? Though I'm talking about direct interview, I'm talking about primary data collection methods. How can I collect the information from that person who is not there? As the person already died, how can I collect the information from that person who has already died? So I have to go to the people who are nearer to that locality and who have seen that accident clearly, and I have to collect the information from that person, which is called as an indirect interview method. So in case of train accident or rail accident, any accidents, we can go for this indirect interview method, guys. The next one is very important method, telephonic interview method. Means you have to ask the informant by giving a phone call. But guys, listen to me. When compared to the previous methods, we are the person who are going directly meeting that person and who are getting the information. So if I knock the door means they'll get the information, they'll give me some information. But if I gave them a phone call, they'll just say that it is a spam number and they'll cut it, right? So means chance of non-response is a bit high compared to the previous two methods. Telephonic interview is a better method which has a wider coverage area, which is the speediest one, because we can give them a phone call within a matter of 2 or 3 seconds. But if you want to go to the person who are residing on a particular locality, it might take 1 day or 2 days or 10 days, no? So sometimes there's no chance that we can reach that person through a particular method. So in such a case also, we can go through a telephonic conversation or telephonic interview in which you can get the information by just giving a phone call. If the person don't want to give the information means he'll just cut the call, no. So sometimes because of their work busy, they may not attend the call, no. It means chance of non-response is a bit higher compared to personal interview and indirect interview. Now coming into the next method, mailed questionnaire method. The name itself is saying that I am going to frame a questionnaire. A questionnaire means, so suppose if you want to go for personal interview, you'll go to the person and you'll ask the person's a particular question, no? Collect all the questions, frame them systematically. The format of that question is called as questionnaire. So make a questionnaire and then mail it. So just a matter of second, it will reach many people. But guys, if it is a phone means at least they will attempt. But here mail questionnaire means they have to open the mail, they have to type the answers and they have to get back to us, no. So for them it is simply time waste, no. So whether they respond or not, it is completely up to them. Compared to telephonic conversation, this mail questionnaire method has more non-response. But the coverage is so wide here. Got it, guys? Now, question is filled and sent by enumerators. It means, guys, so we'll frame a well-drafted questionnaire, like mailed questionnaire only will frame a well-drafted questionnaire, and it will be given to some enumerators. Enumerators means are the persons who will collect the information from somebody else. So enumerators means they are the persons who will collect the information. So we'll give the questionnaire and we'll train them how to ask the questions and how to write the answers told by them. So that's how we'll train them and we'll send them to the public so that they can collect the information more clearly, and that method is called as question is filled and sent by enumerators. Got it, guys? So these are the methods of collection of primary data. So guys, if you observe this interview method, I mean to say personal interview method, indirect interview method, observation method, and question is filled and sent by enumerators method are more time consuming, but they'll give us more accurate data. When it comes to mailed questionnaire method, amount of non-response is so high. Compared to telephonic, it is more high. That's what you need to understand. Got it, guys? So that's what about methods of collection of data, and you know what is scrutiny of data. So what are the 5 steps involved in the statistics definition, guys? Collection of data, classification of data, presentation of data, analysis of data, and giving valid conclusion. Now we are done with collection of data. Got it, guys? So we're done with collection of data, right? So what is the next one? The next one is classification of data. What do you mean by classification, guys? After collection of data, after collecting data, since we are collected with a particular purpose, we have to analyze it. So means those collected data will not be directly used for the purpose of analysis, because the collected data is called as raw data. And that too, guys, if it is secondary data, we'll check for the internal and external consistency. No? So after that, we have to avoid unnecessary data. And we have to classify that data, which means whether it is useful for you or not. If it is not useful for you, leave it aside. So that part is called as classification of data. So avoiding the unnecessary things and arranging all the necessary things in a proper order is called as classification of data. So that classification may be with respect to an attribute, or with respect to a groups, or with respect to classes. It depends upon the purpose that we are collected. Okay. So what is the use of this classification of data? Guys, the collected data, raw data is will be in a zigzag order, no? So to arrange that data in a proper way, we need classification. Means classification puts or presents the data in a neat manner so that comparison is easy for you. And analysis is also possible only after the data being classified. And I already told you, we will eliminate the unnecessary data. Okay. So only necessary information will be there after classification. So what are the types of classification? So guys, classification is of 4 types, guys. Qualitative data, quantitative data, chronological data, and spatial data. What is qualitative data? Guys, the name itself is saying qualitative data, which is called as ordinal. Got it? Means we cannot express it in terms of numerical values. Qualitative data that deals with an attribute. Attribute means it can't be measured numerically, like social status, caste, religion, sex, marital status, qualification of a person. All these things can't be expressed numerically, no? If it is marks, I can express them numerically, right? Yes, the things that cannot be expressed numerically are called as attributes. If classification is done with respect to attributes, the kind of classification is called as qualitative or ordinal classification. Now, what is a quantitative or a cardinal classification? If you are dealing with a variable, means classification is done in respect of any measurable characteristic, like profits of a company, heights of group of students, marks of group of students. Yes, that is called as quantitative or cardinal classification. Got it, guys? So here we'll classify the data either into discrete distribution or continuous. That depends upon the factors that are used in the data, or that depends upon your need. Okay, now what is next? Chronological data means if your data is varying over time, that is called as chronological data or time series data or else temporal data. Data which is varying over time means, for example, if you are collecting the information about marks of group of students in the past 5 weekends. So every weekend we used to conduct an exam, no? So let me collect the marks on the marks of group of students in that weekend. So marks of student A in weekend 1, weekend 2, weekend 3, weekend 4. So he got some marks. Let it be 50 marks, 55 marks, and then he got 48 only. Now here he got 60. So here your data is varying over time, no? Such kind of classification is called as chronological classification or temporal classification or time series data. When data is represented in data is classified in respect of successive time points, that is called as time series data or temporal data or chronological classification. Now, what is a spatial classification? The name itself is saying, yes, my data is varying over place. Yes, data is arranged in respect of your geographical location. For example, if I wanted to collect the temperatures of 4 different cities, A, B, C, D. Let me assume that A is a city, B is the other city, C is the other city, and D is the other city. So my data is varying over place, right? So if classification is done with respect to geographical location, that data or that classification is called as geographical classification or spatial classification. Got it, guys? Coming into the next one. So are we done with collection and classification? Yes, collection of data, and we went through different methods of collection of data. Classification, we went through what are all the 4 types of classification of data. Now, collection is done, classification is done. The next one is presentation of data. Means once the data is classified, the data can be presented in a systematic way. So this presentation of data can be done in 3 ways. One is textual presentation, the next one is tabular presentation, and the next one is diagrammatic presentation. Got it, guys? Textual, tabular, and diagrammatic presentation. Once the collection is done, then only you can do classification. Once the classification is done, we are going to present the data. So this presented data can be analyzed very easily. That is why we are going to present the data in a systematic way. So once the data is collected, so we'll check for the consistency of the data. I've already told you what is consistency of data, internal consistency, external consistency. I've already told you, no. So, and then we'll classify it. Now we need to present the data in a very attractive method, and we need to present all these things by highlighting what is required, what is essential, what is most essential. We'll highlight them and we'll present them. Such presented data can be analyzed very easily. So the first presentation or first mode of presentation is textual presentation. The name itself is saying that I'm going to present my data with the help of number of paragraphs. So I'll write the data in the form of text. So I'll just write down my data in form of the text. Not only with one paragraph, with many paragraphs, I'll present my data. So guys, if you want to understand what is, suppose I'm dealing with the population of a particular city during different years. So I'll write for the year 2010. This much of population is there. In the next sentence or in the next paragraph, I'll write for the year 2020. This much of population is there. Out of this many male, this many female, this many children. So like that I'll write. Means if I wanted to know what is the female population for the year 2020, I need to read out the entire paragraph, no? So it's not that I can pick a particular figure directly like this. You have to read out the entire data, then only you are in such a position to pick that figure, right? So it means it is very difficult for the analysis purpose if the data is presented textually. But guys, any official reports of inquiry commissions will be presented in the form of textual presentation because it is to be understood by common man also. That is why any official inquiry commission reports will be presented by textual format only, as it is the presentation which is easier to understand for a common man also. So guys, but this is not so good for the purpose of analysis. That's why we are going for the other presentation, which is tabular presentation. Of course, this is the best mode of presentation for analysis purpose. So if you want to do analysis quickly, you can use tabular presentation. The name itself is saying that I'm a table. So my data is presented in the form of a table. So here, what is tabular presentation and what are the parts of table that we can see here, guys? So tabular presentation means it is a presentation of data in a systematic way in terms of rows and columns. These are called as rows and these are called as columns. Horizontal ways are called rows and vertical presentation is called as vertical terms are called as columns, right? So along with column numbers, column titles, row titles, column formulas. So everything that is provided here, guys. So next, what is the next mode of presentation? Diagrammatic presentation. So guys, as you all know, textual presentation is a common, is understandable for a common man, but tabular presentation is best for the purpose of analysis. When it comes to diagrammatic presentation, it is the most attractive mode of data presentation, right? Like that. And one more thing that I need to tell you about diagrammatic presentation is, guys, if there is an increment or decrement in the values in the table, we just need to observe. But when it comes to diagram, if the diagram is here, you are just able to, at a glance, you are just able to understand that there's a trend here, just a little bit downward trend, and then it went through on its own. Guys, got it? So means these type of hidden trends are also be presented in a mode called diagrammatic presentation. So this is the most attractive method, but data values cannot be taken perfectly like tabular presentation. So, but hidden trend can be easily identified by using diagrammatic presentation. So as you all know, textual presentation is a convenient way for a common man. But for a statistician who is convenient, tabular presentation. In tabular presentation, we'll present the data with the help of row numbers, column numbers. I've already told you, no? Now let me talk about what are the parts of table, how do you present the data. Okay, rows means horizontal classification, columns means vertical classification. So guys, a table is presented this way, as you all know. So before this, at the topmost part, we have to give a title to the table. Madam, how is this title? What is this title? So this title has to tell us about what information is there inside the table. Suppose if I'm talking about complete census. So this title must be like, so census of a particular country, of a particular state, or of a particular district. So like that we have to provide. So a table title should be self-explanatory, means that has to explain the content that is there in the table. So the first part of the table is title, which is the entire topmost part of a table. Now, I've already told you there are rows and there are columns, right? So here, the next part is, let me show you the next part. The next part is stub. Stub means row headings. So for every row we'll write headings, no? These row headings or sub-row headings are also called as stubs. Next, captions means column headings. All the column headings are called as captions. So captions and stubs put together is the other part. We are done with the title, no? Next, we have to talk about captions and steps. Captions means column headings and column subheadings. Stubs means row headings and sub-row headings. So usually, guys, there are no sub-rows, there are sub-columns only. So if there is a classification which is divided into two parts, we have to consider them under columns. So what are stubs? row headings. What are captions? Column and subcolumn headings. Okay. Now, the next part is box head. So guys, try to understand. Box head is the entire upper part of a table which includes column numbers, subcolumn numbers. If there are subcolumns, we have to mention those numbers also. Along with them, if there is any formula that is used in this column 1, subcolumn A, you have to mention that formula also. It means box head is the entire upper part of a table that contains column numbers, subcolumn numbers, along with the formula that is used in the column or subcolumn. So what box head contains? Box head is the entire upper part of a table which contains all the column, subcolumn numbers along with the formulas, along with the units also. Now, the rest, middle we have to write the data, no? This is called as body of the table. How do you call it as? Body of the table. Now, let me assume that, guys, I have collected this data from some other secondary source. So now I have to write source note. Look here. Source note means if the data was collected from somebody else, means if your data is secondary data, you have to mention the source of this, from where you have collected. So that source can be written somewhere here. Source note. This is called as source note. Now there is another note called footnote. What is footnote, ma'am? Footnote means any other leftover information from the table can be written here in footnote. If you forgot to write something on the table, that can be written as a footnote. So any leftover information. So footnote is a phrase or statement that contains all the leftover information. Along with that, guys, we can't write this much of column heading, no. So column heading should be very short, right? So if there are any shortcuts like, so just if I write L means ladies. If I write G means gents. If I write M means male. If I write F means female. So if those things, those kind of shortcuts are there, the shortcuts are completely explained in footnote. Got it, guys? So everything, every leftover part, every clear detail, if you want to tell something else, that can be written in the footnote, which is written at the right side of the table, bottommost right side of a table. So the source note and footnote together, another part. Means how many parts are there? Title is one part. Subs and captions is the other part. Box head is the other part. Body is the other part. The last part, source note and footnote. So how many parts are there in the table? There are 5 parts actually, people say. So here you can see the regular form of a table. These are stubs. These are captions. These are captions. Of course, this is a body of table. There's no source, but they have provided footnote. That is what about tabular presentation. So guys, look here. This is the box head that you can see. The formulas that are presented, column, subcolumn numbers that are presented. Got it, guys? Now try to understand. After presenting the data in the table, you can go for analysis because this is the best mode of presentation. But what is the attractive mode of presentation, guys? Diagrammatic presentation, no? So how many types of diagrams you can see? Here you can see frequency graphs and non-frequency graphs, guys. So I'll tell you what are non-frequency graphs. Line chart, bar chart, pie chart. The name itself is saying that I am not having any frequency. Okay, for example, guys, let me tell you, time series data. Is it a frequency data or non-frequency data? Non-frequency data, because a particular time can't be repeated anywhere, no? Like spatial series is also a non-frequency data because there is no repetition in the place. There might be a name which is assigned for 2 places, but this place can't be that place, no. So there's no repetition for time series data and spatial data. So all the time series data and spatial data can be presented under frequency graphs or non-frequency graphs. Non-frequency graphs only. Non-frequency graphs means no repetition at all in the particular variable. Got it, guys? So here line chart, bar chart, pie chart, of course many charts are there which will come under non-frequency graphs. Frequency graphs, I have already told you, the graphical representation of mode is histogram. The graphical representation of median is ogive. Of course, the limiting form of this histogram will be polygon and curves that we can see here. So What are the diagrams which are based upon their dimensions? Zero dimension means they don't have any dimension. Pictograms don't have any dimension. One dimension diagrams, line chart and bar chart. Two dimension diagrams, as you all know, rectangle, square, circle, pie diagram, graphs, of course, histogram, polygons, curves. They're all two dimensional diagrams because they have x and y variables. Three dimensional diagrams, cubes, cylinders, of course, spheres. Types of charts. So guys, this is very important. What is a simple chart? It is a chart, means it's a diagram that represents the magnitude of only one factor. If you are talking about only one factor, that chart is called as simple chart. If you are talking about, suppose if I am talking about, guys listen to me, marks of Mr. A in different exams, that I am talking about only one person. So I have to go for simple chart. If I am talking about marks of Mr. A and Mr. B in different exams, here I am talking about how many students' performance? 2 students don't. So I have to go for a chart called multiple chart. So when there is more than one factor, we have to go for multiple chart. When there is only one factor, we have to go for simple chart. What are non-frequency graphs? Let's talk about the first non-frequency graph, which is pictogram. Madam, what is pictogram? So guys, under this method, data can be represented with a particular picture. For example, let me assume that I am talking about the population of a country. So I am assuming that this picture is going to tell me 25 crores. This picture is going to tell me 25 crores. And let me assume that in the year 1990, the population of my country was not 25, guys. Let me take it as 10. So in 1990, my country population was, let it be 80 crores. So I have to draw how many diagrams? 8 diagrams. Got it, guys? 1, 2, 3. Like that, I have to draw how many? 8. Let me draw 8. One picture is going to draw, I tell you, how many crores? Oh, 10 crores. So I have 80 crores population. So I'll draw 8 graphs. Now, when it comes to 2000, my population became 90 crores. Means I have to draw how many graphs? Yes, 9 graphs. Means, again, I'll present the same picture. But this time I have to draw how many pictures? This time I have to draw 9 pictures because my population of the country was 90 crores at that time. So draw 9 pictures. So it is saying that the population is 90 crores. Now, during the year 2010, my population became 100 crores. Means I have to draw how many pictures? 10, no? 1, 2, 3, 4, and then 5, and then 6, and then 7, next 8, next 9, next 10. So how many pictures I draw here? 10 pictures. So this is called as pictogram. Means under this method, data can be presented with the help of pictures, where each picture is going to represent a particular quantity. So madam, what is the advantage and what are the drawbacks of this pictograms? Guys, this is very easy for a common man to understand. Like one picture is going to tell you 10 crores. Then 9 pictures are there, means the population is 9 into 10, 90 crores. But guys, if I'm having a population of 95 crores, I'll write 9 diagrams. Along with that, can I write half a diagram? So yes, no. Means if data is expressed in terms of fractions, if the data is in terms of fractions, these pictograms are not so suitable, right? So guys, that is what the drawback of pictograms, guys. So pictograms are displayed by pictures. Single picture represent a fixed number. So every picture is going to tell you some number, but the problem is, it can't show you decimal values. These pictograms are also called as ideographs, that is provided to you here, guys. But the problem with this is there's no restriction that you have to show a picture. It can be a picture of any language. It can be a sign of any language. It can be a symbol of anything. Whatever you want, you can write. But the thing is, If the data is in terms of fractions, it is not so good. Of course, it is not usually meant for comparison, because we can't even express decimal values, but the best measure should express all the decimal values also, right? As of course, in statistics, we used to deal with crores of figures, no? So data must definitely be expressed in terms of decimals, and that is not so suitable. That's why pictograms are least accurate, guys. Now let us go for the next diagram. What is the next diagram? Line diagram or histogram. Try to understand. This is line diagram. Guys, it's not histogram. It is histogram. So what is when is line diagram is used? So guys, line diagram is used to represent time series data. What kind of data? Time series data. If you are talking about single time series data, you have to use simple line diagram. If you are talking about more than one time series data, you have to go for multiple line diagram. So what is this? How do you present this time series data? The name itself is saying that my data is varying over time. Means I have time and data y at particular time period t. So I'll have t and yt. T is presented on x-axis. Data on at that time period is denoted by yt. For example, population for the year, so for the year 2002, my profit was 5 lakhs. For the year 2003, my profit was 8 lakhs. For the year 2004, my profit was 9 lakhs. For the year 2005, again my profit was 5 lakhs. For the year 2006, my profit was 11 or 12 lakhs. 2007, it is almost 14 lakhs. 2018, it is almost 24 lakhs. So I'll present the values of points like this, and then I'll join them with a line. This is called as line diagram. So how many members data that is presented? Profit of one company is mentioned here, no? So means we are talking about only one factor, no? If you discuss about one factor, you will call it you will use simple line diagram or multiple line diagram. Simple line diagram. So here time is represented on x-axis, profits at that particular time is represented on y-axis, tyt is there. But guys, whenever this time series data exhibits a wide range of variations, for example, my initial profit was 5 lakhs and then my profit became 1 crore. Again, my profit became 50 lakhs. So I can't present 5 lakhs and 1 crore, because if I want to present 5 lakhs, listen to me guys, my scale on y-axis should be 5, 10, 15 like that. If I keep on writing 5, 10, 15, 12, 20, so 1 crore means my graph exceeds the paper that is given to me. I can't present it, no. So means whenever your time series data exhibits a wide range of fluctuations, for this yt, you will apply logarithm. So on x-axis, you will write t. On y-axis, you will write logarithm of yt. As you all know, logarithm helps you in shrinking a value. Well, it can be helpful in reducing its value. Even if it is crore, 1 crore. 1 crore means its value will be 7 point something only. So try to understand. So its value will be reduced to a great extent by using logarithms. In such a case, instead of t on y-axis, you will present log yt, and the graph that is so obtained is called as logarithmic graph. How do you call it as, guys? Logarithmic graph. So whenever you want to compare two or more variables, you have to go for simple chart or multiple chart. Multiple chart. Here we have written only one time series data. It means profits of one company. If you want to write another profit, means you will draw with some other color, means you will get some other line. So there are how many members information that is provided to you? Two members information. This kind of line chart along with the first line, second line can also be drawn. That red color is going to talk about company B and this blue color is going to talk about company A. So here we are comparing two data, right? Yes, in such a case, we'll use a diagram called multiple line diagram. The diagram that we draw here is called multiple line diagram. But guys, if we are talking about profit of company A along with, listen to me guys, if you are talking about profit with number of employees, profit is expressed in terms of rupees, but number of employees are numbers, no. Means you are talking about a time series data with two variables having different units, no. In such a case, you have to go for line diagram only. That too, it is simple line diagram or multiple line diagram. Multiple, but with different units, no. In such a case, you have to go for multiple axis line diagram, where this axis separate units, as both of them have different units, no. So this is completely imaginary, guys. How can a line separate two values of y on y-axis itself? It's not possible. This axis is imaginary. That imaginary axis is helpful for you in separating units. So whenever you want to compare, you want to present one single time series data, you have to go for simple line diagram. Two time series data means you have to go for multiple line diagram. More than two means you have to go for multiple axis line diagram. Sorry, two time series data with different units of data means you have to go for multiple axis line diagram. Got it, guys? So you know what is multiple line diagram, you know what is multiple axis line diagram, and you know what is simple line diagram. Simple line diagram is used to present single time series data. Multiple line diagram is used to present more than one time series data with same units. Multiple axis line diagram is used to present data more than one time series data with different units of measurement. So that's what about line diagram, guys. Next, what is a bar diagram and when is this bar diagram is used? Guys, I've already told you. To present time series data, you will use line diagram. To present spatial data, you will use bar diagrams. Okay. So there are two types of bar diagrams, guys. One is horizontal bar diagram and the other one is vertical bar diagram. So listen to me. Horizontal bar diagrams are used for qualitative data and spatial data. Just now I told you. So horizontal bar diagrams means bars will be like this, guys. Bars will be on y-axis. That we are not aware of. We usually aware of these kind of diagrams, no? This is called as vertical bar diagram and this is called as horizontal bar diagram. In general, we will use vertical bar diagrams, but if you want to talk about qualitative data or spatial data, you have to use horizontal bar diagram. If you are talking about time series data or quantitative data, you have to go for vertical bar diagrams. Bars means it is the rectangle of equal width. Bars means rectangles of equal width. Now tell me, guys, when is simple bar diagram is used? If you are talking about only one factor, only one time series data or only one spatial data. If it is spatial means you will use horizontal bar diagram. If it is time series means you will use vertical bar diagram. But my question is, when are you going to use simple bar diagram? If you are talking about only one factor. When are you going to use multiple bar diagram or grouped bar diagram? Multiple bar diagram is also called as grouped bar diagram. Whenever you want to compare two or more related series, you have to go for multiple bar diagram. Now we have another bar diagram which is called as divided bar diagram or subdivided bar diagram or percentage bar diagram. So guys, if you look at this example, this is just simple bar diagram which we have used horizontal bar or vertical bar. Vertical means it is a data that is varying over time. If you observe this data, it is a time series data. Profits in lakh rupees for the year 2002-2003. The same data that we draw for a line diagram also, no? So it is only one factor, no? Then we went through simple bar diagram. That too, why we went through vertical bar diagram? Because it is time series data. But guys, if you look here, we were given with two types of production. One is wheat production and the other one is rice production for the years 2005, 6, 7, 8. Just tell me what kind of data it is. It's a time series data. Since it is a time series data, you need to go for horizontal bar diagram or vertical bar diagram. Vertical bar diagram only. But it is a time series data for one variable or for two variables. Two variables. Since it is for two variables, we have to go for. Yes, tell me. We have to go for multiple bar diagram. Got it? What kind of diagram you can use? Multiple bar diagram. Look here, guys. Here, we have displayed rice as a common bar and this is wheat. This is 2005 rice production. This is 2005 wheat production. And the same 2006 rice production, 2006 wheat production. So 2007 rice production, 2007 wheat production. What is 2005 rice production? 12 and 25. No. So sorry. This is rice production and this is wheat production. So rice production is generally shown with an empty bar. Wheat production is shaded, guys. So if you want to compare, you can simply compare. I have already told you what is a multiple line diagram also. Now, what is component or subdivided bar diagram? This is very important factor, guys. So means, guys, I'm talking about number of tourists that are visited to a particular city. Here I have mentioned cities. So So means my data is varying over place. So I have to choose horizontal bar diagram. Madam, then what is the subdivided bar diagram? Guys, listen to me. Let me assume that I'm talking about my city. Let it be Hyderabad. So this Hyderabad was visited by many foreigners. Means out of these many population, means let me assume that there are 5 lakhs people that visited Hyderabad this year. Out of these 5 lakh people, only 2 lakh people are Americans. 2 lakh people are Americans. So I have separated Americans. And then 1 lakh people are Englishmen. This is 1 lakh people. Next, the rest 2 lakhs were French people. Means there is a 5 lakhs tourists who visited Hyderabad city. Out of these 5 lakhs people, again I have subdivided category. What are they? So number of Americans, number of English people, number of French people. So means it is a spatial data which has subpartitions. So subdivided diagram, this is called a subdivided bar diagram. So means each bar is going to represent the magnitude of given phenomenon that is subdivided into. So this is the value of a given phenomenon. This is talking about tourists. That is subdivided into again Englishmen, Americans and Frenchmen. Got it? So whenever you want to compare the internal factors, you have to go for a diagram called subdivided bar diagram. Now coming into the next diagram, which is sliding bar chart. Madam, what is a sliding bar chart? So the name itself is saying that I am sliding. So it's a bilateral chart, means it has 2 parts which are going to represent 2 components of a factor. I'll tell you in a very easy way, guys. So guys, let me assume that in my institution, during the year 2023, I got 90% success rate in CA foundation. Means what percentage of failure is there? 10% means there is a chance of success as well as failure. So if I find that 90% of my students got succeeded, what percentage of students got failed? It's 10%. Means any institution to show its performance, they will show sliding charts. Not only an educational institution, when it comes to hospitals. In our hospital, if you look at this diagram, they're saying that heart disease patients were 90% cured. It means 10% of my patients were not cured from heart diseases. So TB, 80% got cured, 20% doesn't cured. Cancer, 80% got cured. Cancer, 20% got cured. It means 80% haven't cured. So next, ulcer, 85% of population got cured. It means 15% haven't cured. So means it has contain exactly 2 components. One is success, another one is failure. Got it, guys? So guys, is it a qualitative data or quantitative data? Now I am talking about qualitative. That's why I used horizontal. Otherwise, I went through vertical. It depends. It can be either horizontal, vertical, but people go for only horizontal diagram because they're talking about qualitative phenomenon. No, their success failure is completely a qualitative phenomenon. No. Yes. Next, pie chart or subdivided divided circular diagram. The name itself is saying that I am talking about the total value of, yes, I'm talking about a circle which is subdivided into many segments. These segments are calculated, or these segments angle will be calculated by using a component called central angle. So this segment, you should not draw like this. You have to calculate the total angle. What is the total angle in a circle? 360 degrees, no? Now you can divide these segments based upon the central angle. Madam, how do you calculate central angle? So guys, here, drawn an appropriate diagram in view to represent this data. So source, customs data, in excise, and of course income tax, corporate tax, miscellaneous. So revenue of a particular country from these components. Means I'm talking about the revenue of my country only from different components. This is the revenue of whole my country. Means 80 plus 190 plus 160 plus 75 plus 35. Totally 540 million rupees is my revenue from these heads. Got it? So now I'll calculate the central angle. Madam, how do you calculate central angle? Central angle means volume of particular component, which means 80 customs, by total volume, which is 540, into total angle 360 degrees. Like that you will calculate central angle. Here they got 53 degrees. 127 degrees and 10 degrees and 50 degrees and 23 degrees. Totally it is 360 degrees. But what is the total revenue in million rupees? I've already told you 540. Now you can draw Venn diagram. Got it, guys? So from excise is denoted by this symbol, IT is denoted by this symbol, customs. So you can go through this pie diagram whenever a particular component is divided into many segments. So what are frequency graphs? I've already told you. Histogram or area diagram, which is a graphical representation of mode. So guys, for example, so I want to present or I want to understand what is a histogram and how do I calculate mode with the help of histogram. I'll show you with a simple example, guys. So let me assume that I have classification from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Let it be my classification. And my frequencies are this way: 5, 10, 15, 20, 25, like that, and so on. 0 to 10, let it be my frequency was 5. 10 to 20, my frequency was 10. 20 to 30, my frequency was 15. So next my frequency was this much, 5 again. Next my frequency was this much. So let me assume that this way my class interval frequency I draw on the axis. Now how to calculate mode? So guys, mode is the highest frequency, no? Yes, which class is having highest frequency? 20 to 30, no? So guys, note the upper class boundary or lower class boundary of this model class. From this upper class boundary to its previous class upper boundary, draw a perpendicular line. Draw a perpendicular line from the model class upper boundary to its preceding class, like that. Draw a perpendicular line from the lower class boundary of model class to its next class. Got it? Next class, lower class boundary. These two perpendicular lines intersected at a particular point. Are you able to see this point? Draw a perpendicular line from this or point of intersection. This perpendicular line touches the x-axis at a particular point. No, let it be 21 or 22. That 22 is called as mode. How do you call it as mode? This is how you can calculate mode of a particular class into particular distribution by using diagrammatic way. So next, why you're calling it as a area diagram? Guys, if you observe this, we will calculate mode only if the classes are having equal class interval. So means the length of all these rectangles are same, no? And height of this rectangle is proportional to frequency, right? Height of this rectangle is proportional to frequency. What is the area of this rectangle? Class length into frequency, right? Yes, area of rectangle is equals to class length into frequency. Now let me show you the data that is provided to you. Histogram contains rectangles, so with no space between them. So area of each rectangle is proportional to, just now I told you, frequency of the class interval. And the total area will be proportional to total frequency, no? Yes. So guys, tell me, in histogram, to draw histogram, we should not have any space between the rectangles. Means there should be class limits or class boundaries. Boundaries means if you were given with an inclusive series, convert it into exclusive series. Then only you can draw histogram. Whenever there are class limits, convert them into class boundaries. And one more thing, whenever the class length is not same, you can't calculate mode. In such a case, convert your class frequency into frequency density. Means on y-axis, instead of frequency, draw frequency density. It means the area of rectangle is proportional to frequency or frequency density now. Frequency density. Got it, guys? So that's how you can compare frequencies. You can calculate the mode. Now, what is a frequency polygon? So just guys, mark the midpoints of this histogram. Connect them with straight lines. If you connect them with a straight line, that is called as frequency polygon. If you connect them with a free hand, that is called as frequency curve. If you just connect it with a free hand, guys, if you connect it with a free hand like this, this is called as frequency polygon. But if you connect them, these dots with a just straight line, this is called as frequency polygon. Both frequency polygon and frequency curves are the limiting forms of histogram. Okay, so now you know what is a ogive. Ogive is a graphical representation of what? Ogive is a graphical representation of median and all the positional averages. Madam, how do you calculate median and of course all the positional averages? By using ogive. So guys, ogives are of two types, guys. One is less than ogive and the other one is greater than ogive. Less than ogive is the graphical representation of less than cumulative frequency. As you all know, less than cumulative frequency is usually in increasing order, no? So on x-axis you need to write upper class boundaries. On y-axis you need to write less than cumulative frequency, and if you draw, it will be a J-shaped curve. But when it comes to greater than cumulative frequency, you need to write lower class boundaries on x-axis. You need to write greater than cumulative frequency, and that will be in inverted J-shaped. The point of intersection of less than ogive and greater than ogive together is called as median. Of course, if you want, you need not use this less than ogive and greater than ogive. Just draw less than ogive curve. As you all know, it is a J-shaped curve. On x-axis, upper class boundaries will be there. Let it be 10, 20, 30, 40 like that. On y-axis, less than cumulative frequency is there. So I don't know what are the values. So I'm simply writing my y-axis scale is this way. So let me assume that my total frequency was 20. It means n equal to 20. Now I want to calculate median. So median means I'll calculate n by 2. What is n by 2? 10. So on y-axis, I'll just look at 10. I'll draw a perpendicular line to my less than cumulative frequency curve. From there, I'll draw a perpendicular line to x-axis. This point is your median. Suppose if you want to calculate third quartile, it means I need to calculate 3n by 4, right? So what is 3n by 4? 3 into 20 by 4, which is 15. From this 15, I'll draw a perpendicular line to my ogive, and then I'll draw a perpendicular line to my x-axis. It touches the curve at 31 or 32. That is what my third quartile. This is what my median. If you want to calculate ninth decile, you will calculate 9n by 10. So what is 9n by 10? 9 into 20 by 10, which is nothing but 18. So I'll draw a perpendicular line from 18 to y-axis, and then I'll draw a perpendicular line to x-axis. This is what my ninth decile. Like that, I can calculate any positional measure by using these ogive curves, guys. And there's a very important concept. Okay, so that's all about ogive curves, guys. So usually any frequency, most of the frequency curves are bell-shaped curves. Most of the regular frequency curves are bell-shaped curves. Of course, we have mixed multimodal curves also. Why I'm calling it as multimodal curve? Because this is a increasing curve, and then decreased, and then increased, and then decreased. So guys, how many modes that you can see? 2 modes. That's why we'll call it as multimodal curves, which is also called as mixed curve. Got it, guys? So we have U-shaped curves, we have J-shaped curves, but most of the curves are of bell-shaped curves. So this is how you can calculate all the positional averages by using ogive curve, and you can calculate median by using your histogram, and what is a line diagram and what is a bar diagram that you are aware of. So you have to understand when is simple bar is used, when is multiple bar is used. Like that, you need to verify what data is given to you, what diagram suits to the data that is given to you. Then only you should answer the MCQs that are related to theory, guys. So try to understand the concepts in a better way. Then only you are in such a position to understand the answers that are related to this topic. In particular, this topic we can expect multiple theory questions, guys, which are dependent upon diagram, of course, collection of data, classification of data, presentation of data. From everywhere you can expect a question. Collection classification is very easy for you. Presentation textual tabular is easy for you. In diagrammatic we have many diagrams. Try to understand the difference between line diagram, bar diagram, of course frequency graphs, non-frequency graphs, of course circular diagrams, of course pie diagram. Each and every diagram has its own significance, guys. Try to understand the importance and try to understand when is that particular diagram is used. If it is used, for what factor you are using it, you all need to consider these factors, guys. Then only you are in such a position to understand the concepts better.